Good morning. Please find your seats. Our program will begin in 2 minutes. And as a courtesy to the presenters and those around you, please take a moment to silence all mobile devices. Good morning. Please find your seats. Our program will begin shortly.
Microsoft's been doing a ton of new cutting edge things with technology these days and always trying to up the last feature and development.
We just love that Microsoft is dedicating more resources to the open source community.
Developing in Azure, I would say, was quick and easy to get our data stores out there and get things wired up together.
Microsoft's always coming out with the latest and greatest solutions that helps me get my job done.
I'm really in love with the fact that they engage at significant levels all across the board, and they have everything out there in GitHub.
Honestly, these days, I'm a big fan. The company that's really headed in the right direction, just on all levels.
We're like, bring it on. We want more.
Please welcome to the stage Executive Vice President, Cloud and AI, Scott Guthrie.
Well, good morning, everyone, and welcome to the Microsoft Connect event here in Las Vegas, which we're co-hosting together with the Dev Intersections Conference. We have some great content to share this morning, as well as some awesome announcements and some really fantastic demos. And in addition to our in-person audience, we are also streaming this event live to hundreds of thousands of developers around the world. And some of the developers watching, both here in the room and online, have probably been using Microsoft technologies for many years. And some have never used any Microsoft technology or development tool ever before. And we have some great demos and announcements today that we think, regardless of your experience with us, are really going to make you as developers even more productive. And I'd really like to thank everyone here for joining us. We now live in a world that runs on software, a world where code drives the experiences we interact with on a day-to-day basis. Not just in our phones or on the web, but with everything. Our cars, our homes, and our work environments now run pretty much entirely using software. And this is what makes it such an exciting time to be a developer right now, and to be able to build apps and solutions that can have an amazing impact on people's lives. And it really has never been a better time than now to be a developer. Our goal at Microsoft is to provide developers with a platform and tools that will make you incredibly successful. It's a mission we've had since the very beginning of the company. And in today's event, we're going to walk through and demo our latest development tools and cloud platform innovations that enable developer success. The new Microsoft has everything you need for creating the next generation of software applications. Whether you're a .NET developer building a web app, or a Node.js or a Python developer on a Mac doing the same, whether you're a C# developer targeting Android or iOS, or a Python developer using Vim to create a custom analytics solution running inside a Linux VM. And you're going to see demos of pretty much all of this throughout today's event. And throughout the demos today, you're going to see how we're working to enable developers to build these great apps, again, regardless of which language they're written in, what operating system they're developed on, and what devices they target, all in a really powerful, open, and productive way. And just to kind of prove this is real and kicks things off and start a little demo heavy, what I'd like to do is invite Chris Dias and Amanda Silver on stage to actually show building some of these capabilities end-to-end using a wide variety of different languages. And just to prove this openness is actually start demoing it on a Mac and using a non.NET language, and really kind of highlight how this great developer tooling and the flexibility that we have with both our Visual Studio tools and Azure enable you to build fantastic, amazing solutions. Here's Chris.
All right, thanks, Scott. So before we get started, the first thing I want to do is introduce the Tailwind Traders application. You're going to see this in a number of demos this morning. Tailwind Traders is a fictitious home improvement site. It really showcases the future of connected app experiences. Now, the reference apps you'll see this morning are all powered by the Azure Cloud, built with best-in-class tools, and made smarter through machine learning and AI. So let's get started. I'm going to start over here in Visual Studio Code. Visual Studio Code is our lightweight cross-platform editor. It's really focused on the core developer inner loops. Let's go write some code. Actually, I should explain first what I'm going to go and build today. So as part of the Tailwind Traders application, I'm going to go in and build an online storefront. And we're going to sell something fun here. In relation to the upcoming holiday season, we're going to have an online store, and we're going to sell garden gnomes. All right. That'll be awesome. So we're going to start in VS Code. And like I said, it's our online, our cross-platform editor. And let's get started. First thing we're going to do is going to make a little bit of space here. We'll close down the Explorer. We're going to zoom in so you can see everything that's going on. And in case we go to the workspace, I'm going to turn on a new feature in VS Code. It's called breadcrumbs. So I'll go up to the command palette. I'll say view toggle breadcrumbs. And now at the top, it might be a little bit difficult to see, but we can jump up there. We can go up to the top. If I press Enter, now we can navigate through the workspace, through files in a particular folder. We can actually even navigate within a file itself. You can see we're navigating around with this nice little outline. So let's jump into some code. So for out of the box, the Visual Studio Code, we've got a great editing experience for plain JavaScript powered by the TypeScript compiler. And so if I come in here and I just say app dot, I get the standard IntelliSense list. And IntelliSense was revolutionary. It came out almost, I looked it up, it's almost 25 years ago with Visual Basic 4. And what's great about it is it tells me what I can program against in my classes. But the problem with it is it doesn't tell me what I should program against. So it turns out, with the power of the cloud and machine learning, we can make IntelliSense smarter. And we do that with something called IntelliCode. Let me show you what that looks like. I'm going to bring up the Explorer View-Let. And the Explorer View-Let gives me access to thousands of extensions in the marketplace. And I'm going to search for IntelliCode. And once that IntelliCode. Oh, I got to spell it right. IntelliCode. There we go. And I've got it disabled so I can show the before and after. We'll just re-enable this extension and restart VS Code, and we'll get back into our coding. And so let me zoom in again. So now when we come in here, if I type in app and I hit dot, what we're going to see at the top of the expression list, or the completion list, is a number of options that have a star next to them. And that's IntelliCode telling us what we should go and program against. And IntelliCode knows this because we used machine learning to analyze thousands of open source and public repositories from GitHub and train the IntelliCode engine to provide us completions based on what other people have done in the context that you're in. Now, this is kind of an easy example. App is a router object in Express. And you could say, hey, Chris, you probably just went through and sorted them and said those are the most common ones to use. But IntelliCode is smarter than that. Let me show you what I mean. I'm going to create an array. So we'll say var x equals, open brackets. And if I come in here and I say x dot, at the top of the list, I get a set of completions with stars next to them to let me manipulate the array. So things I would commonly do when I have a fresh array, I might push things into it, or I might iterate over them. Now, if we go into something like an if statement, if I say x dot inside the if statement, you can see that our completion list is different. The top of the list has things that I can test, like the length of the array or the contents of the array with index of. So let's try index of, and we'll see if there's the number 1 in there. Of course, it's empty, and there won't be, but you get the idea. And we'll go into our block. And now in here, if we say x dot, you can see, whoops, x, oh, I got the cap lock on, x dot. There we go. Now you can see that I've got methods in the array that let me manipulate the array. So like splice, for example. So I did index of, I found something in the array, now I want to splice and take it out. All right, so IntelliCode is very smart. I've shown it here in JavaScript. It also works for TypeScript, Python, Java, and C#. And it's going to continue to get smarter over time as we continue to train the engine. And in fact, you can train the IntelliCode engine with your own code, and that's something that you'll see a little bit later on this morning. OK, so now we wrote a little bit of code. Let's run our application and see it in action. I'm going to press F5. And what's going to happen is VS Code is going to start up the node runtime locally on my machine. So it's going to start one debugger. And it's also going to start up the browser and another debugger so I can debug both the client and the server code at the same time. And so here's our nodes, our gnomes, and our node, because we're doing node. I can add a couple of these to the cart. You can see up here in the cart, everything looks good. And I've got a couple of recommendations down the bottom. All right, I'm happy with this application. It's running locally on my machine. So what I want to do now, though, is actually we'll stop the debugger. And now what I want to do is take this and I want to deploy it to the cloud. I want to test it out there before we push it to production. And to do that, I'm going to actually use something called, or I'm going to use Azure App Service. Azure App Service is our platform service for hosting and scaling web applications. And to manipulate our application or talk to it, I'm going to actually use the Azure App Service extension. And the App Service extension, actually have a number of Azure extensions installed, all contribute over here on the left-hand side to something we call a view-let. So I have the Azure icon, and we have the Azure view-let on the left-hand side. So I've got my App Service node up here, and I can drill in and see my app services. I've got Cosmos DB, or access to Cosmos DB. Cosmos is our cloud-scale NoSQL database. It has massive throughput and single-digit millisecond latency, so very, very responsive. I have access to my storage, my Azure functions. So if I'm creating serverless functions that I want to only pay and run for the compute, I have access to that as well. And I actually have access to my storage accounts as well, which, for if I have unstructured data or large data blobs. And another cool fact with storage, you can actually persist your static websites and host them very rapidly and for very low cost in storage. But let's go and we'll deploy this application to the cloud using the App Service extension. And here's my development website. It's a very simple site that I've got set up. Now to deploy it, all I have to do is right-click on the site and say Deploy to Web App. And what this will do is we'll package up the application or the folder locally, and it'll ship it up to Azure and deploy it there. Now, this will take about 20 seconds to deploy. So while we're doing that, a couple of cool things I want to point out in the App Service extension. One is this application settings node. And settings for an application actually turn into environment variables that my app can access. I have access to my deployment slots. So if I've deployed multiple versions, I can roll them back. And I even have access to the log files for my application. So if I want to go in and review the log files if something went wrong, I can see those right here in VS Code. OK, so we'll close that down. It looks like the website has been deployed to the cloud, and there it is, and it's running up in Azure. But you see, we've got this spinning thing right here, right? And no gnomes are showing up because we're not accessing the data. When we ran locally, we were actually accessing a local MongoDB database, which you can see down here in the Cosmos extension. And so since we're up in the cloud, we need something that is in the cloud, so we're going to use Cosmos for that. One of the cool things about Cosmos as a developer is that it supports multiple open APIs. So it supports Cassandra, Apache Cassandra, SQL, and in this case, since we're a Node application and Mongo is very popular in Node, it actually supports the Mongo API as well. And so using the extension, I can actually drill in here and see the documents that exist in my database. In fact, if I'm brave in this demo, I can edit them and persist them back up into the cloud. And so what this means is, from a developer perspective, if I want to move to the cloud and take advantage of the massive scalability of Cosmos DB, I can continue to use the same tools and frameworks and just point at the Cosmos DB database. So to do that, we'll go back up to our app service extension. And there's another node here called Connections. And so if I come in here, this actually gives me access to Cosmos DB. And we'll expand this as time goes on. And once we click on that, it's going to ask you what the subscription is, what the account is, what the database, which is what we just drilled into earlier. So we're connecting it up to the database. And the last thing it's going to ask me is what the environment variable is that my app is listening on. Okay? And so this is going to inject it as an app setting into the app. So when we do that, it's going to go ahead and update the application. So that's been done. If I look at our app settings, you can see now that I've got a Mongo URL in there. And that means if I come back over here to, oops, I closed that tab, that's OK. I can right-click on it and say Browse the website again. And now what we're going to see is that our website will come up, and now we're connected to data in the cloud. All right, so now we've moved up to Cosmos. And again, I can come in here and I can add to the cart. And if I look into the cart, I can see that I've got my list, and I've also got a couple of recommendations based on the products that I've got in the cart. Now, with the holiday season coming up, I've got a couple of gnomes that aren't selling very well, and I need to make some space in the warehouse. And so what I want to do is offer up some sale items. I really want to push some products. So in our recommendations down here at the bottom, I want to offer up some of these gnomes that aren't selling too well. Now, this recommendation service is written as an Azure serverless function. And this makes perfect sense in this model because like if the holiday season's coming up, it's going to scale with me. And I'm only going to pay for the compute that I use in this service. So let's go see what that's going to look like. So we'll go back over to VS Code, and I'm going to switch over to my function, the recommender function. And we'll close down that again. Now, this function is actually written in Python. And that's cool because I can take advantage of libraries like NumPy or scikit-learn. Now, I am not the best Python programmer. The lack of semicolons drives me a little crazy. But I was looking through the code earlier, and I feel like there's a couple of things that I can change in here to do what I want to do. So if I come in here and I change the items that we return to the recommender to be 2, so I always want 2 recommendations, and I always want to force 1 sale item to happen in the list as well. I think this will do what I want it to do. Now, to test this out, normally with a serverless function, you got to deploy it to the cloud to try it. But what we can do is set a breakpoint right here, and I'll press F5. And what's going to happen is we're actually going to spin up the Azure Function Runtime, which is installed locally on my machine. It's written on .NET Core. It ships and it supports Windows, Mac, and Linux. And this is the exact same runtime that we host functions up in the cloud. So now the fact that it's running locally on my machine means that I can debug it. So we get a nice little URL because that's the HTTP endpoint that we're going against. So if I click on that, what we'll do is we'll hit it, and then we break in the debugger in VS Code. So now we have the nice, lightweight debugging experience of VS Code. I can do things like see all my local variables, and I can hover over items, and there's my top 3. And I can see at the top I've got 2 recommended ones, and the last one is the GNOME sale. So I think my change is pretty good. But like I said, I am not the best Python programmer. And so I would like to get a couple of additional eyeballs to look at this before I make a pull request and submit it. Now, I don't know if you can see it very well, but there's I've got an extension called GitLens. And GitLens provides me lots of cool information about Git. And it shows here the blame on this line. It says Amanda Silva worked on this 6 days ago. So Amanda is probably somebody that, hi, Amanda. Amanda is probably somebody that can help me out with this. So what I'm going to do now is I'm going to start a collaboration session with Amanda. And we're going to use Visual Studio Live Share. And I can see over here that Amanda is actually online, which is good. And I can message her, I could send her email, but because I know she's here, she's right online, I'm going to click on the invite link.
So all I have to do once I get the invitation is to just accept it. And what you can see is no matter what I'm doing in Visual Studio, I'm actually going to get into Chris's instance of his workspace. Now his workspace is hosted in Visual Studio Code on the Mac. I'm on Windows in Visual Studio. And yet, even if I don't have all of the SDKs that he's using on my machine, I can actually go ahead and see what he's working on. Now you can see this in the Solution Explorer. You can see all of the files that he's been working on. But even further, I also get the context of where his focus is. So I can actually see you, Chris. What's going on?
So I've got a, excuse me, I've got a couple of changes that I wanted to make here. I'm trying to push some sale items into the recommendation system. So I made a couple changes here to say, hey, you know what? I just want to see 2 recommendations and then 1 sale item. I ran it, debugged it. Looks pretty good, but I'm not confident in my changes.
Okay, well before I make any changes, I always really like to build everything. So I'm just going to go ahead and build this. Now what you can see here is that this is actually launching a terminal that is actually being hosted on Chris's machine. So we're actually compiling the Azure function written in Python against Chris's Azure Function SDK on his Mac right there. And you can actually see I have access to localhost as well. So I'm going to now further launch a debugging session. So I can go ahead and attach to Azure, attach to the Python functions and go ahead and launch into a debug session. So now that I've done that, I can go ahead and tab to the localhost, and I can actually hit his localhost. Now this is going to bring me back, and it's actually going to hit a breakpoint right here in this context. Now that we're in a debug mode, I'm in debug in Visual Studio, and he's also in a debug mode in his Visual Studio Code instance. I get all of the experience that I've come to expect from my debug experience. So for example, I can add a watch, and I can expand the list. And I can see here all of your gnomes are listed, but the sales, it looks like, are last. And I thought you said you had to move those.
I do want to get rid of some of these gnomes. So if you can move that up to be first, that would be awesome.
Sure, let me just make a change here. So let me just stop debugging. Now I'm just going to select this and move it back. And we'll just put it right at the front, right here. And just hit a plus. And we'll run it one more time. And let me just remove this breakpoint and just run it again. So again, this is running. Now we can actually go back to localhost, and I can refresh this. And yep, it looks like we have 50% off, so it looks like everything's great.
Awesome. So I only have a minute left in this demo. I want to make a quick pull request. Can you hang out and merge that in for me after I do it?
You betcha, Chris.
All right, so let's stop the debugging session. I'm going to come over here to my source code control view. And I can see here's the changes that we made. There's the changes that I made, and here's the change that Amanda made, so they look good. One cool thing is that LiveShare actually pre-populated the commit message with the fact that Amanda and I collaborated on this. So I'm just going to add one more thing, add sales, and commit that locally. And now what I want to do is I want to create a pull request. And to create that pull request, I'm going to use another extension that I have installed. It's called the GitHub Pull Request extension. And the GitHub Pull Request extension is a collaboration between the Visual Studio Code team and the GitHub team to bring the core inner loop of working on pull requests into the environment. So I can come in here and I can see different pull requests that might be assigned to me, created by me, and things like that. And if I want to create a new one, all I have to do is click on the plus. It's going to ask me what branches I want to use. And once I do that, it's going to create the pull request locally on my machine, and it's going to push the branch up to GitHub, and it'll be done here in just 1 second. There we go. Now, Amanda should be there. Could you take a look?
Sure, let me just take a look here. Okay, I do see your pull request, so let me go ahead and look at this. And in GitHub, I can go ahead and just merge the pull request. You can see that it already lists that it's co-authored by me. And I'm going to confirm the merge. And after this is done, you can see that it actually is going to kick off an Azure DevOps build. And I think everything's going to be deployed to production. So you want to check it out, see if it's working?
Yeah, that was fast. All right, so if we come back over to our site, and if we refresh the page, hopefully here we're going to see our sales items front and oh, there we go. There's the node, or the gnome. Looks like the Scott Guthrie gnome. There we go, 50% off. So, please come to the site, buy some of these, and let us know what you think.
I think our work here is done.
Thank you very much.
Chris. Adios.
So you just saw some amazing things in that demo. In Visual Studio, you saw IntelliCode, which is a new code editing capability that uses AI to improve IntelliSense recommendations for C#, Java, Python, and starting today also for JavaScript, C++, and XAML. Live Share, which was the technology that enabled Chris and Amanda to share a live coding session in VS and to code and debug in real time, even though one was on a Mac, one was on Windows, one was using VS Code, one was using Visual Studio. It really transforms how you can do remote pairing and collaboration. Our new GitHub integration, which brings pull request workflows directly into your code editing experience. And as part of that, you saw the new experience we're delivering today that enables you to work on pull requests directly from GitHub without having to clone inside your tool. And you also saw some of the Azure tooling extensions, which we've added now to both VS and VS Code, that make it really easy to deploy apps to the cloud and manage all your Azure resources directly within your development tool. You also saw in that demo a few of our new innovations inside Azure, including App Service, which is our fully managed web app hosting service that can host any web app. It now supports not just Windows-based web apps, but also Linux and Docker container-based web apps as well. Azure Functions, which is our serverless event handling offering, which can scale to process billions of requests concurrently, and supports many languages, including C#, Node.js, Java, which just went GA a few weeks ago, and now Python, which is new starting today, in which you can now build your serverless functions in on Azure. And then you also saw Cosmos DB, our globally distributed multi-model NoSQL database service, which provides developer API support for MongoDB, Cassandra, and Gremlin Graph. And then at the very end, you saw a little bit of our Azure DevOps pipelines, which we'll go into more detail later today, which is our CI/CD build service that works for Mac, Linux, and Windows, and which can be easily used and integrated into any GitHub repository or project. And that is just a small sampling of a whole bunch more things that we're going to be showing later today. But we thought that might be a fun way to just sort of get things started and show you some of the end-to-end experience that's now possible. And throughout the morning presentations, we're going to go into and demo even more developer capabilities that we're releasing, both on the VS Tools as well as Azure side. So one of the things you probably noticed both in that demo, but also hopefully over the last couple of years, is the change in how Microsoft approaches open source. We not only support OSS projects in a deep way, but we've also open sourced much of our own product development. Products like Visual Studio Code and SQL on Linux are now used by literally millions of developers around the world. The .NET platform is now open source and has accepted over 61,000 pull requests from the community. And Microsoft is now one of the top contributors for Kubernetes and is a maintainer of a number of open source projects like Helm, Draft, and Brigade that make Kubernetes easier to use. And more than 5,000 Microsoft developers now commit to open source projects every single year. And in fact, over the last 2 years, Microsoft has had more contributors contributing to open source on GitHub than any other organization. Now, earlier this summer, we announced our intention to acquire GitHub, and last month, we completed that acquisition. GitHub is the largest developer community in the world, and we recognize the tremendous responsibility that comes with it, and we're very committed to ensuring that GitHub continues to operate independently and remains an open platform that supports all developer communities. What I'd like to do now is invite Nat Friedman, the CEO of GitHub, on stage to share more about GitHub and some of the exciting things that his team is doing with it. Please welcome Nat.
All right, good morning. Thank you, Scott. I'm really excited to be here today to talk to you about the work we're doing at GitHub. Now, as Scott said, GitHub is the largest developer community on the planet, with over 33 million developers from nearly every country on Earth. And in the last year, developers made over 1 billion contributions to the open source projects and the private repos that developers host on GitHub. Additionally, more than half of the world's 50 largest companies depend on GitHub for their internal work every day. So GitHub is big, but GitHub is also growing faster than it ever has before. In fact, we just hit a major milestone last month, reaching over 100 million repositories on GitHub. It's pretty amazing. This is an incredible testament to the creativity and energy of the GitHub community, but it also shows how much use of GitHub is actually accelerating. It took 6 years for GitHub to reach its first 3 million repositories, And today, developers create more than 3 million repositories on GitHub every month. That's nearly 100 every minute. It's amazing. So our vision for GitHub is to be the home for all developers, whether you're writing your first line of code or your millionth line of code. If you're an open source maintainer or an enterprise developer, or if you're working at a startup or you're one of the million+ students who live on GitHub, GitHub gives each of us the opportunity to join this global community of developers who are building the future together. And one of the reasons that developers love GitHub is because of the deep care and thoughtfulness that goes into every facet of the developer experience on GitHub. And looking back over the last 12 months, the work we've done on GitHub reflects that approach. This year, the GitHub team has shipped over 150 UI experience and workflow improvements to GitHub. One example is suggested changes, which is a really innovative new feature. Suggested changes makes it much easier for reviewers to suggest a simple change directly in the pull request and for you to accept that change with a single click. So you can actually show the change, not just tell. Additionally, we have now integrated security alerts into GitHub. So basically every piece of software that you build today on the planet, whatever you're doing, it probably incorporates open source. And in 2018, we're all aware of the risk of including or depending on vulnerable open source packages in the software that we write. So with security alerts, if a vulnerability is discovered in an open source package that your project uses, GitHub will now detect it automatically and remind you to update. Our goal is to be not only the best place to create open source software, but the safest place to consume it. In addition, GitHub now features built-in token scanning to automatically detect API keys and passwords that you might accidentally check into your version control and let you know. And we've even partnered with all the major cloud vendors to automatically ask them to revoke those API tokens if the token escapes into a public repo somehow, like you publish it accidentally. Finally, there's GitHub Actions. Now, developers and teams depend internally for their work on repeatable workflows to build and test and deploy their code, of course, but also to do things like onboard a new contributor or merge a change or to respond effectively to someone reporting a security vulnerability. Each team has its own workflows that are composed of custom scripts and third-party services and manual steps, and we rely on these workflows just as much as we rely on the libraries and platforms that we're building our software on. So with GitHub Actions, we've created a way for you to script all of your development workflows directly in GitHub. You can write your actions in any language, and they live as code right in your repo, and they run on GitHub. You can use actions to integrate with or deploy to any third-party service, and the community has already built hundreds of actions that you can learn from. So to show you how this works, please welcome GitHub infrastructure engineer Jesse Frizzell. Jesse?
Thank you, Nat. It's really awesome to be here today. So what I'm going to show you is one of the most common open source workflows. I've had a lot of experience working on open source projects and maintaining them from Docker to Kubernetes and a bunch of others. And one thing every single open source project needs to think about is licensing. So when a contributor makes a pull request to an open source repo, they need to designate that the code that they're giving up can live under the license of that project. And one of the most common ways to do this is by signing off your commits. And this was actually built into the Git tool for the Linux kernel, and that's how they verify that people give up their code. So this is super easy to actually add an action to verify that people have signed off their commits with GitHub Actions. You just drop your scripts into the .github folder here. And we're going to do a deep dive into these scripts later. But first, I want to show you exactly what this looks like if we make a contribution. So let's do that. Cool. So here I am in our repository. And I've changed something in the index.js to fix some bug. And I'm going to commit this. And then I'm going to push it up to our branch. And then let's open a pull request with our changes. And go to merge these into the master branch. So if you see here, our action to verify the commit sign-off is running. And this is actually required by the protected branches feature, so we can't merge this pull request unless this passes. So what's happening on the back end is GitHub is executing a Docker container, which is running your scripts. And you can write your scripts in any language. It's really cool because you have the power of Docker, and it's like any sort of thing that you want. And oh no, it failed because we forgot to sign it. So we have this GIF pop up telling us, nah, you're not going to be merged today. So let's go back over and fix it. And we're adding the -s flag, which, like I said, was added for the kernel. And then you can see here that now our commit message says signed off by, and my name and my email. And then we're going to force push this back up to our branch. If I can type. There we go. Cool. Sweet. We'll head back over to our pull request, and then you see that our action is being executed again. So what's awesome is like this workflow was totally automated. Like at no point did a maintainer have to step in and be like, you need to sign your commit, because that gets like super tedious when you have like 200 pull requests a day and things are moving super fast, which is like totally something that happened to us on Docker. And then we also hosted like a bunch of bots. Like I personally host a bunch of bots on my own infrastructure in my apartment. So now that this is passed, we can merge it. And that was super simple. So let's like take a look again at these scripts. Here we are in the .github folder again, and you can see that we have our main.workflow file. So if we pop that one open, here we have the text editor for this file, but we also have this awesome visual editor, which is super cool. And you can see our workflow here for verify commits are signed off. And this gets triggered on the GitHub event for pull requests. But you can actually trigger them on like any GitHub event. And you can see that in a drop down here. So what you could do, say, is have a action that triggers on every single new issue to a project. So if a maintainer goes out of town and they're the only maintainer on the project, say, and they can say, I'm not going to fix your bug until I'm back from vacation. And that's pretty cool. You can do all sorts of things, which is awesome. It's super extensible. So if we continue diving into our script, though, you can see that we have some scripts in the verify sign-off folder, and that's what is executed inside the Docker container. And then we're also adding our GitHub token, and that gets populated by GitHub itself. So if we look at that script, though, it's just 65 lines of bash. It's super simple. And all we're doing is showing the git commit and then making sure that it says signed off by, and if not, we post the GIF. So what I love about Actions is that like all of this is automated, and previously, before Actions, I hosted so many bots, like I said, on my personal infrastructure, on my apartment, and no longer do I have to do that. I get like all my compute back, and that's awesome. So I'm really excited to see what you all build with this feature, and be sure to send us feedback. And now back to our awesome CEO.
Hey. Thanks, Jesse. So GitHub Actions makes it easier than ever for you to integrate third-party services into your GitHub workflows. But GitHub has actually always been an open, extensible, and neutral platform with a lot of API extension points. And thousands of third-party integrations have been built for GitHub, many of which are available in the GitHub Marketplace. One of the most popular tasks that people do with GitHub is continuous integration. And today we're proud to show you the amazing work the Azure Pipelines team has done to integrate with GitHub. So if you don't know, Azure Pipelines is a cloud-hosted CI/CD service that's great for any kind of application on any platform written in any language. It includes hosted pools of Linux, Windows, and Mac VMs that are managed for you. And it's really easy to use from GitHub because you can just connect it to your repo with the GitHub Marketplace. Azure Pipelines is amazingly free for open source. So if you're working on an open source project or you have a public repo on GitHub, you get unlimited build minutes and up to 10 free parallel jobs across Linux, Mac, and Windows. This is the single most generous open source CI/CD offering on planet Earth. In fact, even though it was just released this fall, there are already hundreds of open source projects on GitHub that are using Azure Pipelines today. And it's really cool to see projects like Python and Next.js and Yarn using Azure Pipelines, which is now doing more than 20 million builds every day. So to show you how GitHub and Azure Pipelines work together, along with the other Azure DevOps services, please welcome Donovan Brown. Donovan?
Thanks, Nat. Good morning, everyone. Let's try that again. Good morning, everyone. Perfect. Imagine you're a developer working in a GitHub repository. As the number of contributors increase, you realize you need continuous integration. With CI in place, upon every commit, the code will be downloaded, compiled, tested, and packaged for deployment. When you visit the GitHub Marketplace, what you're going to quickly realize is that you have a lot of options. But our repository requires us to be able to build on macOS, Windows, and Linux. But we only want to maintain a single build script. This needs to be completely managed for us because we have no infrastructure to spare for build machines. We also need to be able to run multiple builds at once so that our contributors get instant feedback on their pull requests on if it's successful or not. With those requirements, there is literally only one choice, and that choice is Azure Pipelines. It gets even better, because if you happen to be working on a public repo, you get everything that I just said for free. Access to Mac OS, Windows, and Linux, completely managed for you, so there is nothing for you to install, there are no VMs for you to provision. We have one YAML file that now rules them all. Gone are the days of having a YAML file for one CI to get to one platform and another YAML file for another one to get to another platform. One YAML file gets you everywhere. 10 concurrent pipelines and unlimited build minutes. Once you have this wired up to your Azure DevOps application, you now have access to all of your actual repositories. When I click on one of these repositories, we're actually going to be able to go off and analyze that repository and determine some of the better options for you. What we're going to choose here is the Docker image. When I choose the Docker image, it actually writes the YAML for me. And this YAML will work on macOS, Windows, and Linux unmodified. What we're going to do now is we're just going to go ahead and save and run this. When I start running this, Azure Pipelines and GitHub are going to work together such that every time I commit to this repository, it's automatically going to go ahead and start a build for me. That build is actually going to go off and provision the required resources, spin up a VM of the platform that we need, start building our application for us, and when we're done, completely destroy it. You can actually monitor the build here in real time, or because we have such great integrations with the GitHub Checks API, you can come back to your pull request and review the status right here inside of GitHub. Clicking on details, I can see if there was any warnings or errors in my build. And if I need even further details, clicking on that will bring me here, back to Azure Pipelines, where I can see the results of my build. I need to drill in even deeper. I click on a task, and there is the real log of everything that happened so that I can go back in and troubleshoot if something went wrong. YAML is just one way that you can edit your pipelines. You can also use a graphical user interface, which I'm going to show you now when we start talking about release pipelines. Release pipelines takes the output of my build and allows me to now deploy it to all of my infrastructure. I can control when I fan out or fan back in. I can control all the tasks that need to be run. For example, if I click on this one here, you can see all the tasks necessary to deploy my application inside that particular environment. If I need more, I simply click on this plus. This is going to give me access to hundreds of tasks that we've given you out of the box that you can now drag and drop to build your pipeline. It gets even better. These were developed in the open in a GitHub repository. So if you want to learn how we've actually developed these, clone the repo, and you can actually write your own and add your own value. But before you do that, I'd encourage you to go to our marketplace. Our marketplace is where our partners have created hundreds of extensions that add additional tasks to your build and your release so that you can do anything that you want for any language and any platform. Not only can I control everything that happens in my environment, I can even control how the code flows through my environments as well. Because I have CD enabled, every time a build is successful, it automatically deploys into dev, fans out and deploys into QA, and even automatically deploys into my pre-prod environment. But before I go to production, I kind of want to get a second pair of eyes on this. So what I've been able to do is set up an approver. So Sachin gets a notification saying, we'd like to go into production. Is it okay? And he can give a thumbs up or a thumbs down. But the approvals that I need don't always come from human beings. Sometimes they come from third-party systems. ServiceNow is a popular IT-provided service management tool. And sometimes we need to get approvals from that tool before we can actually deploy our code. Instead of doing that manually, I can now use release gates. Release gates talk to external systems and allow them to let us know when it's time for us to deploy our code inside our environments. Now, what I've shown you here is just Azure pipelines, but that is just one piece of Azure DevOps. Azure DevOps is everything that you need to turn an idea into a working piece of software. There's services to help you with your repositories, help you with boards, help you with your artifacts. It's an amazing, I think more of it as a platform. And as Nat said, it's extensible, and we continue to help it integrate even better with GitHub. As a matter of fact, we've just released the ability for you to take your board's work items and link them to the GitHub commits, giving you unparalleled traceability. So please, use the platform and go be great. Thank you so much, everyone.
Thanks, Donovan. So our mission with Visual Studio is to provide best-in-class tools for every developer. We now have Visual Studio Code for developers who want a lightweight code-optimized editor, as well as Visual Studio and Visual Studio for Mac for those developers who want a full IDE. And we now have over 12 million active developers using these tools on a monthly basis to write code and build fantastic solutions. And we're regularly improving all these tools with frequent updates and releases. Today, I'm really happy to announce that we're making available the first preview of Visual Studio 2019 and releasing it simultaneously on both Windows and the Mac. VS 2019 is our next major update of the Visual Studio IDE and includes a ton of great new capabilities. In VS 2019, we put a special focus on improving code editing with IntelliCode, which uses AI to make IntelliSense even smarter and more contextually aware of your code and your architecture. VS 2019 also makes it even easier to collaborate both in real time and asynchronously with LiveShare and GitHub integrations, all the while keeping code quality high with some of our new historical debugging and live unit testing capabilities. And we're really excited to have you download the preview today, try it out, and give us your feedback. We're also announcing today the first preview of .NET Core 3. It comes with significant updates for both server and cloud-based workloads. But also today, for the first time, .NET Core 3 now also brings Windows desktop development to .NET Core, and with support for both Windows Forms as well as WPF. It enables even more flexible deployment of client apps with side-by-side and self-contained exes, and this enables significant improvements to client app development. We also have new features on the server side, including composable UIs with our new ASP.NET Core Razor components, which allow you to build sophisticated single-page applications using only C#. Now, we're proud of the innovation in .NET Core, and we're, I'd say, even more prouder about the momentum it has now in the open source community. There are a number of open source projects that make up the .NET platform, and it's fantastic to see the engagement of developers contributing to all these different projects. More than 61,000 code contributions have been accepted back to the .NET platform, and these contributions are driving the continued advancement and refinement of the .NET platform and making it an even better community for developers. And today I'm excited to announce that we're making the next big step with open source in .NET, and that we're making available Windows Forms, WPF, and the Windows UI XAML open source as well. These client development frameworks are used by millions of .NET developers, and open sourcing them has been one of our top community asks. And the combination of making these frameworks open source, in addition to enabling them to run on .NET Core, we think it's really going to enable even better client application development, and we're really excited to see what people do with it. Now, we already have a lot of innovation happening in .NET, and developers are building some amazing applications with it. What I thought I'd do is show one example of eye tracking keyboard for people who are unable to type. built using WPF. It's an open source project. And I'd like to invite Julius here to talk a little bit about the project and how he built it. Let's play the video.
Hello, my name is Julius.
OptiKey is an on-screen keyboard that allows people to fully control their computer using eye movement. My Aunt Jill, she was diagnosed with motor neuron disease in 2009. It slowly takes away your ability to move and to speak. At the time, I saw some of the tools she was using to communicate. It showed me what people who have those sort of difficulties, what tools are available to them. It also showed me that they're very expensive. And that's really what motivated me in the beginning. It was a sense of unfairness. OptiKey is free. From day one, it'd be free forever. I knew about swipe keyboards, where you swipe a whole word at a time instead of pecking away. And your eyes are actually much more precise than your fingers when they're swiping. So I started playing with this, and I built a prototype over the next year or so. The first time I got a sentence out, hello, my name is Julius, it was incredible. OptiKey is written in C#. It uses a UI framework called WPF, which is a Microsoft product. I published it in September 2015 on a Reddit post. The open source community, it started the next day. I had people issuing bugs that they wanted fixed, then putting their hands up to help fix them, and it sort of started from there. I've had people write whole features themselves. It's now in 19 languages. It's almost limitless, the directions people are taking this project in. Knowing that my project is out there and it's being used by people day to day to make their lives better, honestly, it's the best feeling in the world. I like to think that this software has made it a little bit more bearable where they might have not had any other solutions, and that's huge. I don't really see any limits. It's whatever people imagine, technology is right there with them, enabling them to do it.
And I'm really excited to see how making WPF open source helps us make WPF better for the whole open source community, including developers like Julius who are building these amazing solutions. Now I'd like to invite Scott Hanselman on stage to show us some of the new capabilities that we just announced with VS 2019 and .NET Core, and show off, oh, I like the look, show off some of the cool capabilities you can take advantage of. Here's Scott.
Hey friends, it's happening. WinForms and WPF are open source. I just had to do a little jeté out of the, we're all dancing in the back right there. I'm going to show you some really cool stuff that we're doing with Windows and Visual Studio and WPF. I'm going to go ahead and load up Visual Studio 2019, and I'm going to get this new start experience here. This is the new experience you've got on the left there. I've recently opened WinForms, and I was opening it and playing with it, doing some pull requests. I can go and clone or check out code from Git directly on that first screen. I'm going to go ahead and click on that, and I'll put in a repository for my Tailwind traders. This is the WPF version of my application, and I haven't looked at this code in 10 or 15 years, so you'll have to forgive me. I'm going to hit clone and bring that up into Visual Studio, and you notice how fast Visual Studio starts up. It's already starting to clone this, but at this point, things are already available to me. It's brought it up into folder view. I want to look on the right-hand side here. It says folder view as if I've just opened it up in Explorer, but it has also noticed that I've got my WPF application. I'm going to switch from folder view to solutions and folders. Gets me right to the code that I care about, perfing all the things. Let's go ahead and see in the background there, it says background tasks are still running, but I can still go and move around in my application. We'll go to the coupon service. I'm going to check out some of this code because, as I said, it's been a while. Now, there were some questionable coding decisions that were made 10 years ago, 15 years ago, whenever this was written. I don't know. Look at this. I mean, what is happening here? Someone put a curly brace randomly at the end here. This is not the way God intended curly braces to be. I don't know what schmuck did this, but they're going to be fired. Let's use CodeLens to figure out what the ridiculous loser who worked on this was. It was me. It was me many, many years ago, and of course I was confident in it yesterday. I'm going to actually be able to click on CodeLens, and I can see the chart of the time that I've spent in this application over the last 6,137 days. But my team is now looking at this legacy application inside of Visual Studio 2019. Of course, it still works, still runs. We've also, as a team, gotten together with an editor config file and decided what we want our code to look like. So I'm going to hit Control-EC, a hotkey you might use in refactoring tools, that brings up code cleanup fixes that we can all agree upon. And then I just went and fixed my code according to those styles that the team has agreed upon. So now our curly braces are where we can concentrate, because it's clearly, this is a tabs versus spaces situation, and now we're on the right side of history, which is important. And I'm looking here at find coupon by code. Perhaps this code was written before link. I'm going to select that and hit Control dot, and I can bring up an option to convert this to link, which is nice. Put that all on one line, but I'm actually paid by the line, so I'm going to do that on 3 lines, get twice the money. Notice that I can go and undo that and redo that. Let me see, I can look and see check. Oh, actually it was done when link already existed. I can actually take the link and go backwards and turn that link into a for loop. Totally up to me. Yeah, a single little smattering of applause for link. I respect that. It's an amazing refactoring, and the fact that it's isomorphic and you can go back and forth from one to the other is really cool. Up, I can see here code 10. I look like I've got some magic code, magic numbers that are in here. I'm going to click on that and hit Control dot, introduce constant for all occurrences. That's pretty cool. Hit enter, and I can even look in comments and strings and preview all of those. I'm going to go ahead and Control Z that one. I'm not quite confident. Notice that I've been doing a lot of refactoring, but I've never actually built the thing. So my confidence level is waning. I'm also noticing that there's some code that I want to change, my first big change in so many years. Here's where we check to see if the coupon is a valid coupon, of course, if the expiration is less than now. But in fact, coupons are really just suggestions. The expiration date is just a deterrent, but we are the bold. We don't believe in expiration dates. I'm going to go ahead and make this expire in a year, like when I go to popular bath places where coupons don't really matter, do they? Expiration, and I'm going to use IntelliCode that we saw a little bit of before. I'm using this in C#, of course. var expiration is a date time, so I'm going to say expiration dot, and you'll notice here it says toString, because that's the kind of thing I would want to do at this point, right? I'm just saying that datetime dot. But if I said something like if, now it's in the context of an if. We've given it a container, and I'm going to say expiration dot. Well, if expiration dot toString makes less sense at that point, that's the power of IntelliCode. The AI has gone and looked at all of these base types, compared it against all the different open source projects that use the .NET BCL or that .NET standard library, and thought about how these things are used. So I'm going to say add days, which is conveniently located, and I'll say 365 because rules don't apply to me. And then I'm going to say date time. Now this is another type. What do you think we're going to get when we say date time? Maybe toString, but we're inside of an if, but we're inside of a conditional dot now. Cool, it's right there. Nice. Now I'm inside another container, another bit of context. This isn't just smart sorting. This is an AI-assisted contextual IntelliSense. So now I can go and say return true. Of course, if I said expiration, which is a date time, and looked at it here, I'd get different ordering, which is really smart. So we'll go and do that, and then we'll say return false. Okay, it's really hard to code when everyone's looking at you. If you would all just look away, that would be great. And let's go ahead and build that, because I have no idea what I'm doing. And it looks like it did, in fact, run, which is a good sign. Remember that this is WPF on top of .NET Core. Typically, you have WPF or WinForms sitting on top of the .NET Framework, which sits on top of WinForms, sits on top of Windows, rather. But now you've got your application running on WPF or WinForms, now open source, using the WinUI controls, now open source. And we've swapped out the .NET Framework and put the .NET Core framework underneath it. Now you get improved runtime, you get side-by-side execution. I can go and have a self-contained application. Let's see if this runs. We'll go ahead and bring this up. This is my coupon application. It's pretty sophisticated. Since I'm bringing back this legacy application, and since we are bringing back one of our most beloved and popular applications frameworks, I thought it'd be nice to scan my coupon with one of the world's great technologies, 1998's worst product of the year, the QCat, which only people my age will remember, but that's fine because I need it. Boop. Pay no attention to the part where I typed it right there. Turns out PS2 isn't a thing anymore, so. Scan code, I'm gonna take $20 off of my coupon here, 10%. All right, there is a bug, which is comforting because it's a 6,000-day-old bug. This is awkward. I do have some unit tests. Now I could go and I could say right-click, add unit, run unit tests, and do all that kind of stuff. But I'm going to go up to the search bar here, which has been improved in 2019, and I'm going to use new tech to test old tech. I'm going to start my live unit testing because somewhere in here there's a bug, and I don't know where it is. I'm actually not even looking at the tests right here. I'm looking at the code. Live unit testing is going to watch my code changes, and it is going to look. Live unit testing is watching my tests, looking at the code changes. It is determined that this code could not work. It has 2 tests covering it, one that passes, one that doesn't. I will click on that, go to the test that's not working. Okay, we're going to go and call find coupon by code. I'm going to hold down the control key, and look what happens. Everything turns into a link. I'm going to then visit that hyperlink. My code is now hyperlinked. Find coupon by code. Looks like for the last 6,000 days. That should have been code. Now I'm going to save it. Oh, I didn't have to save. I didn't have to bill. I didn't have to run the tests again. Live unit testing watched the code changes and automatically told me that that code is now fixed and that's going to work, which is pretty freaking amazing. That is live unit testing. I know that you're in shock. It's OK. So I'm going to go ahead and run that again and make sure that that still works. We've been modifying this code and updating it to include a couple of other things. There we go. There's my $20 off. When I say show signature board, even though this code was written a long time ago, this control didn't actually exist. I'm going to do my signature. This is my official signature on all my checks. That signature board is a Windows 10 user interface control that I am using inside of my WPF application with the power of XAML islands. Those Windows 10 platform controls are now available everywhere because a Windows control is a Windows control, and you should be able to use it in every technology. That means maps and inking controls and all those great things. So in this case, it looks like it works pretty well. Before I check this in, I'm just going to come down here and make sure there aren't any pull requests. You can see right directly from Visual Studio. I can check to see if a pull request has come in from GitHub, and it looks like there is one here. Again, staying in that Visual Studio world that I feel productive in, I can go and see that there's actually unit tests. That would have been nice 5 minutes ago. There are some unit tests that have come in that I could have used, but fine. I will go ahead and give a code review. And then the other thing that I can do, actually speaking of pull requests, I'm going to go up to the actual repository where we just open source WinForms and WPF. And look, just in the minutes since we open sourced it, it's been dozens of pull requests. In fact, there's been a couple of days and we've had some partners go and do some pull requests. Here's one from Oren Novotny where he is actually taking the old Vista style dialogue and he's updated it. This has been approved. There's a whole discussion about it. But since I have all the power and GitHub, I'm going to use the ship it squirrel. I'm going to merge that pull request live on stage. Merging the pull request. Ship it squirrel. And since they can't pull me off stage once I've already got on stage, I'm just going to randomly merge another pull request. Because it's open source, baby. We are open for business. We're using Visual Studio, GitHub, and I love you all. Thank you.
So we've looked at some of the great new capabilities that we're adding to Visual Studio, GitHub, and .NET. Let's switch gears now and talk about how you can also use the cloud to scale your innovation even further. Now, Azure is a powerful enterprise-grade cloud service that provides a broad range of services and capabilities. And with Azure, we're really focused on meeting your needs and delivering a cloud that enables you to be even more successful. This means having an end-to-end experience across the cloud services, the management tools, and the development tools that provides an incredibly productive cloud experience, one that's hybrid and enables you to build solutions that run consistently both within our public cloud data centers as well as within your own. It means having a cloud that enables you to use AI and data to infuse richness and richer intelligence into your solutions. And it means having a cloud that you can trust. Trust is a core value of Azure, and we lead the industry in our work on security, compliance, privacy, and responsibility. And the focus we've had on delivering innovation, trust, results is really leading to tremendous adoption of Azure right now. You know, startups, governments, and over 95% of the Fortune 500 companies in the world are now running their businesses using the Microsoft Cloud, and specifically Azure. And these are just a handful of some of the customers running on Azure today. Azure now has 54 data center regions deployed all over the world. And this enables you to run your apps closer to your employees and customers than ever before and scale your solutions globally. Now, Azure is a broad cloud platform. You can use Azure just for infrastructure and just take advantage of it for base compute, storage, and virtual machines. But one of the things that makes Azure really powerful is the coherent set of highly engineered services that enable you to develop, deploy, and scale your apps even faster. These services include built-in high availability and automatically handle things like security patching and updates. And these services also enable you to adopt containerized, serverless-based computing architectures for both your new applications, as well as the ones that you might be modernizing if you have existing apps that you want to move to the cloud as well. And a serverless-based approach can help guide you to design your applications to scale and respond even better. And the other big benefit of serverless computing is it helps you save money by enabling you to avoid having to pay for server resources that you might not be fully using. And what really matters is that you as developers can build amazing solutions with these services and have a huge impact on the world with these capabilities. And what I do is invite Troy Hunt, who runs a popular security website, which helps people learn whether their passwords have been stolen, talk a little bit about his experience and about his site. Let's play the video.
My name is Troy Hunt. I develop security software and I build a little website called Have I Been Pwned? So I wanted to write things targeted specifically at the people charged with building software and help them understand how to build it securely. A very public data breach happened in late 2013 with over 150 million different accounts in it. I went, okay, well, maybe I can build something that people can actually use to assess their own exposure. And that was really what started Have I Been Pwned? I was just curious and I wanted to build something. The objective was to build a data breach notification service and to play with Azure. I launched Have I Been Pwned in December 2013. Within weeks, it just took on a life of its own. It was in major news outlets. Suddenly there were masses of people, like normal, everyday, non-technical, non-security people, using the service. And I lost requests. My challenge was, how do I deal with these just sudden, unexpected, massive increases of scale? Ultimately, the solution came via functions. By running Azure, suddenly you have a scale which is not bound by any sort of logical infrastructure over the top of it. It's just like, here's my code, just run it and send me the bill. So I've solved all of the scale problems for things like the API, which is hit when people come to the site. And it's also massively reduced the cost because functions are just so cost effective to run. So I was explaining the possibilities of coding to my son the other day, and I said, mate, you can sit here at home and you can write code that you can put out there in front of the world. And that code could fundamentally change the world. And you can do that because you have access to things like cloud services that allow you to do this for basically no money. And this really is the story of Have I Been Pwned as well.
So Troy uses services like Azure App Service and Azure Functions to run Have I Been Pwned? And as you heard him talk about in that video, it's really enabled him to build a service that is lightning fast, distributed around the world, and really doesn't cost pretty much any money to run. Now let's talk about another service in Azure that we're seeing tremendous growth with, which is our Azure Kubernetes service. Our Azure Kubernetes service, as we call it AKS for short, delivers a fully managed Kubernetes-based orchestration service. It provides auto-patching, auto-scaling, and update support. It enables you to use the full breadth of the Kubernetes ecosystem when doing development. It also supports our AKS DevSpaces offering, which provides a really fast inner loop development experience that's integrated across both Azure and our Visual Studio development tools when building Kubernetes-based microservice applications. And today, we're really excited to announce support for a first-of-its-kind serverless computing option with AKS that enables you to provision and scale your Kubernetes-based apps more efficiently and save lots of money. Our new virtual node option enables you to elastically provision additional nodes inside your Kubernetes clusters in just seconds. This gives you the flexibility and the portability of containers, while also ensuring that you pay only for the compute resources that you actually need and use. And virtual nodes is powered by a technology called virtual kubelets, that we've developed, and that we're also today donating to the broader community through the CNCF Foundation, which hosts and promotes open source cloud native software. And what I'd like to do is invite Jeff Holland on stage to show off Azure Kubernetes Service, demonstrate how you'll be able to take advantage of the DevSpace's capability to get a really great inner dev loop development experience with Kubernetes on Azure, and then save money using our new virtual node serverless option. Here's Jeff.
Thanks, Scott. I'm really excited to show you these exciting features today. So I'm a developer for Tailwind Traders, and I've been tasked to fix a bug. And you can actually see the bug right away if you look at our website. When I look at a product, I see these circles here. Now, this should actually be showing me information on whether this product is in stock and where I can pick it up in the store. But obviously, something's not working right now. I don't see that information. Now, for our business, we're powering our backend services entirely inside of the cloud, running as microservices, as containers, inside of Kubernetes. A lot of exciting stuff there. Now, what's great here is when we do this in Azure, we don't have to install or run anything on any VMs. We're actually just using the Azure Kubernetes service. So this gives us Kubernetes right out of the gate so we can get started and start publishing our code to it. Now, if I look at Tailwind Traders, here's our Azure Kubernetes cluster. And right here in Azure, I have everything that I need to get started. I can upgrade and choose the version of Kubernetes that we're using, control the scale very easily to add more cores, to add more memory. I really like this Insights feature, though. What Azure Kubernetes Service is doing here is actually looking at all of the logs and metrics in real time and giving me insights into the health of my cluster. Now, there's nothing here in these charts that makes me think that there's a problem here with CPU or memory, so let's keep drilling down to try to find this bug. Now, here I can drill down deeper and see the individual containers and services that are running within my Kubernetes cluster. And what's exciting here for our business is that we're actually running many different services here. In fact, we have over 60 different containers that are powering our service together. And here I get a real-time view of all those things. I see we've got 60 containers running in Kubernetes. And the service that I care about is actually this local inventory one. So let's drill into the logs and see if there's any clues here of what might be going on. And again, another huge value add that Azure's providing is I don't just get the logs straight from Kubernetes. It's indexed them all for me. These are all searchable, so I have this nice experience to easily find the problem. Now, right here, I can actually see, all right, there's an exception being thrown in product controller inside of this container. Let's take a look at the code now and try to find that bug. So I'm going to come over here to Visual Studio 2019. And let's find that piece of code here, our product controller. And what I really want to be able to do is just observe the code. What's happening here? I want to do something like set a breakpoint and run this code and try to figure out why is an exception firing. But even something that simple can actually be a little bit complex when running in something like Kubernetes. Because check out this URL right here. This is not a .com address. If I tried to call this right now on my machine, my computer is going to say, I don't know the IP for this service. I don't know where this is. Because this actually maps to another service, one of those other containers running inside of Kubernetes. Well, now as a developer, when I'm using Kubernetes, does that mean that now I have to take all of those 60 containers, all of Kubernetes, and run them on my underpowered machine to debug this thing? And that's what's exciting here about Azure Kubernetes Service, because Azure Kubernetes Service actually comes with a great feature called DevSpaces. Now, what DevSpaces allows me to do is debug and test and code locally, but power that development experience by the cloud using a personalized dev space. So here I've said, hey, I want to develop in my dev space called Jeff. It's going to power the cloud to give me all the context of Kubernetes so everything just works. So when I do want to debug this, when I want to set a breakpoint, all I have to do is push run. I just click the debug button, the same thing I do with all those other applications that I'm used to using. Visual Studio right now is syncing my code to the cloud, using the cloud to power this debugging experience so I can step through the code. Now, just to show that again, if I actually come here to the website, I'm not setting a breakpoint on our production website. This is Jeff's own dev space. This is my own copy of the website, powered by the cloud, connected to Kubernetes. In fact, another great feature of dev spaces is if I want to have a team dev space or a feature dev space, I can share these and collaborate with my team so that I get that rich and rapid interloop development. So let's see if we can hit this bug now. I'm going to refresh this page. And in that Visual Studio session in my other screen, we hit the breakpoint. That call to this service worked. I got the response back. And I can actually come right in here and see what happened. And actually, by doing this, I can eyeball the bug. I see here that there's this value property that's getting returned. I'm actually not expecting that in this object cast, so I just need to parse that value first before I get the in-stock information. So let's go ahead and do that now. I'm just going to stop the debugger, take off that breakpoint, and let's do this simple code fix, the quickest code fix in the world, and that's it. And again, to test this change, I don't have to fiddle with containers. I'm not going to publish anything to a container registry or do a Kubernetes deploy. I just push run. All I had to do was push run, just like I'm used to doing for every other application. And if I come over here now, as this runs and syncs with the cloud, let's try to refresh this again. And now we see that that code change was, in fact, the fix to the bug. And here now I can see the item is in stock, where I can pick it up in the store. I could go back into Visual Studio, check this in, and let it roll out into our production cluster. So this is great. It's made me very productive as a developer. But there's one more very exciting thing I want to show you today. Now, in Azure, I can easily control the scale of my Kubernetes cluster. How many cores is powering this? How much memory? But if you think of an event like Black Friday, this number can actually be extremely daunting. If I set this number too high, I'm going to be paying for resources that I'm not using. But if I set it too low, my website's going to get overwhelmed. We have thousands of customers every second hitting our website. They're going to have a slow experience. The machines are going to get overwhelmed, and they're going to lose sales. Now, Scott announced just moments ago this one-of-a-kind feature inside of Azure called Virtual Nodes. And when I enable this, what this is going to do is continue to burst out into serverless containers when my Kubernetes cluster needs more resources. This gives my Kubernetes cluster almost instant and unlimited scale in just a few seconds. So let's actually test this out now. I'm here in Kubernetes again. I've got my Cloud Console, and I'm going to run this load test. This is going to simulate a massive load test, pushing a bunch of load on that website we were just looking at. And if I actually watch this now, you'll see I have a few replicas already running inside of the provisioned cluster. But as that traffic increases, as I start to need more resources so my website doesn't slow down, so those services don't get overwhelmed, Azure automatically and very quickly is spinning up brand new containers. But I really want to emphasize this. This is not spinning up within my cluster. These are serverless containers being created for me, much lighter than a VM. These are ready in just a few seconds. And this is continue to scale out, provision just the code that I need, so those customers get a really rich and unlimited scale experience to complete their service. Now, I can even check this out here. If I come into my subscription, again, what Kubernetes is doing here is it's creating all these serverless containers for me. And when my traffic slows down, these are going to be deprovisioned for me, so I only pay for that burst traffic when I need it. This is extremely exciting, and honestly, my favorite part of this feature is actually at the end of the day when you turn this on, and your COO is going to have your cloud spend in one hand, and it's going to have your website performance in the other, and they're going to call you up. They're going to say, you know, Jeff, how did you do this? You got this number exactly right. How did you know just the right number to set this so we only paid for what we use? You don't even have to tell them about this feature, okay? I won't say a word. This can be our secret. You can just smile and say, you know what? I'm that good. That's what you pay me for. I could use a nice bonus. That's fine. I won't say a word, all right? This is just another example of how Azure makes every operations team excellent when using powerful services in Azure, and every development team excellent using things like dev spaces and virtual node. Thank you so much.
So in Jeff's demo, you saw a microservice-based app running in AKS that was made up of many different container instances. And as you adopt microservices, you inevitably start to partition your application up into more and more containers. And when we talk to customers, we often hear it's difficult to kind of reliably package up and deploy and manage all of these apps. without an easy way to bundle into a simple, portable package. And we've been working with others in the Kubernetes ecosystem to help solve this challenge. And I'm really excited to announce today a new open source specification called the Cloud Native Application Bundles, which enables developers to package distributed apps into a single file that's easy to deploy on any runtime or cloud-based environment. And we work closely across a broad ecosystem of partners to support this project, including Docker, who are the first to support CNAB bundles across their Docker app tool and up on Docker Hub. Now, one of the most important decisions you'll take as you look to build large-scale cloud applications is how to store and represent your data. And let's spend some time talking about how you can do this with Azure. Now, Azure provides a flexible set of choices for operational data services. Our Azure SQL Database, Postgres, MySQL, Redis, MariaDB, and Cosmos DB services are databases that we provide as a service, which means we provide and manage all the infrastructure for you. And it also means that we provide the database service with an SLA that you can depend on. This means you don't have to manually configure your databases for high availability or have to manually patch and upgrade them. These are just capabilities built into the service that we provide for you. And this enables you to be even more productive and build applications faster while still preserving the flexibility to use your favorite database of choice. Now, let's talk about one particular database that we're very excited about, which is Cosmos DB. Azure Cosmos DB is the first globally distributed multi-model NoSQL database service that delivers horizontal scale out with guaranteed single-digit millisecond response time. And we've seen just incredible adoption of Cosmos DB over the last year since we released it. And it's today one of the fastest growing services across all of Azure. And the reason for that incredible adoption is really because it enables you to build just amazing cloud solutions that weren't possible in many cases to do before. With Cosmos DB, you have a horizontally scalable database that puts data everywhere that your users are. Cosmos DB enables you to automatically replicate that data to any Azure region around the world to give your users lightning fast performance regardless of wherever they're accessing your application. Cosmos DB allows you to elastically scale your storage and performance throughput across one or multiple Azure regions with zero application downtime. You can start with just a few gigabytes of data and then scale to manage petabytes of it. And you can start by processing, say, just 100 operations per second, but then ultimately scale to millions of operations per second if you need it. And best of all, with Cosmos DB, you pay only for the storage and performance throughput that you provision. And Cosmos DB is unique in that it allows you to program against it using a wide variety of different data APIs and data models. We support MongoDB, Gremlin Graph, Table, SQL, Spark, and now Cassandra APIs against the service. And this again gives you maximum programming model flexibility and enables you to easily reuse code libraries and code that you already have. Cosmos DB also now has support for multi-master write scenarios, which brings literally unlimited read and write scalability by virtue of its decentralized masterless replication protocol. And this guarantees single-digit millisecond response time for both reads and now writes at the 99th percentile anywhere in the world. And you can literally have apps running all over the world, reading and writing concurrently across all your different Cosmos DB instances. And this is something no other database service in the world delivers with the type of SLA and performance guarantees that we provide. And these are just sort of some of the incredible innovations that enable you to build these sort of planet scale applications. Now, one company that's taking advantage of Cosmos DB in a big way to drive its growth is ASOS, which is an online fashion retailer that serves 18 million customers around the world today. Let's hear from them about how Azure helped them scale to over 1 billion requests over Black Friday and really transform their retail operations. Let's play the video.
ASOS wants to be the #1 fashion destination for 20-somethings around the world. We don't have shops. People know about ASOS from the internet. If we have 1 minute where that digital platform is out, we're not serving our customers.
Because ASOS offers such a wide variety of products, 87,000 at any one time with 5,000 new ones added each week, we've invested heavily in the recommendations platform we need to help our 18 million active customers discover the things they love. We really like Cosmos DB as a fully managed database service. Cosmos DB is used as the model store, the gateway from the offline to the online data science worlds. It allows us to distribute the data models to be near the services wherever in the world they're deployed. We like the immediate elasticity, so we can store data models of any size. We like the very low latency for random reads. During peak sales periods, we need extra compute power to cope with customer demand and manage our large data sets. On Black Friday 2017, ASOS services backed by SQL Azure and Azure Cosmos DB processed 750,000 orders. The product API served more than 1 billion requests over Black Friday through Cyber Monday, bursting up to 5,500 requests a second with an average response time of 39 milliseconds.
We had literally no problem throughout the entire weekend.
Azure has delivered as a rock-solid platform to create an ever more compelling consumer experience.
Now I'd like to invite Rima, who's one of the core architects on the Cosmos DB team, on stage to show off a cool scenario in action. Here's Rima.
Thank you, Scott. Good morning, everyone. Super exciting to be here. Now, Tailwind Traders is a global e-commerce site that wants to fundamentally transform the way people shop around the world. You've seen the pretty amazing capabilities in compute here. What about the data? In this demo, I will show you how easy it is to build a globally distributed data application powered by Azure Cosmos DB. So how do you create a globally distributed database? Very simple. You come to Azure portal, you click New Databases, then you click Cosmos DB, and then you will specify all the typical parameters that you would for any other Azure service, such as subscription, resource group, your account name. The most interesting thing here to pay attention to is the set of APIs that you could pick from. If you're coming from a relational background and you're familiar with the SQL, you can pick a SQL API. If you have an existing app in Mongo or Cassandra, you can choose MongoDB or Cassandra API. Or if you're working with Graph, you can pick a Gremlin API. You choose the API of your choice, then the location where you want to start out, the geo-redundancy capabilities, and then the multi-master if you want to enable the rights all over the world. Another thing I want to show you is how easy it is to set up virtual networks with Cosmos DB. This enables you to further isolate the connectivity to your Cosmos database to a subnet or a set of subnets to have further control. Then you click on Create, and that's it. You have just created a globally distributed database with very powerful capabilities. Now, my Tailwind Traders database is already stored inside Cosmos database, and I can come in here and see all of the tables, all of the databases. I can see that it's distributed across 2 regions worldwide. What if I want to work with the data? All I need to do is come to the Data Explorer blade inside Cosmos database. I can explore my shopping cart database. I can see all of the products stored inside Cosmos DB, all of the parameters and the values of it. The other thing that I can do is I can actually directly query from within the Azure portal. So for instance, if I want to find out all of the items inside my shopping basket that cost more than $100 and get the results back in near real time. Now, remember, this is not just a regular database. This is a globally distributed database. And if my application becomes super popular, let's assume now I get shoppers in Europe or in Asia. Now I also get users in Australia. All I need to do is select the regions where I want my data to be, and then click a Save button, and that's it. The data gets seamlessly replicated into those regions and becomes available for querying locally for the users inside those geos. And I can support both reads, writes, and queries. And as I'm adding and removing any number of regions at any time, my application continues to be highly available and continues to serve the data at all of the time. This is enabled through multi-homing API capabilities of Azure Cosmos DB. So let's see this in action. Here I have 2 front ends running side by side. One is running in West US, and it's communicating with the Cosmos DB region in West US. And next to it is the Tailwind front end running in East US, right here. So what I'm going to do is I'm going to add an item to my shopping cart, and see in action how Cosmos Database performs a replication and serves the data in the front end in the web US. So let me add it to the cart. I added it here, and then it instantaneously becomes available in Cosmos DB in the West US region. And all of this is built in. You don't have to add that extra code into your application. Another feature that is super popular with developers in Cosmos DB is called change feed. Change feed is a change log that we expose to developers to build event-driven serverless applications. Basically, you can react to all of the changes that are happening to your data across the world in near real time and integrate it with services like AKS or Azure Functions. So here's an example of the code running inside Visual Studio 2019 that performs a recommendation for all of the items that I'm putting inside my shopping basket. So it's an Azure function that will react to all of the items I put into my shopping basket and tries to recommend what are the other items I would be interested in. So let's see this in action. It's running right now in the console window right here. Let's assume I want to add Coffee Maker Red into my shopping basket and see how the Azure function reacts in near real time. I'll add it to the cart. And right here, we can see that the recommendation trigger got triggered. Again, super powerful to build event-driven serverless applications at planet scale. Now, one of the fundamental challenges that any application, in particular popular application, really has to deal with is the scale. And not just the scale, but performance at scale. For a global scale application like Tailwind Traders, events like Black Friday, Cyber Monday, a few weeks before Christmas, this is when the shoppers go into the panic mode, start doing a lot of shopping for their loved ones. In this case, what we've done is we've simulated the traffic, simulating one of those big events, and distributed the data across 26 regions worldwide. I want to point out this number right here, the average throughput per second. 203 million of transactions per second. Just think about this scale. This is roughly 1 billion of transactions per hour and trillions of transactions per day and per month. This is unprecedented scale. And at all of this time, if I come to my metrics, I can see that I'm serving the requests to my application roughly between 1 to 2 milliseconds for reads and 4 to 6 milliseconds for writes, with the 99th percentile for all of these requests guaranteed to be in less than 10 milliseconds. And if I look at my availability, my application and my data continues to be highly available, serving these millions of requests per second worldwide. So there you have it, Azure Cosmos DB, the industry's first globally distributed database service designed to enable any application developer to build an app of your dream. If you haven't tried it yet, you absolutely owe it to yourself. It's awesome. Thank you so much. Have a great Connect. And with that, back to you, Scott.
All right, thanks. As Rita just showed, I mean, the power of Cosmos DB is pretty awesome. And just the number of customers that are now taking advantage of it and really driving incredibly high throughput scenarios is pretty amazing. And what's cool about Cosmos DB now is it's easy to get started and try out. Our pricing for Cosmos DB now starts as low as $24 a month. And we have a free 30-day trial version. You can also go ahead and get started if you just want to kick the tires with no obligation and not having to pay anything. And definitely encourage you to give it a try. It really starts to enable you to build applications that just weren't possible before. And we're super excited to see what you do with it. Now, our goal with Azure is not only enable you to save data, but also add AI to get even more intelligence from that data and to make your applications even richer and smarter. And with our Azure Cognitive Services, you can now easily call pre-built AI models using REST APIs or using our .NET, Java, Python, and Node SDKs. And the great thing about our Azure Cognitive Services is that you don't have to be an AI expert in order to take advantage and add AI inside your applications. We provide great AI models to do things like speech-to-text translation, image detection, video transcription, language services, and more. And you can run these models in the cloud. And now, in fact, Azure is the first cloud provider that also enables you to take these models and push them down to the edge or run on premises with our new container support. Now, earlier this year, we also introduced native integration between our Azure Cognitive Services and our Azure Search service to enable you to unlock even more power. And Azure Search enables you to index any type of content and build rich text experiences, search experiences from it. And with this new Cognitive Services support, you can now index images, videos, and PDFs and have built-in AI richness like face and object detection, sentiment analysis, video transcription that make your experiences even more intelligent. And we've worked with some pretty amazing customers that have built some fantastic experiences using our Azure Cognitive Services. And what I'd like to do now is invite Seth on stage to show us some of the ways that you can take advantage of AI in your applications as well. Here's Seth.
Awesome. Thanks so much, Scott. You can clap. It's okay. I wore my nice shirt today, so that's what I'm here for. I'm excited to show you how to take advantage of AI in your applications today. Here to help me with the real-life application, I'd like to invite Jesse Perelius, Senior Director and Data Architect at the MBA. Let's give him a hand. How you doing, my friend?
Hey, good to see you, Seth.
So what do you do at the MBA?
So my role at the NBA is the collection and reorganization of data sources that are critical to the business, making sure that they're available to whichever groups need them in whatever format they require.
Awesome. So tell us about the scale of data. Are you getting a lot of data?
We are. I'm thinking particularly today about the still photos that we take at each game. We typically have 2 photographers taking about 500 photos, each about 7 eggs apiece, and that with 50 games a week, that's turning into hundreds of gigs per week.
That's like billions of photos, right? It might be off by order of magnitude.
You know, terabytes per month,
okay,
whatever.
that's close, yeah.
So yeah, lots of material.
So why is it important for you to go through this data quickly?
It's mostly social media. Everybody wants for their apps and for their accounts to have the absolute latest, best, highest quality photos right away. They can't wait days or hours in order to get the material.
Awesome, and they usually just want to know what's in the pictures, right?
That's exactly it. The image is taken, and if we can automatically identify who the players are, then we're most of the way there.
Awesome, well let's take a look at the application. Why don't you describe what we've got going on here?
Right, so we've got images that are taken at the arenas, replicated into blob storage, and then we have cognitive services looking at those images, providing all sorts of metadata there, stored in the cloud and accessible through Azure Search. Then you can go and build a front end off of that, like we have over here.
All right, let's search for one of the world's most famous. Do we have any NBA fans here, by the way?
Probably a couple.
It's like the dude
One
in the
or
back's
two,
like,
yeah.
me. All right, so let's search for LeBron James and see what comes up. Here comes LeBron James. Let me click on this. So this face comes from Cognitive Services, or are you doing anything for it?
Nope, we just gave Cognitive Services 1 or 2 pictures of LeBron, and it figured out who he is on all these other pictures.
That's amazing. So what is this sidebar here for?
Okay, so as the season goes by, you're going to get a lot more images, particularly of any one individual player. So you want to kind of narrow things down a little bit. You can put in the period where the photo is taken to go and sort of look at the latest game. Or if you're looking for images that not just have one player in them, that have multiple ones that you're interested in, you can just click on that kind
All right,
of
let's take a look. I went to the University of Utah, and so Kyle Kuzma was a basketball player there. Let's see if it finds Kyle Kuzma and LeBron James. So I'm going to scroll down, and I'm going to test my Cognitive Services. I'm getting a little sweaty here. Want to make sure it works. Okay, so it looks like it made a mistake here, Jesse.
Have a look.
Oh, he's in the back there trolling LeBron James.
There you see.
So, okay, before I let you go, during our pillow fight last night, you were telling me a little bit about how you feel about Azure and what the experience has been like. Do you mind sharing with everybody?
I'd say it's been very positive. The components that we need in order to build our services are all there, and we were able to integrate them to get us where we needed to go.
Awesome. Well, thank you so much, Jesse. Let's give him a hand.
Thank you.
Okay, so let me show you how easy it is to build a search solution that's intelligent with just 3 easy concepts. 3 easy concepts: ingest, enrich, and explore. So I'm going to go over here to this demo right here. The pre-step is you have to make the resource. And to do that, you click on Create Resource. And if you go down to AI and Machine Learning, it's this thing right here. I've already created one myself. And since I like magic, I called it Merlin. And this is just Azure Search. Now, let me show you the process. Again, the first step is to bring some data in. And what I have here is I have hundreds of thousands of images, well, just a little less than 100,000 images that I've uploaded from a well-known data set called the COCO data set, and I just wanted to see if it worked. Okay, so the first thing we need to do is we need to ingest this data, and to do that, we go to import data, and you can connect to your data source, and there's a number of data sources. So if you already have your data already in the cloud, easy to just pull this in. I've already gone through this step, and now for the enrich part. Okay, so I'm going to call this my cognitive skill set. Cognitive skill set. It knows how to spell better than I do, actually. And let me show you the hard part. This is the enrichment part where we add all of the AI. Get your science hats on. I'm going to do this, and then I'm going to do this, and that's it. Right? Because when we're searching, if you click those, we know you want to use cognitive services, and what we're going to do is we're going to augment your pictures with metadata from what it finds. Imagine being able to search pictures that you've just dumped into blob storage. Okay, so again, ingest, we've done that. Here's the enrichment part, and finally explore. So we're going to explore this data source. I'm going to go back to Merlin, and this index that I've already built, you notice there's like almost 100,000 images. I'm going to click on it, and you can build a pretty front-end app on top of this, but I'm just going to use the Search Explorer, and I'm pretty excited because my demo is almost done. I'm going to treat myself to a fancy dinner. So I'm going to see what the computer thinks a fancy dinner is. Again, I just uploaded 100,000 images, and now I'm going to search on it. So I click search, and looks like it found something, CH dinner. Looks like there's some text in there that it found. Here's what it sees. It sees a plate. It sees an awesome design, book and art, clearly a fancy dinner. So I'm going to go ahead and click on the picture and see what the computer thinks is a fancy dinner. I feel like it's trolling me just a little bit. But again, I've showed you with 3 easy concepts: ingest, enrich, and explore, how you too can build an intelligent search application in minutes. Thank you so much. Back to you, Scott.
Thanks, Seth. So the great thing about Azure Cognitive Services is that you don't have to be an AI expert in order to take advantage of AI within your applications. But we also know that a lot of you want to be able to build your own AI models and tailor them for your precise business needs. And you typically need to do 3 things when you want to build your own AI models. Step 1 is where you prepare the data. Step 2 is where you build and train an AI model from it. And then step 3 is where you deploy the model and start using it within an application. Let's walk through how we streamline all 3 of these on Azure with custom models. And I'm going to basically use a simple example in this case, which is building an AI model that allows me to answer the question of how much a particular car is worth. Step 1 of this process is going to be to prepare my data. Now, data scientists building AI algorithms often spend, on average, 80% of their time doing data preparation steps. Working to take data from multiple sources and merge it together, finding and fixing anomalies, and standardizing formats. It's a fairly arduous task that a lot of people often refer to as data wrangling. Our Azure Databricks service is an Apache Spark-based analytics service that's optimized for Azure. It enables you to quickly launch and scale up Spark clusters on demand. It includes a rich interactive workspace that makes it really easy to build Spark-based analytic data flows, and includes built-in adapters that allow you to work with all of the data that you can store within Azure. And it makes it really easy to prepare data for any custom AI-based data workflow, whether the size is in gigabytes, terabytes, or even hundreds of petabytes in size. Now, once we've built and assembled and prepared the data, the next step is building and training an AI model from it. For example, with our car scenario, we might want to create and train a model that predicts the value of the car using a data set of historical car prices. And this process of building, training, and testing the model is going to be iterative. And as I evaluate different attributes and as I try different hyperparameters, I want to be able to kind of evaluate which fits best for the model to more accurately predict the outcome. Now, our Azure Machine Learning Service helps dramatically with this process. It enables you to train and evaluate models on any number of servers running inside Azure. You can literally scale from just one server in Azure to using hundreds of thousands of servers within just a single parameter change. And Azure Machine Learning enables you to use every popular data science and AI framework out there, including PyTorch, TensorFlow, scikit-learn, Onyx, and more. And in addition to supporting every popular AI framework out there, we're also introducing new capabilities such as automated machine learning to help you identify and use the best algorithms faster, and to be able to do hyperparameter tuning to find the best model more efficiently. And with our new Python-based SDK, we're also enabling customers to integrate with their favorite Python-based development environment, whether it's VS Code or a different tool of their choice. And all these things really enable you to dramatically improve both the performance of the models you create and do so in an incredibly productive way. Now, one thing I'm very excited to announce is our machine learning service has been in preview the last year. And today, we are announcing that it is now available in general availability all over the world and ready for you to start taking advantage of it and to build great custom AI models with it. Now, with our Azure Machine Learning model service, you can build and deploy AI models that you create and cause them to run anywhere, including in our Azure Kubernetes service for online API scenarios, or using Azure Batch, which enables you to do batch processing scenarios, and of course Azure IoT Edge, which enables edge-based computing scenarios, as well as Azure Stack. Because the models are all container-based, you also can even run them anywhere else that supports containers in your existing on-premises environments. This gives you maximum flexibility to really use AI everywhere and inside every one of your applications going forward. And the great thing about this is that you can use this AI flexibility with any data service inside Azure. And so any amount of data that you store inside Azure, you can now start to add AI to it and basically start to make your apps even more intelligent. Now, we've talked about a lot of stuff here this morning in this keynote, but the opportunity to build applications that change the world has never been greater. And as you see in this keynote, we're working hard at Microsoft to deliver the developer tools and the platforms you need to do this. And the combination of the Visual Studio family of tools and Azure really deliver an amazingly rich set of capabilities that enable you to build apps that can be written in any programming language, use any operating system, target any device, and scale to run literally all over the world. And to close this session, I want to share with you sort of an inspirational story from a team of developers at Cincinnati Children's Hospital who are using software to help patients and families navigate through what is one of the most stressful experiences in their lives and stay informed and focus on what matters for their family and for their children. And I want to say before we roll the video, thanks so much for attending this morning's keynote. Stay tuned also because Scott Hanselman will be up next, and have a great rest of the event. Let's watch the video.
Calvin was born with a very rare genetic condition. When we first started coming to Children's for his appointments, I actually got lost quite a few times.
Everyone understands that need for technology to help families navigate this really large medical center, as well as the care of their child. That's our mission, and that's what we're always looking for. How do we enable better patient care at Cincinnati Children's?
So Karen is that digital concierge that our patients and families interact with through a mobile app. We knew we were going to need a platform that provided agility and allowed us to move fast. And so Azure was a logical choice in that.
We didn't have experience with mobile apps before, so this was kind of our real step into Azure. We got to be able to stay in a language space that we were familiar with, which was C# and writing on the .NET Stack. By going with the Xamarin Forms route, we were able to leverage code reuse as much as possible. One of the things we got to try new was the Azure Function, and this was our first serverless project. So this shifted our mindset of how we wanted to approach Karen as a platform. So we looked at how do we decompose Karen into the respective pieces. We knew we needed a fast database. Cosmos DB rose to the top. With Karen, one of the features that we wanted to include was a chatbot. By leveraging the Microsoft Bot Code samples and also Lewis, we didn't have to worry about building out a language model, maintaining it, training, and that sort.
So in our work with our Karen app, we're really proud of the fact that it's working. Patients are already seeing value from it. That's what matters to us.
Cincinnati Children's has been amazing in our lives. Having the app definitely gave me a new perspective on the hospital. I can know what's going on with my child because I have the Karen app. And I think that it's helped me be a better mother to my child.
Welcome to Connect 2018. I'm Beth Massey. I'm the product marketing manager for the .NET platform, and I'm here with Jeff.
Hey there, I'm Jeff Fritz. I'm a senior program manager on the .NET community team. And this has been tremendous. Scott Guthrie with the keynote, all the program managers from these various announcements, products that are being improved. Visual Studio 2019.
Preview came out today. Awesome.
Everybody can go out there and download it. There's a blog post with all the features recapped.
Take a look at the Visual Studio blog, and all the new features are listed right here. What's your favorite, Jeff?
Oh, it's got to be LiveShare.
In the box.
In the box, right? I pair program with people all the time, and to have that in the box means I don't need to tell people, go find the extension, make sure it's installed. It still works great in Visual Studio 2017, but it's right there. Everybody's on the same page right from the get-go in 2019.
Amanda and Chris showed that actually with Visual Studio Code
with Visual
as well.
Studio Code.
Okay, that's super cool. Scott Hanselman showed off a couple cool things, right? New refactoring.
Yes.
IntelliCode is more intelligent, right? You can train it.
You can train it against your source code.
That's cool.
So that it'll give you better suggestions about the code that you've written and that your team is managing. And you can invite somebody else to join you. There was something about
like
AI.
that? Did you see me?
That was
sticking?
amazing.
Did you even feel the movement?
I
Like
was,
the air?
my heart was fluttering.
Oh my goodness.
How amazing was that? So some AI announcements today too.
I know, right? Azure Machine Learning
We were just
Service
talking about
is-
IntelliCode and like all this AI stuff everywhere. So what's up with Azure Machine Learning?
AI is the best. Azure Machine Learning Service going GA today.
Cool.
So if you're
Awesome.
a data scientist who want to build your own models, we have
Yeah.
the infrastructure and the code. It's like GitHub, but for AI.
That's fucking cool, dude.
But I thought there was a better announcement
Well,
about.
I'm a little bit more biased, I
Yeah.
think, towards
Are you?
something called .NET, actually.
You wear that on your sleeve.
On her shirt.
Maybe. Open
We worked on that
sourcing,
joke all day. and it just- it
WinForms,
came
and
out.
WPF.
Yeah. Yeah.
Okay, WinForms
Right?
and WPF, right? WinForms.
And WinUI XAML controls, right? That whole library. So we actually basically open source all of the Windows desktop frameworks today.
Yeah, right.
That
I mean,
is a big deal.
WinForms has been around for what, 17, 18 years? It was.
Yeah, since the beginning, since
I
.NET.
was 2 years old when I first started writing some
And
WinForms apps.
you were 2. That's so
Amazing.
cute.
You've aged well.
Thank
little
you.
older than
Thank
that.
you. Yeah, I'm 20, what's 17 plus 2.
Well, the other thing we did is announce the .NET Core 3 Preview 1 today. So you can build WinForms and WPF apps on .NET Core.
Cool.
So that runtime is going to give you some benefits. So being a little more faster, right? Better performance. We also are
It's
allowing
side-by-side.
side-by-side,
Right, that's the
So
huge thing for me.
you won't break apps because we don't. You can install the framework with the app, right?
Right.
Self-contained
Self-contained
EXEs. So yeah, that's going to be a big deal. I'm pretty excited about that. In Visual Studio 2019,
Yep,
you're going
all
to
the
use
tools are
to
there.
build WinForms and WPF apps on .NET Core. All right, that's pretty cool.
I know I'm old school. I love WinForms.
Actually, WinForms is great. Actually, it is.
It is.
We also announced a couple other things. Okay, so we've got a lot of announcements around Azure, right? So new pipelines announcements. We're going to have Ed Thompson later. We'll talk a little bit about that. We've got IoT. And we've got Suze Hinton later that's going to talk about some of that. We have a really good lineup, actually. If you guys take a look at our agenda, we've got Scott Guthrie. You're going to have a chat with him, right?
That's right.
Okay.
Ask me anything.
Ask him
yeah.
anything. Ask him
Live
anything. We'll take
on
live
the street.
questions on the Visual Studio Twitch channel. So head over there and ask questions.
Absolutely.
We've got Brendan Burns.
Oh, I already have questions queued up for him. I'm pretty excited.
Right.
So, I mean, for those that are watching, it's important to know that this is for you. Please submit your questions. I could ask a million questions of these people, but I'd rather you ask the questions. And so make
Especially
sure you
like a
submit-
co-founder of Kubernetes, right?
Yeah,
so
I mean,
that's
so that's-
something to talk about.
That's
right?
important. So just for a little logistical, we're in a little gap here. In about 10 minutes, we're going to cut to Scott Hanselman's keynote as well, which is chock full of excitingness.
We have even more cool announcements than that one, actually. I'm a little
Yeah.
privy to a couple of them. I'm not
Oh,
going to blow
yeah.
it.
Don't
I'm
say it.
not
Don't
gonna
blow it. Don't
I'm
blow
not
it.
going to blow it.
And then after that, after Scott Hanselman's, make sure you stay tuned because we're going to have Scott Guthrie, Brendan Burns, we're also going to have Eric Boyd, Corporate Vice President of AI over
Yeah.
there. And we're going to have
some fun with
Suze
him, I think,
Hinton,
right?
among others, right? Who else?
Absolutely. We got Scott Hunter and Mike Harsh coming over. We're going
okay.
to talk to them all about .NET, so ask really hard .NET questions.
I've got Edward Thompson. We're going to be talking about tips and tricks around Azure DevOps. I am so in desperate need of help. I know Ed can help me.
Ed is a cool dude. He's also super tall, actually. So I'm glad you're doing it because I would look like this.
The
right?
table levels us out.
I need
So,
a booster chair.
Between us,
Yeah. What? Just
Don't-
between
don't watch
us.
for a second.
Just between us and the 100,000 people online. Yeah.
which one was your favorite demo of the last one? Just between us. I don't know.
You know.
I'm a little.
I think his name rhymes with Beth.
You did great.
Thank
you did
you.
great.
You're so
Actually, I think everybody did really good.
Hanselman had a lot he had to cover there.
Yeah.
And he's just flat merging pull requests.
Right.
On
I mean, we're
GitHub
already getting pull requests
for new WinForms
for
features.
WPF and WinForms. This was really cool. Actually, I thought Amanda and
Oh my
Chris did
goodness.
great. I mean, they opened the show with live share. I mean, that was really cool.
IntelliCode running with Node.js,
Yep.
JavaScript, you're getting those rich suggestions, tremendous capabilities in
And then,
VS Code.
you know, we had dev spaces too, right? I mean, that is really mind-blowing, right? Like, can you remember, like, having to set up everything on your machine in order just to develop an application,
Running
right?
full Windows Server with SQL Server and the web server,
Right?
so I could debug everything
Well,
and make sure I had
especially
the
with large
same-
teams and
Right.
really
Yes.
complicated systems nowadays, this is going to make it. It's going to be life-changing for people, right? Like for developers. It
I
really
remember
is.
and I used to be able to do this a long time ago, kids. I'd be like, hey, well, it works on my machine. You can never do that again.
Well, I mean, that's
Goodbye.
like production. You know, we have things to. This is like just development.
I
Set
know.
up my development environment, right? I mean, and that could take a week, right? Now
That's
it's
true.
like this is totally cool.
Now we actually have to work.
Yeah, and it
What is
changes the way
this?
you develop anything. Large systems, large teams.
Mm-hmm.
You know, that's really cool.
I don't have to wait for all my tests to run because, right, I've got live unit testing running in Visual Studio as I'm writing my
Yep.
code. I can't make the excuse, well, I'm waiting for the test to run and the compile and all this stuff. No, it's running and it's fast, and I know immediately if I broke the build before I even make the commit.
Well, and
I
we
like
know
not
who
knowing
breaks the
some-
build all the
I like
time,
not knowing
so,
sometimes.
right
I
here.
check in row,
Just-
right? You know, just check it in and see what happens. Break the build.
So a couple other things we saw. Cosmos DB.
Mhm.
What was that
Okay.
stat you saw right there?
200 million requests per second.
I mean, amazing. I mean, amazing, right? The geolocation is incredible on that. And how easy it is to set that up
Yeah.
too, right? I mean, yes, I want to write.
And that's on a good day. 200 million requests
know.
a second. I just want a million requests.
That's crazy. I mean, I haven't seen that scale of 200 million requests per second since my kid was hungry the other day. I mean, I haven't seen the dad jokes
Or
are
me.
flowing.
They are flowing.
And I think there's a .NET SDK now for Cosmos DB too, and like,
Yes.
there's a lot of really cool stuff around Azure Cosmos DB, which is cool.
Absolutely. So, you know what might be good for folks if they're interested in seeing more about that is our last session today here on Twitch. If you
yes.
check it out, we're going to have Andrew Hall and Paul Yuck,
Oh.
and they're going to be talking about 5 Azure services every developer should know.
Absolutely, yeah. We'll start with app service, I think, first, and we'll walk through some 5 different services and Cosmos DB and storage.
I think
and
I
SQL
might
will be
even
there.
stay for that.
You might
Maybe.
stay. You might stay.
Okay.
You're kind of hosting the
She-
show.
She's been side-eyeing me since yesterday, okay? I mean, let's be honest. There's one right there.
Okay, well, you know, it's just,
Nice.
it's a stink eye, is really what it is.
What happens in Vegas stays in Vegas unless you're streaming it to all these people everywhere out there.
So we have a really cool set, actually, multiple sets here. We're going to be going back to back to back, right? And
I've been tweeting pictures through the morning. This is tremendous, right?
So here's a question.
we
By
have
the
a
way,
question?
questions already work. So again, submit your questions. We want to see them. Here's a question that we
question.
cannot answer, but I want to verify that questions do come in from Vasily. Do you have plans to eventually run Visual Studio on .NET Core? That would be an excellent question.
Excellent
for
question.
Mr. Hunter.
It is an
Or
excellent question, but it
Amanda
runs on
Silver.
.NET Framework. So .NET Framework is here to stay, okay, just so you know. And Visual Studio runs on .NET Framework, and so does a lot of major product lines from Microsoft.
She knows the answer.
All right, so yeah, I know the answer.
So if you know all the answers, what was supposed to be in front of the dot for .NET?
An ASP. That was supposed to be in front
You're
of it.
killing me with that one. I'm going to have to come up with a good answer.
It's an ASP.
Like, I feel like it's like a dangling participle or something. Like, what is in front of it?
It's just .NET. It's like, it's a thing.
There was a C# in front of it. It was C#.NET, right? There was a VB in front of it.
So we're actually going to talk about Java later, too, by
That's
the
true.
way. We're going to have Brian Benz on later, and he's going to go through some services in Azure that every Java developer should know. And
Okay.
that's going to be really interesting for me, actually.
My Java skills are so rusty, I got to tune in and watch.
I'm going to have some really noob questions, but there's actually some guys from Red Hat going to be in the chat room. So
Okay.
ask them
Good.
questions, too, guys, online. So, yeah.
Fantastic.
Yeah.
Java was my very first language.
Yeah?
Java 1.0.
Awesome.
I still remember, because I went to college here at UNLV, just over on the road for my undergrad.
Really?
And I still remember Dr. Yonina S. Cooper. She was the one, she taught me
Really?
object-oriented programming. I remember writing my first triangle code, like to find the area. And I'm like, I don't know what to do. She's like, well, why don't you just make an object? And I was like, it clicked.
And your head exploded
I
and
was
you
like-
learned object-oriented programming.
It was
Yeah.
right. It was Dr. Yonina S. Cooper just down the road here.
It's sort of like I still need to make that break with functional, though, right? So that I haven't had that aha moment with functional programming.
I had that
quite
one
yet,
years
so,
later.
yeah.
It was it was messy. They had to mop the floor.
Your head exploded.
It was like everywhere. Right.
Was it F# all over the place?
Yeah, but see, when I was at Penn State, I learned VB5. So I was getting a little bit of object-oriented, and I wasn't quite there until C#.NET.
VB, what a fun.
Yeah.
I never did that. I was Fox Pro.
Oh, that's
You know
right.
what? And what's funny is I always mention that language like every time I'm an interview. Now I'm a host, and I still mention it. So
It's kind of like if you went
all
to
my Fox Pro
Harvard, you're
peeps.
like, hey, you got to find a way to bring it up. I went
So-
to Harvard. No, I went to UNLV and the University of Utah. That's where I went.
And actually, Brian is a local, actually, so it'll be a lot of fun. So it'll
Didn't
be
have
fun.
to drive too far.
Didn't have to drive too far. You can just come right
Yeah, the
over.
time zone is a killer for us.
Yeah, killer for you two. I had to come in from the East Coast. Come on
It's
now.
backwards. It should be fine.
Oh.
You're actually up earlier.
That's right.
Right?
But I got to stay up and watch my birds play last night. I was plenty happy with that.
So we only got like 90
Yeah.
seconds. Can you give
Okay.
us a preview of what people could expect maybe for the next one? I haven't seen very much of it.
All right,
for
so
the next
Scott
keynote,
Hanselman's
Scott Hanselman,
keynote. So there's a couple cool more .NET announcements
She's even
in there.
doing the dance.
I
mean,
am
it's
very
gotta-
excited about it. Yes.
There's an Azure demo that's coming up in this that is so killer. We were talking about it at Ignite, saying it'd be really great if we could make it do this. And oh man, it is so good.
Awesome. Well,
I think there's some more AI in there too.
oh yes, my colleague Francesca is going to do some amazing
Yeah.
things. We got about a minute left, so we want to make sure that you stay tuned to Scott Hanselman's keynote. Also, directly after Scott Hanselman's keynote, you're going to have the opportunity to talk to Scott Guthrie.
Guy in a red shirt.
A guy in a red shirt. You can ask him any question you want, and then we have a series of amazing guests. And we don't want to just like ask them questions. I would love to, but I really want your questions, and I want to be able to answer any questions that you might have and have them ask. And it's really pretty much anything. We get them on the board here, and then we ask them.
Yeah.
Oh, yeah.
So we have about 20 seconds left. So we'll see you after the keynote.
Please welcome to the stage Partner Program Manager, .NET Team, Scott Hanselman.
Hey, friends. I thought it would be cool to do a wardrobe change because it's Vegas. There should be as many wardrobe changes as possible. I am very thrilled to be hanging out with you and to share some of these cool things, and I'm shocked that they've actually given me any time at all, much less a keynote. But we have put together this wonderful parade of talented individuals to go and share with you some of the cool stuff that we're doing that will make you happy and productive. We're calling it Happy and Productive Development. And as always, I want to iterate what a wonderful thing it is that we are all welcome. We can all be developers as we move into the future, no matter who you are, no matter what you're building. You know, every developer has the potential to make that app or that new website or that new something that's going to change the world. The modern world is running on code, and it's all powered by applications that we're making, and these simple little things, whether it be an open source artificial pancreas that I use and I'm using right now, or a website, or an app, all of these things can completely change our lives. Now, these apps that are changing lives can be business apps, they can be IoT solutions, They could be games, or AR, VR. The platforms and tools that we're trying to share with you, that we want you to use, we want you to experience, provide everything you need to build that next generation of apps with the language of your choice. It's all about choice. It's all about you, and it's all about your choices. Now let's take a moment. We'll recap what's new, and then we're going to show you some amazing demos with some amazing friends. So some of the things that we announced in Scott Guthrie's keynote, some of the new innovations in Azure around Azure App Service. This is the fully managed platform. The functions, this is the serverless offering. This lets you scale infinitely, and it supports C#, Node.js, Java, which recently went GA, general availability, and now Python, which is new in Azure and functions today. And of course, Cosmos DB, the globe scale, world scale, multimodal NoSQL database, supports MongoDB, Graph, Cassandra, and now has reserved instances. And then DevOps Pipeline, free for open source projects. I'm already using it, enjoying it very, very much. We saw Visual Studio 2019 with IntelliCode. I'm going to show you a little bit deeper demo a little bit later. Live Share lets developers share their development session, their coding session, their editing experience in real time without pushing pixels around. We've got deep GitHub integration inside of Visual Studio, bringing those pull request workflows directly to the editor where the developers are spending their time. And then we're also seeing Azure Tool integration, making it really easy to deploy your apps, directly from the editor. And then, of course, my favorite thing, .NET Core 3, bringing really big updates, significant updates to the desktop. So you've got Windows desktop development with .NET Core supporting both WinForms and WPF. And it's going to give you a really flexible deployment experience with side-by-side and self-contained executables. It's going to be great. That preview is out. And then we also have new functionality on the server side with composable UIs in ASP.NET Core with Razor components. It's going to give you full stack development with .NET for the first time. And we're going to see the future is even brighter as Blazor and moves into the product. So what does it take to be happy? What does that mean? Like, what is a happiness-focused environment? For me, it's all about being in the flow. I've talked about productivity in the past in my talks, that zone where you are the most productive, and you don't want little things to slow you down, whether they be little things in your editor or little things in your IntelliSense. I'm going to spend some time right now, and I'm going to show you some Visual Studio products. The Visual Studio family has all of the tools for any developer anywhere. So you've got Visual Studio Code on Linux, on Mac, on Windows. It's a great code optimized editor. You've got a full development IDE with Visual Studio or Visual Studio for Mac with those best-in-class tools for developer productivity. And we try to get Visual Studio to be working the way you do. We want Visual Studio, frankly, to get out of the way and let you do your job as best as possible. So I'm going to spend a little time here showing you some happy and productive development in Visual Studio 2019. I've got an app up here. Now, what we did here, just to be interesting and mix it up a little bit, is I've got the coupon reader again, except rather than the WPF coupon reader, which I showed earlier in Scott Guthrie's keynote, this one's written in WinForms and has been upgraded to .NET Core 3.0. So it's basically the same thing again, but we did it in WinForms. I thought it'd be cool. Now you'll notice a couple of things. These are subtle, but they are surprisingly impactful. If you look at the title bar, notice that there isn't one. You've got a compact toolbar, and the menu has basically moved up, giving you an additional line of code or a line and a half, trying to get out of the way. It's almost like full screen mode is slowly becoming the default inside of Visual Studio. So there's been reduction of space to give more time and more space for your code. Also, a subtle thing down here, this is the document health indicator. And this is telling me that maybe my document isn't as good as it could be. If I click on it, I'm going to go directly to a squiggly. Now, I think this is a little bit of an oppressive squiggly. I'm a fan of this, but the team has gotten together and they've made an editor config. And that editor config is a standard that lots of editors support. Visual Studio, Visual Studio Code. And you can say, well, this is what we've decided upon. We are bad people. We use spaces and not tabs as a team. And you can then oppressively force your team to use spaces. In this case, my team is saying that I should probably not use this, so I can remove that qualification. And then the document health indicator moves back to green. What's exciting about that is that the team decides on it. We can check that artifact into our code, and it works everywhere. Then editor config can be basic things like white space, which I joke about, but then it can also be rules and specific things about the language that you're using with extensions to editor config, and that's all built in to the experience. And then when you do your when you do your code cleanup, that also respects editor config as well, which is nice. We saw CodeLens and what a joy that is, and being able to see who's working on what check-ins are coming in, what are new, what are deltas. And then with IntelliCode, I want to spend a little bit to do a demo. I want to spend a little more time talking about that, because we saw with things like DateTime how IntelliCode works, trying to give you IntelliSense, almost like IntelliSense++. It's that AI-assisted IntelliSense. If I go and say something like default coupons, if we zoom in on that, is a list of coupons. Okay, so this is a base type list of coupons. So I hit dot and I get listy things. I get things like add, right? And then if I say if default coupons inside of the if, I get a different experience, because count would be an appropriate thing to check on in a list. If I go and say something like coupon list A equals default coupons dot, I can get other list-based things that will pop up. But these are base types. This is actually a model that has been pre-trained and shipped. And you'll notice that there are base models, C++, C#, et cetera. But you can go and train on your own code, because I'm less interested, frankly, in my DateTime and my list stuff. That comes by default. I want it to understand what coupons do and how coupons should work. I want it to think about how my team uses it. And I want to get a model that is trained. And by the way, I'm training that, and I can still go and do my code and do my things. Everything is cool. When I said coupon A, default coupons, to array, A dot length, look. Okay, those are my default IntelliSense things, right? But when IntelliCode goes and trains this model, I can then share it with the rest of the team. It copies that link to the clipboard, and then the rest of the team can go and bring that in. And here is a custom model, and you can see here it says this model covers 35 classes. It's actually looked at my code, done AI on it, seen how that code is used, and then now my custom types are all available with smarts throughout my application, which is really cool. So now when I go coupon, look, it automatically pops up coupon text and external ID and ID, because it has identified that those are the ways and those are the things that I might be using coupon for elsewhere in my code. If I were using it differently on a different team, they might have a different model and they're going to get a different experience. That experience is going to be optimized for how their code works. It's such a much, much smarter way of doing IntelliSense. And the fun part about it is that I find myself scrolling down within IntelliSense less and less, and I find myself going C dot tab dot tab dot as it goes and anticipates my next move, which is really a joy. So I hope that you enjoy that and have some fun with it, as much fun as we are having. So I can share that with the team, and then the team can pick up that model a little bit later. Now I want to do something a little bit unusual here, and I want to shift gears outside of Windows. I'm going to go ahead and close Visual Studio. I'm going to switch over to something you don't see every day. I'm going to switch over to Ubuntu. Hang on. My phone is buzzing. It might be a blood sugar. Oh crap, it's a phone call. Hello, yeah? What do you want?
Yeah, hey, Scott, it's Jonathan. I was hoping you had a minute. Do you think you can help me with a quick bug real quick?
I am on stage. I'm doing something, and I don't want to talk to you because I am on stage live.
Yeah, it's just, I was trying to add a promotional coupon to the Tailwind Traders app, and it doesn't seem like the scanner works anymore. And I figured since you just open source WinForms like, I don't know, an hour ago, and you're wearing that shameless open source shirt, you'd maybe feel obligated to help me?
Okay, yeah, I would be happy to help you, but I'm in Ubuntu. I don't have .NET installed. I don't even have Visual Studio. I'm in a VM. I don't want to leave my VM.
Yeah, that's all right. Actually, I sent you a message over Skype, so if you check that out, what I sent you is a Visual Studio Live Share link. All you need to do is click that, and you can jump right into my session and start working with me.
Okay, joining live share session. It has got me in my Visual Studio Code. Joining collaboration workspace. And hey,
You should see my cursor and any text highlights I'm making.
Is that you moving frantically around the code?
It is, yeah, just for you, Scott.
Thank you, sir. Okay, this is pretty cool. So I don't have C# installed. I'm looking at the remote. This is my style. I'm inside of Ubuntu. It's my, my theme, which I like. Okay, I see your mouse there, your cursor. And what is the problem? What do you want me to fix?
Yeah, so if you check out the scan button, click event handler, that's where we handle the actual input of the coupon code.
Right,
and for some reason, it isn't working for me, which is really stressing me out because I added this new promotional coupon that I'm excited to show you. Does anything stand out about this code that you think
No,
we might
well,
need to
I don't
fix?
want to fix your bug because I can't concentrate because it's just so bad. You're doing this if not, reverse inverted if thing, and I don't like that. I'm going to click on the little light bulb dealie and hit invert if, and then there we go. Now I can concentrate because that was just bad. But wait a second, though. I don't have .NET. I don't have C#. I don't have even refactoring. Whose light bulb is that?
Well, it's mine. With LiveShare, because we're remoting all of my developer environment to you, you're not only able to see my cursor and files, but you're also able to leverage all of the language extensions and SDKs that I have installed, even though I'm in Visual Studio on Windows and you're on Visual Studio Code in Ubuntu.
So the presentation of that dropdown, the clicking and the doing of it, I didn't do it. I just told you to do it. You didn't do it, though. The computer did it.
That's exactly right. What we're doing right now is sharing context, not screen. So your view of the world is very different than mine, but you're benefiting from all the productivity enhancements that Visual Studio 2019 provides.
So if I select text, you see it, and if you select text, I see it.
Yep.
And then, okay.
And then if we select it together, we clash in a very beautiful way.
That's very exciting. Yellow and blue make green. On the left-hand side, though, I see Git, and then I see the change that I just made, but that's not my Git, that's your Git.
Yeah, unfortunately, LiveShare also remotes all of my Git metadata, so there's no way for me to hide the local changes from you, no matter how bad they are.
Unfortunately, but that's amazing, though, because then I can go in here on my side. I can see the diff of what just changed. I'm actually looking at the diffs from your side on my side presented in the way that I think in Ubuntu, in Visual Studio Code, and you're running Windows and Visual Studio 2019.
Yep, exactly.
And I can even go and comment on this?
Yeah, one of the great things about LiveShare is because it's real time and it allows you to view diffs as well as add comments, it effectively serves as a real-time lightweight pull request.
Very cool. Okay, that's cool. So back over to, now you're with me over in main forms. I'm over in coupon service. Where do you want me to be now? Because we need to fix this bug because I have a kind of a thing I'm doing.
Yeah, let's take a look back in mainforms.cs in that scan button handler.
Okay.
And I think there's something wrong maybe with the coupon service code where we're calling finding a coupon, or there's something just not working right there.
All right, so you say scan, find coupon async. I'm going to right-click go to definition, which I assume is happening on your side, but I get to navigate the code naturally. I'm moving around even though you might not even be in the same file as me.
Yep.
First or default async. I'm getting like pop-ups and it's giving me help and everything. Your computer must be working hard. .external ID is wrong because this is find by ID, not by external ID. So we're going to go in. Oh, hey, I'm getting little stars too. Wait a second. This is a coupon. X is a coupon.
Yeah, you know that custom model you just trained like 2 minutes ago? Yeah, I got that already. And LiveShare is automatically sharing all of my IntelliSense with you, including IntelliCode augmentation.
Remoted LiveShare IntelliCode over Visual Studio LiveShare. Wow. Very cool. All right, so I fixed that. Now, can you what do you do? Like run it on your side and tell me what you see?
You know, Scout, with LiveShare, you also can even run and debug applications on your end, even though they're running on my machine. So if you want to set a breakpoint on line 46 where you're at,
you
can go ahead and switch to the debug tab and select the WinForms application and just start that up.
Okay, so is it going to happen here, or it's telling you? I'm putting you on its puppet strings, right? We're sharing this, like we're in a debug session together.
Yeah, well, we're about to be.
Okay, so I just hit go. Can we, okay, so we're at a breakpoint. So do me a favor, people in the back, can we see his machine maybe and like do a split screeny thing? Okay, cool, so I'm on the right and I am in the much cooler theme. And Jonathan is in Windows on 2019. We're at the same breakpoint. Okay, cool. So then if I hover, I can see the same stuff. I can see all of my different, I got watch windows, I got locals, I got all that stuff. Now, this is a WinForms application, so I'm going to need you to run it and then maybe send me, email me a screenshot of what you see to make sure that it works.
You know what, Scott? You can actually do that yourself. If you want to go ahead and continue the app, we can take a look at it and see whether we fix this bug.
All right, so I hit continue. For those of you who missed that, on the right-hand side, I'm running Ubuntu. What we're doing is remoting the window of the desktop Windows application that Jonathan is running. I'm moving my mouse over here. Who is the little head that's chasing my mouse?
You're controlling my cursor right now.
From Ubuntu.
From Ubuntu.
And I hit scan, and I hit the breakpoint. I'm working the way I want to work from my world, running Ubuntu, running VS Code, helping a Windows developer using open source WinForms and .NET Core 3. And I'm having a lovely, lovely time. If you thought we were not serious about open source and your tools anywhere, we are serious. And I don't want to squeeze you for applause, but I'm worried that you may be dead inside. I am starting to suspect you did not need my help, JC.
Yeah, honestly, I was just a bit jealous that you had this Scott Hanselman and Friends talk and you didn't invite me, so I just wanted to call you up and interrupt you.
All right, well, thank you for calling me. That was a totally inappropriate use of your power.
All right, man. Thanks as always, Scott. Let's get tacos later.
Thank you, sir. That was Live Share, seeing something that you haven't seen before, which is the actual remoted UI. And of course, this doesn't mean WinForms runs on Linux, but it does allow me to collaborate in ways that were never possible before. And with Visual Studio Live Share, we're just getting started. Now, Visual Studio 2019 preview is available today for Windows and Mac. We're trying to make everybody more productive with features like IntelliCode. We're trying to make it so people can collaborate, whether it be on GitHub, work asynchronously, work on Live Share. I'm not pushing pixels around, I'm pushing out context. Things like historical debugging, live unit testing. I want everyone to go and download the preview, check it out, give us your feedback. And I also want to point out that you can safely install the preview side by side with your existing VS setup. It won't mess things up. And if you're using Visual Studio 2017, you can download Live Share and try that out as well. Live Share is available everywhere. It's a fantastic tool and such a joy to use. It's going to be integrated and built into Visual Studio 2019. Now, one of the things that is the heart of Visual Studio is the extensions. When we put out Visual Studio 2017, we had 500 extensions at launch. With Preview 1 of Visual Studio 2019, we have over 400 extensions on the first preview. That is a staggering amount of extensions with languages that you haven't seen before, new technologies. We're just getting started. It's such a wonderful ecosystem. A lot of these are open source and on GitHub, and they enable great new scenarios inside of Visual Studio. So I'm pretty excited that we have almost exceeded the number of extensions on Preview 1 that we had with launch of 2017, which is pretty hot. Now, one of the things that we want to do is talk about the cloud and trying to figure out that getting to the cloud is easier than you think, but we don't want to necessarily tell people how to do it. We don't want to insist that you must go to the cloud this way. There's so many benefits to move to the cloud. Now, in the old days, you had to go and get a container, load it on your horse-drawn carriage, and bring your new compute power into the data center. But now, if you want to scale, you can just move that slider to the right. The entire second page of my resume is pulled out completely. It all said how to scale a website, and now Azure does it for me because we are sitting on top of the shoulders of giants, and things like scale are not the problem anymore. Now, every developer can get their apps into the cloud. They can run at global scale by just moving that slider to the right. So how can we do that, right? There's one destination, which is a more manageable, more fun, more enjoyable cloud-based system, but there's different paths to the cloud. We need to acknowledge that. And what I think makes Azure special and why I enjoy working on it is that we meet you where you are on your cloud journey without telling you that you have to do it this way or that way. We have options like IaaS, which is kind of like owning your own home. You bring up a virtual machine, you're responsible for it, you have to run Windows Update or apt-get update, and it's yours, you own it. You have maintenance and upkeep. Then there's platform as a service. This is like a bed and breakfast. You're in someone else's home, they're managing the house, they're taking care of it for you. You just have to go and spend time in the room that you rented. And then there's things like serverless, like a luxury hotel, like the one that I'm staying in, because I'm a freaking rock star. And I thrashed my room, and I'm going to come back, and it's going to be put right back the way I found it, because it's serverless. I don't even think about it. There might be a virtual machine underneath my room, not my problem. That's that experience. But here's the thing. Is the goal to live and stay in a hotel 24/7? No. We as people, sometimes we're at home, sometimes we're at an Airbnb, sometimes we're at hotels, and we move between these environments. Why shouldn't our software be the same? Sometimes a virtual machine is the right thing. Sometimes compute is the place to go. Sometimes you add serverless. There are different paths to the clouds, and hybrid applications often have components that take up a different part of that experience. It's not a continuum as it is multiple places on the path there. So I want to bring my friend Cecil Phillip to come out and talk to me about how you can bring your applications to the cloud.
Hey, Scott.
How's it going, sir?
Thank you. Morning, everybody. So I have some really cool stuff I want to show you today.
All right.
Now, our good friends at Tailwind Traders have built this web application, and they've been using it for their customer support specialists, so they could track some of the orders that's been placed inside of their system. So for instance, I can come in here, and I can search for a customer. Let's say we search for Michael. And I can pull up his contact information, but I can also see his order history that's here. Now, this application has been pretty rock solid for them, so they haven't needed to make any changes to it as of late. And actually, when they built this application, they use a combination of ASP.NET Web Forms, they use jQuery, and they also use a SQL Server database to store some of this information.
Okay.
Now,
where is this running right now?
So right now, this is running on their internal infrastructure.
Okay. So IIS under someone's desk.
Right, exactly.
Okay.
Now, the thing is, business has been going really great for Tailwind Traders. So they're starting to outgrow their infrastructure that their application is running on. So now they're looking to the cloud to make use of some of the platforms and service offerings that are available inside of Azure today.
Cool.
Now, the thing is, these developers haven't been keeping up with the latest and greatest when it comes to web technology. So they're a little bit concerned now. They're concerned that their application might not be able to run in the cloud without making significant changes. So what I want to do in the next few minutes is show you how we're going to take this application, we're going to publish it into Azure App Service, and we're not going to make any code changes at all. So let's head over to Visual Studio. And what we're looking at is this Web Forms application in Visual Studio 2019. Now, I'm going to go over to the Publish dialog. Now, remember, this is the same Publish dialog that they use whenever they publish the IIS 6 that's running on their infrastructure. But this same Publish dialog can help us get our application into the cloud. All I need to do is make sure I select App Service, and then what I'm going to do is create a new profile. And then I'll have to enter some information about my subscription and what's the name of my application and some of these types of things. Now, I've already done this, so I'm going to go ahead and open Configure so you can see what my Publish profile looks like. Now, one of the interesting things here that I want you to see is that I have my database connection string in here. So what's going to happen is on Publish, my web config is going to get updated. And so now this is going to point to my SQL Azure database that's in the cloud, and not the one that's running on-premise today.
I see. So when I hit F5 and I debug locally, it's my local IIS and my local SQL Server Express or my data centers one swaps it out when I publish.
Exactly, exactly. So now, in the essence of time, I've gone ahead and published this application. So I'm just going to click on the URL. And as you can see, it's still running the same way as it was before. The difference is now it's running on my Azure App Service instance.
This is the same 10-year-old Web Forms app that's running, what, .NET 4?
Right, same Web Forms application is running .NET 4.6.1.
Okay, cool.
Now, what I'm going to do is I'm going to head over to the Azure portal. So here what we're looking at is the App Service instance that the application is running on today. So if you follow me on the left-hand side, you can see that I have a various set of options that I can configure. So for instance, I might want to set up something like deployment slots. And what that will do is allow me to set up different environments for my application. So I could do something like have dev, test, and production environments. So I could do things like A/B testing, or maybe I want to verify a build before I swap it into production.
And simply by virtue of the fact that you moved it into Azure, now you have that capability. When before you would have had to make another IIS apps, application and move on.
Right, I would have to make another instance or something, but now I just kind of have that capability there for me.
Okay.
Now, as I continue to scroll down on the left, you can notice I have things like I can set up SSL, I can set up custom domains. But one of the things that I think is really cool is that we have the ability to set up our scale up and scale out options. So if I click on scale out, you can see that I have the ability to enable auto scale out. And what this will do is allow me to define some rules that will let app servers know how I want to add additional instances to my application based on, as my load increases or decreases. So what I can do here is I could just I'll call this rewards scale. I'll give this a name. Really quickly. Oops, sorry about that.
It's hard in front of a lot of people.
I know, right? Like, the keyboard just doesn't work the same way. Now, what I'm going to do is I'm going to add a rule. Now, this rule is going to say every time my CPU percentage hits about 70%, I want you to start adding additional instances to my app service instance. But I have other things I could do too, like I could look at the memory usage or even the disk usage as well.
I see. Every application is different. They have to scale for different reasons.
Exactly. So I'm going to go ahead and hit add. And now all I have to do is hit save, right? And so now I'm going to have those auto scale out rules available for me. So that's just one less thing I have to do for myself now.
Right, that's that slider bar that slides to the right based on your application. Now you don't have to go and rack new servers.
Right, exactly. Now, stepping forward a little bit, another thing that might be really important after you've published your application is I might need the ability to get really rich logs and telemetry information. So we have a service called Azure Application Insights that does exactly that. So if you look at my dashboard here really quickly, you can see that I have the option to look at the server response time. I can see the server requests. But I can also see the failures for the exceptions that might have been thrown in my application. So on the left-hand side, I'm going to click on failures. And now I can dig down into the operations and exceptions that have happened in this app. So I'll select one of the exceptions that fired here. And here on the right side, I'm going to click on drill into, because I want to get some more details about what's happening here. I'm going to click an instance of this exception. And now, in no time at all, at the right-hand side, you can see we have the exception details. We have information about the call stack.
This is that yellow screen of death that you might have seen occasionally in production where you shouldn't.
Right.
And you tell the user to send me that information. Everything that goes wrong in the application is automatically being logged, and you didn't have to do anything.
Right, but just a little bit less scary over here.
Yeah, it is less scary.
Now, under related items, I'm going to click on user flows. Now, I really like this view because what it does is it allows me to see the path that the user took to get to that exception. So what are the things that this user did before that exception actually fired? And I could take a look at it here and see exactly what
I see. It's putting the error in context.
Pretty much, yeah. Another cool option we have is the ability to look at the debug snapshot. Now, what this is App Insights has gone ahead and taken a snapshot of that exception. So we can get an understanding of, well, what were the state of the variables, what were the state of the world, essentially, as we hit this. Now, here on the right side, I have the ability to download the snapshot as well. So if I wanted to, I can download the snapshot and I can load it into Visual Studio, and now it'll just engage my debugger. So again, I could use my local debugging tools to kind of see what happened in the service that was running inside of Azure.
So it's almost like you're debugging in production, except you're not. You're bringing the production dump down, and then you see that experience, all the locals, all the watches right there.
Exactly, exactly. All right, so we've seen how we can deploy this application, and now we're getting some rich debug information. Now, how about we spice this up a little bit? I'm going to head back over to the application. And here on the left side, you see we have this option that says Enroll in Loyalty Program. Now, what was supposed to happen is that every time we hit this checkbox, the Tailwind Traders folks want to go ahead and kick off a workflow. And this workflow is going to go ahead and verify the user and enroll them in that loyalty program. Now, we actually haven't implemented this workflow yet inside of the application, so we're going to go ahead and do it now. And we're going to use it with some features that are inside of Azure today. So I'm going to go back to my Azure portal.
So you're not modifying the code of the app, though?
No, I'm not modifying the code of the app at all.
Because the app works. It's cool.
Right.
Okay.
So we don't want to change it, but what we're going to do is we're going to extend the app using some features that are inside of the portal. Now, what we're looking at here is my Azure Logic app. And now this is a way for me to create serverless workflows, but we're going to do it in a very, designer-focused way.
Okay.
So I'm going to click on my Logic App Designer. And now what's going to happen is that you're going to see that designer pop up. And it's going to show me that workflow that we just defined.
Okay.
Now, what happens when we hit that checkbox is that we're going to update a record in the database. And that's going to essentially flip a flag. It's going to say, I want you to enroll this particular customer. So the first thing that happens here in my workflow is that I'm monitoring this customer table. Now, anytime there's a change in this customer table, my workflow is going to kick off. The next thing it's going to do is going to get the actual row of information, right? Like, what customer did we just change just now? And then the last thing that we're going to do is send a text message to that particular customer using the phone number and also their name. But remember, we got all that information from the database.
So those things, first name and mobile numbers, flowed through because you picked them up from the customer table earlier.
Right. And then we can get some other fields from the database too. So if we take a look over here, I can see different things like the city, country, email address. Again, like whatever is in that row, like we can pull that in and we could work with it in interesting ways inside of Logic Apps. Now, if I wanted to extend this workflow, I can hit this plus button. And if I go to action, you can see that we have a large number of connectors that we could use. So for instance, if I wanted to, I could connect to something like Azure Service Bus, or I could make an HTTP request. We also have a lot of enterprise connectors. So if I wanted to connect to something like SAP, I could do that right inside of here as well.
The whole marketplace of connectors that are serverless things that run inside of Logic Apps in the context of Logic Apps, not as part of your web app.
Right, not as part of my web app. So as you can see now, what we've done is that we've used Logic Apps to essentially create an extension to our already existing website. And all it's doing is just monitoring that SQL Server database, and I was going to kick off this workflow that we've defined here in the designer.
Fantastic. Thank you so much.
Great. Thank you. Thank you, everybody.
What I like about scenarios like that is there are things that you can imagine how you could apply that right now. You could leave this talk and you could think about how I could go and extend my application in that way, adding functionality without completely rewriting or porting. That way it's not a big thing to move to the cloud. It's a natural thing to move to the cloud. There's a couple of resources here you might want to take a look at, maybe take a picture of those. You've got an opportunity to get help. Actual human beings will talk to you and help you potentially move your .NET applications into Azure. And then if you already have Visual Studio subscriber benefits, there's a number of new migration tools that are automatically a part of your benefit. You've got Cast Highlight that will go and rapidly scan your code and basically give it a health check to tell you whether or not it's ready for the cloud. And then Cloud Pilot that will help you move your apps to the cloud, make the required changes to migrate to containers or VMs, to change your connection strings to go to Azure SQL. It's totally up to you. Those are automatically built into your subscriber benefits, both Cast Highlight and Cloud Pilot, so check those out. Now, this idea of serverless, once your application's in the cloud, you take it to that next level. You don't necessarily have to build your application entirely with serverless. You can evolve it using serverless. You've got a whole series of great managed services that are building blocks so that serverless is less of a buzzword and more of an empowerment. Azure App Service allows Cecil to go and move his application up there. He can then augment it with functions and do consumption billing, Logic Apps, as we saw there. He could use AKS with the new virtual node technology that just got announced in Guthrie's talk, or use Service Fabric and scale to completely new heights. Now, when you do all of these things, you might want to front it with API management so that you have a friendly front end that your consumers can then use your APIs. In the past, the billing for that was fairly fixed, but now we're announcing consumption tier for Azure API management. So just like that really consumption-based billing that you expect on serverless, that is now applying to Azure API management as well, kind of creating API gateways for those traditional backends in case your API shows large spikes. Now, I think it's cool that you can build your favorite apps with .NET. I've built lots of great apps from Baby Smash and WPF, which is open source now, which is awesome. My baby is now 13, so I've been using .NET for a very long time. I love imagining apps and building them with .NET. And the growth that happens in the .NET community right now is just continuing. We are seeing 1 million+ new active developers using .NET this last year. We've got over 750,000 .NET Core 2.0 developers. There are so many people using .NET Core. It's such now a vibrant community. It just makes me happy that I picked .NET for my place. This is my people, and I appreciate you all. You can build anything. You can build WPF apps, you can build WinForms apps. You may have been doing that for the last decade. You may have just jumped in with a Xamarin application. But the fun thing about .NET is it's your platform for building any kind of app. All of the people who are watching, who are WinForms devs or ASP.NET MVC devs or who are doing IoT work, know that your skills translate. I can become a dev on a Raspberry Pi, or I can do IoT. I can use my editor. I can use Emacs, and I don't know how to exit it, but I can use then Visual Studio. I can do any platform, anywhere, any language, and it makes me happy that I have that flexibility of movement. I can imagine stuff that shouldn't be possible. You know how they always joke about the PowerPoint compiler? Yeah, it'll be great. We'll just make a PowerPoint compiler, and that'll be a thing. Well, I want to bring out my buddy Christos, because he's built a really interesting idea with .NET that is just too crazy not to show. So let's have him join. And he's bringing props, so that's exciting. How are you, sir?
I'm good, thank you.
So I wanted a PowerPoint compiler, but you do most of your architecture work on the whiteboard. So you had an idea, and I told you it was crazy and stupid, and you shouldn't do it. So of course, as any good engineer does, you did it anyway.
We did, yeah. We started at Ignite. We had this idea of doing something with
magnets. He made these magnets. These are really cool. I thought this was like a marketing gimmick. I said to myself, okay, these are magnets. They are magnets that show Azure services. I'm like, okay, that'll be fun. I can put those on the whiteboard, and those will be cool. Now, of course, for the demo that we're going to show you here, these are a little small. It's Las Vegas, so we did the only thing we could. We made giant magnets.
Yes.
So show me what you're going to do with these giant magnets.
Okay, right. So first of all, we're going to design an architecture for our web app. So it will be a web app, and we'll start with the app service. It's going to hold our web application. We're going to have a SQL database to store our data. We're going to have a storage account for some website assets, and finally some serverless goodness with functions.
Okay, you probably should draw some boxes line. Here, let me add some value.
Right. In fact, we want a Key Vault as well to store some sensitive information. We shouldn't be having them on web configs and stuff like that. So I'm going to write Key Vault.
Okay.
Right.
Because we don't have an icon, I guess, for Key Vault. So Key Vault, of course, is going to store your connection strings, your certificates. It's a component of this. And then you could, I guess, draw lines and do the kind of boxes and lines diagram that one does when they're making an architecture. It looks very official. I do this all the time. You know that you've reached a certain level if you can just stop here and still get paid. Yeah. But at some point, I got to go to the portal now, and I got to type all this up, right?
No. Let's not do that. Let me give you, what we did actually was giving people the ability to take that and do something amazing. So I'm going to take my, my application here. It's a sample app that we wrote together. We have the subscription selected. So next I'm going to press continue, and this will allow us to take a picture. So let me take a picture of the architecture like this. Now check this out. This is really good, right? I'm going to use this one.
Okay.
And what this one is doing right now is actually sending that image all the way to Azure Cognitive Services, analyzing the picture, and coming back with the services. So see what happened there?
So you can put this directly into production.
So you go from the board to the phone in a few seconds.
I love that you actually made me a whiteboard compiler.
It's a whiteboard compiler. And in fact, you don't need the magnets. That's very important to highlight. You don't need the magnets. You can write the whole architecture by enumerating the services like Key Vault and Web.
Well, I just realized that you wrote Key Vault because you didn't have the magnet for it. It recognized that. It knew that that was an Azure service, and it made that.
Yeah.
Okay.
And if you don't have the magnets, now imagine that. You're in a team using Surface Hub, and you're collaborating on Visio.
Okay.
You can take a picture of that as well.
Well, you didn't actually do anything, though, because you just showed me a list of stuff.
Calm down.
Oh, excuse me.
Next step.
Pardon me.
Right, now we're going to select this region in Azure, so US East. And then we're going to select the resource group. Listen, tacos.
Tacos.
I'm hungry already.
All right.
Right, tacos. Sorry, let's do that. We don't want to use an existing one already. So tacos and press deploy. Did you see what happened? We're kicking off the deployment.
So do you have like some web service in the back end, and that thing's talking to Azure now?
No, everything's running on the phone.
You're running what, like Azure SDK, and you're calling the Azure?
So we have the Azure SDK, the .NET Standard SDK that we have available. And what we're doing is we're using the phone to actually deploy everything to Azure. So everything is self-contained. And in fact, we're running all the tasks in parallel, as you can see over there. And the idea is that we want to be very efficient. So you can go from whiteboarding your session with your team to being on Azure in a few minutes.
I don't believe it. Lies. It's all lies.
Right. Let me show you how the code works, right?
Okay.
And you might ask, like, are you a guru in ML?
I assume that you have a PhD in data science.
You know, I was a total noob. When we started this project, I was like, I want to see if we can do it, right? We had the idea, we chatted about it. So two services that we decided to use was the Azure Cognitive Services, the custom Vision AI. And in fact, as we were developing the application, the feature recognition the feature logo recognition came available for us, so we're the first ones to try it out. So if you go to the service today, you'll find it there. It makes that prediction much more efficient. And in the code here, we have 2 classes that do most of the heavy lifting. You'll see that we only have probably, 8 lines of code there that take the text that we typed there or we wrote, and it translates that to something that we can understand in the system.
So seeing a picture of text and turning it into text, I get that. You send that up to Azure, but the image part, you made those images custom. How did you teach Azure to know what that meant?
So we took a couple of pictures of the architecture, different examples, and then we uploaded to the Azure Custom Vision, and we trained the model for that, and then we moved into the code. So what we're doing here is we actually call out to the service the model that we trained, and then it brings us back the enumeration of the services that we have on the whiteboard.
Fantastic.
2
now,
calls.
You mentioned .NET Standard.
Yes.
The .NET Standard allows you to write a library, and then the standard is then implemented and runnable anywhere. Yeah. This is running on the phone, to be clear.
This one's running on the phone. It's a Xamarin application that has a shared code written in .NET Standard. And in the phone over here, as you can see, this is the deployment manager, which kicks off the tasks.
And it's interesting because you're using taskfactory.start. This is quite compact, but also sophisticated parallelism that's happening on the Android, on the iPhone. Or if you chose at some point in the future to move it to another place, you could do that, like WinForms or WPF, because .NET Standard is everywhere.
Exactly. So you can lift it and shift it and take it anywhere you want.
Okay.
Our app settings here to configure your services. And in fact, we should go back into the portal to check whether that's done. So if we go into our resource groups, we can see tacos there.
All right.
And check that out.
And there you go.
5 services.
Fantastic. So you created those, and then of course there's more than 5 because of the supporting underlying things like an app service plan, and then you deployed it with app service.
App service to support the the logging, the build, the distribution, and everything else. And in fact, as of today, this is open source, so you guys can go out there and download it and test it and see how and where you can take this, because it's an amazing
Fantastic.
experience.
What a great sample, and I love that we argued about this at Ignite, and I told you it was totally impossible, and you did it anyway.
We did.
And that makes me very happy.
Thank you.
Thanks for hanging out.
Thanks for having me.
All right, fantastic. Literally, I was just walking by the booth, and I was like, he's like, yeah, I got this idea with the magnets, and I was like, come on, that's just dumb. You can't do that. And he did it anyway. It's such a joy when people go and do stuff like that, and we can showcase it. We can think about that. Whatever idea that you've got, you can probably make it happen as well. He pulled that off in a couple weeks since Ignite. He used the Visual Studio tools for Xamarin to build the application on the phone. Again, no back end to go and do that. There's no supporting web service because he found that the phone had the power to do what he wanted to do. And then he went to Visual Studio App Center, and that does his deployment and his management, and he ended up putting it on both Android and on iOS. Now, .NET Core 2.2 is now generally available, and we're happy to announce that huge improvements on performance, especially when you put things in IIS. You don't have to put things in the cloud. You can go and do this in IIS, and you're going to get great performance just by upgrading up to .NET Core 2.2. And then we're ready for you when you do move into the cloud. We've also added HTTP 2 support as a preview in ASP.NET Core, and so much more. There is a huge list of improvements for web APIs, for security, API security. We've updated all the templates to Bootstrap. We've got new Angular support. We are moving so fast. And then on Enterprise, on the database side, on Entity Framework Core, we've added support for spatial extensions for both SQL Server and SQLite. Your database, your platforms, your locations. Such great fun that's happening right now in the .NET Core space. Now, this one's interesting. The .NET Foundation. It's an open source foundation, and it's there to guide and to shape .NET. There's a new governance model. Now, you might think, oh, that's not really an exciting thing at all. A new governance model is actually hugely exciting because what's happened here is something that you would not expect from Microsoft. The foundation board is expanding from 3 seats to 7, with just a single seat appointed by Microsoft. And the remaining 6 seats will be elected by the community. Board elections are going to start in January. Anyone at all, any person who has committed to a .NET Foundation open source project can run for the .NET Foundation board, and you can vote. And this new structure is going to really help the foundation scale with this growing ecosystem that we've seen. This is based on the way that you see the GNOME Foundation do things. And it's going to allow the community to really take a strong leadership role in what we do with the newly open source WinForms and WPF. We've got this amazing platform in .NET and this amazing thing to run it on in Azure, and it's great to have the .NET Foundation supporting us in all of those things, and I'd like to see the community jump in, start running for those board seats, and make it happen. We've even gone out and we've got some new expansion on our technical steering group with new corporate sponsors. We've just added Pivotal, Progress, Telerik, and Insight, and they are adding to the already illustrious group of people like Red Hat and JetBrains and Google, Unity, of course, Microsoft and Samsung, all there as corporate sponsors to help move this technical steering group and the .NET Foundation forward. So I appreciate all of them and the fact that they are joining us in this journey. Now, you've heard me say your apps in any language. You know that I like .NET, but Azure's not just a .NET shop. Everyone is welcome. You can do anything that you want with any language that makes you happy. Your tools, your languages, your apps. We saw a cool example just then that was using .NET, but was also doing some cool stuff with machine learning and a model that was custom trained. I want to invite Dr. Francesca Lazzeri to come out and talk to me about building intelligent apps with Python and Azure Machine Learning so I can learn more about this.
Hi, Scott.
Hi,
how are you? So over the next few minutes, we are going to learn how to create a pet detector together. We will be using Azure Notebooks, Visual Studio Code, and the Azure Machine Learning Service to train, optimize, and deploy a deep learning model that can recognize the different breeds of dogs and cats.
All right.
So these, in this repo, as you can see, there are many different files that we're going to use for this demo. You need to import this file in Azure Notebooks. That is our free Jupyter Notebooks service hosted on Azure. And a new feature that is in Azure Notebooks is that I can connect to a data science virtual machine to run the compute in my notebook. So as you can see here, I'm using a GPU DSVM.
It says GPU though, that's graphics processing. What does that mean? Is that special?
Yes, it's special because, as I said, the model that we're going to build together is a deep learning model, and the deep learning models need a large data set that usually is like training data, and the GPU can really help with the training process.
Okay, cool.
So let's connect to it. And as you can see, we are going to open a notebook. A notebook is similar to a blog post. The only difference is that there are so many different cells. In each cell, there is some code that I wrote. To run it, you can click on Run, or you can just click on Shift, Enter, as you can see. And this specific notebook uses TensorFlow, that is a library for deep learning, and also Oxford Pets dataset for the data. So let's look at the data. Here we have pictures of 37 different species of dogs and cats, and all the data lives in the images directory of this project. So as you can see, let me show you.
So as you're moving from cell to cell, you're hitting Shift, Enter, and it is actually executing that. So like you said, it's like a blog post, but it's code.
Yes.
And you as a data scientist, you live in notebooks.
I live in notebooks. Now that I show you the data, the next step is to train my model. Here, this cell is going to take just about 20 seconds for two main reasons. As I said, we are using a GPU data science virtual machine. And the second reason is because we are using transfer learning, which is a very powerful technique that allows me to just retrain the final part of a layer, what we call layer in machine learning. So this, again, it's very, very fast. Okay. So let's look at the result of this training. So as you can see, we got an accuracy of about 79%. This is the test accuracy, which is pretty good because the first model that was published in 2012 was able to get only an accuracy of 59%. But, you know, as a data scientist, we always want to do better. So let's try to do something more. Azure Machine Learning Service has a feature that is called Hyperdrive that can help me with hyperparameter optimization. So hyperparameter optimization is a way for data scientists to change values at the parameter levels to improve the results that you can get. So let's run this part. Also, as you can see, I need to get the reference to the workspace, which is a container that I can use to manage data and compute resources. So let me run also the training script, and now I'm ready to create and submit a hyperdrive job. And that is this part. As you can see, I'm doing a random sample of the learning rate, and I'm also trying 20 different values here, and let it run up to 4 jobs at the same time.
So you're trying to optimize it, getting us beyond 79%.
Yes.
And you're trying different things. You're plugging in different variables?
Yes, exactly. And I'm using Hyperdrive, that is a feature in Azure Machine Learning Service. So another cool thing that we can do here is that we can look at the progress of the Hyperdrive run using the Azure Machine Learning Jupyter widget. So let me show you how it works. You can just look at the different results. Here I have a completed Hyperdrive run for us. And as you can see, in real time, you can look at all the results of your different runs, like for example, the run ID, the duration, when it started, and you can look also at the different metrics. You can see that now we got a much better metric. So this is actually the validation accuracy. The test accuracy is 90%. So as you can see, just in a few minutes, I was able to improve my model accuracy from 80% more or less to 90%, which is pretty amazing in my opinion. So data scientists love to use Azure Notebooks for their experimental code because it's both, I think, very interactive and maintain a rich history of their experimentation. But how I would say data scientists and developers can collaborate together. So this is a problem that we have to fix somehow. So I think developers can use Visual Studio Code to take the experimental code from data scientists and turn it into a Python module. So this is a Visual Studio Code that is running on a Python extension. So the file we are interested in is the demo file, that is exactly the file that I was showing you before in Azure Notebooks. As you can see, immediately Visual Studio Code asks me, do you want to import it, the Jupyter Notebook, into a Python code? Of course, I want. And here, what I need to do immediately is to save it. Let's call it demo.
I noticed right when you did that, it lit up.
Yeah.
With new stuff, run cell. Are those the same cells?
Yes. So now here, the code cells are transformed into a Python file, and we are leaving the markdown cells just as a comments. So, and let me show you. The most beautiful part is that you can just, let's say, click on this cell, and then I can click on this other cell. And you can see that the output from these two cells are visualized in this Python interactive window. So I'm really having the same interactive execution experience that I was having earlier in Azure Notebooks. So this is really amazing. Now I'm ready to start refactoring my code. I can just select a part of my code. I can click, and for example, I can use the extract method to write a new function. Let's call it HiScott function. And here is the new function. I can keep doing this for the whole file, but now I have already a finished version of the file. As you can see at the top, I sorted all the imports, and here I have split the code into different functions just to clarify the training steps.
So are you saying that you've turned the Python notebook now into an application that then can be shared and be reused?
Exactly.
And did you get IntelliCode for all the same kind of experience?
Yeah, let me show you exactly. So after that you have a trained model, the next step is to create a score file. Azure Machine Learning Service made this very easy because the only thing that you need to do is to create this score file that define how the data coming to the service needs to be processed and how the model needs to be used to make predictions. And let me show, the only thing that I think I need to add to this script to resize the image is a little piece of code. And here I can type it, for example, image. And as you can see, there is an Intel code that is really suggesting me what to do next, what to type in next. So as you can see, it's, let's, for example, here. So as you can see, it's really, we are using AI to write AI, and this is done by IntelliCode, which is really
and what's
amazing
cool about it is
for a data
all the
scientist.
tools work together. All the tools are working together.
Yes. So now that we have a trained model and a script and a score script file, the next step is really to deploy this model as a web service on Azure. As you can see, we can click on the Azure icon, and here we have our Azure Machine Learning extension. And what you just need to do, you can see all the models that you have deployed, all the models that you have created here, and you can deploy them as a service to, for example, Docker container that is running on Azure Container Instances.
So this is a trained, this is the 99% model, the 98% model.
Yes, exactly. And here I have the model that I already deployed. So now let's test this model. Let's see if really this model can, for example, recognize the breed of my dog. Here I have a test up. As you can see, the only thing that here I can do is to type at the top this, just to turn it again into a Python file to get the same experience, the same interactive experience that I was getting in Azure Notebooks. I can try to run on cells, and I want to use again this Python interactive window to look at my prediction results. So again, this is the model that we deployed, and as you can see here, you can see the same results. You can look at the prediction results, and this is actually the image, the photo of my cute little dog. His name is Leonardo, and the model is saying that he's an English Cocker Spaniel, which is
that's true.
It's true. Yes. So yeah.
That's fantastic. Thank you so much for sharing.
Thank you.
So we have seen we just watched Dr. Francesca go and create, optimize, deploy using Visual Studio Code and Azure Notebooks a deep learning model, and then she put that into the Azure Machine Learning Service and then called it from code. I, as a .NET developer, could then maybe consume that model, make that available to me in any way that makes me happy. I could use ML.NET to consume that. Whatever I want to build, it's available to me. Whatever language, whatever framework, whatever platform that you're committed to, we're committed to it too. We're going to support your languages with all the different tools, whatever makes you happy, whatever makes you feel productive. We're going to try to make those tools to turn your great ideas, whether it's a whiteboard compiler, or it's moving an application that is 10 years old to the future, or if it's a machine learning model for your dog. We've got you. Everyone is welcome. We want you to be happy. We want you to be productive. I hope this session helps you a little bit to understand the broad set of options that we've got available on the platform for developers. We explored happy and productive development. We saw how the cloud can be made easy. We saw how you can deliver intelligent applications using .NET, using your favorite languages and frameworks. And I want you to go out and learn about application development on Azure. You can go check out aka.ms/AzureAppDev and take a look at that new place that we've launched for cloud developers, launched today. If you haven't figured it out yet, we're not joking. Microsoft loves you. We like developers. That's why I work here. I got a whole day of awesome sessions. If you're watching this live, continue to watch. Tell your friends, twitch.tv/Visual Studio. We've got content for the next several hours. Take a picture of that slide, because there's a lot of great stuff from a lot of great people that's going to happen. Stay with us for amazing live coding sessions. Those are going to be on Twitch, on Mixer. Follow us at MSFT Connect on the Twitter. Thank you very much.
Oh my gosh, so great to see Scott Hanselman with all those amazing demos. He built and deployed an Azure service from a whiteboard. Love the keynotes here at Connect. And right now, if you're watching us on the live streaming channels, if you're on Twitch, if you're on Mixer, get over to that Twitch chat room, because now it's your turn to ask the question.
that people are increasingly giving us credit for is just the wealth of our development tools that are now work with every language and on every platform, married with that cloud platform is a really powerful 1-2 combination. And then for enterprises, we have a very unique story around hybrid computing. Sure. For people that are doing IoT and or edge-based scenarios, I think our Azure IoT services are very differentiated. We're seeing some really great results with some of our AI capability, in particular around speech and image recognition, that are very differentiated versus, say, AWS or other cloud providers. And you'll see us continue to really push hard on, really enabling people to be more successful, and ultimately customer success is really, I think, the top measure that we aspire for.
Cool. All right, so questions are coming in. By the way, we want your questions. I have 1,000 questions that I could ask, but I'd rather ask your questions. The first is, are there any plans to bring the new GitHub PR integration into VS 2019? For example, the code review features for Azure DevOps.
Yeah, so I mean, the nice thing is, and we showed it this morning, both in VS Code and VS 2019, both now have native GitHub integration. And so, yeah, you can do pull requests directly inside the IDE. You can do code reviews directly inside the IDE. We even, with VS 2019, when you first launched the tool, instead of just launching into a blank IDE, we actually, the opening dialog even has the ability for you to select any Git repo or any GitHub repository, paste it in, boom, you just in. And so, yeah, we were definitely trying to make that Git and specifically GitHub integration super first class, and I think you'll be pretty happy with what you see in it.
And that's cool. By the way, if you're not using source control, please do. I've lost like weeks worth of work because I didn't do that. And it's cool that we have all these tooling to help people do that as the default.
Yep.
Which is kind of nice. All right, next question. Any plans for PowerShell support in the IntelliCode functionality in VS Code and VS 2019?
It's a good question. I don't know where, I have to confess, I don't know if we have IntelliSense support with PowerShell yet. But if we do, then I think the IntelliCode support would be pretty easy for us to enable.
Right.
So yeah, it's great feedback, and it's definitely something we should follow up on. I know we do have IntelliCode support now for .NET, Java, Python, Node, TypeScript, JavaScript, and C++.
Which is a lot. I mean, I just saw basically the IntelliCode, Francesca did a demo where there was IntelliCode on TensorFlow, and I was like, holy cow, that's amazing. Yeah. Okay, next question. Are there any plans with Azure Stack to bring Office 365 or any other SAS service over to it?
We're certainly adding more and more things to Azure Stack. And so, expect to see more of our first-party services run on it going forward. We haven't really announced anything specific with Office 365, but we are definitely doing work to add more and more functionality on top of Azure Stack. And pretty much every 6 months, you see more services show up on Azure Stack. And we see just a ton of excitement and energy around it. So it certainly could be possible in the future.
So there's some more GitHub questions, but before we go there, I wanted to see if I could clarify. Microsoft bought GitHub, but GitHub is its own thing. Is that right? I mean, how would you explain the relationship there between GitHub and Microsoft? Because I know Nat gets a lot of questions about that.
Well, yeah, I mean, we're super excited to have GitHub be part of the overall Microsoft family. And I've always been tremendously impressed with the work that GitHub's doing.
Of course.
I think, anytime you have an amazing company like GitHub, you want to make sure that, and especially one that has a real responsibility as being a community for developers of all platforms, you want to be very careful with how you manage it. And that's why, we've decided to keep it as independently run. And so Nat works for Microsoft, he works for me, but he's the CEO of GitHub, and we have sort of kept the GitHub structure independent from the rest of Microsoft, similar to what we've done with LinkedIn. And that's partly because we want to make sure that they maintain that independence, and that we're a good steward of the broader open source community, and making sure that people recognize that independence and recognize the fact that GitHub's going to support every platform, it's going to support every cloud, it's going to support every device. And so it is part of Microsoft, but at the same time, you'll still see it kind of managed separately, similar to what LinkedIn has been, and it's worked very well for us with LinkedIn.
Awesome.
And our top goal is really take care of developers that are on GitHub today, to grow the GitHub business and help support them. And I think we're off to a good start, and I think Nat's doing a great job. And customers are already noticing, wow, GitHub's getting a lot of feature enhancements that have been asked for a long time, just in the month since it's actually been part of Microsoft. And we're spending a lot of time on making sure that that again we do a great job, and that we are super responsible in terms of taking care of that community, which is an incredibly powerful, vibrant community.
Yeah, and so I wanted to couch that because we're getting some GitHub questions, and I felt like maybe there should be a clarification, and that's awesome. Are there any plans to partner with GitHub and add Roslyn-based support for code navigation? For example, click to jump between classes, methods, etc., for the major languages.
It's a great feature request. I think you will see, the nice thing we have now, both with the Visual Studio family of tools, so both VS Code, which is built on Electron, which is originally built by GitHub, and obviously the full VS is, we do have very rich language services and just a ton of wealth in the IDE, and then GitHub obviously has a ton of wealth as well, and so in terms of capabilities and richness, and so you are definitely going to start to see more and more fusion of those capabilities, so that if there's unique things like code navigation that we have in VS, how can GitHub optionally, if they think it makes sense, take advantage of it? And then even today, you saw a lot of how we're taking the richness of GitHub and the community and the collaboration, and making those extensions inside VS and VS Code optional. We're never going to force people to use either side, but we do think there's huge opportunity to make that experience even tighter. And I'm excited what we've already done, and stay tuned for more things like code navigation and other things in the future.
Awesome. Here's the next question. Should SSRS or reporting slowly be migrating toward Power BI, or are there improvements coming for SSRS that won't be provided with Power BI in the future? That's a really specific question.
Yeah, so SSRS, we don't know, are SQL Server reporting services. And it's a super popular way that you can go ahead and create reports. Often sort of think of as printed tabular reports, where people want very fine-grained levels of customization. Where Power BI has historically been more around data visualization, and so you can think of it as charts and graphs, versus SSRS sometimes is used for kind of much more tabular reports. They're built by the same team, and so you are seeing more and more integration between the two. And so I do think you'll start to see that SSRS functionality natively provided inside Power BI, but we'll continue to have SSRS as a separate product as well.
Cool.
And there's a super vibrant community, but we want to make sure that community can also, if they want to, publish using Power BI and take advantage of that as a cloud service as well.
Cool. All right, more questions. Azure is a great platform, but as an individual, it can be difficult to test complex scenarios without spending, and they put $3 signs, which I believe on Groupon means it's going to cost a little bit. Are there any changes on the horizon that have a cheaper dev layer for very basic testing?
Yeah, we do a couple things. I mean, it's a great question. One thing we are trying to do is make sure for all of the different services we provide, how do we have entry-level tiers? And so, for example, even with like Cosmos DB, historically people would say, I love Cosmos DB and the capabilities, but I don't want to spend $200 to, for a low-volume site or do testing. One of the things I announced in the keynote today is sort of a $24 a month option. That's if you run it all month. And we also now have kind of free 30-day trial editions that you can take advantage of. And so we are definitely looking at how do we make all of our services available in a more entry-level way, which helps both with just exploring and using, but also certainly helps on the testing. We then do also have MSDN. And so if you are an MSDN subscriber, we do give you free Azure credits each month. And those can be up to $150 of free Azure credits that are particularly useful for testing and for dev test purposes. And so that's another mechanism that we're providing, in addition to kind of lowering the costs, is just to also give people free credits that they can use as part of their development process. And so if you haven't checked that out, definitely recommend. But every MSDN subscriber, whether you're pro or whether you're enterprise, comes with these built-in credits, and they can save you a bunch of money.
Yeah, I know that a lot of the demos that I build use the built-in credits, because as an employee, I get one of the subscriptions, and I've never gone over quota. I might have gone over on some of the internal ones. Don't tell anyone, Scott.
Okay.
Just FYI. All right, any plans to have Mac OS VMs in Azure? Related question, I can use Mac OS Build Agent in Azure DevOps. Does it need to run in Azure or some other way?
Yeah, for the build agent that we use for Azure DevOps, so one of the nice things with Azure DevOps is it supports doing CI/CD, whether it's through the Azure DevOps code repository or now through GitHub. You can kick off a build every time a pull request or check-in happens. And we support Windows, Mac, and Linux as build agents. And so the question here, first of all, is the Mac builds are actually done with Macs that are racked in a data center. For that build DevOps, and it's not only so you can do Mac applications, but for iOS applications you need to compile them on a Mac,
sure,
because the tool chain only works in a Mac, and so probably the most common use case for that is actually for building iOS apps. We don't right now support kind of virtualized Macs that you can rent by the hour. Instead, they basically run in just that DevOps configuration. It's a little tricky managing Macs in that type of environment, which is partly why we haven't general purpose the virtualization layer yet. But it's good feedback and something I'm sure we'll keep looking at.
Awesome. This is a more serious question. What is the HTML color for Scott's shirt?
I better say I don't know.
FF0000, right? RGB? FF0.
I'm not sure if it's perfect red or at some point there's probably some color app we can use.
Did you just one day wear a red shirt and now you have to wear it all the time? Is that what happened?
Pretty much, yeah. I gave a talk in 2007 at one of the Mix conferences that went well, and I was wearing a red shirt. And I just thought it was a lucky shirt. And so the next year I gave another keynote and I said, oh, this shirt worked last time.
Yeah.
And so I wore it again, and it became a bit of a tradition. And now if I don't wear a red shirt,
they think you're sick or something.
Or people yell at me, and I get tons of abuse on Twitter. Not serious abuse, but people are don't pay attention to anything I say. They just ask me why I'm not wearing the red shirt. So now I feel like I have to wear the red shirt every time I present.
I'll be honest. I've been in meetings where you walked in without a red shirt, and I was like, where did they put Scott, and who is this imposter? But then you started talking.
I don't wear it every day, but I probably wear it at least 2 times a week. And then
Really?
I wear it for every talk I give.
If I wore the same shirt, my wife would be like, hey, look, get out. Gotta buy it.
I do have 15 or 20 of these.
You really do?
Red shirts. Yeah. I don't wear the same shirt. I mean, I do wash it. Yeah,
Okay.
Thank you.
Okay, well, that's important. All right, next question. With VS19, are there plans to be able to offload some of the work it does to background tasks or completely separate threads for large solutions, which will get stuck or take an extremely long time?
There's a lot of work that we've done pretty much with every release of VS to do a couple of different things. One is we're making more and more Visual Studio out of process. So I remember when I first started working in Visual Studio, everything ran in one giant process because back then processes were more expensive.
Right.
And I distinctly remember sometime about 10 or 15 years ago where we just ran out of address space.
Oh no!
In that process because we just had so much address space loaded of different libraries and things like that. And so we've steadily moved things out of process. So it's sort of like a background task. You can think of it. It's less of necessarily a thread, but how do we basically isolate the processes, which has helped for a bunch of things. And so some of the compiler services, some of the language services, some of the Azure tooling now runs out of process. And the benefit there is it does enable VS to get even more fast and responsive and scale, especially to take advantage of more processors. And so, yeah, you'll see that even in VS 2019, we've done that more. And solution load time is a key area that we've invested in specifically with VS 2019. And hopefully try out the preview and give us feedback, but you should see it load much, much faster.
It looked pretty zippy when Scott did it. Another important question. If you do well at Microsoft, do you have to change your name to Scott?
If you do really well, you do.
Yeah, of course.
Yeah,
okay, well, at least my name has 4 letters, so I'm working on it. Next question, what is the best IDE for .NET development on Linux?
The best IDE for .NET development on Linux? Probably VS Code at this point. Yeah, I mean, VS Code is, and we showed it in the keynotes. VS Code is pretty amazing in terms of just seeing the adoption and groundswell of it.
Yeah.
Both for .NET, but impressively for non.NET. And I think at this point, VS Code is probably now, for non.NET developers, the most commonly used development tool on the planet.
Which is, that happened really fast. Did you just wake up one morning and someone said, hey, here's your newspaper, and also here's some news on VS Code? I mean, how did it happen so fast?
The team's built a great product.
Yeah.
I mean, I think we introduced it about 3 years ago.
At a Connect.
At a Connect, yeah. And it might have been Connect 3 years ago. And so it's been awesome just to see every year it's gotten richer and richer and better and really kept that core code-focused ethos. And and what's great is it works on Windows, it works on Linux, it works on a Mac.
And it has a really nice ecosystem.
Yeah, it's a great ecosystem, monthly releases, and I think it's the #1 followed project in all of GitHub. And that was before we bought GitHub.
Nice.
So it wasn't something that we arbitrarily
So we're not
did.
cheating. We're not
cheating.
boosting.
Yeah.
We don't boost scores, by the way.
But,
they run their own stuff over
But
there.
even if you look not just at Microsoft conferences, but Amazon had their conference last week, and they highlighted VS Code in one of their keynotes, and Google ends up using VS Code in their keynotes. So it's great to see, and it's not like we're sponsoring either Amazon or Google. But it's great to see, developers want to use great tools, and it's awesome to see everyone's adopting VS Code and VS.
Awesome. Next question, how will the Azure API Management Consumption Plan compare to the standard plan? Azure API Management Consumption Plan.
You might have stumped me on that one.
I don't know what that service is.
I think it's a new billing model that you can use, which is actually purely consumption driven. I think, and I could be wrong, but I think this feedback's coming from people have loved our API management service, and we've seen a whole bunch of enterprises adopt it and had a lot of success with it. But the entry level for that plan, if I remember, started at a couple $100 a month for the standard plan. And I think this new consumption plan now gives you a much lower entry, kind of similar to that question we had a couple ago about helping with testing and things like that. And it's great for lower volume use cases where you don't want to have to start off by paying a couple $100 a month. If you're a large enterprise and you're doing billions of API calls per month, you're probably just going to stick with the existing plan, the standard plan you have. But that consumptive plan is very good for very elastic cases, and particularly good for people that are just getting started and don't want to have to pay up front for something that they're not going to fully use.
Right. That's amazing. All right, next question. Was VS Code written from the ground up, or did it use Studio as a base?
It's a little bit of both. The VS Code editor was written from the ground up. So the core development tool was all written from the ground up. Having said that, we have leveraged things like Roslyn, which is our language service, the debugging, some of the debugging engine hooks inside VS, and several of the other services. Those places we've reused some code, and we've built them in such a way that we just have one team build one module, and it can be used inside both the VS IDE and VS Code.
Right.
So we don't have two separate teams building the same thing. But the core VS Code itself was written from the ground up.
Yeah, and I'm starting to remember now because I had Eric Gama on at a Connect where he explained like Roslyn is running out of process in this thing called OmniSharp, and when you build extensions, that's why it's so zippy. Everything's running somewhere else, so you're getting really good experience.
Yeah, I mean, the nice thing about the Roslyn or the VS Code architecture, and this is again what we're also doing inside VS now, is because you can run extensions out of process. It also just means that extensions tend not to conflict with each other.
Yeah.
Or frankly, more specifically, when an extension screws up, it's really easy to identify which extension. And I think we've seen other development tools, and even VS historically in the past, you get one extension that slows everything down, and it kind of gives everyone a bad rap, and developers aren't sure why something is slow. And that out-of-process model helps versioning, it helps reliability, and it also really, frankly, helps from a performance perspective, both be fast, but also identify which extension is not fast if you're having a performance problem.
Yeah, and I've had extensions crash, and it says, "Oh, hey, this extension crashed. Do you want to restart it?" I mean, it's very it's very subtle, but it's also very nice, as opposed to years ago in Visual Studio when an extension went rogue. It's like, why is Visual Studio taking 40 gigs of memory? You know, and it's not Visual Studio, it's something else generally. All right, next question. When are you planning to release Visual Studio 2019? Everyone always asks this question, and then the standard answer will come out almost every time.
Standard answer probably when it's ready, right?
Yeah,
or something.
that's right.
My guess is it'll be in 2019. I don't know if we have an exact date. I mean, we are trying to be quality driven. You know, today is the first preview,
right?
And so, you know, we're going to be looking obviously closely at feedback, but you know,
we usually go through 4 at least. I've seen 4 like versions of a preview at the last. I think that was the last Visual Studio.
Maybe last. It depends on the release. And then the other thing that's changed quite a bit has been, you know, we're much more agile. So that even like, for example, when VS 2017 shipped, we would do kind of quarterly major updates.
Yeah, I saw
and
that.
I think we did 4 or 5 or 6 major updates with VS 2017. And so, you know, that also means that there's not like a hard date when we have to say like everything is done. You know, instead we can be very quality driven,
right,
and release on that date the features that are ready, and then know, hey, the next quarter we can go out with more features when they're ready. And you know, I think that ability to have both predictable releases but also maintain the high quality and be very agile, you know, I think that is something we certainly hear resonate very well with developers.
That's cool. I mean, I do a lot of my work in VS Code now because I do a lot of Python stuff, and every once in a while I open Visual Studio and there's always like an update, which is pretty cool. It shows how agile we are in updating these things. All right, next question. Are there now any plans to port WPF to other OSs other than Windows now that WPF, et cetera, are open source? Are we planning on moving like WinForms and WPF to work on Linux, for example, or Mac?
We're not right now, at least at Microsoft, porting those libraries to other OSs. We do have obviously Xamarin, and that is designed to be portable, and Xamarin does support the same XAML standard that WPF supports. Yeah, having said that, now that these languages are open source, or these frameworks are open source, you know, we are going to have people that are going to be contributing. One of the first contributions we took, even in the keynote this morning, and he'd been working on it for a couple weeks because he knew about the announcement coming. But the pull request was extending the, you know, some of the theming support back to Vista and older operating systems, and that was an accepted check-in. So, you know, I do think you will see people take, now that it's open source, there'll be more of that technology that will become more available elsewhere because it is open source. And then Xamarin, we are investing in as probably the biggest area for how we're enabling cross-platform UX.
Cool, cool. All right, next question. When will Blazor become a product? I missed this announcement.
I believe we are effectively making it a product today. .NET Core 3 has the Razor composable components.
Is that what it's called?
No, I think I made it.
Yeah.
It's Razor composable UI, I think. But it's basically our single page application mechanism for how you can build single page apps in a browser all in C#. And so I think that is the technology that was Blazor, you know, with a new name. So I think that is part of .NET Core 3 Preview 1 today.
Okay, so you should download it and take a look. Next question, will Visual Studio 2019 be able to integrate with your own in-house Git repository, or is it limited to GitHub only?
No, VS 2019 has Git tooling that works with any Git repository, including your in-house repos. Now, some of the pull request integration is specific to GitHub, since standard Git doesn't sort of have, you know, GitHub has really popularized that kind of PR concept. But the core source control, Git lens, version control management, that's all built into VS 2019. It'll work with any Git backend.
Okay, so it's not just a GitHub thing, it's all Git will work.
Correct, yep.
All right, so I have a couple of questions. By the way, keep the questions coming. I love them. The first one is, many organizations are struggling to find ways to integrate AI into their applications. What are some suggestions that you have for easy starters for them?
One of the things that we showed in the keynote this morning is our Azure Cognitive Services, which is one of the easiest ways to start with AI. And we have a whole bunch of pre-built components that do speech to text, video transcription, sentiment analysis, and more. And that's one way you can add some pretty strong richness. And then Seth here did a demo showing using those cognitive services with our Azure search service. And so you can literally just dump a directory of files, whether they're images, videos, PDFs, and it will search index using AI, all that content. So that's a pretty easy way to get started. The other thing I'd recommend if you're a .NET developer is to check out the ML.NET library, which is a .NET library that, again, enables you to take advantage of a bunch of pre-built ML algorithms that you can apply just on standard .NET data structures.
Yep.
And that's a really easy way that you can effectively operationalize models inside any .NET app that you've written. And then we have more advanced tooling with our Azure Machine Learning service, with our Jupyter Notebook service we call Azure Notebooks, and our Azure Databricks offering that let you do fully custom AI. But I'd recommend starting with cognitive services or ML.NET if you're just looking to kind of get going and you aren't a data scientist, you don't understand the statistical background behind ML or AI, but at the same time you want to do something cool.
Yeah, just think of it as like a framework and call it.
Yep.
And I believe a lot of the services have like free 40,000 call. I don't know what the number is, but you have a free set of calls that you can do.
Yep.
And then the other thing that I saw, and maybe you can mention this a little bit, my understanding is there's a way to take cognitive services and lift and shift them down. And tell us about that.
Well, what you can do with cognitive services now is you can run them in the cloud as a service where we give you an API.
Right.
But then we also allow you to package up a cognitive service as a container.
Right.
And so you can basically take the container and run it on your local Kubernetes cluster or any Docker-enabled host that you have. And so that really gives you the flexibility to use our cognitive services anywhere. And if you use our tools to build AI models, you can also package them up as a container and run them anywhere as well. And so, there's very powerful apps that people are building where, for example, let's say they have a local camera.
Yeah.
And they want to do face detection or computer vision, and if you've got 40 frames per second or 60 frames per second, taking a picture, uploading the cloud, and doing reasoning on it, the latency and the bandwidth needed is just not practical. If you can run that AI model doing computer vision on the device, you can do that in real time and save yourself a bunch of money and have very, very fast latency and not have to have any bandwidth going back and forth to the cloud. And so, we're seeing a lot of people starting to take advantage of this containerization approach. And it's something today that's unique to Azure. The other cloud vendors sort of want you to run using only their AI services. And while we enable you to do that too with Azure, we think this container flexibility is a real differentiator for us.
It's pretty amazing though. I mean, especially with computer vision, sending pictures up to the cloud and then waiting for something back when it's happening real time is not good. And my understanding is we don't, like if you're running that in a container locally, we don't send any of those pictures up to Azure ever.
Yep.
So if you're working like in an environment like a hospital or a lawyer's office where the data needs to stay there, no worries. All we send back is how many times you called it.
Yeah. The nice thing is it's great both from a performance perspective and from a cost perspective because you're not paying for bandwidth and you get that lightning fast performance. But as you mentioned, it's great from a security and from a privacy perspective because you don't have to worry about these pictures are going somewhere you don't know. You have complete control over it. And you can even sort of make the guarantee to say if you're a retailer, for a customer that's entering your store, the data, their picture never leaves the store.
Yeah.
Which is a nice, in this day and age where we're all worried more and more about privacy, is a really nice promise to be able to make.
And the other thing is, and this is super important, is at Microsoft, we don't use any of our customers' data to build these cognitive services models, which is kind of cool.
Yeah, I mean, I think that's one big difference of our business model versus someone's business model that might be more ad-centric is, we make a very firm promise to our customers, which is their data is their data, and we don't look at their data and we don't use their data to try to monetize our own business.
Awesome. All right, a couple questions. What about Angular support in .NET Core 2.2? Will we see a good template with full working Angular CLI?
We might have that. I don't know. To confess, that one I don't know off the top of my head.
Cool.
We'll
That's
have
a
to follow
very
up on that.
specific version. I know there's Angular templates when you run Visual Studio, but I don't know if that specific version has one. If it does, great. If it doesn't, let us know. Happy to. All right, AKS, Azure Kubernetes dev spaces are great, but it is planned. Okay, is it planned for support developed with local Docker for Windows with Kubernetes?
Yeah, the thing, one of the things we're trying to do with AKS, and Jeff Holland did a great demo in my keynote. So AKS is our Azure Kubernetes service. Is how do you enable Kubernetes-based development and make it very fast and fluid? And a challenge is, as you move to microservices and containers, increasingly you've got a solution that might have 25 or 100 projects in it, with each project mapping to a container. And that experience when you press F5 in a local instance, go get coffee and come back as it's booting up. And if you've got an app that is designed to run on a 8-core, 12 gigabyte system, your laptop is just not going to be fast and fluid.
Right.
And so that's partly why we did this AKS offering, which gives you a way that you can actually do your Kubernetes development locally, but run and debug remotely. And that way you just spin up AKS cluster in the cloud, and on your local laptop you can be connected and you can make a change at F5. It just recompiles the container in question. It doesn't have to rebuild or recompile or relaunch everything else.
Right.
And you got this very fast, fluid experience that feels frankly like what you're used to from a development perspective over the last 20 years. And another nice thing then is you can have multiple developers sharing the same cluster, so that you have like one dev team environment and you might have 25 developers, and they can each see their slightly different slice as they're debugging individual components, but sharing resources. So it's great from that perspective. I think we might at some point enable dev spaces with Azure Stack locally, but it's, if you just want to run locally, you can use the standard Kubernetes tooling to do that. And so we do support that in VS.
Right.
But the real magic with dev spaces is this ability to leverage a remote shared cluster to enable kind of much faster developer workflows.
Cool. All right, so we have a couple more questions and we're running out of time, so we're going to go through these really fast. Are you seeing trends for devs to be specialists versus generalists? Is it becoming impossible to know enough about all Azure offerings to be fluent in everything?
It's a good question, man. I think the thing I'd recommend to people is be a generalist enough to know how all the pieces fit together.
Right.
This is true whether it's with Azure, with say .NET, or with other technologies of just, what is a NoSQL database? What is a relational database? What are the pros and cons of each?
Right.
And what are the raw capabilities? And then I'd pick a couple areas to go and become a specialist in.
Right.
Because as you mentioned, if you're just sort of an inch deep in 1,000 things, that might not be enough to do anything super well. But if you can at least understand broadly and then go deep on a specific area, that would be my kind of recommendation from a career perspective.
Awesome.
Whether
So
it's with Azure or anything else.
Yeah, all I know is that when I start Azure, like every couple of weeks, I see a new thing and I'm like, oh man, I barely am starting to understand the things that I know. And so it's pretty good. So just to finish out, we have about 90 seconds. What are some recent developments inside Microsoft you're personally most excited about?
It's tough. It's like asking, which is your favorite child?
Yeah.
I think, rather than talking about individual services, there's lots of products and services that I'm very excited about. Whether it's in Azure, whether it's in Dynamics, whether it's in Power BI, whether it's in Visual Studio, in .NET. There's tons there that I'm excited about. I think the part I'm more excited about is just sort of the openness and of how Microsoft's changed, and the fact that a lot of my announcements this morning weren't just that you can use open source with Microsoft tools. These are things that we've actually contributed back to the open source community, whether it's VS Code, whether it's a lot of the Kubernetes work with virtual kubelets, as well as some of the cloud native application bundling work that we announced today. And just the number of Microsoft teams and engineers that are now major contributors to open source.
Right.
We'll have more than 5,000 Microsoft engineers that will make code contributions to open source projects this year alone. And like that openness is a real change, and it is both helping us contribute better in terms of a broader range of developer communities, and it's helping us also take great ideas and make our products better. And so I do think it's something that from a long-term perspective is going to be great for everyone.
Awesome. So you have like a last-minute pitch for Azure. What do you want to say to developers about Azure and how they should get started?
Well, if you missed my keynote this morning, please go watch it. Whether it's around Azure or around developers. I mean, the first half of the keynote was primarily actually just around development and a lot of the tooling work that we're doing. But it's, I'm a big believer in show, don't tell.
Right.
And so if you just watch, forget the keynote speaker. He was okay, but
really good demos.
But the
though,
demos were very good.
Yeah, so good.
And it's nice that everything we showed you can now download and use today. And really look forward to seeing what you build with it.
Awesome. Well, I'm excited for our next guest. Thanks so much for being with us. Scott, we actually have Brendan Burns over there to explain Kubernetes to all of us.
Fantastic.
Thank you so much for your time, my friend.
Thank you so much.
All right, so I get to pick up my fancy water bottle with a straw and come over here to talk to the awesome Brendan Burns. I'm excited to ask him a lot of questions because I know about Kubernetes, but I don't know enough. So you're going to help me with that, is that right?
We'll try our best.
All right, so tell us about yourself for those that have been living under a rock.
Oh, well, I don't even know what's living under a rock. So I'm Brendan Burns. I'm one of the co-founders of the Kubernetes open source project. Kubernetes is a container orchestrator. It's basically a way of taking a whole bunch of computers and joining them together into a single shared resource, and then using those resources to deploy a wide variety of containers and put together what has been come to known as cloud-native applications. So, and then I work for Azure, obviously, and there, in addition to the Azure Kubernetes service you just heard about with Scott, I work on I run a bunch of other teams that deal with sort of DevOps and APIs in general, and open source, a lot of open source on Azure.
So I know there's a lot of devs that have heard about Kubernetes, and maybe I'm in this camp where I need to know a little bit more. How did you come up with that name? Or how did that name even come up? Kubernetes, I mean, it sounds like a future thing.
It wasn't me. It was one of my co-founders, Craig McCluckey. We've talked about this a little bit, but the project was originally called 7 of 9. So the original internal container orchestrator that we used was called Borg, because it's like the Borg, it's the Borg collective.
That seems more apropos, I think.
And so 7 of 9, if you've ever watched Star Trek Voyager, which is a way of admitting that I watched too much Star Trek.
Oh my goodness.
7 of 9 is like the Borg character in Star Trek Voyager, and so I originally called it 7 of 9 as the code name. And then it became Project 7, or as these names iterate, these code names iterate. But then we had to launch, and we needed a launch name. And we were thinking a lot, Craig actually was thinking a lot about, well, we were all sort of batting words back and forth, but Craig was driving to work, as he tells it. And he was thinking, well, what does it do? And Docker sort of had all of these sort of nautical, they had the whale, and they had sort of like, so there's a lot of sort of marine analogies going on. So he's like, well, it's like the person who drives the ship. Kubernetes is like the person who drives the ship. And so he looked up helmsman, the word helmsman in Greek, and and Kubernetes is Greek for it. We actually pronounce it wrong. I think if you're actually Greek, you pronounce it something like Kubernetes or something like that. But it's too late.
Everyone's been saying it wrong.
Yeah,
it's too late.
It's our fault. So it stuck, and we launched from there. And it turns out, in retrospect, it's actually also the root of cyber and cybernetics. So the word cyber actually comes from Kuber in Greek. And it totally looks like we planned it, and we totally didn't.
No, we're going to delete this in post because you totally planned it.
We totally planned it, yeah.
So with the advent of this new kind of technology recently, there's a lot of terms floating around. I'm hoping, because this is Kubernetes for the clueless.
Sure.
There's we have Kubernetes, we have images, we have containers, we have Docker. Can you make sense of that for us? I mean, help us out.
Yeah, I mean, so I thought maybe we would do a little whiteboarding.
Let's do it.
If that works.
Yeah,
so,
let's do it. Let's go to the screen
here.
Let's
go to the screen here. Hopefully this will show up. And I'll turn it a little bit so you can see there. But hopefully we're broadcasting this out to everybody. So
Are
they're
you
not
on a
looking
Surface Go right here?
I am on a Surface Go.
And you're doing like a distributed computing talk here on a Surface Go.
I love my Surface Go.
Man, this is amazing.
I totally love it.
This is amazing.
I walk to work a lot, and so
Okay.
like the fact that it's 1.5 pounds is just it's life changing.
All right.
All right, so when we're talking about a container, there's actually sort of two parts of the container. There's the image.
Mm-hmm.
I wish I had my pen. And then there's the kernel. I should just not spell words. Kernel. Yeah, I should just not spell word.
No, this is okay. I love it.
But so the image is actually what a lot of people are thinking about, because when you used to build things on a VM, if you had a VM here, you have like your app here maybe and some shared library, and maybe you have a couple of different apps, and they both depend on the same shared library. And now you're in this sort of thing that people call DLL hell or dependency hell, where it's hard to upgrade one application because two applications depend on the same thing, and you make a little change, and it has all these downstream effects that break things. And so people got into containers a lot because they were really interested in separating the images so that you could have multiple different images, and they ran on the same kernel, but all of the dependencies are up here in the image. All of the things that you need, so these images become very hermetically sealed, and so you can upgrade each one independently. They never interfere with each other, and they're also isolated from a resource perspective. So in terms of RAM and in terms of memory, they have totally separate sets of resources that they're using, and so they are isolated in a way that makes them easy to use. So that was sort of what got people into containers originally, because if you think back to the days of VMs, it was really hard to manage. You ran all these scripts, they failed, and after it failed once, could you run it again? Maybe, if you built the script right. It's very hard to understand why it broke, how it broke. Whereas with a container image, it was idempotent. If it didn't work, you just installed it again. If you upgraded, you didn't worry about stuff left over from a previous version messing around with stuff. So that's really why people started getting into it. But again, this boundary here, this is all just one machine, right? Like it's all just running on one machine. And so, but most systems, when you're building these distributed applications, they need to be on multiple machines.
Right.
And so that's where an orchestrator, so I'll erase here.
Let me pause you there for a second, because one of the things that sometimes I conflate or get confused with is the notion of an image versus a container. Is it the same thing, or what's the difference?
Well, container is this word that's gotten kind of overloaded.
So help me out. Maybe you can demystify it.
Sure. Maybe I will. I'll try and draw a different picture here. So there's sort of two different pieces. There's the cloud.
It's very cloudy.
It's very cloudy. I'm going to try and draw a laptop here. There's my laptop.
Holy cow.
I know, it's not bad, right? The degree in art.
That's
I'm not even kidding.
Oh, really?
Oh, yeah.
And you got into distributed systems from art?
It was computer science and art. I have a double major in computer science and art. So anyway, you do a bunch of work on your laptop, and you build up a container image. And you can think of a container image really as basically just being like an archive. It's really just a bunch of bits, binaries, files, all kind of smooshed together, right? So you have that image here.
And so image is the same as container?
Well, it's a container image.
Okay.
So I guess maybe the right way to say this is it's like a class versus an instance.
Okay.
Right? So like the image is the class. The container, the running container is the instance.
Okay.
Right? And so you take the image, you push it up into the cloud, into the registry, and then on a bunch of different servers, you can run that same image. And then they're running on the kernel. And so you have a bunch of, if this is your class, you have a bunch of instances running on different machines.
And in this case, an instance might be a whole software stack, for example, for running a service.
Right, and the reason they're called containers is that, effectively, if you, inside of the kernel, so like the kernel has things like the easiest thing to think about is like the process ID space, PID space. So every process that runs has a number associated with it. Typically, on a normal machine, there's only one of those.
Yeah.
Right? There's only one process 1, there's only one process 2, there's only one process 3. With a running container, you actually create a separate PID namespace for each container. And so there's actually there's a process 1 in each of those.
I see.
And they can't see each other. And so that's why they're that's the running container part is this like isolation inside of the kernel.
That's cool.
To keep the applications apart from
and
each
you
other.
keep talking about kernel. That basically means the OS, the operating system.
Well, you have to be very specific.
Okay.
It actually means kernel.
Okay.
Right? Operating system is also a vague word, it turns out. Because like an operating system is the combination of the kernel and the user space.
Got it.
So like, you look at like an Ubuntu, it's going to ship a kernel. It also ships things like bash.
Right.
So the bash isn't in the kernel. It's an application that uses the kernel. So with a container, all of the user space stuff, all of bash and all of that kind of stuff, it's in the container image.
I see.
But the logic that implements like accessing a file or accessing a disk, that's in the kernel. Cool. And what's important actually is that logic in the kernel is shared between multiple containers.
I see.
And that's actually important because it means that the containers themselves are actually not secure, right? Because they share that kernel. If there's an exploit in the kernel, I can jump out of my container and into your container.
I see, with like a funky system call.
With a bad system call or whatever, right? And so it's really important for people to understand that containers are there to sort of keep us from stepping on each other. But they're not there. Like if you're malicious and you're mean, I'm not letting you run a container next to me.
I see. So it looks like when you're running a container, it thinks it's, because like every process when it's running, it thinks I'm the only one running because I'm the best one. And then you swap it out and it's suspended. And same thing with
idea, but applied to the file system, applied to CPUs. So you can lock them. You have a multi-core CPU. You can lock containers to different cores. So you can say this container has exclusive access to this core. This container has exclusive access to that core.
Okay.
The operating system normally would switch you back and forth, but if you're locked, it won't, and it'll protect your resources that way.
That's cool. So now that we understand that we're making these logical things called containers that have functionality, that they think they're the only program running, then we need to start talking about two things, and hopefully you can help me with this because I always have a hard time with this, is how small, because some people might put like their SQL Server all the way to their ASP.NET application in a container, but that feels wrong.
Yeah.
And some people might put like a single function into a container, but that seems wrong as well.
Yeah.
How do you know what granularity to use, number one? And then the second question, which I think gets to Kubernetes, is how do you start to manage how these things live with each other?
Yeah, for sure. So, in answer to the first question, in some ways, I said it's like a class and an instance. It is kind of like designing classes. Like you could almost say the same thing about objects in Java or whatever. Like how do you design the right object? But there are guidelines, right? And so generally speaking, the container is a unit of scaling.
Okay.
Right? And so you talk about your Java Tomcat server and your database. Well, if you put those in the same server, you probably can only create one container instance. Right? Because you don't want to create lots of copies of that database. You're only going to have one instance of that database. So now you're restricted, your horizontal scaling of your web server is limited by the fact that you've placed it in the same container as your database and you can't scale your database, right? So generally you would say, I want to separate the web serving tier from the database because I want to have 10 copies of my web serving tier, but I might only have 1 or 2 copies of my database.
Right. And one is a fallback and one is a primary.
One is a fallback and a primary, and if I'm living dangerously, maybe I just have one.
Right.
And so that's what you're thinking about, right? It's how do I break things apart into horizontal scalability? I think the other thing to think about is the container image itself often becomes an artifact that is produced by a team.
Okay.
And so if you want to decouple your teams, oftentimes you decouple them by having them produce different container images.
So it's not just a technical thing, it might be an organizational thing as well.
Correct, and so you're sort of, the same thing with like object-oriented programming, and classes come in because you might want to have an interface that separates 2 teams. And you might do that just to build better teams, right? And I think in general, Kubernetes was trying to build these abstractions that allow you to decouple your different pieces from one another.
Awesome.
Right?
Well, I've heard the saying in computer science goes that when you have a problem and then you solve it with distributed systems, now you have 2 problems.
10 problems.
Sorry. Yeah, 10 problems. So how does Kubernetes help with orchestrating? Because that's what it is, an orchestrator.
Right.
Because some people, and I confuse this, and maybe you did too at home, I confuse Kubernetes with like actual making containers and being Docker, but it's not.
No,
it's not Docker.
Not at all.
So tell us about that.
No. Well, Docker kind of straddles the line, but because it's both the builder and the run. And I think one of the reasons I have this trouble with container and container image is Docker is actually both the thing that builds the image and the thing that runs the image.
Yeah.
and that confuses people.
Yeah.
No, so an orchestrator is really intended to provide tooling around. So the container, I call it the runnable thingy. It's like you imagine you have this black box and you can press a play button on it and it plays.
It runs.
Right, and it runs. But there's all sorts of stuff like, what happens if it stops running? What should you do? How do you know it's healthy? What if I want 3 copies of it? How do I bring load balance traffic to it? All this kind of stuff. That's how. That's what Kubernetes provides.
I see.
Right, and there's actually a series of examples that we could step through.
Let's do that.
You want to do that?
Before
All right.
we do that, though, there's a couple of questions.
Sure.
There's lots of chatter on serverless versus containers and what to use when. What do you suggest before we dive in?
Well, so I think it's important to distinguish between serverless, meaning I don't have any servers, versus functions as a service, which is a programming model. Right? And I think they got kind of conflated.
Yeah.
Right? But we actually in Azure offer serverless containers. Right?
Oh.
So Azure Container Instances is serverless containers where you give us a container image, we run it for you. But it's like infrastructure as a service, right? It's like, we just run it. It's like you gave us a VM image and we ran a VM, but instead you give us a container image and we run your container.
I see.
But it's not, we don't tell you how to program, we don't tell you what language. Like functions as a service, there's only a certain number of programming languages you can use, a certain amount of memory you can use. There are none of those restrictions in our serverless container offering. Right?
I see.
It's IaaS. It just happens to be IaaS where you don't see a machine.
I see.
Right? And then there's functions as a service, which is a programming model, event-driven, on-demand. It's a way of, and tooling, easy to use tooling, makes it really easy for you to take a piece of code and push it up into the cloud. So I think it's important to distinguish between those two things. I think that I see functions as a service being really great for webhooks, for
the internet glue,
or like, hey, something asynchronous happened on some queue. Somebody uploaded a file, and I want to do something in response to somebody uploading a file. I think containers are more oriented towards longer running processes or large scale serving, where you have thousands or hundreds of thousands of requests a second, and you just need to have something that's running all the time.
I see.
That's a place where containers are more useful. I think ultimately when we look at the apps of the future, what we're going to see is people are building with a mix of containers, functions as a service, and data stores.
How do you manage them together? And then now we can get into the
Kubernetes.
Kubernetes.
That's Kubernetes. And in fact, actually today we just announced the preview of virtual nodes for Kubernetes, which basically takes that serverless container infrastructure and marries it up with Kubernetes orchestration. So you can actually orchestrate the serverless containers using the Kubernetes APIs. So you can either decide, do I want to deploy containers to VMs or do I want to deploy containers to the serverless container infrastructure?
Oh, that's amazing, because then you don't have to worry about, because usually the first time I set up Kubernetes, and I did one time, and because I went through the tutorial, like all good people do, I had to set up VMs to do stuff.
Yeah.
But with this, there's no VMs.
There's no VMs. It's all Azure service. It's all in Azure service, and there's no, we do all the upgrading of the OS. We manage the OS for you. If a machine fails, it just moves over to a different machine. All that stuff.
Can I choose like a machine that has a GPU on it yet?
We have GPU in Azure Container Instances, not in the virtual nodes currently.
Okay,
but
cool.
Yeah, it's coming.
All right, let's take a look.
All right, cool. So I have a simple little YAML file here. So one thing you'll see actually is Kubernetes loves its YAML. So when I see here, I'm describing the containers that I'm going to run.
And so this is the file. I'm sorry to interrupt you. Just so I want to understand. This is the file that says, here are all the images that I want to run in this application.
In this pod, which is one sort of atomic scheduled thing, one replica of your application.
Okay.
So this is only just running a single instance, not running multiple instances. There are other primitives for creating replicated things, 3, 4, 5, 6, 7.
Okay.
We'll talk about those in just a second.
Cool. Let's do that.
All right, but first we're going to create this pod. So I'm going to say kubectl create -f.
And what this is doing is this is getting all of those image definitions and getting them ready to run as containers together.
It's actually making a declarative statement to the cluster saying, please run this. Okay. I want this to exist.
Okay.
Right? And so then, having done that, if we say kubectl get pods, you can see that we have this one up and running. It's been running for 17 seconds.
So this basically, when you create it, it's getting all of those images, creating containers, running
Downloads them. Yeah.
Okay.
Runs it on the orchestrator.
And then the pod represents like a logical unit of containers together.
Yes. Yeah. And the reason it's multiple containers is you might have an application container, and then you might have a container that's doing something like log forwarding. So it's reading the logs off the application, shipping them to Azure Monitoring or something like that.
Cool.
So then Kubernetes actually has a lot of tools for sort of debuggability, including the ability to port forward. So that server is running, it's not on the internet, but it's running on port 8080. And actually, if we go back over here, you can actually see, you can see its IP address. So there's its IP address, which is inside the cluster.
I see.
But then I can actually port forward it, which means that I'm going to port forward traffic from my local machine here out into the cluster, so that I can play around in my application without it being exposed to the internet.
Okay.
But I can do development, I can push it up, I can run it, test it without it being exposed to the internet.
That's cool. And while that's going, just a quick question, because I've been able to do like Docker run and be able to port forward,
right?
You know, so I could expose it. This is more like Docker run, but with multiple images.
And well, no, but more importantly, connected to the cloud.
Okay.
This container is executing in an Azure data center.
Oh my goodness.
And so the port forwarding is bringing the network from the Azure data center down to the local machine here.
Holy cow, that's amazing.
So this is the Quar demo, which is the Kubernetes Up and Running book that I wrote with Kelsey Hightower and Joe Beta, who's one of the founders. It's kind of a way of like exploring some of the features of Kubernetes.
Right.
And in particular, we can go over here and take a look at this liveness probe. So one of the ways that Kubernetes makes it easier to run these distributed systems is it will automatically restart your application if it fails, right?
Oh, cool.
And not just if it crashes, but actually if you define it as being unhealthy. And the way you define it as being unhealthy is you can say, hey, please hit this web endpoint. If I return 200, I'm healthy. If I don't return 200 or I don't return anything, I'm unhealthy, and I want you to terminate me, right? And because that's good because maybe you get deadlocked or you get overloaded or something bad something bad happens. Your process is still running, but you're not successfully processing web requests.
And you won't get like some beeper in the middle of the night.
Right,
to
and so
restart
you don't want to get a page and all sorts.
Mm-hmm.
You want the automation. The one way to think about this is, there's planes out there that fly by wire, right?
Mm.
Like you just literally fly them, and then there's things like, like the B-2 Stealth. There's a computer there.
Yeah.
The only way that thing stays in the air is because there's a computer driving it.
Right.
Kubernetes is the same way, right?
Okay.
Like there's a computer that's trying to keep your application healthy for you. So we can actually drop back over here, and I will terminate this one. I'm going to delete the instance that I have.
And this is running in the cloud. I mean, how did you map this all? There's like, do you have to like do something with kubectl in order to?
So when you create the cluster, you download this configuration file.
Okay.
And the configuration file gives you like the certificates and for accessing it.
Okay.
Actually, I use AAD for accessing it and the IP address and all that stuff. And then once it's done, but it's through AZ. You just say the AZ tool. You just say AZ get credentials, and boom, it's on your file system. You're ready to go.
Love it.
So then if we go over here to this health check one, what you'll see here is this looks similar, except for I've added this liveness probe, right? And so what liveness probe says is, I want you to hit this URL on my container to see if you're healthy or not, right? And it's going to probe it every 3 seconds. So you can see the period seconds is every 3 seconds. So every 3 seconds, Kubernetes is going to hit this endpoint.
Holy cow, that's amazing.
See if you're healthy. So we can run this one.
So like if you're making a Flask app, for example, you just have an extra function there ready and be like, yeah, I'm good.
Yeah, and you can do stuff. I mean, you can do more advanced stuff. You can check to see if you can talk to the database. Maybe,
that's true.
Maybe like, you have a connection pool and the connection to the database has screwed up somehow. And if you can't connect to the database, well, you can serve web requests, but you're not really healthy.
Yeah.
You'd prefer that it terminates you and you come back up and maybe you reconnect successessly when you terminate, right?
So healthiness is defined
healthiness
by the programmer.
is application defined by the programmer,
cool.
right? And so just like we did before, we can do kubectl create chef. So we're going to create this, but now we're going to have this health check. And if we reactivate the port forwarding, and we go back over to here, I'm going to reload, go to the liveness probe. And what you're going to see here is you can see the health probes happening.
That's cool.
Right? It's every 3 seconds. You can see that it's 3 seconds. There's a 3-second interval. Now what I'm going to actually do is I'm going to set it to fail. So I'm going to set the health check to return 500s permanently. So we'll say it's permanently failing. You're going to see a 500 in there. And now what you're going to see if we go back over to the terminal, is, so if you saw here, there's 0 restarts.
Yeah.
Now if I do a kube control,
There's going to be a restart every 3 seconds.
There's, actually it's only once because it's in memory.
Oh, I see.
The fail always is an in-memory setting.
Got it.
So it fails once, but then it comes back, and I haven't clicked fail again, so it's healthy now.
Okay, cool.
Right? So it's got 1 restart. And so you can see there, like, obviously it's a contrived example with me setting fail, but if you had a real application health check there,
really cool.
it fails, Kubernetes creates it automatically.
All right, let's burn through some of these questions because people have some questions while they're going. Any plans on using Firecracker for better container isolation, or does MS contribute? I don't know what Firecracker is. Maybe
You don't know what Firecracker is?
No.
Oh, Firecracker is interesting. It's so AWS recently announced it's an open source, very thin container optimized virtual machine.
Okay.
It's actually very similar, almost identical really, to Hyper-V containers.
Okay.
So we've actually had Hyper-V containers for a couple of years at this point. Very similar idea. Because as I said earlier, containers aren't a security boundary.
Right, of course.
But the hypervisor is, and so what you can do is you can take a hypervisor, a really optimized kernel, very, very stripped down, very small, and so you can boot up something that looks and feels like a container, but is actually more like a really, really thin virtual machine. So it's secure. And so actually there's a number of projects here. Kata Containers by Intel is another one. And you can actually so you can integrate Kubernetes with these runtimes. So right now on Azure, you can run, using nested virtualization, you can run Kata containers and Kubernetes to have secure containers.
Cool.
And actually, Hyper-V containers is the infrastructure that we can use for something like ACI. So I think it's really great to see this kind of innovation happening in open source. It's great to see people thinking about this. I'm sure that we'll all collaborate on a single container runtime at some point.
Yeah.
So that's the way we work at it.
Great question. Next one. I don't know Kubernetes containers. Let's say I develop web APIs to connect with our mobile apps. What could be a reason to learn Kubernetes and implement it instead of using what I know and just host the API in a normal web service?
I would say if you're happy with what you're doing, you should stick with it.
And that's it.
Right?
I think this is important, right?
Right. Yeah.
Because there are new things come out and we're like, oh, we need to spend money doing the new thing.
Yeah.
At what point will this thing that he's or she's doing be like, you should probably consider now using Kubernetes? What are the smells? For people?
So I think if you're worried about agility, like you feel like you can't push code fast enough, or like rolling out your software is a scary experience.
Yeah.
I've talked to teams where it was like, yeah, we do a rollout once a month, and everybody's on call for the 48-hour period.
Oh my
and
gosh.
It's this like 10-page long checklist of like step by step of how I roll out the software, and it's like you're burning the bridge behind you. Like you can't walk back. Like you're like step by step. If you find yourself in that mode, if you're scared of deploying software, that's probably a good indication that like you maybe should think about some of this stuff. If you run into outage problems where you log onto a machine, you make some fix, it restores itself, but then you forget what you did to fix things.
Yes.
And you're developing these machines that are snowflekes. Like that's a good indication that maybe you should. But something like app services is already kind of immutable and has a lot. So if you're content with the limitations of app services, that's great, fantastic. Stay with it, right? I think Kubernetes will help you relative to app services would help you build, some sort of more multi-layer applications or take advantage of the open source ecosystem a little bit more. But like. Yeah, I would do it because there's pain. If you think that it will help with pain, rather than like, oh, we should do this. Like we want to be buzzword compliant.
You don't want to make pain for yourself. You want to alleviate pain, and if it does it, then you should do it.
Yeah.
All right, so we just did health check. What was the next thing you were going to show us?
All right, so I'm going to show you a little bit about load balancing. So when you're load balancing traffic into Kubernetes, it's this thing called a service. And if we take a look here, there's a service. The basic idea is this defines a load balancer that's going to target a bunch of containers. And the way that it targets it is this selector. My app is demo.
Okay.
And if you looked at that, the pod definition that we had before, it has, where is it? The label. It has a label right here that says app is demo. So it's like tags. So you tag a container, and then the load balancer looks for things with that tag, and it brings traffic to those pods.
Okay.
And so we can actually go and do. I'm going to delete because I'm going to. We're going to delete the one that we have because I'm actually adding a readiness check. I'll talk about readiness checks in just a second. You were saying?
Yeah, so as this is loading, I noticed that in your YAML file, are you defining, like, because I'm looking at your code, there's no code there at all. There's just YAML files.
Yeah.
Where are the actual containers coming from?
Well, that's the image. So the image I built separately.
Okay.
I pushed it separately. So the image repository becomes sort of an abstraction point between the build process and the deploy process.
I see.
So you do a lot of work to build your image, you test it, you qualify it, you push it into a registry. And then you deploy it using the YAML config. So you really have separated the act of building from the act of deploying.
And that's cool because then, for example, if there's a failure, a health check comes back as bad, it can roll back to a previous container if you tell it to do it.
You can definitely do that. And hopefully we actually have a demo of that too. And
let's do
it. So I'm going to show you the services first. So we can say kube control we'll create this container. And what's important in the container actually is in addition to this liveness probe that we saw before, there's now this readiness probe. And the idea behind a readiness probe is it tells whether or not the thing's ready to be part of a load balancer or not, right? So one tells you I want to be restarted. The other says, hey, I'm not ready to serve. Maybe I'm loading a big database file.
Right.
Maybe I'm still initializing and booting up. I want you to keep me alive, but I want you to not bring me any traffic.
Cool.
Right? And so now we can create that service. And when you create it already exists. So I must have left over from when I tested to make sure the demos were working.
And while you're typing this is actually really cool because I recently deployed to Kubernetes. I don't know, someone helped me. Lena, one of my coworkers, helped me deploy. We have a machine learning model that's using GPUs that we need to deploy. And having a readiness check is actually super useful because I'm loading a pretty big machine learning model.
Exactly.
And so I gotta put this in.
Yeah,
to the
exactly.
service.
So you see this service here, it's got an IP address associated with it. This IP address is different than any of the containers. So when you target that IP address, you get load balanced out to the containers.
That's cool.
Right. And actually, if you go back over to our app here, we can actually see in the DNS query. I probably have to restart port forwarding because I restarted the container. We'll restart port forwarding. If we go over here, I can actually say demo service and do a DNS query. And what you see here is that there's a DNS entry for that IP address. So in addition to creating a service to be the load balancer, Kubernetes has also programmed DNS for the containers so that when I refer to demo service, when I say like connect to demo service, it's going to use DNS to look up the IP address and connect. So I can actually use my services names in my code to connect my various layers of my services together.
That's cool. And that's just internal inside the pod.
Inside the cluster. And inside the all containers in the cluster.
I see. So you might have multiple pods that represent logical units of your application.
Yeah, they're grouped by services, load balancer, given a DNS name. And so like my front end connects to back end. It doesn't connect to a specific pod. It connects to the back end service, and the traffic is load balanced to all of the containers there.
That's really
right.
cool.
And so actually I can say, we can go back over here, and I can take a look at the endpoints. You can say kube control, it'll say watch.
Is it kube cuddle or kube control or
kube control, kube CTL. Some people say kube cuddle. I don't.
You heard it here first, folks.
No. Plenty of people, reasonable people will disagree.
Okay.
Oops, cancel. Get. And so there's the endpoints for my service, right? That's the container that it'll load balance traffic to. I only have one replica for right now, but you could have multiple replicas. But what I was going to show you is if I go over here and I go to the readiness probe, and you can see the probe coming through. I'm going to set it to fail. So it's permanently failing. It's going to throw 500s. If we go back over here, what you're going to see is in a little bit of time, it's actually going to get removed from the load balancer. So it got removed from the load balancer. So now I don't have any, which is bad, which is why I need replicas.
Right.
But like that entry got removed from the load balancer because it's failing its readiness check, right?
Wow.
And so if I go back over and I say, okay, let's succeed instead. Let's go back to succeeding. So now it's going to start returning 200s, hopefully. Yeah, so now it's starting to return 200s. We go back over here. It got added back into the load balancer, right? So that shows you that dynamically you can remove and add different endpoints from the load balancer, whether or not they're healthy or not. So you can ensure that you can do things like a zero downtime rolling upgrade of the service. So I can go from version 1 to version 2 with user traffic coming at me with no downtime, right?
That's really cool, right? Because like my service started failing recently, and now I can go in there and actually respond with, hey, this is not healthy.
Right.
Restart me.
Right. And we can actually I actually have an example.
Let's do it.
Do you have,
Yeah, let's do it.
You want to go through it?
Yeah, I do.
All right, so this is a little bit more of an involved example. I'm actually going to hide just so I have more screen real estate. This is going to use a deployment, and a deployment is a way of replicating containers and also rolling out from one version of a container to another version of a container.
Okay.
All right, so here we go. So we're going to take a look at that service. We were talking about services before. So here's the service for my deployment. I'm going to create that service. And then I'm going to deploy the deployment with V1 of my app. And so one of the things you'll see here is there's 5 replicas of this application. Version is V1. It's a really simple app, actually. All it is doing basically is it's catting V1 into this index.html, and then there's Nginx serving that file. But
Okay.
really simple.
Cool.
All right, so we're going to deploy that.
How are you getting it to type all that stuff? It's like Mojo.
So this is we have this demo script that was built because whenever you do demos, you always make typos.
Yeah,
Always.
no, I know.
Always,
It's
right?
true.
So it's really nice to have it be scripted. It's still live. It's still doing all the stuff live, but it's scripted and it runs it through a little tool that makes it look like it's typed. So I use it for I use it for a lot of my demos.
What's the tool called? Is it called AutoHotkey?
It's actually no. It's like it's hacked together with a bunch of little like Unix tools. It's a combination of it's this thing called PV, which is a Unix command line extension.
Sorry for the little.
No.
It's like
it's
demo
totally
or
cool.
to demo.
It's totally cool. No, it's I love it. I always feel a little bit bad because I have people come up to me afterwards. Sometimes they're like, "Wow, you type really fast," and I'm like, I have to admit to you that it was typed for me.
Cool.
All right, so we created that demo with 5 replicas, and now we're using this is Tmux to do everything together. So you can see here I have V1. I want 5 to be there, and I have 5 up and running. All right, and what you're going to see in this middle window here is it's hitting that, and you can see that the host names are changing, which shows you it's going to all of those different replicas, and it's getting V1 back. All right, so let's actually upgrade to V2. So I'm replacing the little one-liner to replace V1 with V2.
Man, with set and awk.
I know, you can do it all, right?
You can do everything.
You can do everything. So what you can see here, though, is like my V2 is starting to come up, right? And in here, you're going to see V2 and V1 mixing in, because now I'm in this mode where, let's escape. I'm in this mode where I'm rolling out from V1 to V2. So you see mostly V2 at this point. I've got 4 replicas of V2 running, only 1 replica of V1. And pretty soon we're going to get to a place where, so I have 5 replicas of V2, no replicas of V1. So I just did a rollout from V1 of my application to V2 of my application. No downtime. Done. Less than a minute, right?
That's amazing.
But imagine I don't like it. V2 is not where it's at.
No,
it's not where it's
V1
at.
is
V1, so we're going to roll it back. So we just say Q control, roll out, undo. And now a rollback is really just a rollout in reverse. And so what you're going to see here is now I've got V1, got desired V1, and this is going to start. V2s are coming down. 4 replicas of V2, 2 replicas of V1. We're going to keep doing that. Now you're starting to see some V1s in the load that's going to my service. You're seeing V1s start to pop up. And in another 15 seconds, we're going to have rolled back. So not only did we roll out with 0 downtime, we rolled back with 0 downtime, all while I'm sitting here chatting with you.
If you specify, like, is there a way to specify, like, if there's an unhealthy check on a rollout, to just go back?
It doesn't do the rollback, but it pauses. So that health check that we talked about, every time it creates a new replica, it waits for that replica to become healthy and ready. And you can actually set a period of time. Like, I want it to be healthy for 20 minutes, right? Just because you know from experience that it takes a while for problems to emerge, right? And so every time it creates a new replica, it will wait for that health check to go that long, and only then will it move on. And if the health check fails, obviously if it's failing the readiness check, it's not going into the load balancer, right? So you're not bringing any traffic to it. And if it fails the readiness check for too long, then the deployment is considered failed. And it aborts the deployment, and you can then have monitoring or whatever to say, hey, something bad happened here, or even automatically say, oh, rollback.
That's
You can detect it and then issue this rollback command if you want. Depends on sort of who you are and what you're building the application for. But I think it gives you an idea of like some of the power that's built into Kubernetes.
That's really cool. Like, look, traditionally this stuff back when I started programming was me basically rebooting a server and hoping for the best.
Yeah. No, we've come a long way, I think.
And this is pretty amazing. So for those that are new to this, where can they go to find this run through this demo themselves to make it work?
Yeah, so these demos are going to go up on GitHub in my repository, but there's also a lot of really great material on the Azure Kubernetes site on azure.com, as well as honestly on the kubernetes.io website has a lot of great material. There's a great Kubernetes Slack channel that for the whole community, like the entire Kubernetes, like across the world. There's 1,000, 2,000 people on it live, not just subscribe to the channel, but like live at any particular moment.
That's impressive.
Which is amazing. KubeCon's coming up in Seattle.
Oh shoot, when is that?
Next week in Seattle. It's sold out, unfortunately.
Oh,
but
do you need me to pick up chairs or clean toilets or something?
Yeah, it's convention. It's at the convention center. 7,500 people come to the convention center.
That's amazing.
It's amazing.
Well,
awesome.
Congratulations. This is amazing. We've really needed this in software development, I think.
Yeah, hopefully it helps. And I think there's more to go, but we'll keep working on it.
Awesome.
So.
Well, thanks so much for spending some time with us. Again, please stay tuned. We are going to take all of your questions. Right over there, we have my good friend Jeff Fritz with a couple of awesome people. You're going to see them right now.
Thanks so much, Seth. Oh my gosh. We had great announcements this morning. Lots of great stuff around Visual Studio, both 2019 and for the Mac. I've got Amanda and Uni here. I want you to introduce yourself so the friends out there in live stream land know who we are.
Sure. I'm Amanda Silver. I'm the Director of Program Management for Visual Studio, Visual Studio Code, TypeScript, Windows tooling, a whole bunch of different kinds of things.
Hi, and I'm Uni Ravindranathan. I'm a Group Program Manager on the Visual Studio for Mac team.
Awesome. So we've got great new releases folks can download for both versions right now and updates for VS Code. But what's new in VS for Mac?
Right. So before we start talking about VS for Mac, I just want to call out all the previews. I mean, the announcements today are all live. We highly encourage everyone to go try them out. Here's our preview page. One of the things about Visual Studio and Visual Studio for Mac is we've made it such that you can install the preview releases alongside your production environment and not mess up anything at all.
Yeah, that's huge, right? Because I want to be testing. I want to know what the cool new things are that are coming without breaking those things I need to build on a day-to-day basis.
Yep, and we tend to think of this as the foundation on top of which we'll start, publishing new features and updates regularly. We're really looking for some feedback on how things are going and, really adjusting to that feedback.
It's our viewers' opportunity really to get their voice heard. If there's something that works great for them, we'll enable that, we'll enhance it. If it doesn't work great, maybe we don't put as much into it.
Yep. So one main goal of this release, Visual Studio 2019, was to make it easy for developers to get started on their code. Okay. The code could be anywhere. It could be on your machine, but more likely you're working with someone else in a source-controlled environment. That could be a repo on GitHub. It could be a Team Foundation version server, running Azure DevOps or something like that. So we want to make it such that you can easily get started on your code.
Okay.
And for that, we have introduced a new experience to get started. Let me show you that first. In Visual Studio for Mac, we have a new start window that lists all of the projects that you want to get started. So here I have some projects on my machine, but I can always go to a repository, clone, and check out some code and get started there as well. In the interest of time, I'm just going to go open something on my machine.
Okay.
So here I have an ASP.NET Core solution from a repo that I found somewhere on the internet. It has essentially, this I think is the demo.
It's perfectly safe, isn't it, Uni? Perfectly safe.
This I think is the demo that we used in our last Connect event, if I'm not mistaken. I just didn't have access to our latest demos. So here is the Smart Hotel website. It's an ASP.NET Core front-end application.
I remember that demo, yeah.
Yeah, and that is backed by an Azure function that runs some serverless code to do some processing. One major investment that we're making in Visual Studio for Mac in the next version is to make our code editing experiences that much more reliable, fast, and fluid.
Okay.
We are actually rewriting the code editor from scratch, all using native Cocoa APIs that allows us to give really fluent experiences on the Visual Studio for Mac side. Combined with the work that we've done on Visual Studio, our language services that we're building for .NET, we believe we can provide a fantastic .NET coding experience on the Mac in this update. So you'll start seeing some of the improvements in the code editor, appear over the next few previews.
And I feel like that's a similar experience we've had with Visual Studio, 2019, 2017, and we've leveled up the performance of those code editors over time.
Yep.
And we're bringing that same knowledge now to VS for Mac and leveling it up, based on some of those things we've learned in full Visual Studio.
Yeah, I mean, historically, there was a lot of duplication of efforts and so on and so forth. I believe that the work we're doing here allows us to bring value to customers, both sets of customers, almost instantly across the two products. So here's an example of a C# file that I've opened, and I'm going to show you just a couple minor things. Most of these innovations and improvements will start showing up in the next preview for Visual Studio 2019. So here we have the light bulb experience that suggests a bunch of fix-ups. You could choose to sort of make an individual fix-up, or you could say, I want to fix a whole bunch of code issues together. If you choose the Fix All option, we provide you with a dialog that shows you all possible suggestions that you could act on. You could choose to select an individual suggestion. We'll show you a preview of the issue in your code and the fix-up, and then you can go make that change per se. So we want to make it possible for you to detect issues and fix issues very quickly in your code. Visual Studio for Mac has always had support for source control, but one major investment we're doing in the next version is to sort of rewrite our source control support as well. We will have support not just for Team Foundation version control, but definitely GitHub and every Git scenario as well. So source control is another major investment that we're making in Visual Studio for Mac. And finally, we have always had capabilities that allow developers to publish to Azure and various other web endpoints. We're making investments into that space as well. So for example, we just recently added the ability to not just publish to Azure, but to a folder, so you can then copy and deploy the code to your favorite server. We have support, we just added support for Azure Functions 2.0. So you can create a new Azure function and set up your trigger. So here's an example where I'm adding a new function. We have a rich wizard experience that lets you configure the function, lets you want to create a trigger, and so on.
As an IDE user, I love having that hand-holding experience that gets me from, I'm not quite sure what I'm doing, right through the wizard and published. Tremendous. Great to see that in Visual Studio.
Definitely, we want to take away the complexity from you and make it really simple to make it possible for you to publish to Azure. So that's something we're doing here as well.
Let the experts take care of that complexity for me.
Yep.
So I can focus on my knowledge.
Absolutely.
Awesome.
Amanda, do you want to show some of the things we have in the
Sure, yeah. I mean, so I just want to kind of reiterate some of the things that Uni was talking about, but in the context of the Visual Studio for Windows version. So what you see on the screen right now is actually the Visual Studio installer screen. And
I know it well.
And I think for anybody who works at Microsoft, we're constantly installing both the latest release and kind of the internal nightly builds.
Previews, dog foods.
Right, exactly.
Oh, yes.
So what you see here on my installer is that I actually have two internal builds. I have one for the latest Visual Studio 2017 update, as well as the 2019 preview. But this is basically the same exact experience that an external user would get. It's just they wouldn't see the little int there. But I needed to get this to get all the demos ready. I had to use the previews. I wasn't going to risk it by installing everything this morning.
So I can start installing that and do Visual Studio 2019 on my stream later this week, next week, and we can start live coding on Twitch.
Today.
Yeah, today.
Oh,
yeah. I
man.
mean, what's really great about this is, when I talked to, in fact, I was just talking with the development team, and they were talking about their process for adopting new tools. And typically what they do is they, pick a couple of developers on their team to kind of go scout it. Right? And so those devs do maybe a little project to kind of go see what the tool looks like and come back and do a report for the rest of the team. But this makes it really easy because, it used to be that you had to have kind of like a burner machine because you were too worried about it corrupting your developer environment.
Oh, yeah.
But now that we have the channels and we've done all of the work to kind of make sure that they can be updated independently, you're really not at risk to corrupt your dev box.
Good. Oh my gosh, good.
So that's thing one that's super cool. So now let's jump into 2019 itself. So as Uni was talking about a minute ago, we have the start window. So you can see, just like he showed in the Visual Studio for Mac experience, we also have a start window experience. And really there are two reasons that we did this. Number one is for users who are absolutely brand new to Visual Studio, and possibly users who are new to your development team, for example, we've gotten feedback that they are just drowning in complexity when they see the entire IDE. They kind of don't know where to start.
There's that intimidation of the blank screen.
Yeah.
You open it up and it's just that gray background.
It's just, there's just a lot. It's not just the blank screen. I mean, we have the start page, but even the start page, there's just a lot of information density that's in there. And to be able to absorb all of that is kind of intimidating your first time out.
Okay.
The other thing that we heard from a lot of more senior and experienced developers is basically that the Visual Studio, when it was originally designed, you probably remember this, you had to go to Best Buy and get 12 discs and install.
Oh my gosh, yes.
But the result of that was that not only was the product entirely contained in there, but all of the documentation and all of the templates were contained in there.
Oh,
so it was really this like self-contained package to start your development.
We used to get sandwich boxes to store those discs in so that we could carry them around because we were in
They're
college.
all collector's items now, don't throw them
Oh.
out. But there
If
were
I
also
only
the
knew.
books that came with it. I mean, you had like the whole getup was not just your machine; it was the entire physical aspect
you had a
of
kit
it.
that you brought with you. This is my Visual Studio kit.
But
Oh my gosh.
nowadays, what we find for modern development teams is that their startup experience, like when you're getting started on a new project or when you're a new developer joining a team, for the most part, they don't necessarily use our templates that are in Box. They actually start with an online hosted repo, right? And so what we're trying to do with the new start window is to make it so that it's a lot easier to kind of get started with an online hosted repo, and that's kind of the most predominant experience that we encourage you to use, right?
Sure, because my team members, new team members, I want to point them, here's where we keep our code, go start over there.
Right, exactly. And I think once you start to curate what kind of feeds you look at and other things like that, this is going to become really, really useful. But let's go ahead and actually try that. So let's clone or check out a repo. So I'm just going to copy this one. Oops. Copy that and come back here and just let's clone it. And I forgot to delete this, so we will just call this Desktop Taters 3 and clone it.
Not like you've practiced this once or twice, right? Yeah. Not at all.
No, apparently not enough. So what you can see here is that this is actually using the Team Explorer to actually connect to that GitHub context and to actually clone that locally in this particular box, right? So now you can see that it opens in a solution in a folder view, but I just need to click this Solutions and Folders to actually pick which solution I want to take a look at. So now that I'm in this context, you can see that I'm actually loading the solution with the WPF project itself loaded right here. So that's pretty cool. The other thing that you might see here is this little thing on the left right here, which says projects are loaded and ready to use. Background tasks are still running.
What's it doing in the background?
Yeah, so what we're really trying to do with Visual Studio 2019, I mean, I think a lot of people have seen in 2017 that there have been pretty dramatic performance improvements, right?
Oh, yeah. We've seen those numbers, those demos where, time to load the Roslyn source code, right?
Yeah, and live unit testing is dramatically improved. So what we've been trying to do is to move more things to be asynchronous and out of process in Visual Studio itself.
Okay.
And so what you're seeing here is that there are some things that are still running in the background, but that the project you can actually go forward with. You don't have to wait for anything before you actually kind of go ahead and get things going.
So is it doing things like looking at my NuGet packages or any of those
Sure.
Roslyn
I mean,
tasks?
it's doing any kinds of things that it needs to do to initiate the project. But basically, as soon as the project is loaded, the source code is loaded, and basically, we think it's safe for you to type. In other words, you will get the IntelliSense experience you need in the background compilation experience you need. Then we'll notify you to say, hey, go for it. But in the background, we'll still do some other things to kind of get everything primed.
So I can go open a Razor template or open a WinForm designer and start tinkering around in there while those other things are happening.
And anything that you really push forward because you want to do it immediately, it'll obviously push that to the top of the queue and make sure that that's the priority. Yeah.
Okay.
It's kind of amazing how much Visual Studio really is an OS inside of an OS, but it's a pretty complex app.
Oh my gosh, yes.
Yeah.
So I want to make sure that our friends out there that are watching the live stream that we're answering your questions on Twitch. If you have questions about the new Visual Studio, whether it's 2019, Visual Studio Code, or Visual Studio for Mac, send us your questions out there in the Twitch chat room, and we'll answer them here for you while we're going through the demos here with Amanda and Uni.
So the other thing that you'll notice here is that the top level menu bar has actually been collapsed. And part of the reason that we've been doing that is so that you have basically more room for your code. So if we go ahead and we load like the main view model, and you can see it, this is a pretty small resolution. It's not something that I would ever actually work in. This is the only reason we're doing this is for the live audience. But
I love working on my laptop. Come on, Amanda.
But I mean, in this context, it really highlights how helpful it is to have, yet another menu bar that
it's gone.
That's a whole line of code right there, right?
At least.
So
At least,
having
right?
another line of code in my view is actually super useful. So that's one thing. The other thing that you'll notice is up here in the corner, I have kind of my information about my profile, and then I also have live share, which I'll use in a second. But the idea here is that we want to take all of the static information about your presence and the context of who you collaborate with and kind of put that up there in the right-hand corner. The other thing that you'll notice down here is that we actually have the coupon reader WPF on the lower right-hand corner. So we can actually see that along with the repo that we're in and kind of which branch we're in GitHub, how many changes I've made, things like that. And then you can also see down here in the lower right-hand corner, we have kind of like a checksum that basically says, hey, everything's compiling. But as soon as I were to make an edit and things wouldn't compile, that would go to red or yellow, depending on if it's warnings.
Okay.
But that kind of tells me whether, like, the state of the health of my code that's in my code editor.
Yeah, I used to use an extension that our friend Mads Christensen wrote that would put a little watermark in the background to indicate if there was errors or something.
So Mads is on the team, so a lot of his great ideas actually come directly into Visual Studio eventually, right?
Awesome. Okay.
The other thing that we've also been trying to do, kind of along the lines of the fact that some of our new developers are telling us that they're overwhelmed by the capabilities that Visual Studio has, is we're really trying to improve discoverability, right?
Oh, yeah.
And so one of the things that we've been working on a lot is improving the search experience inside of Visual Studio.
Okay.
So for example, I could do something like search for refactor, and you could see all these different refactorings come up. And it's not just, various different refactorings that are available, and it would change context based on what was highlighted, but also the hotkeys. Right?
Yeah.
So what's super cool, and this is coming in the next preview, is you're going to be able to actually launch a command directly from the search itself. So I can just with normal no mousy, I can do typey.
And you don't know the shortcut keys, but I want to do.
You don't know.
Right.
Right.
Go find this.
But it's not
do
just it's not just a text command. It's also like I could, for example, search for Android, right? And I could see, there's, first of all these Android settings. There might be some new project templates. Like I could say, what is it? tvOS or something like that. What is it? iOS, like I could search for that. You could see, various capabilities that I might have. I don't have Xamarin installed on this particular one.
Yeah.
But I could go to definition, and you'll see that it's not like perfect, right? Because I don't have a space in there. It's all fuzzy matching, and over time this will get better and better and better and better because it's a hosted service.
Oh, very cool.
Yeah, so that's pretty cool. So let me show you one more thing, which is live share in this context. So again, I'm showing you a WPF application here, right? And so what I'm going to do next is I'm actually going to invite Uni, who's over here on the Mac, to basically do a live share for this project.
Okay, so wait. You're going to take a WPF app, right? Now, is this .NET Core 3?
It's .NET Core 3 WPF app.
Okay.
Yeah.
And I mean, a Mac doesn't run WPF, right? Because it's Windows Presentation Foundation.
Right.
But he's going to be able to work with the code.
He's going to be able to work with the code, so let's try it.
All right, so let's try it. So we're going to set up a split screen
Should
here.
everything go well? Yeah, so I'm going to go to the right.
And then we're going to dock Uni to the left.
Yep. And I just need to copy that. I haven't sent it to you yet, Uni, so don't freak out. And I'm just going to paste that there. And so he should be able to join.
Great. So in my Teams window, I'm seeing the link. Just with a single click, I can open up VS Code with live share running in it.
Yeah.
Oops. Let me just try this one more time. Amanda, can you? Oh, let me just click your link.
And let's make sure you're docked to the left side there.
These are preview bits, so please excuse us if.
Is it working?
Let's try it again. Can you send me a new link, please?
Sure.
Share it again.
Share it again?
Mm-hmm.
Let's try that one more time. You can close your browser and try it one more time.
All right.
The other thing you can do is copy it into your VS Code instance.
One last time.
Yeah. Oh, there we go. That looked good, right?
Mm-hmm.
Oh, no.
There seems to be an issue with the extension.
Okay.
But let's just walk through the scenario.
Okay. So, so basically what would happen is if he wants to join in, then basically he can just go ahead and jump into the WPF session and actually be able to debug this session.
So you're debugging on the Windows machine, and
Yeah.
he's able to connect in and see all the debugging information, the locals, run watches,
Right.
and inspect as you would be on the Windows machine, but from VS Code, whether it's on Mac or
Right.
Windows.
Right, exactly. I just sent you a different link, so let's try that
All right.
one more time.
Looks like it was updating an extension or something. Let's
Okay.
try. Let's see if this works.
Okay. So if you go to the live share viewlet there, you can click on Join Collaboration Session and then just enter the URL there.
All right, let's try that. Let's hope this works.
Okay. So
Yeah.
it looks like it's joining. It'll take just a second to actually join the session. It'll give me a notification as soon as he's in. So this actually says, okay, Uni's in.
There we go.
Yeah, so what's really cool about this, and let me see if I can kind of scroll back out to,
Oh, we got zoomed
trying
in.
to zoom in, and now I'm trying to zoom back out. But anyways, there, now we can see some real code.
It's that two-finger zooming on the touchpad.
So you can actually see some of my highlights in here. Uni can see it in the context of his Visual Studio Code instance. But what's really cool is I can actually allow Uni to do some debugging on his machine. So what he can do is
And we should clarify, I don't have the code on the machine, right?
Sure.
It's all coming
It's all being
from a
shipped across.
machine.
He doesn't
Let's
have
make
the
sure,
Windows SDK
and let's
on
make
his
sure yours
machine,
is snapped on the left side there for everybody.
Let me just move. Is that better?
Yeah.
All right. So makes the debug window really small, but let's try. So what I'm going to do is I'm going to switch over to the WPF application, and I'm going to start debugging. So again, the app is not running on my machine. It's going to run on her machine, and we can work on this together.
So you're
on the
requesting
problem.
requesting the debug. It's going to come over to this machine,
That's right.
Amanda's, and all right,
All right,
traffic
let's
that
try.
back and forth. Okay.
So I'm going to launch, and if you look
Yep.
at that on Amanda's screen.
Yeah, you can see that both of our machines are actually launching into a debug state. That's odd. We're getting a compile error. But I'm not sure what's going on there.
Let's try it one more
it's
time.
hard to see it.
Can you do
Okay.
clean?
You could try that.
And you can see on my screen, I'm seeing the same build outputs, including, unfortunately in this case, errors. Just in case this was to work correctly, I would be able to just run this app from my machine, put a breakpoint, all without Amanda doing anything, get the complete IntelliSense experience and debug through the application.
And this is part of live streaming and live TV is sometimes things error out, and that's okay.
Yeah.
But this actually opens up to a pretty good question while we're trying to figure this out. From our friend Steam Jockey in the chat room asked, well, how does Visual Studio Live Share communicate if you're on a tight firewall framework, firewall network? What kind of communications should they expect? Is it using something like an IM, instant messaging back and forth?
So actually what's happening is that it uses an Azure Relay service. So this
Okay.
is a service that's available in Azure to basically create a connection. And then once that's done, then it's just
Peer-to-peer.
basically peer-to-peer.
So, and if I'm on a tight firewall network, right, where tight restrictions on our private network, can I just do direct connections without connecting out to Azure?
So yes, that's one thing that we're working on over time. So basically, you have to have the Azure Relay service itself to do the initial handshake.
Okay.
But beyond that, then you can actually work in a
Then
firewall
hands-off.
context. Yeah.
As only the amazing Amanda Silva could do it. She was talking to you and debugging and fixing the problem at the same time, you know?
We're professionals. We can make things happen.
So here the app is running. We got lucky. Thank you. And I'm going to put a breakpoint, and I'm going to actually, you can see the app is running.
Sure.
I'm going to put a breakpoint, and let's go ahead and click the refresh button.
Yeah, you
Amanda.
ready to refresh?
Yep.
So this is a WPF application again, and look, we're actually hitting the breakpoint in my context, right?
Right.
As well as his context.
And I can see everything as well, right? So here is my breakpoint. Let me go ahead and make a small code change. In this case, I'm just going to add a WPF. You can see I'm getting the full IntelliSense experience inside Visual Studio Code for the app that's running on a machine. I'm going to call it system.windows.messagebox.show. I'm going to just call it hello world for now. And I'm going to run it, right?
Yep.
Good?
This is,
and when the app runs, there
Yeah,
you go.
so you can see the hello world just popped up. So he just did an edit and continue on his VS for Mac
From Mac.
machine. Yeah, right in the context of our live debugging session.
Okay, that's pretty impressive.
Pretty cool, huh?
Oh my gosh, yes.
Yeah.
I mean, edit and continue alone, right, is pretty cool by myself. But to be doing that handoff back and forth, there are so many things that I could see folks wanting to be able to do that with, whether it's Windows Forms, WPF, or whatever other framework we support,
Yep.
right? There's other programming languages out there.
In a team setting where people are constantly switching contexts, it'd be so much more work for me to go ask her about the repo, get the code in my machine. In this case, I couldn't even do that, but let's assume I'm working on a different kind of application, and then debug through it.
Right.
This is her problem. She set it all up. I'm just helping her, and that was really, really powerful.
So why don't we take some questions
Oh,
for a
yes,
second?
absolutely. So there's a really good question here about multiple screens. If I'm using Visual Studio across multiple screens, if they have different DPI settings.
Ooh, you're in for a treat.
Yeah?
Yeah.
I have this problem at home.
Yeah. So this is actually something that we've been taking on for Visual Studio 2019,
Okay.
and the first preview should show some progress, but the second preview will show pretty dramatic progress.
Fantastic.
Yeah, so everything should start to get pretty crisp in the course of Visual Studio 2019.
I've got that 4K display on my laptop, and when I drag over to the side screen that's 1080,
Yeah.
everything gets old.
Yeah. So we've been working on it, so it's coming.
Oh, that's great.
Yeah.
Now, what kinds of performance improvements have we put into live unit testing?
Oh, well, I mean, first of all, test discovery itself is pretty dramatic. It used to be order n kind of algorithm, and now it's basically a linear algorithm.
Okay.
So that's a pretty dramatic improvement. We have other demos that we've done in the past that show that you can load 50,000 live unit tests in the course of a few seconds. Yeah. Yeah.
Oh man, I'm gonna know immediately when I break my build.
Yeah, so that's one thing. We improved doing a stash and kind of a switch branch pretty dramatically, and that was actually in 2017, but a recent update of 2017.
Okay.
So those are a couple things. Solution load time has also been dramatically improved as well.
Sure, because we've got that async
Yeah.
loading process.
Yeah.
Very cool.
Yeah.
Walter in the chat room is asking, does the team debugging with LiveShare work with distributed developers in different cities or countries with relatively slow internet connections?
Absolutely. So that actually was one thing that we've really been trying to work on. I mean, in some ways, the important thing about it is that the entire context of the debug session is not going into the network, right? The only thing that actually goes into the traffic is commands. Right? So it's not like the debugging, because it's being hosted on your machine.
Sure.
It has the compute power of your machine.
Okay,
We don't
okay.
need the compute power of the network. Right?
Okay, you're just
and
trafficking.
so all it is remoting of your commands.
Oh,
That's the
man.
only thing that actually goes over the network, right?
Okay.
And then if there's new information that you might find in, like, let's say a debug inspection, an expression evaluation or something like
then
that.
it's just that information.
It's just that information. So it's
Okay.
actually really, really small, which is pretty
Oh.
awesome. Yeah.
Oh, that's great. I can run it now over my 3G phone.
Yeah.
Are we doing anything to improve Test Explorer integration for Xamarin apps? Dot Morton is asking.
Yeah, you want to
I
take
think
it?
there's a Visual Studio question. So.
Yeah. I mean, so we've definitely been improving the test discovery and the live unit testing experience. I don't know that there's anything specifically that we're doing for for Test Explorer integration for Xamarin applications that I can think of off the top of my head. But it's a good question.
Okay.
Yeah.
And we've got a question here. This might, I think, lead into your next demo.
Yeah.
AGR-TGA. That's a great handle there. Are we going to get the option to either debug multiple projects or at least choose the project with the diagnostics tool window?
Yes. So that's actually something that I'll demo tomorrow at Dev Intersections.
So if you're here local in Vegas joining us.
Yeah, but I don't have the demo ready to go today. But I have something that's super cool.
So about debugging projects.
Yeah.
Right? So
exactly.
debugging experience has been getting better.
It has been getting better. And one of the things I really wanted to show, because there wasn't a lot of love that was shown in the keynote for C++, is we've actually dramatically improved the C++ debugging experience.
Okay.
Yeah.
Oh, talk to me about that.
So I'm playing a little bit of a video here because this actually is an app that is a little bit too big for this machine. It takes
it's
like
an app?
Yeah, it's called Gears of War.
That's not an app. Oh my gosh, Amanda.
So we've been working with the Gears of War team to make sure that their debugging experience is much better.
Yeah.
And so one of the things that really prevented Visual Studio from successfully being able to kind of make their debug process really smooth is that everything was in process. And so because everything was in process, it actually consumed a lot of memory, right? And so what we'll show you here is actually the experience in the previous version of Visual Studio. This is, basically without the out-of-proc debugging experience. But what you can see is this is attaching to the process. And as we start to step through and inspect some things, you'll see that the memory really starts to creep up. It's a little bit fuzzy here, but it's such a cool feature that I just couldn't help but show it.
Oh my gosh. I mean, just the idea of, all right, let's debug a AAA game.
Yeah.
Okay, let's do it.
Yeah, and not everybody gets access to the Gears of War source code. So, so what you can see here is this is actually, we're stopped at a breakpoint, but further, when we start to do inspection of various variables, devenv, the in-memory just starts to kind of creep up and up and up, and we're at about 1.2 at this point. We haven't done any inspection, we haven't done any steps, and now we're doing a couple steps, and as you can see, it just continues to grow and grow and grow, and eventually you end up with an out-of-memory situation, which is really, really problematic because by that point you're probably deep into the gameplay to debug and repro the issue, and so getting back into that state is kind of challenging.
And it throws you completely off of your groove. You were so focused on getting something done, and now out of memory.
Yeah, exactly. So I'm going to just forward this a little bit, and you'll see that we kind of end up with 1.97 or something like that. But now you can see we're going to try it again, and there's an option that you have to go to that will let you run the debug symbols in an external process.
Okay.
And today that works for C++ only, but that's something that'll come down the road for other languages as well.
Got to start somewhere.
Yeah, exactly. But now you can see this is Visual Studio 2019. You can see the nice indigo kind of blue theme here. Again, this is Gears of War. And we're just basically going to execute the same exact kind of debugging process. But what you'll see here is that the memory doesn't creep up this time.
Yeah, it looks like it's staying there, about, what, 470, 472? Come on.
Yeah, exactly. So now we're just debugging the exact same thing, and it's not growing, right? So, and that's because it's basically it's attaching to the debugger out of process.
Oh, fantastic.
Yeah.
That is amazing.
And we just made C++ live share support available as well.
That's right. Yeah. So that's really cool. So. So with C++ live share, like you can basically, if somebody has hey, it's reproing on my machine, but I can't get it on your machine, you can invite them to a live share session. The debugger is working out of proc. It's kind of, as Scott Guthrie likes to say, it's a great day to be a developer.
Oh my gosh, you've taken the works on my machine and say, here, just connect in and try it.
Right, exactly.
Boomy LOL in the chat room. Kudos for you, Amanda. Super cool. Thank you, Boomy. We appreciate that.
And we agree.
Yes, we absolutely agree. This is amazing.
So now I'm going to get untangled because there's one last thing I want to show you that I think somebody was actually asking about.
I think I did see that question a little bit earlier.
Yeah. So somebody was asking about the experience for reviewing PRs directly.
I hate that context shift that I have to do where I'm going to my web browser and then back to Visual Studio.
I mean, especially for senior developers who are bombarded by pull request reviews all day, basically.
Or live streamers who are trying to run a show.
And then they end up with doing shallow reviews because they can't use the tools that they're familiar with.
Yes.
So what we've been doing is working with the GitHub team to create an integrated experience inside of Visual Studio and Visual Studio Code, so that you can actually review your pull requests right in the context of the tools that you're used to. But this is such a cool demo. Like, this is something that got cut from the keynote that I'm so excited about that I had to show it today.
Okay. So folks on Twitch, make sure you get your clips ready so we can get some clips of this we can share out to Twitter and like that. All right.
So this is the normal GitHub extension that you can get on the extension gallery today.
Okay.
Plus a little magic that we're a preview of something that we're working on.
Okay.
I'll tell you when the magic shows up. But if I go to all, you can see all of the pull requests that are awaiting my review, right? So that's pretty cool.
Time to get back to the office.
I know, right? They need me. But I can go ahead and inspect one of these pull requests, and you can see that it brings the context of all of that locally into my machine. And so you can see in my Solution Explorer, I actually have nothing loaded. This is all actually being hosted in a cloud context. So I can go ahead and look at one of these files here, and you can see that I get all of the code colorization that I'm expecting.
Yeah.
But not only do I get that, I also get like hover tips, for example, over the data types, and I get the documentation. I also get the analyzer. So I have ESLint running here. That's a static analyzer that's telling me that this is assigned to a variable but has never been used, right? So that's kind of cool. So the other thing that I can do is let's go look at this other one. Oh, I forgot to show you something here, which is that if I do a find all references on this, you can see that it's going to find all references of that grid legend thing, not just for those mentions that are in this file, but also for mentions of grid legend that are in files that aren't in this PR.
Okay, so I mean, you're blowing my mind here because these are things that I struggle with when I look at those GitHub PRs, and I'm looking at just the text in the web browser. Now I've got the full context of everything, and I can really explore and get my hands on it.
And you can use your hotkeys, and you see the diff view, and exactly. So that's super, super cool. So let's take a look at the other one. So this particular pull request, it looks like is introducing a new dependency on an NPM package that I'm unfamiliar with, right?
Okay.
And so so anytime that anybody introduces a new dependency, I really want to understand more about what that dependency is doing, right? And so so what I'm going to do is do a go to definition on one of the types that's defined in this new NPM package, right?
Okay.
But this NPM package is just picked up as an NPM package. It's not, the source isn't included in my pull request.
Yeah, I don't see a package JSON there that will point me to it.
And it's not even in my project. It's just an NPM depend, right?
Okay.
So what do you think is going to happen if I do a go to definition?
Okay, it's not going to choke and say, oh, I don't know where this is, or a file not found type of
Right.
error,
I mean, that would be like the obvious thing. Another thing that it could do is have a minified minified JavaScript file, which would be like what would happen in deployment, right?
Stop it.
Yeah, but what's actually going to happen if I do go to definition here is it's going to observable.ts. This is the actual source code of the NPM package on GitHub.
It found it.
Yeah, it found it.
Okay.
So basically what this is doing is it's understanding the dependency that you have and mapping it back to the actual source repo where that source is defined.
Oh my gosh.
So this is indexing all of the code on GitHub.
Yeah.
So that you can start to traverse these things.
Wow. Now, does that work with just JavaScript and TypeScript, or will it work with my .NET code also?
It's going to work for everything. So so one of the things that's super cool here is not only can I do a one hop into observable.ts, but I could also go to another one, do another go to definition on another file, and this is now opening yet another file that's defined in GitHub.
Wow.
Yeah.
Now, Martz is asking in the chat room, does this work for Azure DevOps PRs as well? Not just the dependency lookup, but the...
Yeah, so we actually have a great extension that's very similar for Azure DevOps PRs that also allow you to do the review.
Terrific.
Yeah.
Oh my gosh. And then can I do this from the Team Explorer window?
Well, so the GitHub one shows up in the GitHub window
Gotcha.
itself, but the Azure DevOps one I think shows up in the Team Explorer.
In the Team Explorer.
Yeah.
Great. Thanks for the question, Martz. And then I've got one more question that I want to come to here from Zamcat. We saw live share. Does that also work with Xamarin projects?
Yeah, it sure does, Uni. Yeah, it does.
The one part that we didn't show, with client applications, one of the challenges is that imagine that Amanda is sitting in, I don't know, Redmond, and I'm sitting in Vegas.
Sure.
How do we debug this? Can we see the screen, right? Because that's really important.
Yeah.
The one part that we didn't show today
That's right.
is that live share will also allow you to like sort of cast your screen or the application.
Okay,
you know?
so I've seen that with ASP.NET Core, where I can share my server.
But you could do it with a WPF application now. So what we weren't able to set up Uni's Bits today,
Okay.
but Hanselman showed it in his keynote.
Yeah.
If I have a WPF or WinForms application on my Windows machine and I'm doing a live share session with somebody on a Mac machine or an Ubuntu machine, they can also see the app.
Oh man,
And so that'll eventually come for mobile apps as well.
Absolutely.
it just traffics the UI over to the Mac.
Right.
I mean, it's just the HWin, right? In this
Sure.
case, it could be the emulator that we send across.
Oh my gosh, I am so looking forward to Visual Studio 2019 and these updates. I got to get it installed. Now we have a download link for that. Moderators, can you do me a favor? We know the download link. Can you paste that link into the chat room so that all our friends out there that are watching, they can go and download the latest updates for VS for Mac and Visual Studio 2019 Preview 1.
Awesome.
Thank you so much for joining us today, Uni and Amanda. I've learned a ton here. Now, I'm going to start using Visual Studio 2019 on my next stream. I got to get that installed and up and running.
Awesome.
But I'm going to start walking over here. I'm going to head over to the other set because Ed Thompson's over here and he's going to help me with something else on my stream. All right?
Awesome. Thanks,
Thank
Jeff.
you,
Thank
Jeff.
you
Thanks for
so
having us.
much. All right, so let me head over here to Ed. Now, we're going to be talking about things with Azure DevOps. Now, Azure DevOps lets you do all kinds of things to help make your projects better. Now, I've been working on some projects on stream, and I haven't written my code in a way that works really well with continuous integration or pipelines. Ed, can you help me out with that? Why don't you let folks know who you are, and let's see what we can do to work on this.
Sure. Yeah, so my name is Edward Thompson. I'm a program manager at Microsoft. I work on the Azure DevOps team, and my focus is kind of two areas. One is Git and version control, and the other is Azure Pipelines, which is our continuous integration and continuous delivery system.
Now, I had a question earlier today from someone. Is there a difference between continuous delivery and continuous deployment?
You know, there's a lot of these terminologies that kind of get muddled and thrown around.
Oh,
And,
yeah.
you know, some people will say continuous integration is really only when you're building the master branch and not pull request validation. And some people kind of lump the continuous integration term to mean both things.
Okay.
And then continuous delivery and continuous deployment, again, gets a little questionable. Like, what is a deployment? Or if you go to a staging server, is that continuous deployment? Like, if I check in and it automates the deployment all the way to staging, is that continuous deployment? Does it have to go to production? So these are all good questions.
I think continuous delivery is what all those shipping folks are going to be doing here through the holiday season. Just continuous delivery.
That's right.
So I've shared with you a little bit about a project I've been working on my Twitch stream, where I've been building some tools for streamers to be able to build extension, to use web pages and things to enhance their interaction on their stream. And I've never gotten Azure Pipelines to build quite right for it. And I started building it so it could go into a Docker container.
Right.
What are the steps I can take to make that happen so it builds and gets into that container? And then it'd be really great if I could deploy it.
Well, let me show you.
All right, let's do it.
So actually, I've got your project right here.
Okay.
And it's here on GitHub, C#Fritz/Fritz.StreamTools. This is the one, right?
That's the one.
Right.
That's the violator.
Right. And it's an open source project.
Everything's open source.
Yeah.
Absolutely.
And I know that because I actually contributed a change to it.
Yes.
I opened a pull request yesterday. I was really, really pleased about that. And you took it.
Of course.
Oh, well, you know.
Of course.
My code isn't always the best. That's why they made me a program manager, right?
Oh, man.
So what I'm going to do is the first thing I'm going to do is fork your repository. So I'm going to make a copy of it in my account.
I don't mind. Go ahead. You can take a copy.
So I'm just going to click fork. And I've already, like I said, I've been working on this a little
Practicing.
bit. Yeah, exactly. So I'm going to find this one. I've got this. This is a GitHub organization I set up just to manage this.
Okay.
I'm going to fork it right into there. Just takes a second.
I love that little image. Yeah,
I know,
we're
me too.
copying it. It's the old copy machine.
That's right. And then after that, the easiest way to get set up with Azure Pipelines is through the GitHub Marketplace. So Azure Pipelines actually has a GitHub Marketplace extension, and that is by far the simplest way to get started. So all you have to do is scroll over here to the continuous integration section.
Okay.
Click there, and you will find Azure Pipelines right there.
Oh my gosh.
So get started. And of course, it's totally free for open source projects. So all I have to do is hit set up a new plan. I've got this free plan. That's great. That's all I need. And I select the account. Like I said, I've got a couple of GitHub organizations, so I've already got it set up. So I'm going to select this one, the one that I just
forked into.
That's right.
Yeah.
And then just click install it for free. So no charges for open source projects, totally free, unlimited build minutes per month, and all I have to do is click complete. Once I do, it'll bring me over to Azure Pipelines. I'm going to select the repository that I want to use. That's the one I just forked. Click install. It's going to make me enter my password just to confirm. It's going to make me log into Azure DevOps. Click that account right there. And so if you've never used Azure DevOps before, you can go ahead and get started, create a new organization. I'm going to reuse one that I've already set up.
Okay.
I went ahead and set one up for today. And the reason that I did that is so that I could create a project and so that I could, over here, this is Azure DevOps. This is the project I created. What I needed to do is add some secrets.
Okay.
Didn't want to type them in here.
No, probably not a good idea.
Right. All of a sudden, I'll be Bitcoin mining before the end of the talk. So,
I can't tell you how many times I've accidentally leaked a key on my Twitch stream.
Right.
Oops.
I totally believe it. So, so what I've done is I've gone ahead and set up a set of variables that we can reuse later that have those secret keys in there. So
all right, variables. Are those variables that are available throughout my build?
They are. So Azure Pipeline sets up a number of variables itself.
Okay.
But you can also add variables either right here is the easiest way to do it. This is a library. I can just give variables names. Some of them are just normal variables. Some of them are secure. So this won't actually show up. There's no way to see this. You won't see it in the pipeline. You can't echo it out, things like that.
Awesome.
And that's the password for the container registry that we're going to publish to.
All right.
So again, don't want to leak that out.
No.
Right. So here we are. So GitHub's taken us to Azure Pipelines, and we're going to go ahead and set up. We're just going to select the repository we want to build. And when we do, Azure Pipelines is actually going to analyze it and look at the code that's in there and try to come up with the best template.
Best match.
Yeah.
All right.
And it looks at your code, notices it's a .NET project.
Okay.
It suggests that we build a .NET app. I don't want to do that, though.
Okay.
I want to build a Docker image instead. And that's one of the other templates we have.
Yeah. All right.
Because you actually want to do this nice modern deployment system. You want to build your .NET Core app into a Docker image. You want to deploy the Docker image. And so we've got first-class support for that as well.
Yeah, my thinking is if this is a set of tools that folks that are running streams want to use, put down your own little image, configure it with everything for your stream, for your project, and run it wherever you'd like, on your local machine, in the cloud, wherever makes sense to you.
Yeah, I think that totally makes sense. I love that sort of a setup, but it's not something that I'm super familiar with. So we're going to hope that I don't screw anything up as we go, because the code I write is like old school native code these days.
Okay.
So
all right.
This newfangled modern world I'm not super familiar with. So let's see if we can get it right.
Modern world of YAML.
Of YAML, that's right. And here we've got some YAML.
Yeah. So listen, if you're one of our friends out there hanging out in the chat room over there on Twitch, make sure you send over your questions that you might have for us about Azure Pipelines, and or anything about the project that we've been working on, and the moderators will pass them along to us, and we'll be happy to answer them.
Absolutely, absolutely. So this is the default YAML for building a Docker image. I just want to make a few tweaks to it, based on what you want. So first of all, the first thing we want to do is select where we're going to do the build. We support cloud-hosted builds for Linux, for Windows, and for Mac OS. But for a Docker sort of setup, I think Ubuntu is obviously the right way to go.
Oh, it's a nice one to use.
Yeah. So second, here's the variable section. So I can define variables here also that will be used throughout the build process. And I want to change this a little bit. I want to use the array syntax instead. So I'm going to set a variable that has a name of image name. So I'm just going to change this and a value. We're going to change that from your container image name. We're going to call it fritz.streamtools. And
you got a typo in there.
I do, thank you.
Pair programming.
Pair programming, indeed.
Absolutely.
And then I'm going to bring in that variable group that I defined earlier. So that's got all the Azure secrets. So now I can actually refer to those.
Do we need a hyphen in front of value?
No, I don't. Okay. So it's name, value. I don't know my YAML. I'm learning, but I think this is right.
Okay.
And then I'm going to set the Docker file that we want to build. And that should all be good. So that's going to run that Docker file, build that Docker image, and tag it with that. And once that's built, I want to do one more thing. I want to take that Docker image that's built and publish it up to my Azure Container Registry.
Okay, so we have a private registry for our images that it's our working place. It's not public, but it's someplace that we can share these containers from.
That's exactly right. And that's why I needed that username and password. I could publish up to Docker Hub, that's no problem. I'd probably need to authenticate there too. But I want to, there we go. I want to publish to my Azure Container Registry. So the first thing I need to do is run Docker login, and then I can Docker tag that image again. So it's got that tag. It's going to be called, fritz.streamtools. I also want to tag it with the container registry in the name.
Oh, yeah.
And then I can Docker push that image. If I can type it, there we go. All right. So, and let's give it a display name so that it looks nice when we see it. Okay. So yeah. So we're going to build this Docker image. We're going to push the Docker image to our private container registry. Let me just take one more look, make sure. Nope, I missed a closing parentheses. There we go. So that all looks good. We'll authenticate, we'll tag it, and then we'll push it. So when I click save and run, it's going to kick off our build.
Okay, that's too quick for me. My gosh. So, all right, display name that you put down there at the bottom. That's the display name for this step.
For this job, for this step in the build task.
Okay.
That's right.
And I get the scripts. That makes sense.
Okay.
I'm used to seeing those because I'll run them locally on my machine so that I can push to a container registry.
Yeah, that's exactly right. The way I think about continuous integration builds is that I want it to be as similar as possible to the development build.
Okay.
Because that's familiar.
Sure. Now, Kirsten has a good question in the chat room. What if I wanted to add unit tests into this and fail in the middle of it? Is that just another step?
It's just another step. Yeah. You can just run whatever commands. You could you could run .NET test. That's exactly right.
And then run the test, and then if any of them fail, it gets a non-zero return code. It'll stop. Fantastic.
That's exactly right. And then you can even publish the test results up into Azure Pipeline so that you can actually examine the tests and look at, kind of drill down and see what failed.
Oh,
it's
and
very
what program manager doesn't love test results and numbers, meters and things that they can look at?
I do love all of that.
Oh, yeah.
So when I click save and run, what it's going to do is it's actually going to take this YAML, check it into my repository on GitHub. That's why I forked it, because I can't check into yours. At least until you give me that commit.
Until I accept.
That's right.
Give you that commit. Yeah.
So I'll click save and run, and what that's going to do is it's going to kick off our first build. So it's going to create the first Docker image and upload it.
Okay, and it uploads to the registry. Now, eventually, I'll be able to push that out to an Azure, right? I'll be able to do a release and push that to an Azure app service or a container service.
Right.
Now, Kelcomnet in the chat room is asking, they're currently using Jenkins to build and deploy to servers behind a firewall. Can DevOps deploy to those on-premise?
It absolutely can, yeah.
Okay, so not just to Azure.
Not just to Azure. That's one of the really cool things about Azure pipelines is you can kind of mix and match on-premises and cloud, however you want to do it. So, we have build agents in the cloud for you for, again, Linux, Windows, and Mac OS, so you can take advantage of those. But if you have some infrastructure on premises that you want to use, maybe you've got some complicated dependencies that you need to set up, and you want to do it once on your computer and then hide it under a desk and never touch it again.
Oh yeah.
And you can install the build agent on that, and so you can actually build with a mix and match of on-premises and cloud build agents. But the same is true for release. So you can release either to a cloud, whether that's Azure, which I hope it is. I like
Absolutely.
Azure.
Or somebody else's cloud.
Somebody else's cloud is fine too, or on-premises infrastructure that you already have. That's no problem at all.
Awesome.
Yeah.
Okay, so I'm assuming I would have to install a little piece of software on my on-prem stuff so that it can be visible to the DevOps so we can publish to it.
That's right. That's exactly right.
I got you. That makes sense.
Yeah.
While we're waiting for that, Guatello, I hope I'm pronouncing that correctly. How do I set up multi-tenant deployment with the main repository and a different selection of plugins from another repo for each tenant?
Oh, wow.
That sounds really complex.
That's some advanced stuff. The nice thing though is that you can that YAML is very, very flexible.
Okay.
And so you can in fact just run some Git commands if you have a deployment to go to say production and you want to bring in other plugins from another repo. You can just run git clone.
Okay.
You can use submodules. You can use git LFS. So you've got a lot of options on how you want to orchestrate your source code and then send it off to deployments. And so you can decide which builds are going to run based on the deployment target, for instance.
Okay. Okay. That makes a lot of sense to me.
So, I'm sorry.
No, I was going to say with the different ways that you can pivot and write the code there, I guess you can set up that logic to run different sets based on outcomes.
That's exactly right.
Okay.
And you can do a lot of conditions. If this step fails, move to this step. If this step succeeds, go to this step instead. So you can kind of, you can really just build a whole graph of the directions you want to take. You can fan out, you can fan back in, wait on different resources. So you can kick off some builds in parallel, some steps in parallel, and then wait for all of them to finish before collecting all their output, zipping it up or whatever, creating an artifact from it and moving on.
I'm thinking of things like Xamarin apps where I might kick off parallel builds, one for here's the iOS version, here's the Android version, and then at the end collect them together and publish the results.
Yeah, that's a really cool idea. One thing I see people do is they've got a back end that's .NET Core, they've got a front end that's TypeScript, and so kick off the builds for each of those in parallel.
Oh, very cool.
Yeah.
Okay. Now, Kirsten has another question for us. Ooh, looks like we've got some results.
We do.
Let's get Kirsten's question first. Can I access an on-prem database with my unit tests? I'm guessing Kirsten's referring to that are running on Azure DevOps. That feels like a firewall question.
Yeah, that's exactly right. I would not do that myself, but what I would actually do is then move my build into an on-premises build agent.
Okay.
And that way you feel a little bit more comfortable about the security violation or the security separations that you're making.
Oh yeah.
Yeah.
I've actually seen some folks where they'll create a Docker image that's using Postgres or some other database, and they seed that image with whatever test data they want, so that when they do want to run their tests, they pull that test database that's seeded with that stuff, and they connect to that. That way there's no risk of damaging something behind a firewall or on production.
Right. Yeah, so that makes me feel a lot better than touching production with a unit test.
Yes. All right, so what do we got?
Right. So what's happened is, so we've done the Docker build, and what that does is it pulls down all your layers and sets everything up.
Mm-hmm.
And then we go ahead and install it. We do the .NET restore, we do the .NET build, and that's that. And then we've got a Docker image. Very cool, right?
Yeah.
So that's just stuff that you already had. You had your Docker file set up in your repository.
Yeah, we spent some time working on that previously, and it's been running great for me locally, but you've already got it published out to a registry.
I do. And so why don't we take this then and
man.
let's deploy it.
Okay.
Because I've actually got an Azure web app ready to go.
To receive it.
I do, yeah. It's called...
Oh man, it's like Christmas.
ethompsondemo.azurewebsites.net. And I think all that's there now is, hello world, right? Let's zoom in on that. This is the simplest web app ever.
This is live coding.
Yeah.
On Twitch.
Yeah. If I view source, you won't even see an HTML tag. It's text. Printf hello world. Or,
nice.
Yeah. So let's set up a release. And so the release pipelines functionality in Azure Pipelines is also incredibly powerful. So I'll just click on that, create a new pipeline, and I'm going to select Azure App Service Deployment. That's where we want to go.
Absolutely.
But again, this could be an on-premises sort of setup. You can, deploy to IIS. You can deploy to other clouds. It doesn't have to be Azure.
Sure.
But Azure's the one that I prefer. So, and we can set up all sorts of crazy stages. And again, if you saw Donovan's keynote, fanning out, fanning in, very complicated. We're going to have one.
Sure.
We only need one stage right now. We're going to call it deploy to production. And what we're going to do is we're going to tie this deployment, this release, to the build that we just did so that we can grab the build number out of the that got published.
The completed Docker image that was published.
That's right.
Okay.
So you can tie it to all sorts of artifacts so that you can trigger basically when a GitHub repository gets updated. But we want to tie it to a build.
Sure. And every time I start walking through continuous integration or continuous deployment, these visions of the mousetrap game go through my head. You know what I'm saying, right?
I do.
It's like, I know how to put this together, but do I need the bathtub with the guy flipping into it? Or no?
Maybe you do.
Maybe I do.
Yeah.
Okay.
So
that's part of Azure now, is the bathtub flipping guy.
Yeah, definitely. Okay. I think we announced that today.
Oh, fantastic.
Yeah.
Guy in a red shirt mentioned it.
So I'm gonna actually use a newer version. This is actually the preview version of the app service deployment, and I'm going because that's the one that I think has the best functionality and the best support for containerized deployments.
Okay.
And that's exactly what we want, right? So I've got an Azure subscription. Oh, I think I need to authorize it. So I'm going to have to log in really quickly just to tie the Azure DevOps account to the Azure portal.
Right, because DevOps, while it has the Azure name, isn't the same as your hosting Azure plan.
That's exactly right.
For all your Azure services.
There we go. I'll stay signed in.
Connect them manually.
That's right. So you just connect them up because you might want one Azure DevOps account to talk to a different Azure portal account.
Okay. Now, if I do have other people in my organization, I want to make sure that they can't see or touch those subscriptions. They're prevented from seeing that,
that's
right?
tied. Yeah, once the authorization's done, you can do that as an administrator. You don't have to do, you don't have to mess with it ever again. Nobody can do anything. So now that's all linked up, and so that subscription is now nice and locked. And so I can say again, we've got all sorts of options. You can deploy a mobile app. You can deploy Azure Functions. I want to do a web app for containers, and I'm going to do it to a Linux host. And once I select that, it actually figures out all of the web apps that I have that satisfy that condition. Again, eThompsonDemo is the one I want to use.
Mm-hmm.
Registry. So this is our container registry that we set up.
That we published to in the previous build.
That's right.
Okay.
And give that the fully qualified URL. And then the image that we want to use is fritz.streamtools, and we'll use the build ID. So we published a build ID, that's the tag in the Docker image, and we'll just reuse that.
Grab it and carry it along to this process.
That's exactly right. That's why we linked the build previously, so that we could use that build ID and know
that output information.
That's exactly right.
Okay.
That's exactly right. So now we save it, and then we can create a release. It's that easy.
Oh, man.
And we can watch it go just like before. It'll take just a little bit of time to spin up a host and start doing the deployment.
Okay, there we go. Two tasks.
And it'll find that third task. And so this is actually the money task. This is the one that's actually doing the deployment.
Copying that image out and spinning it up.
That's right.
Oh man. That
Very
is
exciting,
so
right?
cool to see. Yes,
Yeah.
right? Because it's like I'm I'm a right-click deploy guy for how many years? I know. I'm sorry.
My buddy
out there.
Damien is crying right now. I hope he's watching, and I'm sure he's saying, friends don't let friends, right-click, publish.
Back in the day, before continuous integration really became a thing.
Right.
We did right-click deploy, and we had a folder on disk. We zipped everything up, and then we took that zip file, we handed it off. You know what I'm saying?
I do know.
We handed it off to our friend in operations, and we both come in at 3 in the morning, and we take that zip file and put it out on the appropriate server, and it was blessed, and we ran our smoke tests, and hopefully we got to go to sleep by 7 in the morning because everything worked. Seeing the deployment like this, I want to cry. It's like 15 years ago, this was a pain in the neck to do.
Oh yeah. You'd get the whole team together in the conference room. You'd buy them pizza because you had to.
And you printed out Word docs.
Right.
This is all the steps. Now, Ed, you're going to do these steps, and Jeff, you're going to do these, and Ron, you're going to have these. And everybody here's your mission that you have to do, and it's 3 in the morning, and you're all bleary-eyed, and you're praying that it works.
Right. It's all totally manual. So many things that can go wrong. So many typos that you can make, especially because it's 3 in the morning.
It's 3 in the morning.
Yeah. No, you got to automate all that stuff.
Yes. Oh my gosh.
Yeah.
So
this should be just about done. We'll give it 1 more minute.
Okay. And we have a question from, is that K Labran, or is it Clabran? Can the YAML be run locally, or should we look into using a build script the devs can run locally and the YAML file calls into its steps?
Right. So right now the YAML can't be run locally. I think that we're working on basically a local executor so that you could run the YAML locally.
Kind of like how I have an Azure Storage emulator locally.
That's exactly right. Yeah. So, but I don't have anything to announce there for sure.
No. But it's a concept that is being explored.
That's right. But what I like to do is actually have the build script. That way I can run it locally. I can debug it locally because spinning up a new build is quick, but it's not instantaneous. It's so much quicker if I don't have to do that. If I can just do it locally and find out what's wrong with my build script, so I can do that debugging, and then I have a build step that is just run the script.
Okay.
But not everybody agrees with me, and so there's healthy debate on all sides.
Well, and we just did that here, right? We ran the build script that built using the Docker file to actually compile and give us the image.
That's exactly right. And so we had a good feeling that it was going to work fine because we'd both run this Docker file already.
Just had to get version numbers lined up, right? The chase of the version file.
Yeah, I know.
Version numbers.
That is tricky, isn't it?
Yes. So we're moving along.
Yeah. So that is still deploying. Sometimes it takes a little while longer.
But hopefully, if you are running this for test or you're running it for production, right, you're not sitting there waiting with bated breath for it to be deployed, right?
No. You'll just get an email when it's done.
Okay.
Right. Usually you're not on camera, sweating the minutes.
No, we're not on camera. Sweating, anything like that.
So, right.
Okay.
So, hey, while that's going, why don't we take a look at what it actually set up in the GitHub repository? Because it's actually done some cool things.
Okay, and this is why you were saying that you needed to fork and have your own version. You needed commit. What did it put into the GitHub repository?
That's right. Let's take a look. I don't have a tab for that. Let me go open it. There we go. So yeah, this is the forked version. And the first thing you'll notice right here is that there's been a new commit by Azure Pipelines.
Okay.
And so what it's actually done is it's set up that YAML file, azurepipelines.yaml right there. And this was what we modified.
That's exactly what you did in the web browser.
That's exactly right.
Okay.
And so now I can just keep making changes. I can just git clone this repository. I can do it right here if I want to make changes to the way the build process works, and it gets checked in. It's called configuration as code. The idea is that you want the way that your code gets built versioned alongside the code itself. That way, as you change your build process, it gets reflected there. So I can roll back to a previous version, and I've got the old build process that reflected that.
Or even if I create a branch because I'm building a new feature, or I'm building a new project that maybe I'm adding a Xamarin application to this, or I'm adding, in our case, we're building a Visual Studio extension. Right. Well, I need to change the build steps because there's now a step to build with Visual Studio.
That's exactly right. But you don't want that in the master branch because that code doesn't exist yet.
Okay.
Right.
Okay.
So this is really powerful. The other thing that it's done is it's set up some webhooks. So now, anytime somebody creates a pull request, it will actually run this this build validation. It'll run our continuous integration build. So if I make a change to the README, maybe I want to clarify this. What does OBS stand for?
Open Broadcaster Software.
Right. So maybe I want to call that out so that people who aren't familiar with it will know.
Sure.
I can open a pull request. Create a pull request. There we go. And there we are. And now what you'll see is we've got this check field here. So what it's actually doing is every time somebody opens a pull request, it will go to Azure Pipelines to start a build for this change that we made right there.
Oh, now, okay. That's pretty cool that it's running the build, but it's running the build for the README. Is there a way that I can put a filter on that so that it doesn't run for Markdown files?
Yeah, so you can, in your build script, you could like maybe take a look at what you wanted to do. Would be the easiest way to do that, I think. Because you might want to do something with Markdown files. You might want to make change. You wouldn't want to do a full code build necessarily.
No,
but you might lint
not.
the Markdown.
Ah, okay, okay. Now, you set that up to trigger whenever there's a pull request. There's a question in the chat room asking, well, can I schedule this? Perhaps based on a cron.
Sure, absolutely. Yeah, so you can set up. So this is our continuous integration build. It'll build every time somebody pushes something to master. I'm sorry, dev. Your default branch is dev.
Yep.
Somebody pushes something to dev on GitHub.
Okay.
Or every time somebody opens a pull request. I could also create a new build pipeline that runs maybe at a certain time, right? So I can let's just go ahead and select that YAML build, and I've got all these triggers here now. So the default
it's right
one,
there.
yeah. So the default one is to trigger based on continuous integration check-ins, but I can add a scheduled build to run as well. Very
there you go,
straightforward.
chat room.
And you got to watch out
easy.
for these time zones, man. So I live in the UK, and so I've got some continuous integration builds that kick off at midnight every night, which is a little bit different when you're here.
When you're in the States?
Las Vegas, yeah.
Right.
I was like,
Pacific time, what? That's 9 hours ahead.
yeah. I was like, why are all these builds running all of a sudden? So, pro tip: time zones are terrible.
They're not terrible. They're confusing.
They're confusing. So, okay. So while we were looking at that, it turns out that our deployment finished. So let's take a look at what happened. It ran and updated to point to my container registry and fritz.streamtools number 77. So let's actually go load up that website. So it was hello world. We're going to hit reload, and hey.
Oh man, look at that. So
that
these
is
are
your
the
stream
tools,
tool.
yeah, that we've been building, right? I've got that current viewers widget that I use and the
Mm-hmm.
current followers, and those are just pulling test data now because we haven't registered any information.
Okay.
So where you had put variables in for deploying to the container registry, I have some configuration information that we put into our app settings around like my Twitch credentials.
Got it.
So that the bot can pull down and appropriately access my channel and pull that information. Otherwise, I just have a test piece of data that just updates occasionally, so you can see that it works. But we can do things like if we go to follower goal up top there and pull that down, configuration, and this gives so this is a little configuration thing. Until we fill out some of these, it'll reload that preview and give us the full information, a little bar, right? One of those gauges. Everybody likes to have a thermometer. How close are we to goal? So that's what this will do.
Cool.
So, oh my gosh, it works and does the thing. Now, when I'm ready to deploy the next version, right? When I finish when I get ready my next feature and I'm ready to deploy that, will I always be triggering the release, or is there something that I can do to say only trigger the release when this happens, right? Now, you pointed out particularly, and I'm thinking out loud, that I use that dev branch. This is where I'm working, but master is my production quality.
Right, because you use GitFlow.
Yes.
We'll have a
feature
conversation
branches.
about that later.
Oh, no. I've been a bad developer.
Anyway, I'm sorry.
Not a problem.
I didn't mean to interrupt you.
No, please. Oh my gosh. I'm in so much trouble.
So what we've done is the release that I set up is triggered manually right now.
Okay.
So there's no sort of automation yet.
Okay.
But what we could do is we could set up, just like you had build triggers, we can trigger a release based on a build. So every time we do a continuous integration build, we're going to upload something to the container registry. Every time that happens, we could trigger a release to a staging server, for instance. And so
I could do that smoke test.
That's
Make
right.
sure that it loads up and has in my case, my Twitch configuration loaded properly for this.
That's right. That's right.
Okay.
So what we did is we just added this one stage, deploy to production. I could add a new stage, and let's call it staging. Let's see if I can remember how to set the. Here, actually, no, that's not what I want to do. Let me get rid of this.
And I love how flexible, because I've built this with ASP.NET Core, it's just a little website. It's an easy sample that we can push around like this, and how flexible the DevOps tools are at picking up and just run with it and let's deploy and package it. Oh,
right. So, and let me change this. So, and this is something I actually do with my blog, which is perhaps a bit of overkill. So what's going to happen here is the first thing that happens in this deployment, and this is the sort of thing that you might have for an automated continuous deployment sort of setup, is it's going to deploy to staging.
Yeah.
And then I can add some approval gates. So I could add myself, for instance, as an approver here. So now we've actually need a manual approval before we go to production.
Yes.
So it'll go to staging all the time. Every change you make goes to staging because it's a staging server. Who cares? Right. But production, of course, is a little bit more important. Yeah.
Oh yeah.
So what you can do is you can go to the staging server, validate that everything's working correctly, and then deploy to production when you're happy.
Very cool. Okay. So that was a manual process. Is there? I'm assuming there's also automated processes,
Sure.
automated gates.
Sure. Yeah. So, I mean, the most obvious one, again, is you could do a time-based trigger. You could do a trigger based on the a build success.
Okay.
Yeah.
Okay. Could I run integration tests with something like Selenium, and based on the results of those tests, decide, oh yes, here's my automated smoke tests, deploy.
Yeah, that's absolutely. You can even do something that. Let me click on that again and edit it. So there we go. Oh, I didn't save that. Anyway, there are all sorts of these deployment conditions. So you can do gates. So here's a really naive one. 5 minutes after the staging go to production. You know, if nobody's running screaming, then you don't cancel it and it'll just automatically go. That's pretty naive. But the more interesting things, I think, are, you can hit a REST API. You can run an Azure function. So something somebody did was Twitter sentiment analysis.
Oh.
Wiring up Twitter sentiment analysis. So you can roll back a deployment if people on Twitter are complaining about it. So there's all sorts of clever things that you can do. Maybe if somebody files a bug against you, you roll back. So that's query work items.
I could put a command in my chat room and moderators could roll back.
That's right.
That's dangerous.
It is. Yeah. So there's all sorts of clever ways that you can build your workflow.
Very cool.
That's what it is. It's a very customizable workflow engine.
And there's notifications hooked up to these steps, right? I'm not just going to suddenly be like, oh, guess what? Version 78's in production.
Right. No. You'll get an email. And in fact, the email that you get when we had that staging to production setup, you'll get an email and you can just click button to approve if you're the approver that's notified.
Okay, and then the deployment process happens, and as we saw, 2-3 minutes later,
Boom.
It's just up and running.
Yeah.
Does it gracefully deploy and swap that out?
Sure, you could do blue-green deployments. You could do, you could do some sort of DNS update, or it's
Staging
incredibly
slot and
flexible.
swap?
You could do what do they call that in Azure? You could swap a slot. Yeah, that's exactly right.
Yeah, the staging, whatever.
Right.
I don't want to get the name wrong.
Right.
Because
same.
I'm going to.
Same. But yeah, I love a blue-green deployment.
Yeah.
It's probably overkill for where you are today, but I think you're going to get there.
There's a question here in the chat room. Speaking of integration tests, like we're talking about, because I really want to make sure that I deploy this properly. Do the DevOps agents have SQL Express or MS Local DB or SQL Server Developer Edition if they have to work with a database?
Right.
Do they have one of those?
Right. The agents themselves do not have a database, but you could talk very easily to SQL Azure or something. Or this is an example of where you might want to run your own agent locally. And of course, it doesn't have to be locally in your data center. It could be something that you've provisioned in Azure yourself.
Okay. Now, I'm going to go to the last question from Kirsten. Kirsten's been pretty engaged during this session. Thanks so much for joining us. Can I use a deployment group to deploy to an on-prem test and then only deploy to on-prem production if the test passed?
Yeah.
That feels...
That's some advanced stuff, but yeah, absolutely.
Okay.
It's really just a very flexible workflow engine. So you can just wire it up to if this, then that, if this, then that.
Very cool stuff. Oh my gosh, Ed, thanks so much for helping me out with this.
Thank you.
I've got to get together with you about this afterwards. I know I'm going to get my hands slapped. Don't tell Donovan. Okay, but coming up, there's something coming up next. Seth, what's coming up next?
That's a really good question. I'm actually really excited because right over here in the back, we have Scott Hunter and Mike Harsh with Beth Massey. I want you to grill them all about .NET. Let's go to that right now.
Hey guys, this is Beth, and I am the product marketing manager for .NET, and I'm here with Mike and Scott. You guys want to introduce yourselves?
Sure. I'm Mike Harsh. I'm a GPM on the Windows Platform team.
Scott Hunter, the director of PM on the .NET team.
All right, so we had some amazing .NET announcements today, didn't we?
Indeed.
Okay, so I think the number one on Hacker News all day has been the open sourcing of WPF WinForms and WinUI XAML library.
Yeah.
What the heck is that thing?
Okay, so yes, it's been trending on the number one spot on Hacker News all day, which has been awesome.
That's been fantastic.
I think there's like 225 comments already, so it's been awesome to see. So there's been some comments on Twitter too. Some folks have talked about what is the story with UWP, why is that not being open sourced? So there's a little bit of naming confusion, and so I just want to straighten that out a little bit. So Windows UI XAML is the official name, what we're calling the UI stack that's in UWP. So the UI that is built into Windows for the UWP program model, we're calling Windows UI XAML. That name is actually reused. That is the name of the NuGet control package that we released to build, and that is what was the first part of Windows UI XAML that was open source today. That will be the project on GitHub that we eventually put all of the Windows UI controls and the rest of the Windows UI XAML framework into. And so timing-wise, that will kind of happen throughout 2019.
Okay, gotcha. So not everything is open right away, but as we make more code available in the coming months.
Is it primarily the controls?
Today, what's available is a set of the controls, and the things that are in the Windows UI library you get packaged today. Those are all open sourced, and then we're going to be rapidly adding more controls to that, and then a little more slowly, but still, hopefully in the next year, get all of the rest of the framework. So
the app layout itself will actually be there as well.
Yeah, and the layout engines, all of the data binding, all of the things that make a UI framework, not just controls.
Awesome. And I know this is like one really big ask from the community, so it's really nice to see this happen today. So really exciting. Do we already have pull requests and everything actually? So
there's been some really really interesting discussion. I've been paying a lot of attention to the WinForms repo. So I should admit, I started my first job at Microsoft in 2000 was as a PM on the WinForms team. So I worked there for about 6 years. So I have a lot of passion for the WinForms space, and so I've been really paying attention, very close, to that repo today. And there was, I think, 2 really interesting discussions. I mean, Oren had the first pull request that Scott did on stage. That was really cool to see. One kind of spontaneous thing that happened in the community today was some of the icons. So the WinForms had to work all the way down to Windows 98, and Windows 98 didn't have a built-in hand icon.
Okay.
And so there was a hard-coded resource. And that meant that you always got the hard-coded resources, and if they changed the system, you didn't get the new ones. And so there was a pull request to say, why don't we update this and not use the hard-coded one anymore, because .NET Core 3 works down to Windows 7. Obviously, Windows 98 hasn't been supported for a minute. And so that was a pretty cool thing to see. And then there's this other thing called a task dialog, which is it's a Windows feature. It's like a super message box. And there was basically a discussion around adding a new class for that to both WinForms and WPF, so you can get kind of a super message box. So it's already like the community's kicking in. Good things are happening.
That's
so
awesome. Well, okay, so let's talk a little bit about .NET Core 3 and it's supporting WPF and WinForms. It's pretty cool too, right?
Yes.
What's the big benefit of that, Scott? What do we get?
So when .NET Core was created, it was meant to solve some of the problems we'd learned over the years building .NET Framework. The primary one being, sorry for my voice.
I know you're sick as a dog.
The primary one being, how many .NET frameworks can you have on a machine? So, we technically support 2 today, .NET Core 2, .NET Framework 2 and .NET 4X. 3.5 is actually a variant of 2, so there's always been only 2 versions on a Windows machine at a time. So one of the benefits you get with Core is obviously you can have as many cores side by side as you want. No longer do you have to worry about risking an application breaking because the framework changes.
I see.
And we don't try to break anybody's applications, but the reality is fixing a bug, maybe you depend on a bug and you don't know you depend on a bug. That happens. I mean, stuff just happens. We want to give customers more control. Another cool thing you get with .NET Core is you don't even have to depend on a framework being on the machine. You'll be able to actually take your WinForm WPF application, compile it down to a single exe that is self-contained. It contains the framework, your application, all of those things. And I think what it really means was, as a developer, you can decide to be on the latest version of a framework and not worry about IT having to go and update all the boxes.
So it's like Xcopy deploy for WinForms.
It is.
It's awesome.
And WPF.
And WPF, right.
And then there's one final other, big advantage, I think, and that is Core is where we will try new APIs. And so the latest, greatest APIs are in Core today. Some of the new C# features will only be in Core. So if you want to be on the bleeding edge of APIs, the bleeding edge of language features, Core is the place to be. That said, .NET Framework's not going away. It will never go away. I said this in my talk today. I'm like, it's part of Windows.
We have a lot of applications at Microsoft that rely on products.
I have this app on my laptop called Visual Studio.
Visual Studio,
it's built
exactly.
on .NET Framework.
Who's ever heard of that, though, Scott?
Right. Who uses that?
So it's
yeah.
But
it's really
the support,
important to know.
it will be supported as long as Windows is supported.
Okay, so the idea is that .NET Framework itself is going to be safe and reliable and always supported on Windows.
Yes.
Okay, and that .NET Core will have more of the bleeding edge features. If you want to take something, you can deploy it with the app, so you don't risk breaking other applications, and so that's why we can move faster with .NET Core.
Right.
Is that what you're saying?
And you can be on.
Okay.
There's 2 .NET Core trains. There's the LTS train, which is the long-term supported train, which about one of those comes out a year.
Okay.
And there's the I want the every other month bits.
Got it.
Faster track. So you can choose which track of Core you want. One app
What
can be
LTS are we on now? 2.1? 2.1?
2.1.
2.1. Okay.
And so the
will be
next LTS will be 3.1.
Okay, gotcha.
So we'll ship a 3.0 sometime in the July, August timeframe, I would hope, of 2019. And that means that the LTS build would show up somewhere in the October, November timeframe if we hit those dates.
So what about on the server side? I mean, we've got to have some improvements in .NET Core 3 for ASP.NET developers too, right?
That's the biggest misconception I think that people had. We were so heavily focused on talking about desktop at build this year.
Yeah.
We were so excited about bringing WinForms and WPF to Core that we didn't talk a lot about the server. The server is just as exciting as to me as the client side. One of the coolest features we're going to have is something that it was codenamed Blazor.
Okay, right.
And this was letting you actually write C# code in the browser. And this is not like fake C# code. This was actually the assemblies download and run in a sandbox.
This is the WebAssembly.
In the browser using WebAssembly.
Yeah. Okay.
And we've been showing that for the last year or so. The first flavor of that will ship as part of Core 3 as well. It'll be part of ASP.NET Core 3. Your code will actually run on the server, but the programming model is still the programming model where it appears that you're writing C# in the browser.
I see.
Inside of the HTML, inside of that.
So you write, they're called Razor components, right?
Razor
so you
components.
create UI,
Yes.
all in C#, and so you have a full stack web development with C#.
Full
you don't have
stack.
to write JavaScript at all.
You don't have to rely on Angular, React, Vue. You don't have to write JavaScript. I mean, we're not trying to. This is not a war against JavaScript.
No,
This is
I love C#.
use the skills that
so-
you have. If you have a lot of C# skills and you want to use those in the browser, bang, you can now use those in the browser.
It's, context switching sometimes too, I mean, I think that's why the appeal of Node, Node.js, because you're just using JavaScript on both sides, right? So these C# developers can enjoy that as well. I think that's fantastic. Actually, there's a question here that kind of relates to ASP.NET. Are there any modification requirements to move ASP.NET MVC Core 2 project to Core 3? Can it be done now?
So the best way to answer that question would be, we just shipped ASP.NET Core 2.2 today as well. So not only do we have the 3.0 announcement,
right?
We just had the 2.2 announcement. What I would tell the customer is they should move to 2.2.
2 first. Okay.
All we did for 3.0, the 3.0 build that came out today, basically has the exact same ASP.NET Core 2.2 bits.
I see.
That shipped as part of 2.2.
Okay.
So there's no benefit to move to 3 yet. Won't be till not later this year, sometime next year.
Wow, preview 1 comes out quick.
Sometime next year,
Okay,
we'll start having the next innovations beyond the 2.2 stuff. They'll start showing up in the 3.0 bits. But today, your best bet is to stay on 2.2.
But we aren't anticipating any major changes that you would have to make to
Our
move.
goal is to make it as easy as possible to move. I mean, there'll always be some breaking changes. 2.0 to 3.0 there's some breaking changes. We assemble the product differently than we did before. I mean, if you're an ASP.NET customer, the ASP.NET frameworks have traditionally come as NuGet packages. And so there was .NET Core, and then there was ASP.NET Core, which was kind of separate.
Okay.
Now we're shipping the whole thing as a monolith again. That's to enable a bunch of cool scenarios. We have partners like Red Hat that have a version of .NET Core they ship. We want ASP.NET Core to be part of that. So it all has to be built from source.
Okay,
So
that makes sense. Cool. So how will we acquire, is the WinForms and WPF? Is that going to also be NuGet packages, or how is that going to work?
You just go download the 3.0 SDK
And it'll be in there.
type .NET New WinForms,
Perfect.
and you're good to go.
Good, great. So you're going to show a little demo of this?
I can do a little demo.
I'm
think
kind
you're
of
going to be
intrigued.
porting a WinForms app here.
So you're going to take a WinForms app on Framework, and you're going to port it to Core.
Yeah. So I've got and first off, I need to also preface, Preview 1 is pretty rough.
Okay.
We knew it was going to be pretty rough.
Okay.
We primarily focused on the actual runtime. So most of the work has been done in the Core 3 runtime. The tooling is a little bit behind us, meaning that File New in VS 2019 does not have WinForm for Core or WPF for Core.
We'll have more previews. It will get
We will have more previews.
Okay.
We don't have visual designers
Okay.
yet, but I'm going to show you how you can actually build a Core project and actually use the designers from the full framework application. So if you go look at my laptop, I've got Visual Studio 2019 here, which is required for Core apps, Core 3 apps. And if I run it, this is a memory matching game. You keep clicking these things until you find the ones that match, and you click through. And so we thought, hey, let's port this to Core. So it's going to be a little crazy. What I'm going to do is I'm going to go here at my command prompt, and I'll do .NET New WinForms, and I'll say output. We'll do matching game Core. So that basically builds me a skeleton of a WinForm application on Core. So let's go back to our solution, and we'll go add that existing project. So now we have a Core WinForm app in here. And if I set it in my startup project, it runs and builds. Hello .NET Core. Ooh.
Awesome.
But really what I want to do is I want to get that game running over here. So I'm going to cheat a little bit.
Okay.
So one of the features we've had in Core for a long time is our project system is pretty cool. That if you look on the screen here, I've got the forms, the program CS, and whatnot. If I look at my project file, they're not in the project file.
Just points to the folder.
It points at the folder, and we glob in all the C# files. I can also have it glob in from somewhere else. So what I'm going to do is I'm going to cheat a little bit here. I'm going to go take all the code. Let's just erase it. And then let's go back and open that CS project again. And we don't screw this up on stage. Let's paste some code over here. And what I'm going to basically do is paste in a item group that tells the system to basically include files from a particular folder. So in our case, we'll just erase this. There you go. So as I save that, notice that all the files from the full framework app just showed up in the core app.
Cool.
That's pretty cool.
So I'm cheating. I'm aliasing into the existing project.
I see.
So any code changes I make to these files happen in both the full framework and the core application.
Scott, good engineers don't cheat, they're efficient.
So now the next thing is, if I build this, I'm going to see a couple of errors. So let's do a build. And first off, as I get a duplicate type, assembly company attribute. And that's because in a .NET Framework application, we typically have a properties app with an assembly info.
Okay.
In core, we said, why have a file that was basically a place to put metadata? We said in core, let's put the metadata in the project file. And so what's happening is, in this particular case, I'm trying, .NET Core is trying to dynamically generate one from the project file, and so there's two of these things.
I see, and they're conflicting.
So we'll tell it to generate assembly info. False. Better. Now, my matching game uses this game logic, and I need to reference that as well. So I'll just come over here, add a reference.
So you're basically switching project systems, and so you're kind of doing some manual changes around the
Yeah.
project system itself, but not the source code.
Exactly.
Yeah.
So the source code's all the same. Now that reference is there, and now I've got the exact same app running on core.
Cool.
And it works just the same as it did before.
Okay, so that's a little manual because we don't have all of the tooling yet, but as you can see, guys, you can take some of your apps that you have today and you can see if they're running on core and how they perform and that kind of thing.
And the
right, to test
repos
now.
have instructions on how to do this for both WinForms and WPF.
Great.
And also, if you hit more than just project system issues, you can use the API port tool to find out which APIs aren't supported currently. And the set of APIs that's going to be in 3 isn't fully baked yet too.
Right.
So if you open an issue with the API, we can take a look at that and add that back.
If you look at my gaming logic DLL or assembly, if you look, I actually had a porting problem, and because I had a porting problem, you can see that I installed the Microsoft Windows Compatibility Pack. That's a NuGet package. So .NET Core by itself, it was designed to be cross-platform, which means we can't ever put Windows-specific things into .NET Core.
Yep.
So we have a NuGet package we put out a while ago in the 2.2, or actually the 2.1 timeframe, I think. And what it does is it basically brings a lot of Windows things back. It brings registry back, brings directory services back, system management back. And so if you try to port some of your code and you find APIs missing, the first thing to look at is go and grab this NuGet package, stick it in. In my case, the game actually saved your high score in the registry.
I see. So
and so I brought this in to
API.
use the registry.
Okay, got it. All right, so that's good. That's cool. So there's another interesting announcement and feature about .NET Core 3 that I wanted to ask you about. These things called XAML islands.
Yes.
Yeah.
XAML Islands. So XAML Islands is a Windows feature that first shipped in the release that I think is just starting to roll out now. Internally, we called it Redstone 5. I forget what the actual official name is because the marketing team picks forgettable names on purpose. It's just Windows 10. And there will be some additional improvements on that feature that are coming out in the spring release for Windows. But basically, the idea is you can take a piece of Windows UI XAML, a control, and you can embed it in a WinForms or WPF app or anything with really an HWind. It's effectively an HWind host.
Okay.
And then you can start to use new UI features. That's what Scott Hanselman showed on stage today with the signature control. That's the ink canvas and the ink toolbar from the Windows UI XAML library, and just plop that into an existing app. So that's what that feature is all about. And that works in both .NET Core 3 apps as well as .NET Framework apps.
Cool. So basically, you're saying I could take my app and slowly take a onesie twosie approach to moving it to Windows 10.
Yes, I mean our goal here is to really bring all these platforms together. So you can use any feature in any app type, regardless of where you started from. You shouldn't think of them as different platforms. It's just one set of APIs you can choose from based on what you want to do.
So I can get a modern browser in my WinForms app now.
That's right.
Okay.
That's very similar to that concept. Is very similar to what we did in ASP.NET years ago. We called it one ASP.NET, which was, hey, you might start with a web form application, but you want to add MVC, or you want to add SignalR, Well, now we don't care. If you start with a WinForm app, a WPF application, you want to go add a XAML UI control, boom, just do that, right? Choose the UI tech that you're comfortable with.
That's fantastic.
Yeah.
And get all the features.
Or have a giant code base, and you obviously don't want to either start from scratch or rewrite
Correct.
large things if you don't want. If you
I
don't
think
have to.
WinForms is like 2002, right? I mean, it started from the beginning.
2002.
And then WPF was like 2007, 8. So these apps are probably about that old.
They've got some good vintage to them.
Yeah, but they're probably business critical.
A lot
And
of
you
them
know,
are.
they have to be modified and they have to be updated.
But there's still a lot of people, actively doing WinForms and WPF development. There's, over 1 million monthly active WinForms developers.
Yeah.
I think it's 2 million.
I think it's more than that. But so do we get like performance benefits as well as part of being on the core runtime?
So you will get some performance benefits, primarily in the standpoint that we've, obviously ASP.NET Core, .NET Core performance has been a big push with us. You've seen us take the web stack and be in the Tech and Power benchmarks. And as a result of that, there's been features added to the language span. There's been modifications to some of the BCL to make some of those results happen. You might ask, well, why didn't you make those same changes into .NET Framework? Well, the reality is we changed some of the file APIs to fix bugs that were in .NET Framework, but I can never put it in .NET Framework because it would break stuff.
I see.
And so there are API improvements. Also, .NET Core is open source, so anybody can contribute. And so maybe something is too small that we would not look at, but somebody makes a performance fix from the community and we accept it. So you will find that Core is going to be a little faster than .NET Framework.
Yeah, so kind of a discussion going on Twitch right now, what we should kind of address maybe. So how does UWP fit into kind of all of this? You kind of started to say like before what the XAML library is. How does this whole thing kind of fit together with UWP?
So you should really think about basically if you have a WinForms or WPF application and you're happy with that and you want to add some new Windows 10 features to a desktop app and you have an existing desktop app, you can start adding those features. I mean, there's many of the WinRT APIs you could use already. With XAML Islands, we kind of closed most of the gaps of things that you can't use in an existing application. If you want to build an application that is fully top to bottom brand new and modern, you can start with the UWP application. There's a lot of investment we're doing in the UI stack there to kind of address some of the gaps that customers have told us about for building line of business applications. Like shore up some of the data story and form validation that we're actively working on. But the real reason that you would pick a UWP to start with, especially if you're building a new application, is you can target other Microsoft devices. So if you want to go build an app on Xbox or Surface Hub, that's your route for that.
Got it. Okay. So XAML Islands are really desktop related only. Got it. Okay, that's very cool. Cool. All right. So want to talk about a couple more announcements, Scott?
I want to show one more demo real quick. Give me 1 second.
Wow. 2 demos from Mr. Hunter.
Well, we showed before. We showed making that game.
Yeah.
Using WinForms.
Uh-oh. Is this going to be in a browser?
Let me shrink this so it fits on the screen for everybody. We also took that same game. It just happened to be that that game was written in a great way where all the logic of the app was written inside of that game logic assembly or class library. So it was very easy to go take the same UI and build it in the web. And so I shared that same project. It's a .NET Standard 2 class library. I shared it across a Blazor app. And here I have the same game running in the browser.
Oh, that's so hot.
That's cool.
That's so hot.
So,
wow.
I thought I would just show that is the goal is, whatever UI you want to build, whether it's desktop UI or web UI, Core is going to be a great place to be for that.
That's cool. And we keep innovating and bringing in more workloads there. Like we have ML.NET as well for machine learning and AI.
We've been doing a lot of work for IoT. Azure IoT runs on some .NET Core stuff. And so in the blog post on .NET Core 3 today, we talked about getting serial port access in IoT for Linux.
We're going to do some fun IoT stuff today,
too. So there's crazy stuff all across .NET.
That's very cool. So actually, let's ask, here's a question from No Content, really cute handle, I like that. Will .NET Native also become for WPF and WinForms now since it's on .NET Core? So you want to talk a little bit about what .NET Native actually even is there, Mike?
Yeah, so .NET Native is the ahead-of-time compilation story that UWP apps use today. And so if you're super familiar with it from developing, there's definitely some quirks around it because it basically looks over all your code and basically ahead of time compiles it to x86 or ARM. There's some features in .NET like reflection. If you don't have a type there that's already been generated, you basically will kind of get a missing method exception. There's some bad things can happen there. On the flip side, you do get a bunch of great performance out of it. So it is a very interesting story. But I believe that Scott can talk about the AOT story for .NET Core is going to go in a slightly different direction, I believe.
Yeah, we haven't really announced that direction, but I will talk what you said, which is a great point. As we started building the WebAssembly work, that's the Blazor stuff. You need an AOT solution, and like, do we use .NET Native or do we use something else? Currently, the Blazor work uses Mono actually.
Okay.
Because that runtime had more support for WebAssembly types of things. The one thing we want to be very good at, we want to be very clear about is when we do a new native implementation, we'll do it where .NET can be .NET all the time. Like Mike said, .NET Native made some sacrifices for security and performance by removing parts of .NET. Whatever we do in the future, we'll give you an AOT ahead of time compile that actually runs all of your .NET code. So it might mean that we have to use an interpreter along with some of the native code.
I see.
But I want to make sure that whatever .NET we give you is the full .NET. And then if you want to go dial some of it down, if you want to go turn reflection off for security reasons or size of device or whatever, you can do that. But because you made the decision to do that, you understand that there's less compatibility there than there was before.
No surprises, basically.
But I don't think the AOT wave will be after the .NET Core 3 wave.
Okay.
So we'll ship .NET Core 3 with Blazor running on the server side, and hopefully we'll start previewing some of the AOT stuff after that.
Cool.
Yeah.
And I think to close the question a little bit for no content there, basically we want to make sure that the AOT story that we develop for Core also applies to UWP. So you have, again, all this is about having a consistent .NET story everywhere, and we want to make sure that we kind of close that gap.
We've slowly been trying to get to what we call one .NET, which is one set of compilers, one set of garbage collectors, one set of jitters, one set of APIs.
I see.
You'll continue to see us shrink and share stuff more and more across the various runtimes. Today the runtimes would be Mono, .NET Core, .NET Framework, and native.
Gotcha. So and because open source has really kind of changed that culture, so now we can actually kind of do this now, right? I mean, before it wasn't possible.
Certainly
really.
easier.
Certainly easier.
But it takes AOT is hard, so it'll take some time.
It'll take some time. Cool. All right. By the way, Skull Crusher for Life, you are awesome. Did he just build that demo while in the middle of the session? Nice. So that's shout out to Scott. Nice job, dude. One more question here. Can I now use WPF and/or WinForms from PowerShell Core and/or on Linux or Mac?
So I don't actually know how to answer the PowerShell Core question. Okay. The Linux or Mac is so basically. WinForms and WPF still rely on a bunch of Windows APIs for input, output for drawing, and so those are still Windows desktop only components. So we have nothing more to share there as far as announcements.
Okay. I'd like to add to that though. People ask this question all the time. It's like, we've been talking about .NET Core 3 and desktop for a while, and it's like, hey, are you going to make WPF cross-platform? Are you going to make WinForms cross-platform? I don't really think you want a WinForms app looking like a WinForms app on a Mac or a Linux machine. So I think we haven't decided, or even the industry has not decided yet, what the best cross-platform UI story is. And so while it sounds great to say WinForms could run on a Mac user would go, why do I have this weird X in the window?
Look right. Yeah.
I don't have the dots over on the left side. That doesn't feel like they match.
Why did you make my Mac look like Windows 95?
Like a Windows 95. It would be. It'd make a Mac look like Windows 95. So I don't think these are the right technologies for that. I don't think Microsoft today has a story on what cross-platform UI is. That's something that Mike and I would love to work on in the future, but we're not there yet. And so but yeah, these are Windows tech. I think for the PowerShell one, that PowerShell core runs on Windows, Mac, and Linux. So yeah, you could probably call some.
I mean, there's probably a bunch of types. Like if you wanted to go use a system.drawing rec, you could there's a bunch of types that don't actually have UI backing. I'm sure you could use inside, but if it's going to basically if it's WinForms, if it's going to do anything HWin related or do a pinvoke,
it's not going to work.
Yeah, it's not going to work.
Cool. Okay, makes sense. Okay, how close is .NET Core to build self-contained executables? Is it similar to Golang? That's a good question.
Yeah, so that's kind of a long roadmaps discussion again. So what we'll do in the 3.0 timeframe is we will give you we'll have some technology we have that will basically take the assemblies that make up your application and compact them into a single exe.
Okay.
It still is all those individual components. They're just
packaged
they're
better.
just packaged better into a single exe for you.
Okay.
The Go question is more of, are we going to provide native exes on those platforms? And that comes back to the AOT story we talked about earlier for WebAssembly and for .NET Native.
Right.
And what ahead of time compile AOT is something we are definitely looking at post the 3.0 wave.
Okay, great, exciting. All right, so one more question here. Are you going to enable application domains and DLL unloading?
So app domains is a good one. That is something that obviously, as we've been working with partners to port their WPF and WinForms apps, it's come up, and it's pretty rare that people actually need this kind of process level isolation like features, but there's some APIs on app domain that are useful, and so we're working to create an app domain class that has a lot of kind of API functionality that more or less, but doesn't actually have the kind of code isolation of an app domain, but it has some of the additional features that we found people using.
Okay.
From that perspective.
Yeah, a lot of customers use app domains today to load extensions, and like even Visual Studio, I'm sure using app domains when you install some other extension into Visual Studio. It lets them load some third-party DLLs into the application, and you can unload them. We're going to build a new library on top of Core for doing that.
Very cool.
It won't be app domains. App domains actually combined a whole bunch of random stuff together, and some of it didn't work very well. And so we don't want to bring the stuff that didn't work very well forward into Core.
But like just to stitch those two things together, that we could make an app domain API shell basically, or shim, that would use that would do the loading and unloading, but so it would be API compatible with your existing code, but then could call the new better functioning actually APIs under the covers.
But we'll give you the same functionality that most people want to use it for, which is loading extensions. We're building a new API right now for that.
Cool. Awesome.
And as a general shout out to any API questions, the best thing to do is to use API port on your code, and either send us a report or share that via a GitHub issue, so we can keep track of these things, because now that we have a public place to keep track, it really helps us steer the roadmap.
Yeah, we had a blog post about. Unfortunately, I don't know it off the top of my head, the URL, but we had a blog post I think in August that Alia on the team put up, and we actually had a tool you could actually run and just point it at your exe, and it would basically look at the APIs and all so you felt safe. It would show you the output of what it was going to send, and then you would press send. It sends us the APIs. That information helps us a lot to know what APIs to port.
Okay, so that we can take a look and say, hey, we know a lot of people use API X, we're going to support API X.
And it's anonymized too. It basically just says these APIs this many times, not necessarily what you use them for, or any variable names or anything like that.
Gotcha.
So
okay, that's awesome. That's awesome.
Privacy scrubs.
Let me throw a question in, just myself off of this,
Sure.
just because it's a common question that people
Would you like
ask.
to host the next session?
No.
Yeah. Okay.
Another one that comes up a lot is, what is our story for WCF? I thought before I wait for it to show up on the screen, I thought we just talk about
Let's
it a
talk
little
about
bit.
WCF.
A lot of .NET Framework applications are using WCF, or they're using .NET Remoting. We're not bringing either of these technologies to Core at this point, but we are looking at alternatives. There is gRPC, which is an RPC model, which is very similar to a remoting or a WCF model.
Okay.
And so the ASP.NET Core team is working with the gRPC project themselves to make that thing have first-class .NET support, and actually make it like it feels very similar to like an ASP.NET or something else would. So we're looking at that.
Okay.
And we're also potentially looking at the parts of service model, which is the low-level bits of WCF that we could bring forward without bringing all of WCF. So we're looking at various angles of how do we solve the RPC problem, because it's a valid concern, and we need to have one on .NET.
That's a good point. Do you guys want to talk a little bit about the .NET Foundation announcement today before we have a little bit of time here?
Of anybody that should talk about the .NET Foundation announcement, the chairman of the .NET Foundation should probably talk about this.
So today.
Was that a self-serve there?
I just thought we were talking about .NET. Let's talk a little bit about the .NET Foundation, and I think who better to talk about it than us, because we're on .NET. So one of the announcements was about the governance model changes. Okay, so basically expanding the board from 3 to 7 people, and 6 of them being able to run anybody that has contributed anything to any .NET Foundation project can run or can vote. I think that's going to let the foundation really scale its efforts more, right? So why does this, really, why do I care as a developer? Well, you care about your platform. You care about the longevity of your platform and the size and the health of your ecosystem, right? So that's kind of what the foundation is about in general, right? It's that center of gravity for open source around .NET. And if we have more people that have a stake in that and are volunteering to do something they're passionate about and help move that forward, we're only going to have more growth and more success with the platform. So that's how I took it. And yes, I am the appointed member on the board from Microsoft. So I have huge passion in this area. So I think that's going to be like a fantastic new era for .NET.
Well, I think another big point in the .NET Foundation is, historically, if you look at the last couple of years, the .NET Foundation feels more like the Microsoft .NET Foundation.
Yeah.
And what the governance model really is about making it equal for everybody. There's only a single Microsoft representative that has to be in the foundation. The rest of it is community elected. So it is not heavily tilted towards Microsoft. The foundation historically has also been funded by Microsoft, and it's going to go to a self-fund cycle as well. So it's going to become more of a independent foundation that's run by the community, and not something that you could interpret the older version of the foundation as more of a Microsoft-run thing.
Right, and I think there's rules in there where only 2 max, I think, board members can be from the same company, so you can't stack.
So you can't stack or anything.
Yeah, so that makes it even more open, more fair, and get better. The idea is to get more ideas as well from other companies as well, and
to be more open, to be more or less Microsoft. I mean, we're riding this open source wave, and we want the .NET and the .NET Foundation to be as open as possible.
And I think there's just a lot of things that we can do, right? When we have that, extra money, we have those extra bodies, we can scale more, we can have, different types of events, we can help, help our community do the things they really want to do too. So I think that's pretty cool. So
I'm excited.
I'm excited.
It's been saying on the front page of Hacker News all day as well. So the community must be excited too.
Pretty exciting. Yeah, I'm actually pretty excited about that.
So are we worried about voter fraud for any of the positions?
We only use .NET for that, so you're fine.
Okay.
So there is a question here. So there looks like they're having a discussion of what are the benefits of joining the board. So that's actually a really good question. And when Scott asked me, I was like, first of all, why me? And then I was thinking about it. Really, though, it's a volunteer position, and you really are about directing the platform, directing the ecosystem. It's really about making choices that are going to benefit .NET. And when I say .NET, I mean the platform itself, as well as the community around the platform. So that's kind of why you would join the board. You have some passion around .NET open source, and you want to help the community. And that's how I see joining the board. I am excited. I have some ideas, and I can't wait to see who else is going to be on that board. So elections will start in January. So yeah, if you guys want to run, we'll have all the information on the .NETFoundation.org website about that. So that's very cool.
Cool.
Are you going to run?
I guess we have one more slot from Microsoft,
You have one
right?
more slot from Microsoft.
I'll have to see the competition. I don't.
Awesome. Cool. So we got a couple more questions here. Let's go ahead and say, any plans for UI automation for Core or UWP?
So we do have UI testing for UWP and for Windows apps with WinAppDriver. I'm assuming you're actually talking about the UI automation class, though.
I'm assuming that's
it would
what
be.
the question
I'm not sure. There's a bunch of different scenarios that UI automation. It can be used for accessibility tools. It can be used for testing. It can be used for actually doing some other scripting of scenarios. So I think I don't think there's any plans right now for any of the frameworks to have UI automation, or at least in UWP. But it would be really interesting to know what the scenarios they're looking for, because that's the thing that we probably have a good answer for based.
Cool. Well, is there anything else you guys want to say to the .NET community out there on Twitch before we wrap it up?
Big thing is download .NET Core 3, try the bits out, give us feedback. I mean, the reality is this is preview 1. I said it was really early, really raw, but we have like 10,000 people that ran that tool, showing us what APIs they needed. What we need is more people to try it and give us feedback.
Well, and definitely go download .NET Core 2.2, which is released today, so make sure you get on those new bits. So thank you so much, Mike.
Thanks, Beth.
Thanks, Scott.
Great. Thank you,
All right.
Beth.
All right, thank you very much, guys. All right, Seth.
All righty, that was awesome. I love .NET. I've been using .NET since it came out. I think it came out in like 1987. Am I close? 84. Sorry, not even close. Actually, coming up next, we have Suze Hinton, who is my awesome office mate, talking all about IoT with Jeff Fritz. Let's take a look.
So I'm totally going to dye the beard. It's going to go red, yellow.
I think
hi,
it'll look
Seth.
pretty good.
Oh, hello. My name's Jeff Fritz, and this is
Suze Hinton.
So why don't you introduce yourself to folks on Twitch who don't know who we are?
I would be totally okay if people didn't know who I was on Twitch, yeah. I'm Suze Hinton, and I am a senior cloud developer advocate, and I focus on IoT at Microsoft.
Now, come on, let's do the TwitchCon thing.
What's the TwitchCon
where
thing?
everybody is? You're not Suze Hinton. I'm not Jeff Fritz. Where our handles on Twitch, aren't we?
Yes. So I'm NoOpCat.
And I'm C# Fritz.
Yep.
All right. So we want to talk about IoT. You know
That's
a thing
right.
or two about that.
Just a little bit. Just a couple of
Okay.
things, yeah.
And we made sure. I know the Noob crew is going to appreciate this. We brought a mechanical keyboard.
We did, although it's not really playing super nice with my computer, so I'm not sure if we're going to be able to use it today.
We'll give it a shot.
Do you want to just quickly say what switches you're using in this and
So
things like that?
I'm using Cherry MX Blues, and these are DSA keycaps.
Mm-hmm. So they're very clicky.
They are. Can you hear that? Can you hear that? Can our audio guys hear that?
If I just like lean in.
Isn't it so good? So, but we're actually going to do live coding like we normally do. But
That's
this is a
right.
long time in coming here, right? I mean, I was talking to you about live streaming in November 2017.
Yeah, it was last year, and we've both been streaming for a long time, and we've been meaning to do something together, and we finally
Yes.
are today.
Oh
It's
my
very
gosh.
exciting.
So we've
Very,
brought
very
we've got the
exciting.
mechanical keyboard
Mhm.
working. We're going to do IoT. We've
We
got
are.
this really cool overhead camera that you're going to see in a little bit. It's way up there. And what do we want to talk about IoT today?
Yeah, so we wanted to sort of talk about how you start prototyping with IoT in the first place. I think what people get really scared about is, well, I don't understand how devices work, and I don't want to do wiring and things, and like I don't understand how the cloud stuff sticks together. So I wanted to sort of make an app like a normal web app, and then show people how you can actually have fun with it and connect it to a real device.
Okay, so and when I think IoT as
Mhm.
the .NET guy, I think C# hat and all.
Yep.
Third hat I'm wearing today.
Yeah, I noticed that.
It can happen. So I always think of a Raspberry Pi, but a Raspberry Pi is kind of like cheating with IoT, isn't it?
It can be a really easy way to get started because it's running a full-blown operating system on it. So if you're familiar with Unix systems, you can run Linux on it, but you can also run Windows on it. So you're sort of writing the same code that you are from day to day, but you're just doing it on a smaller computer.
Yeah,
so
it's cheating.
It doesn't feel as much like lower-level IoT, I guess.
Okay.
Yeah. But it's still a very valid way of prototyping things.
But lower level IoT, as we've seen on your stream, that's where the elite developers are.
Well, I sort of don't like to differentiate between what is elite code and what is not elite code. That's the thing. So,
And clearly, JavaScript is elite code.
well, it's a very high-level
here.
language that you can use for hardware now, which blows my mind. I actually think it's really funny. So that's why a lot of my open source hardware code is done in JavaScript, because I think it's funny. So.
Okay. All right. So if you've watched our streams before, you know we're going to be watching the chat room. We're going to be answering your
That's right.
questions, but you also know we're going to be writing code live.
Yeah, we're going to be juggling a lot of things at once. So I sort of tried to optimize for that today, given we don't have much time
We
to
don't.
pull this off.
And it's counting down in front of us. You
I can
can't
see
this,
it.
but it's over.
Yeah, totally.
The folks watching can't see us, but it's right there.
It's going to be really
And I've
fun.
got the chat room in front of me.
Mhm.
So let's go. What do we want to write?
Yeah. So we're actually going to be using a device today called the MX chip.
Okay.
And we actually have one on the table. So if we can just cut to a shot of that,
Yeah.
you'll actually see that it is a device that has a bunch of different things built in. So
Okay.
it has a lot of different sensors, such as a gyroscope, a magnetometer. I always struggle to pronounce that. It's got a temperature sensor, a humidity sensor. Lots of really cool stuff baked in.
What's a magnetometer? It doesn't
Yeah.
detect magnets.
Well, it senses like magnetic fields, yeah. So you
Oh.
could hold a magnet near it, and then that would actually trigger that sensor to have a different reading. So,
Okay.
Yeah, so it's really cool. There are a few buttons built in. There's a bunch of LEDs as well.
A and B here.
Mhm.
Okay.
And then there's an audio jack and a microphone too. So this thing packs quite a punch when it comes to, let's say you've got an idea and you want to glue a bunch of different sensors together. You can pretty much just start programming this board immediately without having to get stressed out over lots of wires and electrocuting yourself and things like
Yeah.
that. It's pretty cool.
Now, but what's this thing here in the middle?
Yeah, that's a really good question. So we're going to use that today, and that's called an OLED screen, an OLED screen.
It's got a display on it.
It's got a display on it, which is really helpful. And I'm not going to lie, you know when you do like console logs and things like that to debug, you can use the screen to print out variables sometimes if you're struggling to kind of get the serial connection going, or if you just don't want to use the serial connection, then you can also just print variable names to make sure that your code is running,
That's
which
the
is
way
really
we used
fun.
to write web pages.
Yeah, but like the legit use for the screen is to be able to display things like sensor readings, or maybe you want to display some fun stuff like a animated GIF.
Okay, that's absolutely fun. So, all right, let's get started. Let's put some
Yeah,
animated
let's get
GIFs on this.
started. So we have a bunch of different sort of pieces that we need to glue together today.
Okay.
But what I want to do is something fun. So the project that I have in mind, which is fully open source as well, which we're going to share the link to, is basically a way to upload a GIF to a website, preview what it's going to look like on the MX chip, and then you can choose which device to send it to, and then pretty much send it. And we should be able to see a GIF playing on the device today by the end of the session.
So we're not going to look at the device anymore, and we're going to stay focused on your PC for a little bit here.
That's right, yeah.
Okay, so we'll come back to the device in a little bit because we're going to write some code to get that up and running.
That's right. I'm not sure that I'm going to be able to use this keyboard today just because like a lot of my shortcuts were kind of like tuned for the Apple keyboard. So I hope that's okay.
fine.
But it was very cool. It was very, very cool to play with this. I kind of want to buy it for myself. So I'm going to put this to the side. But for those who do watch my stream, they know that I'm like a super big mechanical keyboard.
You've only got 3, 4.
I've got, I think I counted them. I think I have 7 at this point, and I really want to buy that one. So like, this is problematic.
And my gimmick is the hats, and yours is the keyboard.
Yes. So I'm going to cross into VS Code. So like those who watch my,
Yeah. The Vim witch has exited the building.
Yeah. So normally I use Vim, so you can kind of see. I usually have this kind of setup, right, on my screen. So if we cross over to that now, you can see that I have Vim loading. However, I'm going to be good and I'm going to use VS Code today. And part of that is because we have really, really good built-in tools for the MX chip.
Okay.
But also, when you're live coding, like on a live stream, you can use all the help you can get with IntelliSense and things like that, right?
Absolutely.
So that's what I'm going to do today. So I actually have this project on GitHub. If you wanted to pull it down, my online handle for Twitch is noupcat, and that's the same on GitHub as well. So you can go to github.com/noupcat, and I have a project there called mxchip-gifs. And I actually have all the instructions to get up and running, and so I'm pretty much going to be following through them today.
Okay, hey, moderators, do us a favor and grab that link and paste it into the chat room for all of our viewers to be
Yeah,
able to
just so
use.
that they can have a look at the source code while I'm actually developing it.
Absolutely.
I also went ahead and I put this project on Glitch as well.
And what's Glitch for some of the folks that aren't
Yeah,
familiar?
so Glitch is a really cool platform where you can basically like host your code, and you can actually host the entire app as well. And so people can do what's called remixing your application, which is very similar to forking like on GitHub. But on here, you remix it, and then you can host your own version. So if you didn't want to have to like figure out where to host it, because like Azure's a really good place for it, but if you were sort of confused about that, you can also put it on Glitch, which is really, really cool as well. So that should be all up and running for you to use there too.
Okay.
And if you don't have the MX chip yourself today, you can still play with the code and have a look at kind of how this thing would work by going to a really cool tool we have in our Azure samples repo called the MXChip IoT Dev Kit Simulator.
Oh, okay.
So this is very cool. It's not necessarily a code editor. We just have a couple of samples that you can have a look at, and then you can plug your own IoT Hub connection strings in, which is really fun. And then you can actually kind of simulate shaking the device and things like that. And then you can actually see the code running and what would happen on the device.
Okay.
So this gives you a little teaser of like what kind of code you would be writing to do some sort of basic level stuff. Mostly because the C code, the C++ code that I wrote for the device today is a little bit more advanced than this. So.
Okay.
So there's also that. So we have a link to that that dev kit simulator as well.
Okay.
So if people wanted to follow along at home with that, they can as well. So I have that repo that I just showed on GitHub pulled down on my local machine, which is where I developed this. And I made this just for this stream. So I'm very excited to debut it today.
Connect.
Just for Connect.
Okay.
So the first thing that we have here is this is a Node.js like backend. So I know that, I know it's not C#. I'm sorry about that.
Okay. All right. We'll work on that for Thursday.
Yeah, Thursday we're going to be doing little
Absolutely.
bits and pieces. So I do actually have the device code in here, which is written in C++. And the front end is written in JavaScript, HTML, CSS. But the backend server is written in Node.js, and that's because we're going to be using the IoT Hub Node.js SDK today.
Right.
So
Azure isn't just .NET.
It's not just
does
.NET.
JavaScript, Python, all the good stuff.
Java, lots of different things.
Yeah.
It's really exciting. So like Node.js is something that I'm super comfortable with. So that's why I wanted to show that today. But also because like web developers, again, like I mentioned before, they think that, well, I can write this Express app or I can write this front-end site, but I have no idea how to connect it to a device. So that's kind of what I wanted to show today is like an example of like a real-world app with an API and things like that, and how you actually connect it in the end to IoT Hub and to the device.
Okay.
So I have an Express server here, which has a couple of routes. There's not really much to look at yet, but I wanted to start this up in my terminal just so that you can see, and I'm going to use nodemon, which means that every time I make a change, it reboots. So I'm going to just start my server and like cross my fingers that this first step works fine. And I actually have this branch checked out, which is not master, called no cheat. And what that means is I've removed all of the IoT Hub code from here. So this is the part that we're going to be coding live today. So
okay. And then you have master that has it all in there,
Yes.
so that we can, ta-da, it's working.
yes, so we can cheat and like fast forward in time, but we're going to actually like
We're going to start no cheating.
We're going to start no cheating. So if I start up my server, that's actually going to be on port 3000. So if I go to my browser and go to port 3000, it looks like our app's working, right?
Sure looks like it. Oops, looks like you.
Yeah, but we have a warning. So it says, oops, it looks like you need to set your IoT Hub connection string as a process variable.
Okay.
So that's something that we need to do immediately, but I wanted to give you a quick preview of what the app actually does. So I have a bunch of sort of saved GIFs here to share. I'm actually going to pick Nick Jonas because he's been in the news recently because he got married this week.
Got married.
It was very glitzy.
Right, in India, was that?
Yes, to Priyanka, yeah.
Look at us, we are pop culture aware.
So we're going to load this GIF, and this is his mind-blown GIF, right?
Yeah.
And so you can see here that we actually have like some pretty low memory resources to work with on this device.
Okay.
So this app will automatically truncate your GIF if it's too long. So I wanted to show that feature. But you can see here that it gives you a preview, like more or less of what it's going to look like on the screen. And I really like that it picked sort of the main mind-blown part of the GIF, which is pretty cool.
Okay.
And then once we've actually hooked it up to IoT Hub, we're going to have a device list here that we can choose to send, a GIF to one of the devices, which, spoiler alert, is going to be this one over here.
Okay. So what you've built is a way for us to literally take our pictures and publish it to a screen that could be anywhere.
Could be anywhere, yeah. I accidentally sent this GIF to the office this morning in Redmond. So someone, if anyone goes to my desk today, they're going to see like Nick Jonas' mind exploding on, because I have a bunch of MX chips bracketed to my wall behind my desk. So they're going to see that.
And it's all through relaying through the cloud using the IoT Hub.
That's right. So that's kind of the glue that sticks these together, and that's what makes this so magical. Like I literally accidentally sent a GIF to Redmond today, and we're in Las Vegas right now.
Yeah.
And that to me is pretty magical that I didn't have to even be at my desk to do that. So.
And I don't know if I'd use magical and Nick Jonas in the same sentence.
Okay. I just automatically went back to Vim because I wasn't even thinking.
I get it.
But I'm going to use, and you'll notice that I actually have Vim mode.
Turned
enabled
on
in, yep.
Right, so all right, let's explain that real quick. VS Code has a tremendous extension model.
It does.
And there's an extension that'll turn it into being able to handle Vim shortcuts.
Yeah, that's right. So that's what I have installed now. And then I have a bunch of other stuff installed too. So if you have a look along the bottom of my screen right now, I have, you'll see a bunch of stuff that says MX chip and like a serial port and things like that and like device.ino. that's actually the IoT Workbench extension that's designed specifically for the MX chip. So we're also going to be making use of that today. And I have the Arduino extension installed as well. So that's actually pretty neat. And that is why it makes sense to use this as an IDE today.
Okay. Can I use that Arduino extension to work with our friends, the JoulBots?
Yes, you can.
Ah, I've got to check that out.
Yeah, you absolutely can. So it uses the same board manager and the same library manager as like the Arduino IDE itself.
Okay.
So as long as you've chosen the right device in the corner here, then you can do all your JoulBots development right in the IDE. Yeah.
Okay.
Yeah, which is pretty cool.
It is. All right. And friends out there in the chat room, make sure you send in some questions our way so that we can get to the nitty-gritty of what's going on here.
That's right.
Answer your questions. All right, what do we got?
Yeah, so what we have to do is we have to be able to connect this device to this website, right?
Okay, and at this point, you just have that library that's stripping down the GIF to a couple frames, converting it to monochrome.
That's literally all I have. So I have no code running on this device either.
Okay.
So the first thing I need to do is to upload some code so that the device is listening for those messages to come from the website, right, via IoT Hub. So I'm actually going to plug this in, and I'm going to start uploading that. And because of the way that I have everything arranged in this file sort of directory here, I can't use the IoT Workbench, but I can use the Arduino extension underneath. So normally you would use the IoT Workbench thing, but I just don't want to have to open multiple workspaces today. So just bear that in mind. But the instructions in my README actually show you how to use IoT Workbench.
So should we take a look at the
yeah, let's have a
MX
look at the
chip
device
just to
now.
Show okay, it's lit up. A couple things here. I see Wi-Fi is green, Azure is blue, and then user has a little amber light next to it.
Yep.
Version numbers. Okay.
Yeah, so this is all in test mode right now. So when you first turn on the device and you set it up to connect to the Wi-Fi, which again is documented, it will just show this kind of like demo script. And you can kind of play around with it and click the buttons and see sensor readings. But we want to actually put our own code that, that we wrote to be able to handle GIFs coming through the wire down to it. So that's what I'm going to upload now. And so
so we'll go back to your machine.
Yep, so let's go back to my machine. And I have written all of the code here to take care of that. But the one thing that I want to show people immediately is that I have a method name called showGIF. And so we're going to be using that method name in our code later on. So I want you to just try and burn that into your memory, at least your short-term memory. But we're going to be using that. But feel free to go through the rest of the code at your leisure, especially if you're watching on the stream. There's not a lot of lines of code, and it's really just taking a JSON payload, taking the GIF data out of that, and then just like on every single loop of the script, it just kind of figures out whether it needs to play the next frame or not. That's pretty much all it does.
Oh, okay. And this is the code that's going to run on the chip, and it's written in C++.
Yeah, C++, and it's making use of like a lot of different libraries such as IoT Hub and the MX chip libraries, as well as just like the general Arduino libraries too. So it feels very, very abstracted. It's even like easier to use than regular C++, in my opinion, which is pretty cool.
Now I don't feel that like it's as elite coding.
Yeah, right. It's cheating. It's just cheating. I mean, I wrote this like this week, and it only took a couple of days for me to write all of this, like the website, the C++. It's really not a lot. It's just like lots of tiny pieces, but they're all quite small. So I'm going to make sure that I've selected the correct serial port in order to connect to my device. And then I'm going to use just the regular command palette in VS Code.
Okay.
And this is a recently used command of mine because I use it a lot. So you would normally go to IoT Workbench device, and then there's a device upload command. But today I'm going to use Arduino upload just because I wanted my folder structure in a very specific way. So it just doesn't sort of recognize it as an IoT Workbench project. And I'm going to hit upload, and then we're going to cross our fingers and watch the output.
And I'm familiar with the Arduino tool, so it's just bootstrapping it?
Yeah, so it's pretty much just starting up the Arduino app. But what's cool about the Arduino app is you can access it as like a command line tool in a certain sense. So what it's doing is it's invoking the app that's existing on my machine, but it's giving it a bunch of flags saying like, upload this file, and I want you to upload it to this device on this serial port.
Yeah, the text editor in that tool is it's no VS Code.
Exactly. So that's what's really nice about this is you don't necessarily have to stick with that anymore. So this is super convenient, and then we also have a bunch of built-in nice things that the Arduino IDE doesn't have, like IntelliSense and things like that.
Yeah.
So you can see here that that's uploading right now, and
programming started. All right.
Yep. Looks like it finished, and it says uploaded the sketch. So
if we go over to the video, to
yeah, if we go
camera
over
over
to the
this,
device now,
it says
ooh,
connecting.
I just saw the Wi-Fi light come up. That's a plus.
Send me a GIF.
Cool. So it looks like it's waiting for a GIF. The Azure light is lit up too. So it looks like it's successfully connected to Azure. So for now, we're good.
Okay.
We'll see.
We'll see.
We'll see. So now it's waiting for a GIF, but we have no way to send it the GIF yet, right?
Okay.
So let's go back to our server, and we're actually going to require like a brand new package, and it's the IoT Hub SDK for Node. So I'm going to go to require, and it should autocomplete. There we go. See, that's amazing. So good.
And people think that's cheating. It's not cheating.
It's not cheating, it's productivity,
It's
right?
coding faster.
Yeah, I mean, I'm not going to lie, it's been kind of nice to be working in this. I've actually been a bit more productive than ever, I'm not going to lie.
No comment.
Okay, so let's move on. Let's move on. So I have, I actually have a .env file, which you will see in my file list on the left.
Okay.
And that contains a very private connection string to my IoT Hub.
Okay.
And again, I have instructions in my README on where to find that in IoT Hub and things like that. So first, I need to actually extract that connection string. Then, if it actually finds it, we want to start connecting to IoT Hub, right? So I'm going to have a conditional that says if connection string. Then I'm going to need two different things from the IoT Hub SDK.
Okay.
I'm going to need a registry so that I can like read the list of devices.
Okay.
And then I'm going to need a client so that I can then tell a device to do something. So
that makes sense.
So there's a couple of things that we need. So I've already on line 6 created a couple of temporary variables code, some undefined variables code client and registry. So I'm going to make use of them. So the registry will just be iothub.registry. And this IntelliSense is amazing. And then I'm going to do from connection string. I'm sorry, I'm just not used to this in Vim at all.
Wait till you see IntelliCode.
Yeah, I actually saw the demos for that today. Scott made it look amazing. I'm very excited about it. So the SDK access to create that registry is simply just .from connection string. The client is actually exactly the same, except for IoT Hub.registry, it would be IoT Hub.
.client.
Yeah.
Okay.
That was not a trick question. So we're going to do connection string again. Okay. Oops.
People have watched me stream. They know how smart I am about this stuff.
All right, so I use my good old Vim command, :W to save. I have no idea if that saved or not. It looked like it did. All right, so if we have a connection string, we're going to like start up our registry and our client. But then we have these two, what's it called, routes that I've set up.
Okay.
So one of them is API devices list. So that sounds like it's going to list the devices that are registered under IoT Hub. And then we have /API/GIF, and that's a post request. So that's where we're going to be sending the GIF from the front end, right?
And you're going to want to receive and transmit it to IoT Hub, I guess.
Yep, that's correct.
Okay.
So at the moment, I put in these kind of like placeholders, just saying, if there's no registry or no client, then just send back something so that it doesn't blow up.
Give it
But
a response.
underneath, we can do something like, let's see if we can get at least like the devices listed first, right?
Okay.
Because we have like 18 minutes. So like we got to get a
You
wriggle
noticed
on.
the clock too.
All right, so I'm going to do, all right, so if there's no registry, then just return out with an empty list of devices. But if there is a registry, we can do registry.list. That's the actual command. And then what that takes is it takes a callback. So it'll be function, and there'll either be an error trying to list them, or we'll actually get a list. Make sense?
Sure.
So then we're going to go to inside of this callback, and we're going to say, okay, so list, actually, if error. So let's be good and check for an error first.
Error handling? Come on.
Yeah,
now.
we are. Res.
You're so responsible.
Res.send status. Well, I'm not that responsible because have a look at what I'm going to do. I'm just going to send a 500. But if there isn't, then we're going to do registry. No, list. So we already have the list. So we're going to do list.map, and then we're going to get some devices, right?
Sure.
And I'm going to make this fat arrow function. So we want to create an array with just the names of the devices, right?
Sure.
So we're going to return the device.device ID. That's what it should be, I think. Yeah. I think that's
and
right.
the device ID will be the name that you've assigned to this device.
Yep, that's right. So I'm going to just do a name list. Name list equals list.map, and then it's just going to have an array with like a bunch of strings in it. And then we're going to do res.send, and then we're just going to send, I called it name list, didn't I? We're just going to send that array. And then I've set up Express to just be able to like send JSON back and forth, so I'm pretty sure we should be good from there.
Okay.
So we can go back to our terminal and make sure that our code didn't blow up. It looks like it just restarted okay. And I'm just going to give it one quick look to make sure I've done this right. It looks like I have. So let's see what happens. So let's refresh our page. Let's just choose a GIF just so we can get that list up again. And it says no devices found. So let's have a look to see if there was an error. There wasn't. That was weird. So let's see if there was an error. No, it is there.
It just took a
cool.
second
Okay,
to
it just
load.
took a second. Cool. So you'll see that I have a device called Vimwitch. And I have a bunch of other devices. So you can see I have some in my office. I have some at home.
Jeez.
So that's pretty cool. So that's actually working. I thought it wasn't for a sec, but I just didn't trust my own abilities there. So confidence is important.
Oh, yeah. So Skull Crusher for Life, great nickname. In the chat room is asking, any recommendations for making the MX chip more portable with a power source?
That's a really good question. So because this takes a micro USB, this has a micro USB port, which is how you power it.
Yeah.
What a lot of people do if a device has something like that is they use like a USB cable and then one of those mobile phone like portable battery things to have as a backup to charge your mobile phone with. That works really, really well because that's going to give you the 5 volts to be able to kind of power this. So that's usually what I recommend for people because you can just throw it in your pocket. You can use a lithium battery, but you have to have a pretty powerful one. So like those mobile phone ones already have the right kind of power for that.
But you're going to have a IoT device in your pocket walking around. What are you doing there, Skull Crusher?
Yeah, you should tell us what you actually want to do with it. That would be really fun.
What are you building?
I'm going to do another GIF file too, just to show you, like, if you have the right amount of frames, it doesn't actually show you that message.
Oh, look at the egg.
Yeah, the little egg's really cute. I spent a lot of time on Giphy this week trying to find the cute ones.
Wait, I thought I found a decent one earlier in the week.
Oh, yeah?
Did you grab? We found Joey from Friends.
Oh, yeah. So that one is showing still at my desk because when we were on I think we had like a Teams call and then I was like, send me a GIF, and then you sent me Joey saying, how you doing? It was great.
Oh, man.
Okay, so the other one is this. So as soon as you click send GIF, that actually does do a post request, right? So I'm going to go into my network tab and you'll actually see that happen, and it's going to error out because we haven't hooked it up to anything, right? So I'm going to click send, and you can see here it's pending. But it's not actually going to do anything, right? Because we haven't hooked it up to do anything. So we have to actually fix that. And so I am going to just close this back down again, and then we'll refresh it just to reset it back. And here's what we're going to do. We're going to, first of all, what we're going to do is we're going to invoke a method on this device. That's what it's called, method invocation.
Okay.
So this device right now is listening for a method name. Now, do you remember what that method name was? It's always like a trick question.
Yeah, you caught me up following all this other code.
Sorry, there's been a lot of details today. So I'm gonna put you out of your misery. The method name is showGIF.
That's it.
Yeah. Okay. So I'm gonna do method name. That's one of my params that I have to send IoT Hub.
Okay.
And it's called showGIF.
So this feels, right, as a .NET developer, this feels like very similar to SignalR, where I'm specifying, I'm sending a package to my clients that says, here's the method name to call, and here's the array of arguments to pass into that.
It is actually very similar to that. So, so if I actually learn how to use Vim properly, I need a comma too. Okay, not so much the Vimwitch today. So the next thing we need is a payload, right?
Yeah.
And so what you don't see is that when I choose the GIF file and I choose to send it, the payload is actually this compressed GIF. So again, if I go to send GIF and we have a look at that payload really quickly, you'll see here that there's a data. There is a device ID.
Okay.
And then there's a data.
There's an array of bits.
Yeah, so we have frames and then just like the size of the GIF as it will be on the screen, right? So we need to get that to the MX chip so that it knows what size to do it and like what the frames are and everything. So we're simply just going to send, I think, request.body.data, I think. I think that's what we do in Express. So we want this data here, and we want the body that's coming back from the request.
So we're going to take that frames object and the other stuff that was in that data collection and pass that on.
Yep,
I called
that's
it
right.
data, not data. I'm sorry.
No, it's all good. I always flip-flop between the two because I'm not from this country. So, so there's that. The next thing we need is the device ID, right? So that is actually on rec.body.deviceID, I think, unless I got that wrong. So let's double check that real quick. Yep, so request.body.deviceID.
Okay.
So that's how we understand from the front end, side, like which device we need to send this to in the first place. And then it just comes down to using the client. Whoops, autocorrect got a little...
Gets aggressive.
Gets a little aggressive, yeah. So client.invoke, wonder why it's not auto-completing. Invoke device method, I think. But I'm going to look that up. Oh, it is. Okay,
cool.
So I got that right.
Right.
All right, so the first argument it's telling me is the device ID. So I already have that. Assigned it to a variable before. Method params is next, so I have my method params, right? And the next thing is a callback, right? And so it's going to tell me, like, was there an error or not? So I believe that it should just be error and result. And then we can do fancy things in here, like, send a 500 back to, or a 200 back, depending on like what happened. So I'm going to do that real quick.
If we're going to be responsible handling errors
if
and
error, so
process, yeah.
I'm going to do return res.send status 500. And if we were really like nice, we would actually send back the error that came back with it, but we're going to shortcut that. Otherwise,
we're not cheating.
Yeah,
See?
because we're not cheating.
I got that figured out. All right.
And I'm just going to send a simple 200 if that was okay, right?
Sure. 200, okay.
Yeah, so
Fine
I'm
with
doing
me.
this from memory and also on the spot, so I'm not sure if this is correct, but it seems like IntelliSense was telling me it was okay.
We never do that. Never.
All right, so why don't we just like, it looks like the server restarted, so I guess we just need to test it out.
Okay.
And now I'm scared because like, what if we end up waiting forever and it never happens? But
Okay.
let's see.
So why don't we slide, remember, let's snap that to the left because they're going to do some fun things
Oh,
here.
yeah, that's right, that's right. Yes, yes, yes.
Our friends, the video director, are going to put the chip on the screen now as well.
They are, yeah, which is pretty cool.
All right, it's there now.
Cool. So I'm gonna choose my Nick Jonas because I really want to get this going on the chip because I think it actually came out really cool. So this actually is called vmwitch. So so I've already set the connection string on this device in the EEPROM. So it's storing that connection string in the EEPROM along with the Wi-Fi credentials so that it can connect. I have no idea if it's hopped off the network or not. Sometimes it's hard to tell.
Well, the Wi-Fi light's
But it looks
green.
like it's still okay. But in my own IoT hub, I just wanted to really quickly show that here are all my devices and here it is vmwitch here. So
cool.
This was the SAS token that I used in order to connect. I used this connection string here.
Okay.
So I have actually blanked all them out just so
Yep.
that I'm not spoiling all my keys. But that's just a quick overview of where I got that from in order to connect. So let's try sending the GIF and let's see what happens.
Come on, Nick. Get over there.
You can do it. I think the Wi-Fi might be a bit fritzy, so we'll see if it's going to come
It might be a little
through.
what?
Oh, unintentional
I can't believe
pun.
you just did that.
Yeah, so
Took my
it's
name
still
in vain.
sending. It does take a while because that's a pretty big payload. So, ooh, it looks like our GIF worked.
It's yellow and blue.
It is yellow and blue. So the first 8-pixel sort of like row across the top of the MX chip is yellow. And that just means that you can have kind of like different colored text if you want, which is pretty cool. But it looks like our GIF is loading awesome.
There's Nick.
Do you want to try another one?
Yeah, let's.
All
what
right.
else can we do?
I like the egg actually. Oh wait, no, laser cat. So I got one with like a cat with lasers, which I thought was cool. So let's try sending that. This went a little too well.
I know, right?
I'm not gonna lie, I was not expecting that. All right, let's see if we can get vmwitch to show up the laser cat. It does take a while because it is quite large. There we go.
There it is. Now that one's a little bit harder to see.
It's a little harder to see. What if I really like the can't sleep because it's pretty clear. So let's try and send that one. And this one is only a couple of frames, so it's going to send a tiny bit quicker. Yeah, but honestly, like this is a normal website, which is just HTML, CSS.
There you go.
Yeah, it calls
and
backend.
the yellow split there looks
it looks really
good.
awesome.
Yeah. Okay. But so to recap, it's
Yeah.
just a website
Yep.
that's sending a command to IoT Hub
Yeah.
that relays it to the device that's already registered with IoT Hub.
That's right. Yeah, I did cheat ahead of time and do that. I wasn't sure if we were going to get done in time.
So, and you're just sending it through Azure, and because this is connected to Azure, and we see the blue light indicating that it is connected, it's able to receive that command and execute the payload.
Yeah, and even though this device is connected via USB and powered using my laptop, like if we were to just plug this into another laptop, this is literally just a power source.
Okay.
So it really is going up to the cloud and back down again. Like there's no USB activity happening other than when we uploaded the script to the device in the first place earlier.
Okay, so we could plug this into a phone, mobile juice pack.
Yeah,
or one
exactly.
Of those things
Yeah,
and
you totally could.
run it right there.
Yeah, and so
Very
that's
cool.
kind of how the ones at my desk are. I have like a powered USB hub that's not connected to a computer. It's just got like a DC power support. And they're all plugged in, and then I have these 3D printed brackets and stuff. I should have gotten a photo because it's really funny. But yeah, it's really fun because now people, like I have like this little private URL you can go to when you visit my desk, and people can upload GIFs to me.
Effectively make a little bit of wallpaper behind you.
Yeah,
that's
yeah, it's
big.
kind of fun. So I'm not sure what kind of GIFs I'm going to come back to when I come back to my desk, but I think people are going to have fun with it. So that's pretty much it. We have a few minutes left. So do we have questions, or did you want to look at any of this code in more detail?
So how can you show us how you register the device with the IoT Hub? Because
Yeah,
we
that's a
saw
really good idea.
Where we can order an MX chip on the one page, and certainly through the GitHub repository, there's
Totally.
that information. So how do I register when I get my chip home and I take it out of the box, and I want to make it an Azure chip?
Ah, that makes a lot of sense. So you can actually use the, I'm actually going to just open this workspace now. I think wait, I'm going to reopen this project, but as the actual workspace, just so that you can see how cool this tool is. So I'm going to go here, open. It should ask me if I want to open it as a workspace. It did not. Let me try that one more time. Again, I use Vim for most of my stuff, so I'm not as used to doing this, but okay. So here's where it was asking, well, sorry, you didn't see that, but it was asking me if I wanted to open it as the Azure IoT Workbench project, which is where you really get the power of this. So if you go to IoT Workbench device, for example, after plugging it in, and
Plugging
it actually
it into your PC now, and you're using a Mac, so it works PC or Mac.
Works perfectly. And as soon as you plug the MX chip in, you do actually get this really cool like tab that opens. And it actually walks you through doing all of these really cool sample projects. So even though I'm showing you how to do this now, these tutorials are actually going to show you how to do it. So again, if I go to my IoT Workbench device, see how I have config device settings, device compile, device upload, install SDK, and generate CRC, and that's for like over-the-air updates. But I also have other IoT Workbench stuff. So let me see if I can bring up the top-level IoT Workbench. So I have create project, I have cloud, set workbench path, and examples. So if I go to cloud, I can actually provision all my services here.
Okay.
And then you can also create the device identity and do all of that through
And that's
the work.
under that.
Yep, and that's under the workbench. If you wanted to do it manually, I mean, I can show you that on the portal as well, which is something that I tend to do just because like I don't really need to use that. But
Elite developer again.
it's
right?
not elite development. I know that some people have used like IoT Hub before, and they just want to know how that relates to like what Workbench is doing for them, I guess.
And there's some discussion right now in the chat room that I'm seeing where there's a client on the chip, the chip's connected to Azure, you're sending your commands to that Azure IoT Hub, and then Azure redirects them to the chip because the chip's registered.
Perfect. That's exactly what's happening.
Okay.
So the device has the IoT Hub SDK for C. It has the C IoT SDK, which is packaged up and connecting to Azure as soon as it gets on the Wi-Fi. That's where it's waiting for those like method invocations. And my C++ just has a callback that basically says like whenever I get a method invocation, I'm going to check what that method name is. And so this is where I have device method callback. And then if it's show GIF, then I want to pull down the payload, and then I want to call load GIF, which is my special function up here that loads that into memory.
Very cool. Okay.
So it's literally doing that. It's just kind of like starting up a client connection, a device connection, and it's saying, all right, anything you send me, I'm just going to like perform whatever I need to do on it.
Just listen and then listen for a command coming from the other side.
Yeah, and our Express app is essentially a service client rather than a device client. It's a service that can basically send commands to any device that connected to the same IoT hub that the service is running with. So that's how it works in a nutshell. I'm really glad that that came up.
Oh yeah. No, how do we connect all the lines and make sure that all of the pieces work?
Yeah, there's a lot of moving parts.
So you actually have a private website running somewhere out in the cloud.
I do. I'm not going to share the URL today. Yeah.
No.
But you can actually go on Glitch and host your own, which is really cool. So I do actually have that hosted on Glitch, as you can see here, and you can view the source. So that's chip-gifs.glitch.me. And if you click View Source, that's where you can remix your own from there. You really just have to add your connection string, and then it's actually up and running. So it's actually easier than what we did today.
Okay. Skull Crusher for life.
Mm-hmm.
Good to see a Skull Crusher.
Yes, it is.
Can you use IoT Hub to track statistics for when your devices are connected, for when a device comes back within range of a network and can access?
So that's an excellent question. So you can do that, and we have this thing called operations monitoring. And you are able to monitor all of the different things that happen, such as log events with the device registry, log events with device to cloud, cloud to device, log events when a device connects or disconnects from the IoT hub. So I think that's what you want at Skull Crusher. So you can actually log those things. And then also if you go to activity, I don't think it's activity log, I think it might actually be, yes. So if you go to the overview of your IoT hub, you can actually kind of see a bunch of telemetry, and you can choose what kind of telemetry you want to look at as well, which is actually pretty cool. So we have a lot of neat stuff built in that you can listen to. And there are also events, which right now allows you to listen for things like, did a device get registered with the IoT hub? That's something that you can act on as well.
Cool. And are these devices secured with SSH?
They're all like secure methods of transportation. So it's either AMQP, MQTT, or HTTPS. All of them are on the secure ports.
Fantastic.
Yeah.
All right, and we are just about out of time. Thanks so much for joining us. This was so cool. What is that?
We have a cool GIF, but I don't know where it came from. So it's really cool.
Okay. Thanks so much for joining us. Thank you, Suze, for coming out and joining us
Thanks for
here for
having me.
Connect.
This was super fun.
This is my last session.
Oh.
But this isn't where today ends for me, because I'm actually taking off from here to our virtual attendee party.
Wow.
Over at the Golden Knights Arena.
Okay, now I'm jealous.
So if you stay tuned here,
okay.
After we get done at the end of the day, we're going to have a virtual attendee party live from T-Mobile Arena, home of the Las Vegas Golden Knights.
Wow.
We're going to have questions, we're going to have trivia, we're going to have prizes, all from our sponsors. But in the meantime, Seth, what do you have coming up next?
How's it going, my friends? I am so excited to be back here. Is this on? Am I good? Okay, they're giving me thumbs up. I'm excited to be here. How are you doing, my friend?
I'm doing great. How are you?
Why don't you introduce yourself?
My name's Eric Boyd. I lead the AI platform team at Microsoft.
So the first question, obviously, and the most important that everyone has for you is, are the robots taking over, and how can we become their friends?
The robots are totally taking over.
Okay.
No, I mean, that question is such a great one to get. I've gotten variants of that.
Can I hear some of these variants? By the way, please get your questions in, because I'm sure I've gotten some really weird questions about AI.
You know, I was at an Onyx conference, and Onyx is the Open Neural Network Exchange. It's something we work together with Facebook on, and Amazon and NVIDIA, and invited the whole ecosystem in as a way to exchange, models from one format to another. But at a space, it's a file format.
Yeah.
And after sort of talking about Onyx, I got a question that was, well, have you ever had an Onyx model, like become self-aware? And I'm just like, it's a file format. That's really not how this stuff works. So it was, yeah, there's a lot of misunderstandings around what AI is, how it works, and what people can do with it. And so that's a lot of what we need to work through is AI can do some really incredible things, particularly in the areas of vision and speech and those types of areas. But it's not sentient, it's not self-learning. Like if you have an AI model that plays chess really well, it's not going to clean your floors.
No, I've tried. And it made a mess, and my wife got mad.
Yeah, I doubt it made a mess. I bet it didn't do anything.
It didn't do anything. So here's a question. For those that are out there that are like, because there's a lot of AI this, AI that all over the place. For businesses out there that are like, okay, I think I need to take advantage of this. Where are some good opportunities to start?
Yeah, that's a great question. I spend a lot of time talking to companies about what are their opportunities and what are the things they can do. The great thing about AI is it really is touching and transforming each and every part of every business. And so even like the feature that we showed today in some of the keynotes, the IntelliCode, if you think about that, that's such a small feature in Visual Studio, right? Just reordering the way that the IntelliSense options come back. But they were able to make that better, and by using AI and having a predictive model that knows what am I likely to be using it for, they really made Visual Studio better. Now, how much better? 0.5% better. But if you can do 0.5% across all the different capabilities, you can make so much better. And so, I was talking to one company. It was a beer manufacturer, and I said, "Well, how are you using AI in beer manufacturing?" And his answer was, "We don't use it at all in the beer manufacturing. We use it in everything else, in logistics, in the supply chain, in predicting the inventory that we're going to need, and forecasting the prices we're going to pay. All the other capabilities that they had, they were using AI models in those areas of their business." And so really, that's what's so interesting to me, is just finding each business and how it's going to transform each of their businesses, and really challenging companies. You need to have the creativity to figure out how are you going to actually make your business better? Where can AI really work for you? And really learning those different areas.
So what is a good smell? You remember code smells? I don't know where that term came out, but it's such a weird one.
I don't know that term at all.
Is a code smell is like you're looking at code and you're like, this smells like we could fix it or make it better.
Sure.
Where are the AI smells, so to speak, in a business? Like, hey, maybe you should consider using this programming, because I consider AI a programming technique.
That's right. What are good cases for it? If you have something where you're applying some rules, like the sorting algorithm in IntelliCode, right? Someone came up with a rule that said, let's sort it alphabetically. You can almost always find an AI algorithm that's going to predict or do that better. Fraud detection is a classic place where people have rules. If we get too many requests from this IP address, it's probably fraud. AI is going to do fraud prediction way better. If there are, financial forecasts, I'm going to look at these 3 things about, the industry or the trends and sort of project what our finances are going to look like. AI is going to do that better. Insurance industry is getting completely redone. If you think about how insurance works today, they look at 5 different factors about your driving history or your car you have, or maybe your neighborhood. And AI can consider 10,000 factors effectively.
I see.
And so those are things where AI is going to do a much better job of predicting. And so, yeah, those are all things that smell like AI would do well in it.
So tell me about the data requirement for AI. Because I've had people come up to me and be like, hey, just do some AI. And I'm just like, well, can you give me some data? Why is data such an important element of AI?
Yeah, one of the first things I talk to companies about when I meet with them is, if you don't have differentiated data, you don't have differentiated AI. So what is the thing that you have that's special and unique about your business that's going to make your business and your product better? And so, if a company's not collecting that today, and a lot of companies, I've talked to companies and they're like, oh, we throw all that data away. And you're like, that's going to be the foundation that you're going to build your models and make things successful from. But you've got to understand, what is that differentiation? What is the thing that you've got that's unique about your business that you can build a great data asset on, and then build models on top of that?
So before you even start thinking about AI, you should probably think about saving your data.
Just making sure that, and saving, collecting, and really looking for places where you have data where you can tell this was a good outcome or this is a bad outcome, right? If you take insurance, this person defaulted on a loan, this person didn't default on a loan. So I can now use that to predict. Forecasting financials, I predicted very accurately based on this information, I predicted poorly here. The more you have those are the labels. That's the stuff that's going to feed into your model, and it's really going to, be the way that your AI algorithm is going to learn. And so if you have that, then you've got the foundation to do something interesting.
Awesome. So you're using the term a lot, model.
Yeah.
And for those that maybe don't know what a model is, how would you describe, what is a model?
Yeah, a model it's really just a system of predicting what's going to happen based on some inputs. And so, I mean, you can think of a really simple model. You can think of Scott Guthrie was talking about, I want to predict the price of a car. And so a model could be as simple as, you know, I take the year that the car was, and I take the condition of the car, and I multiply it by 3, and that's the price of the car. That would be a particularly bad model. An AI model is now going to take those same inputs and come up with a price based on, you know, how AI sort of learned. And so there are a lot of different ways you can represent models and think about them, but at its base, that's what a model is. It's something that predicts something.
Awesome. So we want all of your questions, so make sure you get them in, and I want to ask them. For those that maybe don't have a lot of data, and they want to do AI, how can Microsoft help?
So there are a lot of ways that companies can get started. There are a lot of use cases. It depends on what people are trying to do. If you look at their speech, you know, if I want to add speech recognition to any application that I've got, how could I do it? Well, I could go and collect a whole bunch of speech people talking and transcribe that and then build a model that predicts that. Or I could use a cognitive service, which is going to do it way better than what they're already doing. So we have a wide suite of cognitive services that'll just really help accelerate people. You don't need anything to go and use a cognitive service. And you can do speech, you can do vision, you can do language, you can do search. All of these, you know, right off the bat, you can go and get started with them.
Yeah, and it's really easy. I have it here on my screen. You can go to azure.com/cognitive. I think it'll go right to it. And like an easy one to look at is vision. Basically, I'm clicking it right here. And if you go to, for example, scene and activity recognition and images, you basically just upload your picture.
Yeah, it's really simple. If you have, you know, you want to be able to identify the objects in a particular scene, just upload it and it'll sort of show you the different things on it. Then you can go further with that, the custom vision service, and you can say, you know, everyone's favorite example, do you watch the TV show Silicon Valley?
Not yet, but I will. Hot dog or not hot dog, is that the one?
Hot dog, no hot dog. This is a classic app. It's a really funny part of the movie or the TV show. You can build that in I built it in 2 hours, but that's because I'm not a great programmer anymore. I used to be.
What happened?
I got old.
Yeah.
I stopped programming is the main thing.
You know, 2 hours though to build a hot dog, not hot dog?
And it was really very good.
Did you use cognitive services?
What I did is I used the custom vision model.
Okay.
And so I went to Bing and I searched for pictures of hot dogs and I found about 20 of them and I put them in there and I searched for pictures of things that weren't hot dogs.
Nice.
And there's your classifier, and it really was very straightforward to go and build.
Awesome. So here's some questions coming in. Does Microsoft AI support self-training classifiers?
So
I think we do with auto machine learning.
So
automatic machine learning will do that.
Automatic machine learning is, yeah, so I guess it depends a little bit what they mean by self-training classifier. Automatic machine learning is going to do a lot of that. What automatic machine learning does is you basically would specify, here's the data set that I have, and I don't know, do I need a support vector machine? Do I need a neural network? Do I need a logistic regression? I'm not an AI expert. Please just figure out the right model for me. And so automatic machine learning is going to do that for you. And so that's available today. You can get that as part of Azure Machine Learning in the SDK. It's one line of code, and it'll go and build you a model just based off a data set.
I have the line of code actually right. I'm scrolling. Here it is. It's literally, oh, no, that's the deployment. Sorry. That's this. Here it is. It's the auto machine learning.
Yep.
It's actually 2 lines, but because one, you define the problem, and to run it, it's actually 1 line.
Right.
It's actually really nice.
It's really straightforward, really simple to use. And we're finding a ton of customers who are using this, and it really broadens the scope. There are really 2 ways I see people using it. One is, you know, if you're a data scientist, there's a lot of tedium that you go through in trying, let's try the support vector machine, let's try a learning rate of 0.1 and trying to change all these parameters. Now you can just sort of say, just give me a model that's pretty good.
Yeah.
And automatic machine learning will just go and do that. The other class of users are people who don't even know what they would need to do. And they can, you know, if I'm a developer, but I don't know how to do machine learning, I can use automatic machine learning and get a model just from 2 lines of code.
So let's see if I understand. So basically, you have a bunch of data.
Yeah.
I usually I think of Excel because it's the canonical. I say Excel and everyone's like, oh, I just pictured a row, like a bunch of square of data. And you say, here are the columns I want to use to learn. And then here's the column I want to learn. You feed it in, and then it does it.
And it's funny you say Excel, because in Power BI, we announced this as in preview, that it'll be integrated as a wizard where you can walk through the experience doing exactly that. And so create a model just from saying, this is the column I want to predict, and here's the rest of the data that I've got.
And that's pretty amazing. I mean, if you look at the code right here, hopefully we can go to the screen, you can see that there is this data script that's basically says get data. And in there you define, and you can see my get data script right over, let me go here real quick. Get data script right here is basically saying, here's the X and here's the Y you want to learn. You give it that, and then it says, I'm going to run a bunch of models.
That's right. It goes through, it tries all the different models. It's really great. It gets a little meta. It is a machine learned model that predicts which machine learned model is going to work best on this set of data. And the more you use it, the more you use it on your sets of data, it actually learns from the history of how it's gone and predicted, and it gets better because it has a great answer of like, well, how well did it predict against the test set? And so the more you use automatic machine learning, the better it's going to work for your data, the better it's going to work for you, which is really pretty neat.
And the cool thing about this, and this is the meta bit, like it's using a recommendation algorithm. So basically like your shopping cart, when you go shopping online and it recommends other products, we have that AI when you run a model and it says, oh, it did okay. It starts to recommend others and it runs them. It's pretty cool.
It's the same idea. It's not necessarily the exact same implementation, but it's the same idea as that. Yeah, really cool, really simple to use. And I think, honestly, going forward, I think more and more stuff is going to start fitting into that automatic machine learning paradigm. I think you're going to start seeing image classifiers work that way. You know, all the types of things that you're doing today, more and more of it's going to fit into automatic machine learning. And that's really our goal, is how do we simplify this stuff? Because there's so many people now who the demand to have a machine learned model, the number of people who want it, the demand for AI is really high. But there aren't enough people who can go and develop it. And so how do we make it simple so that any developer can go and build and have an AI model? You have developers today, if you think about, I use the analogy of a hash table. Developers use hash tables without even thinking about it, right? They probably learned about it in college and they studied what's a good hash function and things like that. No one's ever actually implemented that. They just use a map and they just call it.
Right.
How do we get that, machine learning from the days where it is today, where you kind of need to be an expert in linear algebra and calculus and back propagation, to know this is a space, here's my data, push a button and go do it. It's coming, and we're going to get there.
But you know what? It's still okay to learn linear algebra calculus because it is dear to my heart. Because I'm a nerd at heart. I'm not wearing my glasses, but if I was, you would see. Love calculus.
Well, and this is what you're seeing a lot of people doing. Everyone who's a developer out there today is learning more and more about how to be a data scientist. Cool. And much like the hash table, understanding the fundamentals is really going to be important to doing it effectively.
Awesome. So it looks like Tony from Brazil is watching. We want to say hello to you, my friend. I have an idea in mind to build a face recognition for my business. Customer comes, profile loads for receptionist. Can Azure help me with this?
That's a great question. So we have the Cognitive Service, the face recognition API. And so you can absolutely go and do that and have it recognize your customers and suggest a profile of it. I think it's really great idea, right? A customer walks in and you say, oh, they typically order, this particular cup of coffee or something. You can start getting it ready as soon as they walk in. And so for your regulars, what a great experience, right? I'm coming back to that restaurant every time because they're going to be ready that much faster. They see me coming.
And that's amazing. Like just with computer vision, it will tell you the box around the face.
Right.
And then you can use and chain that together with custom vision with faces of your customers. And so you get the face box, you take the box out, and you give it to custom vision, and now it'll tell you.
That's right. You can build up the profile and the history over time. And so I think it's a really interesting use for how facial recognition. There actually already are coffee shops in China that do this.
Really?
And so absolutely. You walk in and they recognize you and they get your drink already. So I think this is going to be coming more and more.
Awesome. So a follow-on question. But do you have an auto classifier where the data does not have predefined data, so the auto classifier would group similar things? I mean, that's a really good question. Like, look, I'm an engineer, and most people don't know this, but I'm like an AI person.
Yes, you are.
And so, like, right away when you say group things, I'm thinking like k-means or hierarchical clustering or Gaussian mixture models. So there's already ways to do that.
Yeah.
But we have the compute to do any type of machine learning model. Tell us a little bit about Azure Machine Learning Service and what that is.
Sure. So, you talk about you need access to the compute to go and train your different models. That's one of the, why is AI really taken off? It's been three factors. First is the amount of data that's available.
Right.
The advent of big data and products like Spark and Azure Databricks, and now you can use those to really manage your large data sets. The second you alluded to is compute, and it comes in two different ways. One is it comes through GPUs, which have really accelerated the amount of parallel computation you can do on things, particularly matrix multiplication, as well as the cloud, where these GPUs are really expensive, and if I need 20 or 100 of them, I don't want to have to go buy them because I probably only need them for a few hours. And so the cloud ability to go and use all that compute, for the time that I need and only pay for what I use has really transformed it. And then the third thing is the new algorithms, coming up with, deep learning and convolutional nets and things like that has opened up a whole host of applications. And so with Azure Machine Learning, what we're trying to do is bring that together and make it really easy for you to consume. And so, we do it through a Python SDK. So you can be in an Azure notebook or a Jupyter notebook or in VS Code or in PyCharm or whatever you like to use. You're right there in your notebook, and you can get access to start training locally, change one line of code. Now I'm accessing a whole host of resources on the cloud, and managing the data that's stored in basically any way you can store it on Azure Data. Everything from Azure Data Lake to CloudDB, everything is all out there. Cosmos DB.
Awesome.
So yeah, it's all really simple and integrated.
So we started with, if you want to just get started quickly, you should use Cognitive Services.
Yeah.
If you want to customize a little bit, we have some custom versions of Cognitive Services. We mentioned Custom Vision. There's also others. I think you can upload your own acoustic and language models for speech.
That's right.
You can use Lewis to start to tag your own data and so there's easy ways to enter. But let's talk now to those that maybe are more advanced, that are starting to use like scikit-learn or PyTorch or TensorFlow. Can you tell us what the current development process is like and how Azure Machine Learning Service can help?
Sure. It's interesting the progression you walked with. We think about it as cognitive services are, Microsoft's model, Microsoft's data. The custom services are Microsoft's model with the customer's data. And then when I want to get to a custom model, well, then it's the customer's model and the customer's data.
Right.
And so, how do you do that? If I'm building a model, frequently what I'll do is I will come up with the set of data that I have that I think has the best features in it. And I'll come up with the algorithm that I think I'm going to use, and I'm going to go and train it. And then we call that an experiment. And I go and run, and I compare that experiment against the history that I've got, the test data that I've got. And I see how well I performed. And what you find people doing is this iterative loop over and over where they keep changing. Maybe I need some more features, or maybe this feature is going to make it predict. In my car example, maybe the year is not very interesting, but the location, the zip code is, or something like that. What features can I add in? And so Azure Machine Learning will keep track of all of the experiments that you've run so that you can see which one actually performed the best and basically keeps the history of what did you do different each time that you had it. And then when I have a model and I'm ready to sort of deploy it, then Azure Machine Learning will put it in the model registry. And so now I can keep track of all the models that I've got. And as I deploy them, I can understand where each model is in its life cycle. Is it deployed in which different systems? And so I can manage that deployment and management of them much, much simpler. There are a couple of other capabilities that I think are pretty interesting. I talked about sort of the life cycle of I'm going through all these different experiments. A lot of times what I want to do is what's called hyperparameter tuning.
Right.
For each of these models, there are probably a dozen different parameters. The learning rate, the number of nodes in each level, all sorts of different things. And so hyperparameter tuning is a way of helping you select the best ones without having to sort of painstakingly iterate through them all yourself. And so you put all that together, and it dramatically simplifies the machine learning developer, the data scientist, in getting their models developed. They become much more productive. We talk to people who, have spent weeks training a model, and now they're like, we can get this done in a day. I can do this much, much faster.
And the important thing to note is that, look, generally when I'm running these things, I usually run it on my machine, and then my machine is tied up. And then I try to get someone else, and I'm using PyTorch 0.4.197, and Sally's using PyTorch 1 preview because she's all way more advanced than I am. And it's hard to get all these things to match up. How does Azure Machine Learning help people that work in teams and data science teams? What is it about Azure Machine Learning that will help people work together?
Yeah, I mean, there are a couple things you can look at. One is you mentioned like my machine's all tied up. That's the beauty of the cloud, right? Is I can now use extra computation on the cloud. I can put it in a data science VM. I can put it on the training modules, a whole host of GPUs, and have sort of complete access to my machine. The other is really the reproducibility.
Right.
I can take sort of each model and I can sort of run it the exact same way that you ran it. And so yeah, you mentioned the different versions and all the different things that I'd need to do. Makes it much easier to sort of say, hey, we're all sort of working on the same thing and share the code and really stay aligned with it. And that's something that we've learned internally. We have on our internal services, thousands of developers working on the same model in Bing. And how do you do that effectively? How do you have 1,000 people try and make improvements to a single model? You have to have all this infrastructure. And so as we've learned from Bing, all of that infrastructure that we built is coming through Azure Machine Learning, and that's what we're deploying in Azure Machine Learning, all the things we've learned and making that product much better.
Awesome. Well, keep your questions coming. Obviously, any AI questions that you might have, we want to get those in. So there was announcements regarding AI today. Can you tell us about those?
Sure. So a couple announcements that we made. First and foremost, Azure Machine Learning is generally available. I'm really excited about this. We've had a whole bunch of customers try it in preview, and their feedback has been really, really great. They think the direction that we're going with it has been fantastic. We feel like the quality of the service, the quality of our documentation understanding is all great, and so we're happy to announce it as a generally available product. With that, all the things that come with it, automatic machine learning, which we've talked about, is generally available. The hyperparameter tuning, the experimentation capabilities, the model management, the ability to deploy, all of that service generally available and something that people can go and take and use, which is really exciting. Another thing that we announced today is the Onyx runtime. So I talked a little bit about Onyx at the start. Onyx is this file format for exchanging models and for really making it simpler for hardware manufacturers to optimize them. One of the challenges that hardware manufacturers talk to us about is they say, look, I've got TensorFlow, I've got PyTorch, I've got Chainer, I've got PaddlePaddle, I've got Caffe, I've got all these different frameworks, and people expect me to optimize each and every one of them. How do I do that simply? And Onyx says, hey, you can just sort of make this an Onyx model. They can all convert into Onyx, and now you can optimize one of them. What the Onyx runtime is this is the same runtime we've been using in Windows and Windows Machine Learning. It's now available open source. It runs on Linux. It will run on Windows. And it runs dramatically faster than sort of the native implementations. And so we've seen internally, virtually every model has run faster. Some have, the average is probably around 2 times faster. But some have been as many as like 7 or 8 times faster. And so this is available. It's open sourced, and people can go and get it. I'm really excited about that as well. Another thing that we announced, the third sort of major area, is around cognitive services. We are the only company that does containerized cognitive services. Right. People want to be able to run AI models, and they don't want to just consume it in the cloud. Sometimes they have latency requirements, or they have intermittent connectivity for some machine that they're trying to run it in. And so they want to be able to take the model and run it on-prem or on the edge. Right. And so we announced containerized models, and today we announced that the language understanding model is also available in a container.
Amazing.
Yeah.
So Lewis
is now available in containers. So
that's amazing. I was recently in New Zealand, and one of the hospitals there, they wanted to use cognitive services to do OCR.
Yeah.
But they couldn't do it because they could not, the records could not be uploaded to the cloud. This really enables them to start to do that work.
That's exactly one of the use cases we see is, regulations prevent them from moving the data. And so being able to bring the cognitive service directly to where they actually have the data opens up all kinds of doors that previously they couldn't do before. And so we have had a ton of positive feedback from customers on it. People are really excited about this. So I'm excited to see that going out.
It's basically the first ever lift and shift down that I've ever seen.
Yeah, it's interesting. All the, everyone is trying to lift and shift up to the cloud. And look, that's an important trend because the cloud offers a lot of advantages. But as a company, we've been very committed to the hybrid and making sure we work with people where they need to be. And often that means, hey, some of the things we've done in the cloud need to happen on the edge. There are real legitimate requirements for why that needs to be done. And so we want to make sure that that's supported.
Like just basically, and here's a really silly use case that I thought of. If you run a parking lot and you want to have an unattended parking lot and still charge people, you can have a local model taking picture as cars drive in with OCR getting license plates.
That's right. All sorts of examples like that where, we hear of companies that have manufacturing plants that, their connectivity comes and goes, right? They have vehicles that they want to drive out into the field that they might not have any connectivity at all. And so to be able to still run models locally, there's a lot of great examples with drones. They want to fly drones along power lines and sort of see, hey, are there defects in the power lines and things like that, things they need to go repair. You could have someone drive for thousands of miles. You could fly a drone and have it take pictures and say, this is where you need to go to.
That's awesome.
And so, yeah, it works great.
So here's a couple questions. Will ML.NET expand to training framework so I don't have to learn Python, NumPy, TensorFlow, PyTorch, and I can rather stay in C# where I feel at home?
So ML.NET has a whole host of algorithms where you can train models directly in C# in ML.NET. ML.NET, again, grew out of internal technology that we had where a bunch of internal developers used C# and wanted to have a good framework for developing their models in C#. And so we've wrapped it up and made it ML.NET as something that now you can go and train models in C#. We have a ton of developers in C# that are really not well served by the ML community because the ML community says everything has to be in Python.
Right.
And so being able to have ML.NET as a way that you can now stay in C# is really pretty interesting for people. And, there's still a ton of activity happening on Python, so I wouldn't necessarily discourage you from learning Python because that's where there's a lot of value being created. But absolutely, ML.NET's going to let you stay in C#.
Awesome. Next question. AI is more than just image recognition. What about searching for text and dynamic images? Current OCR engine is not accurate and cost per transaction forces us to use on-premise solution.
Interesting. So I'm not really sure what they mean about not accurate.
Or dynamic images.
Yeah, I mean, maybe in videos or something. I mean, so the OCR solution that we have, I get benchmarks on all of our cognitive services on a weekly basis. We're beating everybody else with OCR. So I believe we have the best OCR solution that's out there. It really performs quite well. And, we have, I talked to our researchers, they are very proud of the techniques that they've used, some of the tricks that they've done in their models to make it really perform so well. Additionally with images, you sort of talk about finding different things within the image. I mean, I loved the example today that you had in the NBA example, showing really the face detection working on all sorts of small areas. There's also logo detection, right? And being able to find the logos in all sorts of different places in it. And one of the places where we really pull all this together is in knowledge mining.
Right.
And so you take exactly what you were doing, and now you're extracting all this information from across an image, and some of it is OCR, some of it is looking for text in an image, some of it is face recognition on the image, some of it is sentiment analysis on the image or on the text or whatever it is, and building an index that's now searchable and brings all the, the named entities that you can sort of think of, whether they're people or places and what's the relationships between them. You can bring all that together, and so knowledge mining makes that really powerful.
Now, and I will say, for you that submitted this question, like if it's not working for you, can you email me and I'll look at it? Because I've seen our OCR engine get like words behind chain link fences that say stop that are crooked and give you the right bounding box. It's ridiculous.
I've even seen it. There's, you love the blacked out text where they used a magic marker and you can still kind of see the text underneath of it. And our OCR is telling you what the text is underneath of it, which is really very cool.
It's amazing. Okay, so tell us a little bit about some of the exciting things that you see some of the customers doing, because one of the problems with this technology is people have a hard time like saying, once they get it, they're like, oh, okay, I can see how this works.
Yeah.
But they have a hard time seeing where it might fit in their business. What are some exciting things you're seeing customers do?
There've been a lot of interesting examples. One of the things maybe more fun ones is, we've talked to Shell, and so Shell has gas stations, of course, all around the world. And so they put cameras in their gas stations. And what they really want to detect is fire, which is a big problem at a gas station. But what they also are detecting is the person who's filling up with gas, is he smoking? And if they are, they want to alert the attendant and say, hey, go yell at that person, tell them it's really dangerous to smoke at a gas station. And so lots of applications like that. We see a ton of image classification applications. Companies, Jabil is looking, they manufacture chipboards. And so the last step, they wanted to sort of take an image of it and see, Did we miss any of the solders in it? Is there any defects we can see with this? And so just improving the quality that they have there. We see a ton of bot solutions. People are looking for bots, often in customer support. Can I deflect, 20% of my customer support costs and save myself $20 million while giving my customers a better experience? We see virtual assistants where people want, their branded experience, their voice, sort of interacting with a customer in a virtual assistant way. So we see a lot of solutions there. So yeah, just a ton of applications across the board.
Awesome. So we have a question coming in. How could I use AI to help with accounting, such as invoice coding?
So I'm not an accountant, and I'm not entirely sure what invoice coding is, but I'll guess.
Okay.
Presumably, it sounds like a classification problem, right?
Mhm.
I have an invoice come in, and I need to decide which budget do I charge it to, or which type of invoice it should be, or anything like that. There are a number of different ways you can do it, depending on sort of how your invoice comes in. One is you can do image classification. If you have an invoice that sort of looks like image one, or an image and something else that looks different, you can do it that way. The other is to build sort of text classification and sort of understand what type of system this is. But that's a standard classification problem. And that's the exact example of what I'm talking about, of each business and each industry needs to find the ways that things are changing for them and how they can really use it to make their business better. Where, if you can speed up your classification on your accounting invoices and have better accuracy with that, you just get so much acceleration from that as a business. And so really finding those ways that really getting the industry to have the creativity to understand what are the places they should be using this technology. That's going to be one of the most exciting things over the next few years.
I found early in my career as a programmer, anytime someone wanted me to optimize something, I would look for tasks that someone repeated exactly the same way often.
That's right.
Now I feel like when I'm doing AI, my particular smell is if someone is like altering code like 0.7 to 0.5 or adding extra if statements and then deploying.
Yeah.
Like for me, when you're doing those kinds of tweaks where you feel like you need to take a shower afterwards as a coder, that's a good place to start thinking about using AI.
They're using rules to make a prediction.
Right.
That's what you're sort of describing. Should it be 0.5 as a threshold? Should it be 0.3 as a threshold? And this is where I say you saw this in fraud a lot. If I get 1,000 requests from the same IP, it's probably fraudulent. And I remember in the early days when I was working on fraud, AOL dial-up modems were a huge problem. It tells you how long I've been working on fraud, because they all came from the same IP address. And so you'd shut down all of AOL from that one IP address.
Nice.
And an AI model is going to be much better. It'll learn that, hey, there are different patterns that I should be looking for. And so instead of having these broad course rules, I'll have these, I can really pull in 1,000 different features in and build a model around that.
Let's talk a little bit about sort of the elephant in the room. And this is important because people are looking at this and they're like, hey, how much is this going to cost? If I want to build my own machine learning model and Azure Machine Learning Service, is this going to cost me a lot?
So the beauty of using the cloud is that you use only what you consume.
Right.
And so the cost for GPUs, if you were to go out and buy a whole host of them, they're tremendously expensive. And so the rates that you can use when you're using the training service, is measured in, the tens of cents per hour and things like that. So dramatically cheaper. Building models, yeah, there's costs associated with it, but it's not exorbitant. This is something, and the benefits that you get from it on the other side, I don't think I've seen anyone come back and say, hey, we're not going to build this model because the training costs are too high.
And here's the thing, like I've laid down an Azure Machine Learning Service workspace, and we basically lay down 4 things. We lay down App Insights, which is nothing.
Yep.
We lay down storage, which is empty.
Yep.
Right? We lay down ACR, which there's a free version.
Yep.
Right? And then we lay down, App Insights, Azure Storage, ACR, and there's one more thing that I'm forgetting. App Insights, Azure Storage, ACR, and there's one more that'll come to me at the end.
Compute batch.
Yeah, the compute. Yeah, the compute stuff. And even the compute isn't laid down until you specifically ask for it. And so you can also create a compute environment that has 0 to n nodes.
Yeah.
And it won't even run.
Yeah, I mean, that's, honestly, I don't know how everyone doesn't develop in the cloud these days. The economies of scale that you get from being in a cloud are they just give you such a better efficiency from that.
Mm-hmm. It's pretty amazing. Okay, so we've got about 3 or 4 minutes left. Where can people go to find out a little bit more about this AI stuff, and how can they like get started? Like if you're a programmer and because you already know all about all this AI stuff, what would you suggest someone go do right now?
I mean, the easiest way to really get started is to go and look at the Azure Notebooks and start with there. The Azure Notebooks will walk you through how to use Azure Machine Learning Service. Notebooks are such a great environment for learning in because there's a description of what you're trying to do right in line with the cell that executes the code.
Right.
You can change the code and continue to execute it and make it just go right there in line. That's the thing that I would recommend everyone go and do. It'll both, depending on sort of what you need to learn. If you need to learn how the services work, there are great notebooks sort of walking you through how to use the service. If you need to learn how to build AI models, there are notebooks that'll show you, hey, here's some of the simple AI models. Do I want to do like, the classic MNIST, I can draw a number and sort of have it recognized. Those are really straightforward ways to go and do that.
I just remembered it's Key Vault is the last one. So there's four things we lay down: storage, App Insights, Key Vault, and Azure ACR, right? Which is Azure Container Registry. Okay, so I figured I'd show just a little bit of what this looks like, because a lot of you are probably wondering what this looks like, and like it's really simple. And the cool thing is that the part that maybe we haven't seen, and Francesca showed that a little bit during Scott's demo, is we actually have these amazing integrations into Visual Studio Code where I can go in and submit experiments by right-clicking, right, or view experiments or attaching, right? And that's the coolest part, right? And the other thing that I really liked about this that I've used so far is there's a team of like 4 or 5 of us that work on these models, and all of us can see what all of us are doing.
Yeah.
Like here's an example that you talked about, hyperparameter tuning.
Yep.
It ran 20 experiments, and notice that here there's like this green line. It actually stopped running it because it's like, this one didn't work. This hyperparameter is not working. And that's cool because initially, like usually I'm running a for loop and spanning over hyperparameters like the learning rate or momentum or whatever. Here, it's a smarter for loop because if it's within, and I use the bandit method, if it's within 20%, it's going to kill it.
No, and that's a great example of, usually you'd have to sort of be sitting there and watching and tracking, having it basically printf, hey, this is the learning rate, how it's converging. Hyperparameter tuning is just going to do that for you. And so it's really saves a ton of time for you.
And the other thing is, and this is the part that's really cool, here's all the compute environment you can see on my computer. We have like some batch AI, we have some Kubernetes services in our compute, and it's basically we just submit and forget, and then we can see all the output. It shows us all the output in notebooks. It's amazing. Now here's the part that we were talking about. Models, to me, are like the executable part of AI.
Yeah, that's right.
It's like when you compile your code, you get this assembly. I feel like that's what a model is too.
It's a great analogy.
You put something in and something comes out. And as a programmer, it's something that we want to version.
Yeah.
And in here, you can see we are versioning all of the models.
That's right.
And then we can marry models with scoring files to create images. And then we can do deployments. And so, for example, you can see this simple MNIST service right here. I wrote like a cheesy little app here where I submit, like I can draw a number. This is the cheesiest version, the cheesiest thing. But you can see it returns things from me directly from the service. And then I'm going to make like weird numbers, and you can see that, it really thinks it's a 4. But if I start to do crazy things like this, you can see that it's going to start to be sure about other things.
Right.
And it's pretty cool that you're able to go from idea to submit a job to save a model to create an image to deployment, all within the same environment.
Yeah, I think it's really important. The software development lifecycle for models is different than for software.
Oh, it is.
And so understanding what are the tools that I need and how do I really use that more effectively, those are the things that are going to make you productive and successful in building your models and deploying them. If you try and do it, sort of the standard software way, you're going to have a hard time sort of figuring out how it all fits together.
Awesome. Well, anything else to finish up with, my friend?
I'm really excited that Azure Machine Learning is GA. I think there's going to be a ton of amazing uses for it, and I'm excited to see what people will do with it.
Well, thank you so much for being with us, Eric. All right. Well, the show is not over. We have my amazing colleague, Brian Benz, just over there with Beth to talk all things Java. Let's go to that.
Hey, guys. I'm here. Beth Massey with Brian Benz. Brian, tell us a little bit about yourself.
Brian Benz, I'm actually based in Las Vegas, which is where we're recording this.
This is your town.
I just drove in here, and I've been working at Microsoft for about 5 years, mostly on Java on Azure, which has been increasingly getting easier as we go. And that's what I'm going to show you today.
Cool. So we're going to talk a lot about Java, which I don't really know much about at all. So you're going to probably get a lot of interesting questions from your host today.
Yes.
So
yes.
what part of Java are we going to talk about?
So we're going to talk about a couple of recent developments in the Java world, which are mostly MicroProfile, which is a microservices framework. It's everyone's got a way of implementing microservices, and this group, which is part of the Eclipse Foundation, decided, hey, why don't we get together and figure out if we can make our microservices compatible with each other by building them in a standard way.
Cool.
So that's basically what MicroProfile is meant to do.
Okay.
And it's also implemented this thing called open tracing, which is a way of tracking your performance through from an end-to-end process that includes multiple microservices.
Gotcha.
So,
okay.
Yeah.
Okay.
So we're going to talk about those two things, and I'm going to show you how you can actually run those on Azure, on container instances, and also one of our partners, Red Hat, has an implementation of Kubernetes called OpenShift. I'm going to show you how to do that as well.
Oh, that sounds fantastic.
Yeah.
All right. Let's get started.
Okay.
All right.
So basically, what's on the slide right now is a little snapshot of the community that is actually working with MicroProfile. Some of them actually have implementations already created, including Red Hat. Red Hat is a microservice implementation called Thorntail. So they've taken the MicroProfile standard, which is the Eclipse agreed upon standard, and they've made a reference implementation of it, and they've called it Thorntail.
I love the names in the Java community.
Yeah, yeah.
Well, jealous of those names.
This is the only one that actually has some kind of cool name. All the other ones are like, there is a Spring offering, which is just basically Spring microservices, and some other ones as well. But yeah, this one's the only one that came together and said, hey, let's get a brand and a name. And so we got Thorntail, MicroProfile, yeah.
I hear we have a couple Red Hat guys in the Twitch stream chat as well, so that's great. So
welcome to James
everybody.
Faulkner. Thank you very much for being there. And Aaron Wislang, who actually helped a lot with the demos I'm going to show today. I just want to give him a shout out as well.
All right, so guys on the Twitch stream, make sure that you ask your questions
yes.
about Java and Red Hat. We have the experts here.
Yep. So I did want to go over a little bit about MicroProfile. Basically, there are three things that it started with, which is context and dependency injection. That's a CDI2. What you're looking at on the screen right now, that's the bottom row there.
Okay.
It started back in September 2016. With context and dependency injection, which is just basically a way of managing microservices, and then JSON for reading JSON, and then processing REST with JAX-RS.
Okay.
And since then, they've basically evolved and they added some new packages. And the most recent one is October 2018. They added a newer version of Open Tracing. So that's why I'm going to show Open Tracing today as well, because it's sort of like the latest, coolest thing of the latest, coolest thing.
Cool.
MicroProfile. So yeah. So Thorntail itself is, the idea is it leverages a bunch of Java EE expertise out there. It's an open standard, and as I mentioned before, so Thorntail is an implementation that actually implements the standard that's been put together. So it's just a way of making things work. Everything works through POM XML, so it's Maven based, and Maven Thorntail is the actual command you use, so Maven Thorntail run to actually run things. And for those of you who haven't been working with Java, this might be a little foreign in the audience, but I'll show you a little bit about how this actually works. In fact, let's just get into that now. I've got some things here. There's things about working with MicroProfile with Thorntail in terms of health probes and things like that, but I'll show a little bit more details of this, fault tolerance and metrics and things later.
We like real code, not slides.
Yes, yes. Well, the main thing I want to show you, just before I get into the demo, is this is the whole reason behind MicroProfile.
Jaeger.
It's all I need to do to add Jaeger, which is a implementation of the Open Tracing standard.
Okay.
All I have to do to add Jaeger is just add this dependency into my POM file, and it pulls all the right files in and makes it run for me. And then I can just run Jaeger and look at traces of my application. So Open Tracing, if I may get into my browser here. So Open Tracing is actually an implementation that is open source out on GitHub, and it's a way of tracking multiple microservices from end to end. So you've got this thing called a trace, which is basically I made a web app call, and then I've got 10 other microservices that do things like credit card processing, inventory processing, stuff like that. And each one of those is called a span. So the microservice itself generates a span when it runs and reports back to a log file, and that log file aggregates all those spans together into a trace.
So you can figure out what's going on in each one of those microservices. Is that what you're saying?
Exactly.
Okay.
Exactly. So I'm just focusing on that part, but there's a ton of more features of MicroProfile that you can use. But let's dive into that.
Cool.
So what I've got here is a command window most people are familiar with. All I'm going to do is run my application, which is basically invoked by Maven clean Thorntail run. And as that fires up, takes a minute or two, it actually will start up. It generates a WAR file.
Okay.
And then that WAR file gets used by Wildfly, which is Red Hat's implementation. Because we're using Thorntail here, Red Hat's implementation of the microservices standard. It's going to use Wildfly, which is basically Red Hat's implementation of the Java app server that you can use for that as well. To do that, use a WAR file, and the WAR file actually fires up. And so we're doing a build and then a deploy, and it's actually going to run on top of this.
Cool.
Now, while that's running, let me go. I'm going to show you something else. I'm actually doing this all in Visual Studio Code. Visual Studio Code itself has several plugins you can use to read YAML files. For those of you who haven't been familiar with Visual Studio Code, it's an open source, free text editor that you can use. It's got 1 million extensions, and I've got about 500,000 of them installed on my machine. So I can do things like—
And it supports multiple languages, and Java is one of those that it supports.
Yeah,
That's
I wanted
cool.
to show that. So you can actually use this for managing Java. It's not a full Java IDE, but it is a text editor, and it's great for demos like this. So that's what I use. And
it's good for like quick editing of files and things like that. Is that what you're saying?
Exactly. Okay. Exactly. And it's great for editing things like YAML and actual Markdown files as well, which is what this is. So while that's running, let's just check back to see if that finished. Yep, Thorntail is ready. All right, let's fire that up. So some people in the audience might be familiar with this. This is the application that we decided to build for this just because it's fun. It's Minesweeper, what we call it MicroSweeper. And you can find it on GitHub on BBen's MicroSweeper demo. But anyway, it's just a full Minesweeper application. On the back end, it actually uses
You're doing pretty good.
Cosmos DB. I know. See, this is what happens when I'm doing a demo and I'm trying to do it quickly. It doesn't work. Oh,
wow,
boy.
you're super good.
There we go. All right. And, you know, you do a couple of these. Oh, there you go. And you get the idea here. So it's Minesweeper. It's an application. Every time I finish a game, it writes over here to the scoreboard. It also writes this in Cosmos DB on the back end.
Okay.
So, okay, so let's go in. And the next thing I want to do, so I built this application. This is a MicroProfile application that's sitting there running. Now, I want to trace this using Open Tracing.
Okay.
To do that, I'm going to use the Jaeger implementation. So let's go there. I'm going to use a Docker file for that. And this takes hardly any time at all to fire up. So Docker run, local machine again.
So you're running everything locally here, right?
Yes.
All the microservices, everything is running locally. All
exactly.
Right.
Where's Azure? We're going to get to Azure.
No, that's cool.
But right now, I just want to show how this actually runs. And then we're going to actually deploy this out to Azure Container Instance. So this is Jaeger. So Jaeger is a way of visualizing traces, okay? So Open Tracing is the actual service. And as you can see here, there's nothing that's been found. So if we play over here with some more games of MicroSweeper, there we go. You'll see a couple of traces in there in a minute. Each time that something is saved to the scoreboard, there's a trace that happens.
Another great game. Oh, there you go.
I know.
Okay.
It's just, you know, and that's, of course, Murphy's Law. This isn't when you want the great games. So anyway, let's refresh this. So over here, we're actually going to find some traces. As you can see, Jaeger query is now lit up. So the basic traces you get are Jaeger queries, and Jaeger query is just something that actually runs and checks to see if Jaeger's running.
Okay.
And,
it's like a health check?
yes, basically. And this is a trace. actually, no, sorry, this is a span, and then the trace is this end-to-end thing. And basically the way this graph works, and it's a very simple graph, this is the free version. There are other versions of open tracing implementations out there that you can use that are a little more robust, but this one's just the basic free one. And if this circle is larger, that means the actual trace is taking longer.
I see.
If it's up higher, like this one, that means the actual span is taking longer. So the whole end-to-end process. Okay. So that's what we're looking at here. So that's just basically Jaeger running locally. And there's a bunch of environment variables you can set in Jaeger to actually display things a little more granularly, and I'm going to show that in a minute with some environment variables that we set up. Yes, yes. So let's go in. Let's continue on. So that's just running locally. Let's fire up I'll skip over the properties for now, and I'll show you a demo of those properties later. But the next thing I'm going to do, I'm going to just take this. So in Visual Studio Code, I can fire up a window, a bash window. Let me just close that one because I already used that one. And basically, this is Windows Subsystem for Linux. Okay, so I've been at Microsoft for a while, yeah. But most people at Microsoft are not familiar with the Windows Subsystem for Linux or using Visual Studio Code for Java and things like that. I live in kind of a totally different world. Yeah. It's starting to change, but for now it's sort of a very different from what most people are used to seeing when they're working with Azure. And in this case, what I'm using here, I just hit Control backtick in Visual Studio Code, and it actually fires up a Windows Subsystem for Linux window inside my Visual Studio Code. And that actually is a full implementation of Ubuntu Linux, Bash, running on top of Windows. And you can run that from your command line. You can just open a window. Or if you have it already installed, you can actually set it up here and run it as well. It comes with Windows 10. It's free.
It's right out of the box.
Yeah, it's out of the box.
That's cool.
But yeah, so basically Control backtick, I've got mine set up for Windows Subsystem for Linux. And then I can actually execute some commands. So let's go up here. I'm going to set some variables first. See, now I mentioned Aaron before. I'm going to call Aaron out again. Aaron Wislang, thank you for setting up this particular script for this demo. He wrote it on a Mac. So as you can imagine, when you run a batch script on Windows, it's harder. But if I use Windows Subsystem for Linux, I can just fire this up. I set all the same environment variables and everything. So I'm actually in a Bash environment, and it works just as well as it would on
the Mac.
On the Mac, thank you. So we're going to create a resource group. This takes a minute.
So is a resource group like, you mean like an Azure resource group, or is this
yes.
different?
Yeah, we're setting up an Azure resource group. So by the way, I'm doing all this live from scratch, nothing pre-baked.
Yeah, no, this is real.
And basically, that's what we wanted to show in this particular demo.
Awesome. So you're sending commands to Azure.
Yes, so I'm actually just right now sending commands to Azure through my Windows Subsystem for Linux image. I've already logged into my Azure account. And it's set up. So I created a resource group, and then I set up an Azure Container Registry, which is a private registry you can use. People who work with Docker are probably familiar with Docker Hub, and that's a public registry. You can pay extra on Docker Hub to have private repos, which means you, just like GitHub, where you actually store private Docker files that you have sitting there. Azure Container Registry is a paid service on Azure that you can use to actually store private containers as well. And the reason why I want private containers, private images. The reason why I want that is because I have Cosmos DB connections and things built into this application that I don't necessarily want to share with the public.
Right.
So basically, I set up an AZ ACR create. Will create the actual ACR. Now this is a cool one. Let me start this off because it takes a couple minutes. So this is an AZ ACR build, and this is built on top of Docker build. And what that does is it's actually going into, let me show you the Docker file here. This is actually, it's going to take a little while to run. But while it's running, basically what it's going to do, it's going out to Maven, and it's getting a JDK8 from Maven, okay? And it's going to build some applications using some directories and things. It's going to build a Maven clean package for this. And then it repackages the whole thing after it's compiled using the OpenJDK 8 Alpine image. Okay, and this is what's called a multi-stage Docker file. And the reason why you want to use a multi-stage Docker file is size. So the Alpine image of Java 8 is much smaller than the Maven image. You need the Maven image to actually run and build and compile all this stuff because you need Maven. But then once that's done, the jar file itself, we just need a basic Java image to run. And the cool thing is, you don't need Java or Maven installed on your local machine because it's all pulling it from Docker. So it's pulling it from the Docker Hub using these images, Maven 354, and then OpenJDK 8 Alpine. It's actually pulling those down. So if I wanted to, I didn't do it today, but if I wanted to, I could run this on my Azure shell. For those of you who haven't seen this, shell.azure.com is a pretty cool thing. It's actually a full bash environment on Azure. There we go. So it's taking a second to start. There we go. But I have my Azure CLI on here. I have Cloud Foundry. I have Terraform. I have all kinds of things built into this shell so that I can actually go out to shell.azure.com from any computer, from that dodgy computer in the hotel lobby, and I can actually do stuff here.
That's cool.
This is the coolest thing. So I wanted to show this. That other thing takes a couple minutes to run. So this is Visual Studio Code, an implementation, in shell. So I can actually do things. Here's the same code that I was working with. Where is it here? There we go. Here's the same code I was working with. You don't get all the, interpretations of every file. Actually, it does. It does YAML. So it'll actually work with all the files here. And I could have actually run this technically from here as well, just as well as I could run it on my local machine. Yeah. So this is actually some pretty cool stuff people might not know about.
Right in the browser.
By the way, there's an app on Azure as well. You can use an iPhone app or an Android app, not to run code, but just to run the shell. So you can actually go into Azure Shell and do that as well.
That's awesome.
So yeah, it's pretty cool stuff. Let's see here. All right. From there, let's see what we got here. Hey, good, it's successful. So the actual build was successful. Let's go in and we got to continue on. That was the slowest part of this demo, so good. So now what we're going to do is we're actually going to get some credentials. So we're going to get some credentials here that actually allow our Azure Container registry to talk to an Azure Container instance. So there we go. That runs, takes a millisecond. All right. And that should be real quick. All right, so that's done. Okay, so there's a little bit of a script in here for creating a single container instance, but what we want to create is actually a multi-container instance. So I talked about Azure Container Registry. It's a private registry. We're actually going to deploy what we just built into Azure Container Instance, which is if you're using something like Kubernetes to run your applications, that's great, but it takes a lot of work and maintenance and a management plane and load balancers and stuff like that.
Orchestrator.
Yes, orchestrators.
Right.
So we have Azure Kubernetes Service, which is great. But if you just want to do like a little test or maybe a demo on a live stream, then we have this thing called Azure Container Instance. And one of the things I learned actually recently about this, hat tip to Aaron again, is that you can, I was picturing Azure Container Instance as something that just runs one container at a time. And if I wanted to connect my Microsweeper application that I showed you to my Jaeger application, I would have to have 2 Azure Container Instances. That's actually not the case. I can use one Azure Container Instance and put multiple containers in it.
Oh, I didn't know that. Okay.
Yeah. See?
Cool, because the name kind of makes it sound like it's a container instance, like one.
Yes. So in essence, what it is, it's kind of like a pod that you can use, like a Kubernetes pod, if you're familiar with those, that you can use to actually put multiple containers. And in this case, because we have 2 things running the same container, it's like running them on your local machine where they can talk to each other.
So Azure Container instances are good for what type of applications? Like you don't want to go full blown like Kubernetes, like you said.
Yeah.
What are they good for? Like running batch jobs or things like that?
Yes.
at night or like you would normally do, but you can do them all the time now? Or what kind of scenarios would they, like besides your demo?
For container instances?
Yeah.
They're really, really just good for firing things up quickly and testing them.
Testing them, okay.
Yeah. So I can run this whole thing end to end in about 4 minutes, you know, in a normal circumstance. But if you want to set up Kubernetes,
right.
Even on, you know, any platform, not just ours, but any platform, it's a lot more work, and you have to worry about manifests, and you have to worry about load balancers and applications and interfaces and ports and all kinds of things. This thing is just really, really quick and dirty, if you will, way to set up a container. I want to just run this container. So if you have something you want to share with a customer or a colleague or something like that,
I see.
And you want to make it sure it runs before you share it, you can just fire this up and then send them a link and say, here's your container instance running.
Cool.
So that's the kind of thing I think is the best use of this.
Gotcha.
Yeah.
You can't say it works only on my machine anymore.
Yes, yeah, it works on
it
Docker.
works on everybody's machine.
It works on Docker, that's it. So basically what I'm going to do here is I'm actually going to build a custom YAML based on the variables that we put together. So let's start with copying our deploy ACI YAML. So the thing called deploy ACI YAML is just a way of, it's a really simple manifest, and I'll show you an example of it when I'm done. And then we're going to set up the custom images here. So basically what it's doing is it's taking all the environment variables that I created earlier, and it's putting them into a YAML file that we can use to deploy. And if we can do a cat here, or we can actually just literally open the YAML file now. And it's basically got all the information. We have a local location for this ACI instance, the image that we're going to use from our ACR instance that we created, or Azure Container Registry that we created. The name of the service is Microsweeper. And then there's a little bit of information here. I did mention the environment variables. So there's environment variables that you can use in Jaeger to customize your processing of that.
Gotcha.
And in this case, there's just 3 that we had to do as a minimum. And then you start up, this is the image we're going to use, Jaeger tracing all-in-one latest for Jaeger. This is actually coming from Docker Hub.
Gotcha.
So we've got our custom image, which is coming from our ACR. That's this one here. And then in the second container, we've got our Jaeger image, which is coming from Docker Hub. And once we actually run this, it's going to set all this up. It's going to open some ports. These ports are used for communicating between the traces and spans and the different agents and things that Jaeger uses to talk to open tracing. And by the way, you can find all the more info on the Jaeger implementation on Docker Hub. There's all kinds of images there, and then links to the GitHub repos for those images as well. So much more detail. That would be a session all by itself. So there we go. So that's that. So we actually created the YAML file, and we're actually going to go ahead and just use that YAML file right down here, deploy ACI YAML. So AZ container create, it's going to create our image. It's going to use the resource group we specified. It's going to use the name of the Azure Container image that we created. And it's going to use that YAML file to actually generate everything. So let's just go ahead and do that. And this actually takes a very, very small amount of time.
So one question while we're waiting really quick.
Yes.
Skull Crusher for life, thanks for sticking around all day, dude.
Hey.
Not a Java person, but can you save a trace if you detect a problem to sort of replicate the problem and then troubleshoot it knowing all the steps it took?
Yes, yeah, so basically, by default, open tracing keeps everything. And you actually have to set flush intervals if you want to actually get rid of anything, which is a good idea because it'll store things in a variety of backend data sources. But the main one is just HBase that it uses, which is an in-memory database in the backend. And you have to flush that every once in a while. Otherwise, it'll just start to get really slow and actually slow down. It doesn't slow down your application because it uses UDP. It just actually fires these things off into the ether. But you won't get the latest stuff in your traces when you try and visualize it. So basically, yes, the opposite is actually true. You have to worry about getting rid of some of these versus collecting them. So, yeah.
Yes, there is a demo of OpenShift coming up. There's a question there.
Oh, yes. Yeah. There is a demo at OpenShift coming up. Yes, there will be.
Stick here.
Real quick.
Stay here.
And I've got everything all nicely tied together, so I hope you like it. Okay, so we created our instance there. And then basically what we're going to do here is just show the image. So we've got two things that were created here. And basically this just shows that everything happened. So everything started, everything's normal, good. I won't go into the logs. The logs we're going to go into the open tracing part of it anyway. So in this case, I'll just grab the IP address for this particular Azure Container instance. And once again, this is just a script. It uses JQ to actually grab the IP address from the properties that are returned by Azure CLI call, which is Azure Container Show. And then, let's see, open the application. There's the application IP address. And there it is. Once again, we got our MicroSweeper app. Okay. And then we want to actually show the Jaeger. So that is on port 16686 by default. 1660. Oh, there we go. Takes a second to start up. Now this time, because we had some environment variables set up, MicroSweeper, you remember it was Jaeger Query before?
Yeah.
Now MicroSweeper is the name of the actual application because we named it through the environment variables.
Okay, gotcha.
So then we can find traces, and there's just a couple of traces that I clicked a second ago. But the idea here is because this is in Azure Container Instance, everything's in the same location for you.
Gotcha.
Which is nice. Okay, so that is basically everything running on a container. So as you can see, this is kind of the steps you would take when you're working with an application. You would work on it locally on your local machine, running it, using IntelliJ or Eclipse or Visual Studio Code. You'd make sure it works, and then you want to deploy it out and share it and see if it works on a container. Build your Docker file, then build your YAML file to deploy that. And then just run it on Azure Container Instance in this case. Now, we could take this, we could build a way more complicated manifest that actually deploys this out to Kubernetes.
Okay.
Or some other container-based, technology. Red Hat also is one of our partners, and they've created OpenShift, which is a Kubernetes implementation which not only manages it's not only orchestrating the containers, but it also manages your code and stuff like that as well.
Cool.
So let's go ahead and show that. I already set that up. And we use the OpenShift origin image, which is actually a open source license-free version of this. And as you can see here, we've been playing it a few times, trying things out. But this is the actual OpenShift. So this is MicroSweeper, and this is actually a live IP address out there.
So people can go there right now.
They can go and play it right now if they want to. And basically, when they hit that,
Can see if your app scales.
Boy,
now.
okay, I'm winning today.
You win a lot,
kind of.
Yeah.
Anyway, that's what happens. So anyway, it generates the image. It stores it on Cosmos DB. So let's actually look at that. And then I'll show this. So this is the MicroSweeper app. This is where the Jaeger query is. And you can just refresh that, and you can find traces. So there's a trace I did just a few seconds ago. And looks, as you can see here, one of them is just not performing terribly well. So if this is a real app, you'd want to try that out and see what the issues are. Okay, and let's just look at what that actually took to create. In this case, here's our OpenShift implementation. The actual deployment itself is under Applications Deployments. And we have MicroSweeper. Jenkins is built into OpenShift. And then we have the Jaeger implementation here. And if I go into the MicroSweeper app, okay, so if I go into environment variables, I've set multiple environment variables for Jaeger. So I really tricked this one out, basically, with all the environment variables we need. And this is actually one of the cool features of MicroProfile, is there's code, there's Java code, you have to write that, but then you have your pom.xml, which manages a lot of things. And then you have the environment variables, which you can use, build into your pom.xml, or you can actually use them per deployment. So when you deploy this, if I deploy this, I could have different versions of this that behave differently based on the environment variables that I set up.
Gotcha.
Here. Yeah, and not to make it too much of a Red Hat demo or a OpenShift demo, but we do have builds built into this and pipelines, so that's kind of nice. And the pipelines themselves will deploy things automatically. They run some tests and things like that. So the idea here with Red Hat OpenShift is they took Kubernetes and then they take a version of the application that I've got running MicroProfile, and they do special things with my MicroProfile app.
Okay.
Special cloud native things like back pressure, circuit breakers, and all kinds of cool cloud native application features built into this. So just wrapping back to the beginning with our actual application here, if I look at the pom.xml in Visual Studio Code, let me see here, pom.xml. Inside the pom.xml, I've got all kinds of things for health checks and things. And these run fine when you're running with Thorntail.
Right.
But then there's other things like circuit breakers and things that are just built in automatically. I didn't have to configure them in here. They will actually run and process based on properties inside OpenShift.
And is that also because you're using a standard? You're using a standard.
Yes, so I'm using MicroProfiles.
And so it knows how to hook into all of that stuff?
Exactly.
That's the idea. Okay,
exactly.
got it.
So that's the idea. And that's kind of the promise of MicroProfile itself. So it's an independent, open standard. And the idea here is Red Hat can write an implementation of Kubernetes, which is another open source standard. And they can actually adapt that application based on the common language that they're using between. So we can take Kubernetes, we can write some MicroProfile features, and then those can run. So another app server like Tommy Tribe can do similar things when they're handling MicroProfiles.
Gotcha.
And other app platforms.
So it enhances the life expectancy of these microservices. It does all kinds of stuff for you to manage them.
Right, yeah.
Okay.
So it helps with scaling and management of your actual application and things like that.
That's actually really cool.
Yeah.
That's neat.
So that's basically the session that I had put
Awesome.
together. We watched three things. We watched MicroProfile running locally, and then Azure Container Instance, and then showed you the same thing running on OpenShift. So.
Awesome. All right. I don't think we have any more. Oh, we do have one more question right here. Can we use Visual Studio 2019 to develop Java FX projects?
Oh, Visual Studio 2019 doesn't handle Java necessarily. I mean, you could implement any Angular or JavaScript-based portions of that project, but to do the whole thing together, you'd probably want to use an IDE like IntelliJ or Eclipse.
Typically, Eclipse or IntelliJ is really the IDE.
Yeah, NetBeans. I should
NetBeans. Okay.
I'm going to get. People are going to get mad at me if I don't mention
actually
NetBeans.
remember that name from a long
yes.
time ago.
Yes.
So VS Code's good. It's very good for quick editing and especially all of these files. It has nice syntax highlighting. It has really good, editing experience. You can still edit your Java stuff.
Correct.
But you really typically use a full-blown IDE, just like .NET developers do. They typically use a full-blown IDE, and that happens to be Visual Studio for .NET, but happens to be Eclipse or IntelliJ for Java.
Yes.
Okay.
So Eclipse is sort of the open standard. They have a free version. IntelliJ has a free version, a community version, but they also have a paid version that a lot of big enterprises use. Fun fact, most enterprise Java developers, which is most Java developers, run on Windows machines.
Interesting.
Yeah.
That's
Everyone
cool.
thinks it's sort of like the Mac
So the
world, but it's
development
not.
environment is usually Windows?
It's usually a Windows operating system, and then on top of that, they're either running Eclipse or IntelliJ, or NetBeans, and
deployment is in the
deployment.
Linux.
So there's a lot of different features inside of Eclipse or IntelliJ that help you manage your project interactive. Breaking down projects into different, segments and sharing information back to usually a Jenkins server for CI. And then we also have Azure DevOps, which works really well with
Yeah, I was going to
Jenkins.
ask that, Ed was here earlier talking about Azure DevOps, but a lot of great features for Java developers in that area as well, right?
Yeah, no. So of course, the big one is free private Git repos.
Yes.
That you can use to build, on other platforms which are Git-based, you have to pay for private repos. For us, you don't. And then building pipelines, of course. Big advantage is if you're working with Azure on Java, you already are authenticated with your Azure account when you're working with your projects in Azure DevOps, and it's easy to build pipelines and things. In fact, I wrote a blog a while ago that shows integration of yeah, it actually shows integration of Jenkins, the way that you can play off Azure DevOps strengths and weaknesses. So
Nice.
let me.
Or while you're
medium.
looking it up, one more question came in here.
Yeah.
What is your favorite VS Code, or what are your favorite VS Code plugins for Java? So if you want to play with VS Code and Java,
Yeah.
what are the top 5 plugins you need?
Let's
need
go
to
through my
install?
extensions.
There you
Let's go through my extensions. So Azure CLI Tools is a big one. As you can see from this, I use CLI a lot. Terraform, if you want to use Terraform. Debugger for Java is a very good
That'd
one.
be handy.
Yes, there is actually a Java pack. So there's a Java extension pack right here that actually downloads all of the essentials for working with Java. And then there's some stuff on top of that, like the CLI and Terraform, things like that I particularly like. Red Hat's Visual Studio Code plugin for Java is actually the main feature that that everything else is based on in our extension pack.
Okay.
So as you can see, we work a lot with Red Hat when it comes to Java.
Yeah, they're awesome.
Yeah, they're really good. But
We actually work a lot with them with .NET too. by the way.
Yes.
Yeah.
Steel Toe.
They're actually on
Yes.
the technical steering group of the .NET Foundation too.
Yes.
Yeah.
Yes,
It's been great.
Yeah.
Well, Brian, this is super informative for me. Honestly, I'm really happy that we have actually a lot of great tooling support as well as Azure support for Java developers. You really opened my eyes a lot to that, which is great. Anything else you want to say to the audience out there?
No, just try out our offerings for Java.
Okay.
And let us know. We really value your feedback. You can contact me on Twitter, bbenz, and we actually have a Java CDA handle as well, which is Java_CDA, and a few other. We have a whole team that's working on Java that we've been building things. We'd like to know what people think out there in the Java world, see if we're on the right track, make sure that we're building things that everyone's looking for.
Cool.
And yeah, definitely would love some feedback and let us know how we're doing. And try our stuff out. It's easy to use. You don't have to learn a lot of new things. There's some things that add value that you can learn, but you don't have to. You can use everything as is that you're already used to running with Azure as well.
Cool.
So,
All right,
yeah.
Brian, thank you
All right.
so much. All right,
Thanks.
so guys, we were talking a lot about Azure and Java. Now we're going to talk a lot about Azure and .NET. We're going to go right over here to my two good buddies. This is Paul and Andrew. Hey guys, how are you?
Hey, how's it going?
Thanks
Good
for
to see you,
joining.
Beth.
Thanks for joining. Hey, we're save the best for last, right? Okay, last session of the day.
I
What are
love
we
it.
talking about today?
We're ready to roll.
We got 5 Azure services. How many services are we
I
going to
thought it
talk
was
about?
7. That's 5.
7? Oh, wow.
Let's do
I'm
5.
excited. You want to do 5? I don't know.
We can do 5.
All right. All right. We're going to start off with the best one. Most favorite.
Yeah, I think
Close
we'll
to home.
We'll lead with I think the 2 that are kind of universally applicable and
Okay.
then have a thread through them.
Yeah.
I think one of the goals for today for our talk is we hear from a lot of people. There's a lot of Azure services. We don't know where to start. So we tried to pick 5 services that we think apply to most .NET developers looking to move stuff to the cloud.
Yeah.
Okay.
Certainly
Super
we're not,
opinionated. Like,
Super
if you don't know,
opinionated.
start
Yeah.
here.
Yeah, okay. So we're
Yep.
going to tackle some very common scenarios that .NET developers are building today and
Yep.
what services you could really take advantage of right off the bat.
Absolutely.
Okay, so what's the first one we're going to talk about?
So first thing we're going to talk about is Azure App Service. So we're going to have a sample application that we're going to walk through. We'll go to Paul's machine first while we're doing this.
Okay.
Okay.
And so it's a relatively simple web application, has a SQL server associated that it stores login and some basic interaction data with. And then it's going to let users upload images to the machine, or sorry, to the site, and then people can see images that they've uploaded.
So this is an ASP.NET application?
ASP.NET application,
Standard
core to be
ASP.NET
precise,
core.
but nothing
ASP.NET
about
core,
it that's
not fancy.
yeah, could be written
Just
in
a
either
web
core
app.
or
It's not
.NET
that
framework.
Corey.
No, not that Corey.
Okay.
Not that Corey.
Not that Corey.
Okay, that's a different Corey.
Right.
And so the first service we want to talk about is App Service, because when we're thinking about moving web applications into the cloud, your first question is, where am I going to host this thing? What is the backbone of the application?
So App Service is great for hosting ASP.NET apps.
Absolutely, yes.
Yeah, especially stateless front-end applications, web APIs. No brainer. Start there.
Cecil actually had a good demo in Scott Hanselman's session today, keynote.
Yes.
Yeah.
Yes, he
Pretty
did.
sweet. Yep.
Very cool.
Yeah, I think the way we talk about App Service is if you're looking to start hosting an application in Azure, App Service is where you should start. You may find in some cases that you grow out of App Service, or if you're migrating an existing application, you may have special requirements that it doesn't need. But it would definitely be the place that we'd say, look there first, and only if it doesn't meet your needs, then go somewhere
Yeah,
else.
I love as a dev, it really lets you focus on your app
Microsoft takes care of the infrastructure like the OS patching,
framework
IS,
patching,
scaling it, all these kinds of operational things. You just get to focus on your app.
So we should also clarify, like it doesn't have to be a core app. It can be .NET Framework based app as well.
It can
right?
be
And
.NET
it'll
Framework
patch the
app. In
framework
fact, there's
as well.
even like a number of languages for those of you watching. There's all kinds of languages that are supported. Java, Node, right?
Python.
And also like
Yeah.
Linux and Windows. So
Okay.
just like expanding. There's, it's the easy way to start with these web applications.
Awesome.
We're going to show .NET today.
Okay.
We have
absolutely.
a bias, right?
I have a bias.
Okay. I'm in the right place.
Never guess, Beth.
Never guess. All right, cool.
Okay.
Let's dig in.
All right, so do you want to speak to your app, your beautiful image gallery app?
Yeah, I mentioned
Yeah.
a little bit, but
Yeah.
as Paul said, so if you look at kind of Paul's machine here, you upload images, you can see images you uploaded, and then there's a SQL server associated that holds his login data, and
What's
will
that, a big
record
engine?
transactions.
Because it's all nature.
Love it.
Okay. Got it? All right, so looking from the Azure perspective, so I'm going to switch over to the Azure portal. And the first thing I'm just looking at, just like kind of like a lap around, we'll look at the resource group where we created this. I just think of a resource group like a namespace. For those of you who worked in Azure, you know what that is. And we're going to pick this app service. And just to, Andrew's point, so many things are just built in. Like, so I can see that Azure is handling the health and the status. I can see it's running. I can see which location in the world it's running. It's in East US right now. Get to the public URL, right? But I want to show you some of the cooler things. So as a cloud developer, I care a lot about moving between different environments and making sure that the configuration for each environment remains intact, but I don't have to make changes as a developer to my source code. I really don't want to have connection strings and secrets and things like that in my code. So what App Service does that I really love, you just go down to the application settings, and that's basically your set of environment variables. And for each instance of an app service you have, you would keep the same name, but you could, of course, change the values. Or an operator who has the privileges can save those values. We'll talk about slots in a second, but even if you use slots for DevOps, the settings are aware of slots.
Cool.
Yeah, and then a couple other goodies, these days, HTTPS, SSL, TLS, super important. We, I think in the tooling, turn it on by default now, right?
We do, yep.
Help people get through that. You can set up your own custom domain names, use CNAMEs. So there's just a number of things that you actually, and turns out, had to do to have a real web app. And it's just built in here. Then think about, it's the cloud. So of course you expect a lot of scale. So the first thing I'd look at is, when you need more resources, you can just simply, either through the portal or using a command line CLI, you can just add more virtual resources. I was trying to make a new word today. You didn't buy it. I talked about virtual machines. It's kind of like more virtual machines. You didn't buy it. But you can do that manually. You can also set up auto scale. So there could be a metric, whether it's like requests per second or whether it's CPU, memory. You can scale based on those metrics.
So you can control it or you can have it decide.
You can have it decide. And so basically, I'm just getting more and more instances that can handle the traffic. That's what we call scale out. There's also scale up, which I just think about as kind of improving your hardware, improving your virtual hardware.
Okay.
So in this case, what did we pick, Andrew? I think it was an S2.
S2, yep.
Right, so we got 3.5 gigs of memory, a few CPUs,
Okay, that's cool.
But, our guidance is always start with the minimum app service plan or basically scale that you need. And then try to scale out first, try to use more instances. And then as you need to, then scale up. And then you'll get the best economics from doing it that way.
Gotcha. Okay.
What did I miss? Did I miss anything super cool about this?
So can you think about it like, okay, there's scalability and there's performance. And if you're maybe hitting a performance problem, then you would probably scale up.
That's a good way of saying it. Like if you, another way, people talk about solving things through DevOps. So if you just need more capacity, you need more capability to run the workload, then you would scale out. But if the minimum requirements of just the service that you built as a developer itself, you might actually need to scale up just because you need, even initially you need that overhead of better hardware, more memory, let's say. Like if you have a memory intensive app, I would go for a higher memory SKU.
Okay. A different way to look at that is depending on the resources of a single request. So if you're doing very computationally intensive stuff or high memory stuff, as Paul was saying, so any given request that comes into your application needs a lot of resources. That's when you'd scale up. If the issue is simply handling lots of requests concurrently, then scaling out is going to give you the better economics.
In fact, we were just talking to a customer just yesterday, and they're kind of saying, hey, even with 4 users, I'm actually hitting some problems. I'm hitting some contention. And that's already a sign that either like the hardware needs to change or the app needs to kind of be refactored.
Right.
So you're looking for those kind of signals versus is it more like, hey, when I have a lot of requests at scale, that many requests start to bog it down.
Gotcha.
Right. So
And you're probably going to tell me later how we could actually troubleshoot those types of issues
it's
too.
like, it's almost like a softball lead into maybe. It could happen. Okay, cool. And of course it works. This works really well with our tools. So we just made sure that you just have a express lane to build your ASP.NET apps, your APIs, and just push them into
Great.
App Service.
Cool.
Yep.
Yeah, so I think it's a perfect segue into, I think one of the other great things about App Service is just the first-class integration with our diagnostic tools.
Nice.
Oh, cool.
I would expect that.
Yeah, so should I take a little run through of that?
Please do.
Okay, so everyone has to know, and you need to know this, Beth, that Andrew actually wrote this application, and he's been trying to
it's
tell
probably
me
broken.
all week that it's perfect. Okay?
Okay.
So I told Paul he's been a manager far too long to be allowed to write code any longer.
And as the manager, that's why I use the data to actually balance what you're telling me with what's going on. So let's take a look. Let's see what the data says. All right, so let's look at the overview. So there's a lot of ways that you can get into Azure monitoring. And think of Azure monitoring as the best way to turn the lights on to get metrics, logs, alerting, even deeper application insights. And it's really easy to turn that on from a web app. So a web app is intrinsically more of a developer application thing. So we're going to go straight for the application insights. So I'm going to pick that. That's, again, part of Azure monitoring, just built in. We just did this in the last couple months. We made it easier to turn on what I think of as the best default diagnostics plan.
Okay.
So it collects all the goodies that you probably want by default, but not
What
too
types
much.
of things does it collect?
Yeah, that's a great question. So first thing, we collect metrics and logs. That's standard. But also we collect some APM or application performance monitoring data, really meaning things like we look at requests, which is a big part of a web app. We understand request times. We understand requests per second. And there's some really cool things with application insights. It actually knows inbound and outbound dependencies. And there's a correlation that gets added all the way through. So what that all lets you do is it lets you understand the end-to-end distributed trace of an entire application, which you can understand from logs. Logs are incredibly powerful. I think everyone uses them. But the tracing goes that one step beyond to help you understand full transactions.
Cool.
Also things that we worked on that we turned on. So we have a profiler, helps you get into real low-level detail about, am I spending too much time in CPU? Am I spending it waiting? Waiting for some dependency call. And we have a debugger that lets you collect dumps automatically at low overhead safely, and we'll show some of that too.
That's pretty cool.
So also there's SQL, like you can do SQL level instrumentation.
Oh,
Everyone,
nice. Okay.
especially
Cool.
he likes to blame SQL. So we get to figure out, was it really SQL or was it your code? Okay, so let's take a look. So we'll look at the data. Again, that was easy to turn on. All right, so we're getting some metrics by default. We're seeing some failures. That could be user error, Andrew. Don't worry about it. And then there's response times and things like that. Some different users using it. So let's just look at the most basic things we get out of the box. We have a search. All right, so let's just look at all the data, all the logs, all the telemetry coming in. And here we go. We're getting all kinds of things, like we're seeing requests, we're seeing trace messages. It even understands there's some outbound dependency calls into blobs.
Cool.
That's some of that
Okay.
APM tracing
Yeah.
I was kind of talking about. So this is really cool. It's powerful. You can search. Like I could search just on, exceptions, right? Also, everything you see here, this is kind of the easy view, but you can open it up into analytics. We have this really powerful analytics platform that can search across all of the monitoring, all of the
Cool.
application, even the security data, and you can query and make very specific insights.
Ooh, really custom queries.
Yeah, really custom
deep.
queries.
Okay.
And then that's the kind of thing, I think in our team rooms we do this. We make the queries that make sense for our teams, and we put them literally up on the screen. And it's something we watch all day to kind of see how we're doing.
That's cool.
Right, so it's our metrics or our goals for the team to keep those things working well.
So whatever's important to you, you can create a query and
Yes.
monitor it. Okay.
Now I have to say, I still have no evidence yet that there's any actual issues with the app. So
I
far,
would assume
I
exceptions
think
might be a clue.
Andrew's winning. He's winning the argument. So let's go to the actual failures. Okay, so we have some errors that have been happening over the last 24 hours. You can change the filters. We have 21, 500 errors in the last day. That just, I think 500 is what, internal server error?
Yeah.
It
is,
could be
yeah.
anything.
Could be anything, Paul.
Could be totally anything.
Infrastructure probably crashed.
And he had all day,
Azure
by the way, to make sure this thing had no bugs. Just remember that. All right. So what we're doing, we're looking at this exception here, and we're seeing there's an unhandled exception at the, the controller or the page that does a write watermark. So that was the part, like you took images in, you put your nice little watermark below. Now, does IIS do that, or does your code do that?
That would be my code.
Oh, okay. Want to double check? All right, so we have a null reference exception. There is no object reference. Any ideas what this could be?
You
need more
I'll go look at
information?
I could use a little more information. What else can you tell me?
Okay. Well, we could actually open up a full debug trace. Like, there's actually a dump of this that was set aside.
I would love to see a dump of this.
Okay.
You might convince him.
He's grasping right now. Okay.
So basically, you're saying that App Insights will take an automatic debug snapshot when an exception occurs?
That's right. It's not. It's a little bit less aggressive than every exception, because that'd be wild, right?
Right.
If you think about a mini dump, even a mini dump is kind of like taking all the memory on your machine and just very quickly, like 10
Right.
milliseconds, setting it aside, which is safe, right? It's
Yeah.
even safe in production, but you don't want
a lot.
You don't want to be wasteful about that. Right?
Right,
It's
okay.
chewing up storage and CPU. So we have a collection plan, a collection strategy that looks at a certain number of exceptions that we've seen. Let's say we see over 5 of the same type.
I see.
Then we would go and take an exception, a dump. And then after we collect that dump, we're kind of like, well, we've seen that one, so maybe we shouldn't try to keep collecting the same one over and over again. So there's some things like that in the collection plan, and that's all configurable. But we
Gotcha.
have a default plan that, we try to make sure that law of averages over 24 hours, you're going to see a good distribution of exceptions, and you're going to see, representative dumps from that.
So let me ask you a question. Is it better just to turn this on by default and let it do its thing, or should you only turn it on if you're starting to notice problems?
You have both options.
Okay.
I like to put it on because it's one of those things. It's, hindsight 2020. You start
Right.
getting exceptions. Who knows what the context was? Like, there's easy things to debug, like logic errors that just were always there, or like a config error or a missing dependencies. Like, those are going to break fast, and you might have a good idea from the logs. And that I would never try to debug those things.
Yeah.
But it's more like, hey, at 2 a.m. something weird's happening, and it goes down. Or some of my users, maybe who are in another country, they're reporting issues, and I have no idea how to reproduce that. And that's when a debugger is incredibly useful, right? Because you get, this guy, by the way, worked on designing the debugger. But you get the context of everything coming in, like the local variables,
Right.
the parameters, and that actually helps you understand, oh, it was this data point. So it's not just what broke, it's why it broke.
So you're saying you can open these right up in Visual Studio right from here?
Yes, you can. So
Okay.
here, like, you get this web view that everyone has. It's lightweight. You don't need a dev environment. You can just download the snapshot, and it's basically what the mini dump plus symbols, and what am I missing?
Yep. It's mini dump and symbols, really. So
Some metadata about it.
It's going to be big, just to warn you. It's the full copy of the process memory, which gives you the full ability to inspect and see what's going on, as Paul was saying. But what we had a 3.5 gig server, so that mini dump's probably going to be 2 gigs at least, depending on what the application was doing at the time. So the web portal is definitely the place to start. You experiment around, you look, and when you're like, I really need to really drill in, that's when you want to kind of do that next step of leaving the browser and bringing that down to Visual Studio.
Cool. And just to kind of cut to the chase, so I could open it in Visual Studio, but like, actually, I think I have enough to go on here to ask you a question. So the username is null, and then we're sort of croaking on the right watermark. So any more ideas?
Yeah, so I looked at the code while you were drilling into that. As part of the watermark, to make sure that we know who things came from, I'm actually stamping a hash of the username into the watermark.
Yeah.
And it looks like I had a slight logic mistake. It's actually
Wasn't that the day the intern worked on the code? It wasn't you?
No, it's actually it's a security feature.
Okay, it's a security feature.
So what happened was I'm accidentally letting people who aren't logged in upload images, and you shouldn't be able to upload if you aren't logged in. So I'm really just saving the service.
Oh, that's good. And you're saving the company money.
I am.
Thank you. That's a good guy.
Although
That's Andrew.
I will fix the application to not let people who are not logged in upload, and then we should be safe.
That's
We should be able
nice.
to fix that image.
So just
or
that gives
issue.
you a taste of what it takes. Like, we use logs, we use metrics to investigate failures, and then when you really need to, when you're in trouble, there's things like the snapshot debugger for dumps where you can just
cool.
do that deep analysis. The other thing that we can do is we can analyze the performance. And so one thing I like to do is I open up this perf blade. I like to sort by count. So you can kind of sort from most frequently used APIs and controllers and
That's
pages
cool.
to least, just to understand what's representative of your usage. Also, average, it's good, it's bad, it's averaged together, it's eh. So I'd rather use percentiles.
Okay.
I should patent that. So it's like, we'll take the median, just being like the middle one from the distribution. And now we can look again, we're saying, okay, so people just viewing the home page, 44 milliseconds, it's decent. Like this upload's taking 12 seconds.
Okay,
That's something
yeah.
we're gonna wanna look at. And the cool thing is we debate all the time about the app. I bet there's people seeing things slower than what we see, but you never really know. And now with this data, you actually know. It's pretty cool. Like you see the full distribution of what's going on, and then you can pick one.
That's really cool. That's pretty deep. Actually, there's a question out there that's sort of related here.
Yeah.
So is there any way for App Insights to detect a new recurring issue with a build and send a signal to Azure DevOps to roll back the previous build? So would that be something like, could you detect a problem and maybe switch back to the other slot or something like that?
Yeah, you can do that. So
Okay.
so just in Azure Monitoring all up, there's metrics, and then there's basically actions that you would take. So
okay.
one action would be an alert.
Okay.
That's probably the most common. You could send things to your incident management system or to emails or pagers or things like that. But also it provides a hook where, let's say in your DevOps pipeline, to take that person's question, that would be the signal of, hey, I'm throttling my rollout. At this point, I'm seeing the event that things aren't looking good. So therefore, I'm going to branch off and I'm going to, roll forward is probably what you would do. Roll back, roll forward to a version that worked.
Okay.
And so that scenario isn't completely automatic, but what is automatic is the metrics and the alerting and the events. And then just in your DevOps pipeline, you'd want to hook that event.
Got it.
And I'm sure we'll be looking to add a fully automatic scenario like that.
That's cool.
As soon as we can.
That's very cool.
Yeah, it's a great question. So just to keep noodling on this, so the get is like viewing the home page. The post is the upload. Is that how I think about it?
Post is upload.
Okay, cool. And if we look at that, we see this distribution. We had kind of agreed, let's focus on what the mainstream customers are seeing. And see all these triangles? This says that not only did we measure those requests, but we actually got profiles. And the profile gives us that deep level analysis. And I feel like performance engineering is tough, right? So we want to just make it a bit easier. So the profile, we've been automatically collecting samples with full profiles. And you can see we have some that are 17 seconds. That's the worst one. All the way down to this median, right? We saw the median was around 5 seconds. So let's go here. Let's sort by timeline. And then, Andrew, I'm going to need your help to analyze this. So it looks like we're spending a lot of time awaiting, kind of like awaiting for the CPU. And then the code you're actually running, your code looks like it happens in the very end. So how do I think about this one?
Yeah, so I think what's going on here, and I took a look at it, kind of drilled in, clicked around the traces a little bit more while you're looking at this on my machine, is when the user uploads the image, we do some processing on it before we put it up. And so when we get multiple users uploading, those requests are stacking up. And so that block time is they're waiting to get their turn with the CPU to process that image.
Okay, now do you have an idea of why this method might be blocking, right? Like leaving us in a block mode, so there's a contention?
Well, the issue is to process the image, we need the CPU.
Okay.
And I think our plan, we have 2 cores on our CPU, which means that if we get more than 2 concurrent requests, or 2 requests before it takes time to process that image, then we just have to wait till the CPU frees up before we can actually.
So are we trying to do too much in this web app post?
That is probably the right way to fix this. I don't know that I can make the code any faster that actually processes the image.
Okay.
So probably
it's more like rearranging, refactoring.
So I think the right way to fix this from a performance perspective would be to tweak the architecture of our application a little bit and offload the processing.
Do we have time to try this? Could he try to refactor it?
Yeah, let's do it. What are you going to use
let's
another
switch over
Azure
to your
service to do
machine.
this one?
I am going to use
All
another
right.
Azure service. Thank you, Ben.
Nice.
So yeah, we'll come over to my machine now.
Okay.
So real quick, what I have up here is just a small architecture diagram of the application as we have it so far, which is an ASP.NET Core Web application that's using a SQL Azure database to store user information, and when users upload images, things like that. And we're storing the images that users upload in Azure Blob Storage. So we promised you 5 Azure services. We've talked about 4 so far, right? App Service, Application Insights, Azure Monitoring, SQL Azure, and Azure Blob Storage.
And we just flew by storage and SQL.
We
It's
flew
like,
by,
everyone knows SQL. It's like it's
we flew by
We
storage.
have a database.
Yeah, we flew by storage and SQL. They're
incredibly hard, but you can take it for granted because it's SQL.
Yes.
Talk about them like air and water. They're, you need to store files, and that's what storage is there for. SQL Azure is built from the same source code that the SQL you would run on premises is. So if you're familiar with those things, not like we need to spend a lot of time touring them, but be aware that they're available.
It's your relational database in the cloud.
It's your relational database.
And they
in
run
the
at
cloud.
scale, and they're
Yeah.
backed up for you, and
Okay.
like really good things like that.
Cool.
So.
All right, so I just scrolled down, and so what we're looking at now is an architecture diagram of what we want the application to be. And so what we're going to do here is we're going to introduce Azure Functions as our 5th service. And so Azure Functions are event-driven code that are going to dynamically scale outside the context of my application. And so in this case, the event that we're going to use is uploading the image. And so when the user uploads that image, we're just going to pass it directly through my application. I'm not going to process it all. I'm going to stick it in a new container that's like a queue for waiting to be processed. I'll actually move the code that does the processing of the image, we call it watermarking, into a function that will then run independently of the application. When it's done, it's going to move that over into the blob store that my application actually reads and serves the images from when a user looks at it.
Gotcha. Okay.
So I hate to admit, I've been around for a while, and I've seen this kind of queue pattern where you have workers and web. Is that basically what you're doing? This is the modern way to do web worker with queues?
Exactly.
Okay.
That's
Yeah.
good.
So
Good way to explain it.
to use a kind of very buzzy term, some people might debate is exactly what we're doing, but we're trying to more microservicize the app. We're taking the idea of watermarking and we're moving that out of sort of being, instead of being this one big application that does everything intra-process, exactly, we're going to put it in a queue, we're going to let that worker pick it up.
The end user
process
doesn't
it.
want to wait around for the upload and the processing of the image. They just want to, boom, send it going. So that's feels very asynchronous, very fast. Now he's got a beefier service that can scale infinitely, right?
That's cool.
To go, chunk on those images and do his watermarking.
That's the theory.
Yeah.
All right, so I want to start off by just talking about how we would add an Azure Function project here. I have one created, so we'll kind of go over a second. But in the new project dialog, we have a cloud node under the Visual C# node. And so Azure Functions is the second project in there. And so when I select that, it would pop up. It would give me options for the various trigger types available. I mentioned it's event-driven, so there's a lot of good logic built into the Azure Functions runtime that lets me automatically wire up and trigger, and the runtime does all the heavy lifting for me about creating the objects and things like that. So we'll show that here in a second. I'm going to go ahead and cancel out of this and hop back over to our application in Visual Studio that's ready to go here. Is that?
Good to know.
So I have an Azure Function project here, and so what I'm going to do is I'm going to introduce 2 images. So one is going to be an image or a function that's going to trigger when the image is uploaded. Let me unpin this real quick into my queue. So what the application will do is the application said we'll put it in a holding blob container. That's the word I couldn't think of right there. And you can see it functions. This is the only
a holding pen.
A holding pen. There you go.
Okay, perfect.
And so
it's the Azure jail.
The
storage jail.
The code that we're looking at right here, it's all attribute driven. So I can see that I have an attribute here that's blob trigger, and it's mapping to the container named images. And then my out container, which is indicated by this file access.write, or my out stream, is just also then the images hyphen watermarks.
I mean, it sounds like a lot of machinery, but what I kind of see is there's a couple attributes that just say, this is the storage queue I care about, and it's doing all that pipeline ingest, output for me, right?
Exactly, and that's what I wanted to point out. I don't have to do any. There's no code in my application at all about reading or writing from storage. The functions runtime is going to take care of that on my behalf.
That's cool.
So I'm going to go ahead and hit F5 to start debugging this particular application. So I'm running this on my local machine because in Visual Studio we have a full local copy of the Azure Functions runtime. Same thing that's going to run up in the cloud if I want to develop it locally. Right, you get rich debugging, just the tight inner loop that you've come to expect from Visual Studio and .NET. And just to prove that it's going to work like we expect, I have Storage Explorer here. And so what I want to do is I want to drop an image into my queue that I'm listening to, and we're going to watch the breakpoint get hit in Visual Studio.
So that's your trigger.
That's my trigger. So I have my blob containers
It's the
here.
drag and drop trigger.
Drag and drop trigger, exactly. And then we'll test this working out in the cloud. So let's go to my pictures folder. Let's take this nice little green picture. I'm so creative. Drop that onto my queue. It's going to upload that. And
Very
then when I
nicely
come back to
compressible
Visual
image,
Studio,
right?
yep, I can see that my breakpoint's been hit here in Visual Studio. I can see that it's going to give me the name of it. It's green.png. And so as I hit F5, it's going to go ahead and process that. And then if I go back to my Storage Explorer here and I refresh, I'm going to expect that so I had a second function that when I finished processing actually took care of deleting the old copy. Oh, and there we go. My delete one just got hit. So I had left a breakpoint in there originally. So I hit F5, and that's going to finish. And then we go back to Storage Explorer. We refresh the holding queue, and it should be clean. It's been deleted. And we go to our images watermarked container. We're going to see that we have green.png has been uploaded.
Sweet.
So I've been able to, I have that wired up. And so now in my application, let's go ahead and test this in the cloud, Paul.
Yeah, I'd love to see it.
We don't need to run it locally, but what I want to do is I'm a little worried about messing up our production site. Obviously, you and I are banking our retirement on this photo gallery app
We are.
succeeding.
We nearly broke everything before this too. It was awesome.
And so what I want to do is I want to create a deployment slot. So we've talked about slots a little bit. And I think this is one of the really killer things in App Service. And so what a deployment slot lets me do is it lets me create another place to push a copy of my code in App Service. And then I can publish my application to that without affecting the regular site. And then I can go run tests against that. And then if I want, I could even then start routing a certain amount of traffic to that. Cool. So I've already created so I would create a slot here. So I'm going to call this one blue because I've already created a slot for this one. So we don't have to watch it.
That's
copy
like the
bits
deployment strategies, like blue-green. You're saying I could have, I could swap back and forth.
Blue, green, test prod, kind of whatever you want.
Stage.
And then as you were showing the app service settings a little bit ago, I can choose what I want to do from a configuration. Do I want to clone my configuration? Do I want to share my connection strings? Or do I want to have my own copy and potentially use different storage and a different SQL server here? For the purpose of this, I'm pretty confident in the quality here. So let's go ahead and clone just our regular environment. We'll run against the same storage and the same SQL. That's not a problem. And then from Visual,
there's a question too.
Yeah, I just wanted to let Andrew finish his sentence. But
He-
you know
he's
what,
just
Paul?
going,
If
though.
you want
Let's
to
let
be
him-
the host,
let's
that's
let him-
totally cool. I'll
Oh,
just
sorry.
leave right now.
Sorry about that, Beth.
What's our question, Paul?
Let me
Go
turn.
ahead, Paul.
I'm going to turn
no,
my
go
head
ahead,
this
Paul.
way.
Read the question.
All right.
Practice.
Sorry.
It's good. That's it. Go ahead.
So, Andrew, Beth and I would both like to know. Do you know with function apps what is their roadmap for deployment slots?
Yeah,
Is
do we
that
have deployment slots with function?
Deployment slots are already supported in functions.
Okay.
Sweet.
Cool.
Even better than the
so
roadmap.
it's like GA and ready to go.
It's like GA and ready to go.
There you go.
can do it.
Icky Bite. I love the handle, by the way. You
That's
are
super
ready
cool.
to go. We've got
So
deployment
Icky
slots.
Bite, Yuki, Yucky.
You are Yuki.
Yeah, Icky, Yuki.
Icky, Yuki. Cool. Thanks,
I like
Icky
it.
Bite.
Yeah. So the first thing I just want to show is how to publish to a deployment slot from a developer perspective. And then obviously you can wire all of this up through a CI/CD pipeline as well. But when I right-click Publish on my application, and I choose, I'm going to pick a new target. I'm going to choose Select Existing. And then in the group, once it loads my subscriptions, I'll be able to browse and you'll see deployment slots. So this is Azure AI 2018. This is the resource group Paul and I have been using, and I have deployment slots, and I can see Blue and Function here. I'd already published a copy of this to the function, so let's go.
You guys might have just updated
test
that
it
too,
out.
because I remember I used to have to download a publish profile or something. to
Yeah,
do
you
this.
used to have to download a published profile from the portal. You can always, if you do that, that's still a supported thing. So we have the import profile button right here. But yeah, you can just target a slot via that browsing as well.
VS knows slots now.
VS knows slots. That's correct.
That's cool.
You have to create it from the portal, but once it's created, you can pick it and browse to it. So, and then so let's click on this. This is Blue. This is Function. And so this is going to be the function-based implementation we just stood up. And so what we'll see here is once it loads, I'm going to click on my I have another URL, and it's going to be exactly the same URL that we had before, except I have the hyphen slot name on the end of it. And so this is our function-based implementation, and it looks like it loaded and worked correctly as I would expect. Application Insights is already picking up the data from it because we have it on the site. So Paul could go look at those metrics and check it out. And then
we were just clarifying this, like the monitoring in App Insights works across all slots by default, right?
That is correct.
That's cool. And it lets you know which slot?
There is metadata,
Okay.
so you
All
can
right.
filter.
Very cool.
Yep.
And then, well, I'm not sure. So the last thing I want to show is if we go over to the Application Insights. Did you show the app map earlier?
I forgot. I was on my roll then.
So there's something called an application map, and because we put our function app and our app service in the same Application Insights resource, it's going to automatically be picking up and monitoring that function as well.
Cool.
And so on my application map, which is going to load right here, once it eventually loads.
So the map is sort of like your architecture of all the services?
Yeah, the map is going to look very, sorry, I'm kind of in a weird zoom state here.
When we were first building, just a quick story, we had talked about that. And a lot of times when you diagnose something or when you onboard a new team member, I think a lot of us, we go to the board.
Yeah,
right. We draw a picture, maybe someone's done a Visio or something like that. And we thought it would be cool for developers to have that as a way to conceptualize what's going on, but then overlay the telemetry that's live over it.
That's cool.
Another cool thing is you really, and keep me honest here, I don't think you had to change your app at all to get that.
I didn't. It just worked.
It just worked, right? Because so basically, including Application Insights, it's tracking these inbound, outbound requests it rebuilds.
That's cool.
The topology for you.
Wow. Smart.
Yeah. So it's truly the truth. Like sometimes we even draw the picture and then you look at the data, it's like, ooh, we didn't quite do what we intended to do originally. So
Gotcha. Yeah.
Yeah.
But you can see the function.
It validates your architecture real time.
It validates, yeah. And you can see, you can see the...
Yeah. It looks kind of like the...
I'm doing it again. Okay, we'll go ahead and...
That's all right.
I get so excited.
This is Paul's bread and butter. Paul designed the app map. I'll give him the give him the call out there. But you forgot to talk about it. So it's my
they don't
turn
always
now.
let me out of Redmond. What am I gonna say?
Especially to Vegas.
But we can see the slot here.
1, 2, 3, 4, 5.
We can see the original instance that we have stood up here.
All my fingers.
We can see our function down here. So it's picking up everything and automatically building it. We can see our SQL Server. We can see our blob storage. And so just by turning on Application Insights on the resources that we wanted, it's automatically building an architecture diagram. And we can see performance data overlaid. We can see that 19% of the calls are failing. Like all of this information is overlaid. So to Paul's point talking earlier about why it's a good idea to just turn it on by default, it puts you in a world where instead of being reactive of, oh, people are complaining about a problem, you can go be proactive and watch, are there particular connections that were a problem? Are there times that are problematic? Things like that.
I find like once you have that data too, yes, it helps with troubleshooting. It helps with keeping your customers happy, but also you learn a lot. Like, okay, I had an idea about how people were using my service or my app, but I really know.
Right.
Like I really know for sure, and I know in detail. So it's.
That's actually really cool. So there's a question here that I want to ask you. No Content has a question. Can you use Application Insights outside of Azure Hosting Services so that you only maybe write logs and dumps to Azure? So that's a great question. Can you use App Insights outside of Azure?
Yes, you can.
Yeah.
So an application can just include the App Insights instrumentation engine or SDK in the application. In fact, for a number of years, we did that in Visual Studio Desktop itself. So it's totally possible. And then at that point, you're using the Azure service as your data and analytics store, right? And your app still resides on-prem. What does not work today is having the whole entire thing be on premises.
Okay.
So like having the data storage and the analytics on premises too.
I see.
So that's not yet.
Okay. So you want the cloud to do the deep analysis of those dumps,
Right,
basically.
which is actually
right?
a pretty good usage
Yeah.
of the cloud. Yeah.
Exactly. Okay.
Yep.
That's a great
That's a
thing
really
to
good
mention
question.
because if you can't move the production app with deployment,
Yep.
you can still take advantage of these Azure services to do some monitoring. Right?
Absolutely.
And
And
analysis.
another thing, I think we both have come to encourage this a lot too. Like always, in addition to App Insights, still pay attention to your logs. Make sure you're emitting really good logs. And I can think about for those on-premises scenarios, you always at least have co-located logs with you.
Okay.
And then there's further analysis that you have in the cloud, and I think that's just a great combo.
Right. That's actually a great combo. So we've been talking a lot about analytics and Azure App Service and functions and storage. So those are sort of like some very common scenarios that you would use, like architecture on premises to move to the cloud. What are some like we don't have to demo them, but what are some additional services that you can only get in Azure that you just wouldn't be feasible on premises at all?
So I think one of the really killer ones in Azure, which we didn't talk about, but is Cosmos DB. So Cosmos DB is a database that Microsoft's designed. They built from the ground up, designed to run in the cloud. It has incredible performance. It's a non-relational database, so it lets you really just work with objects in your code.
Objects, documents. You know.
Yeah. And from a performance perspective, there's things that you would have had to work really hard to break it up to get it in a relational model to help SQL perform well. But Cosmos
Was that
DB
called like nth degree normal, or you have to know all that stuff?
And didn't they release like a .NET SDK or something like
Yeah,
that?
it's really easy to work, read and write to Cosmos.
Okay, cool.
Since you're on the topic, I think the work they've done around consistency and replication of the data is truly incredible. Like you can have eventual consistency, guaranteed consistency across a lot of locations. It's pretty amazing. I can't even imagine trying to build that myself. It truly, like you said, it would be just not feasible.
Right.
It would be impossible.
Right. Awesome. Well, these are some fantastic services, honestly. So I think that we've kind of hopefully gave you guys a good show here of some common services you should definitely check out at least and take advantage of. We didn't really talk, like Ed talked a little bit more on the DevOps side. That's another way to go too, is if you're not ready to deploy to the cloud, you can at least try some dev test scenarios you can do in the cloud.
We had these cool lab scenarios. Did that get shown?
Yeah,
so
I don't know if that got shown, but I wanted to mention that.
You can even have your dev environment or your test environment just in Azure, and that's a safe step into the cloud. Kind of decide if that's a good working model for
We also have a website, AKMS, migrate to the cloud, WAC, migrate to the cloud.
Yep.
I think it's been in the chat room actually, so that has a lot of great resources on just like, hey, how do I move? And it talks a lot about
my
app
front
service
end,
there.
my data. App service is really what we recommend, but also
Right.
containers are really helpful too. If you need to preserve those dependencies, it's really helpful as well.
And if you use your favorite search engine and search for .NET Azure, the top result, and I think all the major search engines, is what we call the .NET Azure Developer Center that will have quick starts to all the things we showed and talked about, as well as extra resources.
Very cool. I think that we're building some learning kind of plans that you can actually like work right with Azure right through the browser and do different things, right? So that's a good way to actually check out without, try before you buy.
And I want to hear, are these the 5 services? We arm wrestle about all the time, and I always lose, by the way.
Yeah,
But,
let us know.
But he's right.
Right.
But if you want to hear something else, please tell us.
Absolutely.
We want to make it better.
All right, guys, this is the wrap of the show. I mean,
Whoa.
you guys hit the finale. It was awesome. Thank you so
Nice,
much.
we made it. Thank you,
All
Beth.
right, dude.
This was a really fun show.
Yeah, welcome to Vegas. All right, well, Seth is right over there. Take it away, dude.
All right, it looks like we're done. I'm going to walk over here because I can't just leave you here
You
by your
can't.
lonesome.
Yeah. Actually, you know what? We're doing something right now.
What's that? What are we doing?
Right after this show wraps up.
Tell me.
Stay on Twitch because we have a Dev Intersections code party going on.
What does that mean?
You know what that is? No. So what you do is you
Raise
go
the roof.
Raise the You can win prizes, trivia questions, answer them. You can get entered to win, like they're giving away all sorts of stuff. I have no idea what.
Awesome.
Usually it's a Surface
It's
or
gonna be
something
so
like
good,
that,
so
Surface
good.
Book or
Yeah.
Xbox or something like that. So they're actually at the arena, at the Knights Arena right now at the hockey game, and they're doing it right from there. So thank you guys so much for joining us this full day of Microsoft Connect 2018. I really appreciate it.
Awesome. We'll see you next time. Take care.
See you guys.